Hello everyone and welcome to today's video on Azure Data Engineering at Intellipaat. Do you know friends that Azure Data Engineering is a specialized domain within Microsoft Azure cloud platform which focuses on managing, processing and analyzing data at scale. It empowers businesses to collect, store and utilize data efficiently, thus leveraging wide range of Azure services and tools. The demand for Azure data engineers has been steadily growing as organizations recognize the importance of their decision-making processes. Azure data engineers play a very crucial role in designing and implementing data solutions as they are sought after a wide range of industries including finance, healthcare, retail, and many more. There are various job opportunities as Azure Data Engineer, Data Analyst, Data Scientist, and Cloud Data Architect. Azure data engineers are well compensated for their expertise. The salary for professionals in this field vary based on factors such as experience, location, and the specific role. On average, an entry-level Azure data engineer can expect to earn around $60,000 to $90,000 per year. Within a few years of experience, this figure can rise up to $100,000 to $130,000 annually. Senior Azure data engineers or cloud architects with significant experience and expertise can command salaries exceeding $150,000 per year. In conclusion, Azure Data Engineering offers not only fascinating career but also offers attractive job opportunities and competitive salaries. Whether you are looking to start your career or considering a transition in this field, the world of Azure Data Engineering holds an immense promise for those who have passion for these technologies. Now before we move on and learn more about what is Azure Data Engineering, I request you guys that do not forget to hit the subscribe button and click the bell icon. So we are going to start our session with what is data engineering. Then we will discuss what is Azure Data. Moving ahead, we will also learn about what is Azure Data Factory. Then we will discuss about data duplication. Moving ahead, we will also discuss about pipeline execution of data flow activity. Then we will learn about modern data warehouse pattern. Moving ahead, we will also discuss about Azure Storage and Data Lake Store. Then we will move ahead with data lake data science scenario, data transformation, expression language and debugging. Moving ahead, we will also learn about Azure SQL database deployment option, Azure Relational Database Platform, Azure SQL Database as a PaaS service, and then Azure SQL Database Managed Instance. And at the end, we are going to conclude our session with data engineering interview questions and answers.
Hello everyone and welcome to this video in which we will understand what data engineering is. The world in general has been continuously evolving around the data. Organizations have realized how valuable an asset data can be and how it can manipulate key business decisions, or at least that was the expectation. But back in 2017, Gartner's report stated that 85% of big data projects failed. One of the most important factors leading to this was the available data infrastructure was not reliable enough to make business decisions. According to the CTO of IBM in 2019, 87% of data science projects could never make it into production. Why is that? If data is so valuable and most decisions can be made using the data available, then why were so many data projects failing? Well, we are moving towards a world where we will be producing 435 exabytes of data per day. To put that in perspective, that's 1 followed by 18 zerobytes worth of data. This is where data engineers come into picture. Earlier, data scientists were expected to structure, source, and build pipelines for data. These tasks were often out of data scientists' scope of work or their skill set. The result was that data modeling would not be done correctly. There would be a redundant work and inconsistency in the use of data among data scientists. These kind of issues prevented companies from being able to extract optimal value from their data projects, so they failed. Eventually, more and more organizations began to realize the need of professionals who can transform and transport data in such a way that by the time it reaches an end user like data scientists, they are in highly usable format. Data pipelines are created by data engineers and they are used to build a warehouse of data collected from different sources and used across the entire organization. Data engineering came to be described a kind of software engineering that focused deeply on data infrastructure, data warehousing, data mining, data modeling, data crunching, and metadata management. Data engineers work in a variety of settings to build systems that collect, manage, and convert raw data into usable information for data scientists and business analysts to interpret. Their ultimate goal is to make data accessible so that organizations can use it to evaluate and optimize their performance. While data scientists are highly skilled in maths and statistics, R algorithms, and machine learning techniques, data engineers are more versed in SQL, MySQL, and NoSQL architecture and cloud technologies and frameworks such as Agile and Scrum. LinkedIn's 2020 Emerging Jobs Report and Hired's 2019 State of Software Engineers Report rank data engineer jobs right up there with the data scientist and machine learning engineer. Although there is no such exhaustive list of skills required for becoming a data engineer, but there are a few that have remained in demand ever since. Some of them are knowledge of programming languages like SQL, Python, R, hands-on expertise in relational and no relational database, knowledge of ETL systems, knowledge of data warehousing. Tools such as Apache, Kafka, Spark, and Hadoop add a lot of weightage to your skill set. And last but not the least, cloud computing technologies such as Azure, AWS, or GCP.
Whenever a company or an organization is looking to migrate their data center on cloud, right, you will see that new age companies or born in cloud kind of companies, let's say for example some startups, right, that have started in late 2020s, they would have probably adopted a full cloud kind of or cloud from day one kind of strategy. However, there are enterprises that have been in business, let's say since multiple decades, and these enterprises have had large data estate, right, or large on-premise infrastructures available in their data centers, and it is not possible for these organizations to make an overnight switch to cloud, right? So what is a typical journey that an organization or an enterprise goes through when they are looking to migrate to cloud? And this slide talks about that. And this is important because you also, within your organization, or if you are an part of IT services company, right, then you'll be serving certain clients, right, who are looking to take this cloud journey. So you would be able to assess as to where the customer stands today and what are the logical steps which other customers have taken in general to reach to a very mature usage of cloud kind of a state. So it starts very much with on-premise, right? So data estate modernization journey of a customer. Now this modernization is all about moving from on-premise data centers to running everything on cloud, right? And that too using the best of the options available in cloud.
Just a quick info guys, Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
Okay, so in this context, we are going to see what are the different choices, deployment options that you have in cloud, namely infrastructure as a service, platform as a service, and software as a service, right? We will talk about these concepts a little bit more in detail, and we will understand how a typical customer journey looks like. Okay. Obviously, there will be exceptions. There will be, some companies who do it, some way or the other, right, in a slightly different way. But this is, this slide depicts a very typical customer journey when they are looking to modernize their data estate from on-premise to the cloud. So how do they start, right? They want to first start by modernizing on-premises, right? So they would want to first of all adopt some of the best practices from the cloud and see if they can modernize or if they can upgrade to latest versions. For example, if they have been using SQL Server, let's say SQL Server 2008 version, right, which may go end of support. So they may upgrade to a better version or a latest version of a software stack that they are using. Or a typical first stage to the cloud is migrating using IaaS, which is infrastructure as a service kind of model, to the cloud. Now, what is infrastructure as a service? For to understand that better, let's take a simple example. Let me just check, if other people have joined in. I'll allow everybody to talk so you can ask questions. Okay, so let's take a simple example. Let's say you are running a simple application that is hosted on your data center, and that application is running on some front-end stack, and as well as it has some backend database. Let's say this is and since this is all about data, right? So we are talking about being a data engineer. So I will focus more on the data side of things. So let's say they are running some SQL Server or Oracle database. Okay. So how is this deployment working? Essentially, there is storage and there is compute, right? So imagine, let's not imagine an on-premise data center, which may be a little difficult for a fresher to imagine, but think about a simple small application running on your laptop, right? In this case, your laptop itself is an on-premise data center, right? Because if the database is installed on your laptop, if the application software is installed on your laptop, and if your application is running on your laptop, that means everything is running on-premise, right? This is not in cloud. So essentially, how it is running, your laptop is a machine, right, with certain configuration. Now, what could be this configuration? This configuration could be that, okay, I have a laptop with X number of CPU cores, right? It has got 16 CPU processing, right, processors, or it has got X amount of RAM. So let's say it has got 256 GB of RAM, or 512 GB of RAM, or 1 TB of RAM, and a certain amount of hard disk. So whatever that is, so essentially you have a machine, right, of certain size, certain configuration. On that machine, you have installed a database software, which is either Oracle or SQL Server, to take a simple example, and you have also deployed or installed certain application components, right? And you have built your code on top of that, and now your application is up and running on your laptop, right? As simple as that. And just an expanded version of that is nothing but how things work in an on-premise world, right? They don't run on a specific user's laptop, but they run on a server which is kept in a on-premise data center, and from there other other application users connect to that application. As simple as that. Now, if you want to migrate to the cloud, right, and for all the benefits that we saw yesterday, right, for the purpose of flexibility, for the ability to scale up and scale down quickly and easily, right, for the ability to create a better disaster recovery and business continuity plan, for all of that purposes, you want to migrate to the cloud, right? So you start exploring as a company. Okay, I have this software or this application which is running. It takes so much of configuration, right? It runs on this this configuration of a server. It requires this database. It requires these many application softwares, and this whole package runs on my on-premise. So you want a like for like replacement or like for like infrastructure on the cloud, right? Because for you to migrate to the cloud, right, the customers do not want a lot of changes, because these could be production grade softwares, right, or applications which their end users are using in the production. So you do not want disruptions, right? Typically, customers want to test the cloud, right? Because if this is your first ever cloud migration, where you as a company have been running these applications on premises for, let's say, for a few years already, you want stability. So what you would want is, I would migrate to the cloud, but I want minimal hassle. There should not be any challenges of running this in the cloud. I should not have to make any code changes, right? I should not have to make any database changes. So can I just do, and in other words, in the cloud terms, it is called as lift and shift. So can I lift my application and database components from on-premise, and can I just drop them and shift them to the cloud, right? That is the simplest form of doing modernization to the cloud, and that is called as infrastructure as a service, right? How that would happen? what you will do as a customer is you will assess your on-premise setup. Then what you will do is on a cloud, be it Azure cloud or any cloud for that matter, you will go for a very basic service, which is infrastructure as a service. Now, what is this infrastructure? This infrastructure in this case is a virtual machine. So you will deploy a virtual machine or you will procure a virtual machine. Now, this virtual machine will be exactly of the same configuration as you are running on premise, right? So if you are running a 16 vCore machine on premise or with a Windows operating system, then you will go for a similar machine, right? Or maybe slightly higher version of the machine on cloud, right? So you got that machine. Now, let's say you were running Oracle version 12G on this machine on premise. You will install the same Oracle software on this machine, because this is nothing but one more virtual machine that you have access to on the cloud. So you can do whatever you want in that machine. So you will deploy the Oracle software. You will deploy the any other application component, right? Java, runtime environments, or anything that you want to deploy, any other thing. So now, and you will also deploy your application code to this. You will also migrate your data from your on-premise. So you will take a backup of, let's say, your Oracle database, and you will put it into this newly installed Oracle on cloud. And that's how you will do the migration, right? And there may be, maybe 5-6 more steps involved than what I just mentioned. But net, it does not require any code change. It ensures that you have a compatibility, right? Because you are choosing the same configuration and you are now able to run on the cloud, right? And that is called as first step of modernization to the cloud, because it is very easy. You do not have to refactor your code. You do not have to do a lot of changes, and you can expect the same level of performance as you have in the on-premise world. Now, plus you get a lot of benefits that are cloud specific benefits. Now, what are these benefits? In the on-premise, if your software, or if there was a site level disaster, and if your data center had some issue or some outage, then you will have to fall back to another data center that you yourself own, right, as a company, and maybe it is in another city. So you have to do all that backup, disaster recovery setup by yourself. Here, once you come to the cloud, all of that becomes as simple as click of a button, right? So you can go to your virtual machine and you can choose a backup strategy through a click of a button, and automatically an image of your virtual machine will be backed up in completely different Azure region, which could be 300 kilometers apart, without you having to own any data center in that other geography. If you want, and if your application is so critical and you would want to make sure that another copy of your virtual machine image is also kept into a different country or different geography altogether, that also you can do on a click of a button. Now just imagine, in an on-premise world, you would actually have to first go and install or create a data center in that city, which comes with physical infrastructure, physical security of that site, setting up networking between all the 3 sites. Here you are now enjoying the benefit of Azure backbone of network or Azure backbone of infrastructure. So you are not having to essentially, you are just paying for whatever you are using, right? So you are coming from an capex heavy model, capital expenditure heavy model, to an operational expenditure model, OPEX model, right? So you are paying only for what you need. This is typically how customers take first step towards cloud, to modernize their data estate, going from on-premise to infrastructure as a service. So they can slowly reduce usage of that, because now that everything is running fine on cloud, right? They are also able to take backup. Okay. They will test the BCDR, and once they know that everything is running fine here, they no more have to continue to maintain their on-premise infrastructure. They can repurpose that same machine, the same server, for something else. Or once it comes to, let's say, end of support, or once that hardware is old, they can discard it. They don't have to renew the licenses or buy another set of hardware, because that is another important aspect. Whenever you are maintaining on-premise data centers,
Okay.
Essentially, you would have seen that even our personal laptops, after 3 years, 4 years, maximum 5 years, the performance decreases, right? We are no more able to use it because the technology is continuously upgrading. So every single company who is managing their on-premise data center, they have to do hardware refresh anyways after X amount of years, right? Every company may have a different policy for themselves, so they can start saving that cost, right? So they don't have to do the next hardware refresh, because and that is the beauty of cloud. Here, you do not have to do any hardware refresh. It is the job of public cloud provider. Once you have taken a virtual machine from them, it is their headache to manage it and to keep that machine running, fine. Any hardware upgrades that the data center, the public cloud provider has to do, it is their job. You as an end user or end customer do not have to worry about that. So essentially, there could be multiple ways, right? If you want, you can keep your application open to the public internet, right? But let's say you do not want to, if this is, let's say, some internal employee application, okay? So you know that only your company's employee should access this, right, over a secure network. So what you will do typically whenever you work from home, you are logging into a VPN. You can put your application inside a virtual private network in a way that only the authorized users are able to access to it. And if you try to access this application or database over the internet, it will not work. On the other hand, let's say if you are a banking customer and you want to create a net banking software. So your net banking portal, even if it is running on the cloud, you would want anybody to be able to access that over the internet, right? Because your customers will not be part of certain network. So you want to keep it open, right? But yet secured. There are multiple ways, right? How you want to manage that. That is more of a networking concept, but you can do it as per the requirement. It doesn't have to be third party. Typically, in any Azure environment, right, you will customers will have a team. Every single customer, almost, if it is fairly medium to large size customer, they will have a team called as InfoSec team.
Okay.
Information security team, right? And they will create guidelines for their own company as to how networking should happen, how the interfacing has to be done between cloud and on-premise, right? What kind of networks you want to create, what kind of security infrastructure you have to use, such as WAF or firewall, right? At a very basic level, how things should be kept behind the firewall. So all of that will come into picture, and typically this is the job of an InfoSec team of your organization. So we covered one aspect of it, right? Infrastructure as a service. That is typically the first step towards cloud that customers take.
Let's have a quick quiz question, guys. What Azure service is commonly used for real-time data streaming process? Azure Data Lake Store, Azure Data Factory, Azure Databricks, or Azure Stream Analytics? Please mention your answer in the comment section.
That is not why you do it, because why customers take this typically as a first step is because they do not have, let's say, experience of running things on cloud, right? So they do not want to start very heavily on the cloud, right? And that's where they want to feel comfortable first. So they would take step-by-step approach. And the easiest way for them to do is do a lift and shift, right? Rather than building something new from scratch on the cloud, they would typically identify a low-hanging fruit, right, or an application where their software licenses are either ending, or the virtual machine or the hardware on which that application is today running on premise, that hardware is up for refresh. So rather than spending that hardware refresh cost and continue to run it on premise, they will say, okay, why don't we migrate this to the cloud? But let's make that migration seamless. Let's make that migration with minimum possible effort. So let's do a lift and shift. Let's create a similar server on cloud, and then accordingly deploy everything to the cloud and see how it works for us, right? And that's how they start feeling much more confident. But customer journey, right? Not every customer would necessarily follow this. Some customers may be more willing to take risk, more willing to, let's say, start something fresh on cloud, or do migrate from on-premise to something like platform as a service, which may involve some code changes, but that will give them more benefits on the cloud. But I am yet to come to that. Yeah, I mean, that is how customers typically think. So that's infrastructure as a service. Now, what is difference between infrastructure as a service and platform as a service? Now, that is where your data modernization to Azure comes into picture. Okay. Now, imagine you have a SQL server running on on-premise, okay, which you migrated to cloud. Now, how did you migrate your application? You created a virtual machine of exact same configuration, right? Or maybe better configuration on the cloud. And now in that virtual machine, it came as a plain machine, right? Plain empty machine for you. In that machine, you installed whatever you required. So what you required, let's say you were running a SQL Server 2008 version. Now what you did, you installed the same SQL Server, right? You manually configured everything in that SQL Server, right? Now, what is a typical maintenance that one has to do with these database services? Whenever Microsoft or the vendor for that service will release any security upgrades, any security patches, your database administrators have to apply that security patch, right? Also, any configuration with respect to high availability, with respect to setting a backup, or with respect to setting a point in time restore. So some of these concepts, if you are not understanding, that's okay. We will see these in detail. But typically, whenever you are maintaining any database, there are these things, right? You have to take backup. You have to make sure that you are configuring your database properly. If you have to scale it up, for example, let's say you are deploying it on a 16 vCore machine, okay, and your database software is running on that, and your database is running on a let's say 100 GB of storage, okay. Tomorrow your data size is growing, okay, and now you want to scale it up. So in an on-premise world, you will start right from ordering the additional hard disk, all right. Then that hard disk will be delivered, and then your IT person will attach that hard disk to the machine, right? And then you will do all the software based configuration to start using that additional drive, right? That changes from on-premise to the infrastructure as a service. How it changes? You are running a virtual machine, so you can simply select an additional storage device or storage disk, and you can attach that storage disk, additional storage disk, to the virtual machine. So you don't have to physically do anything. You just have to on the Azure portal select additional storage, right? And automatically that storage will get attached to your virtual machine, and you will be able to quickly start using additional storage. That is infrastructure as a service still. Now, what happens in a platform as a service? In platform as a service, Microsoft or Azure tells you that, hey, you want a database, don't worry. You don't have to install that database on your own, right? In a virtual machine, we will manage the installation for you. You just, select that service and click on, deploy. We will deploy it automatically for you. So you do not have to, number one, do any deployment, any installation, or you do not have to get into any basic configuration of that service. Within a matter of minutes, or within a matter of, let's say, 2-3 minutes, you will have your database up and running. That is the beauty of PaaS. You do not have to deploy anything or install anything. Number one. Number two, you do not have to do any high availability setup. We will ensure that your database is always up and running, and we will give you guaranteed SLA that your database will be up and running for 99.95% of time. So you don't have to worry, right? For example, what may happen in an infrastructure as a service? Let's say your database is running fine, your application code is running fine, but what is happening is your virtual machine, let's say there is some other application that is running on that virtual machine, and that application is using that virtual machine CPU so much that there is some stress on the database, because database is not getting enough resources. So because of that, let's say your database stops working or is not getting enough CPU to work properly. That can happen in a infrastructure as a service, right? Because you may not be aware who else is using that virtual machine for what. But Microsoft says, come use our PaaS service, which is platform as a service. This is a database as a service. You will, we will give you SQL database. Continue to use that, right? You do not have to apply any security upgrade. You do not have to apply any security patch to this database. We will do it on your behalf, right? We will automatically keep upgrading and ensure that there is the best of the security always available for this database that you are using. Then you do not have to manually do any maintenance of that. You do not have to worry about high availability. We will manage it for you. And we will also financially guarantee that when we say the service will be available for 99.95%, if it is not available for that percent, we will financially compensate you for that much time of outage, right? So you are getting better guarantee. Now comes to scaling, right? If you want to scale your database service from, let's say, 4 CPU cores to 16 CPU cores, or if you want to increase the storage from 100 GB to 200 GB, we will make it very easy for you, right? You just have to come to Azure portal, go to your database service, and simply change from 4 vCore to 8 vCore and click on OK. As simple as that. Your machine will be automatically upgraded. Your database server will be automatically upgraded. Your storage will be automatically increased. So we will make it absolutely easy and seamless for you. And the best part of it is, if you want to downgrade, that also is very easy. Imagine in an on-premise world, if you have bought a new hard disk, you have paid for it. So there is no point in downgrading. So you cannot save cost anymore. But here, because it's a PaaS service, if you want, let's say for 2 days, 3 days out of a month, when you are, if it was, let's say, employee payroll application, then payroll application does the payroll processing towards the end of the month, right? Or maybe every 15 days, whatever maybe your logic. So for those many days, you can run it on higher capacity. When you do not need that much capacity, again, scale it back down and you can save cost. So all of these advantages that come with a platform as a service. And one of the most important advantage is your service will never go out of support. Now, what is out of support? Out of support means, let's say Microsoft created SQL Server 2008 version, right? It created 2012 version. And so when vendor, right, or OEM for that matter, when they create newer versions of their software, they stop supporting the older versions, right? They will tell you, they will give you some notification that, hey, Mr. Customer, you are using older version of your software. This is the date by which you have to migrate to the latest version. If you do not do, then there will be, no more support available for the older version. That happens in a on-premise world. That also happens in an infrastructure as a service world. For example, in infrastructure as a service, what we are doing, we are just procuring a virtual machine on the cloud, right? And in that machine, we are deploying whatever version of the software we want. But if that version of the software goes out of support or out of warranty, then you have to do the upgradation yourself. But in PaaS, platform as a service, that headache is also taken away. Because in PaaS, these, for example, Microsoft will guarantee you that your SQL Server is always going to be on the latest version. All the latest and greatest feature that we develop will always be available on our PaaS service. That means there is no tension of doing a version change or version upgrade. So these are the benefits of a PaaS, platform as a service, right? You get much lower maintenance overhead. There is very minimal administration activities that you have to do. You do not have to worry about end of support for any older version of the software or service that you are using. And you get all the flexibility of the cloud, right? You can very easily scale up, scale down, and use this service with minimal headache, right? This is the best way to use cloud. So that is platform as a service. And typically when customers migrate to the cloud, right, once they feel comfortable running on a cloud, next step that they will say is, okay, I am running SQL Server or I am running Oracle or whatever, right, on a virtual machine. Now, how can I migrate that from a virtual machine to a PaaS service? So let my application run on a virtual machine, but let's migrate my database to a PaaS, right? And there are similar database, there are also services, PaaS services that are available in the application stack. So you don't have to run your application or code also on a virtual machine. You can run your application code, let's say on a PaaS service that is called as app service in Azure, and your database is running on a PaaS service called Azure SQL DB. So both your database and your application code are all running on PaaS service. Thereby, you are using the best of the benefits of cloud, and that is your next step to modernize the data. So I will tell you how customers decide that, right? So see, the best thing, they know that the best benefits that they will get is with a platform as a service. Then the question is, why would anyone not go for platform as a service, and why would customer choose infrastructure as a service? Let's say if I am telling you that platform as a service will give you more benefits compared to infrastructure as a service, then why should anybody select infrastructure as a service? So there are some reasons to it, right? Now, in a platform as a service, first of all, because there may be certain feature compatibility. For example, let's take an example of SQL Server. Okay, somebody is running SQL Server on the cloud. Okay, sorry, on premise. Now they have two choices: whether to select SQL Server as an infrastructure as a service on a virtual machine, or whether to select Azure SQL DB, which is a PaaS service for migrating this on-premise SQL Server. So for that purpose, typically how customers do that is they will run an assessment tool that is called as, in Azure world, it is called as database DBA, database assistant, DMA, database migration assistant. So it's a small utility that you will run on your on-premise database, right? What in that you select your source database as your on-premise database. Your target database you will select, let's say, as a Azure SQL DB, which is your PaaS service. And on the other hand, you can select the other target as a SQL Server on virtual machine. That you don't have to select because it will be compatible. Now, when you run this data migration assistant tool, it gives you list of all the compatibility issues. For example, it will tell you that on your on-premise database, you are using these many SQL Server features, right, which are available, let's say, in SQL Server 2008. Now, these features, if you were to migrate from on-premise to a SQL PaaS service, which is Azure SQL DB, it may be a very minimal effort, right? Because it will not be as same as lift and shift. In lift and shift, you are choosing the exact same version of the software, exact same version of database, similar configuration of virtual machine, so everything will work fine. In case of a PaaS service, right? Because PaaS services keep evolving, so the Azure SQL DB, which is a PaaS service, may not support every single feature, because there could be some obsolete feature which are not available in PaaS service, because which Microsoft thinks are very few customers are using. So they don't want to include those features, and there may be better alternatives possible, right? So they have deprecated some old feature and they have created better and newer feature. But essentially what happens with that is, if your older feature of SQL Server on-premise are not supported in the new PaaS service, although there may be better features available, but for you as a customer, it will mean that you have to do certain code changes before you can migrate this application to the PaaS service. So that DMA, data migration assistant, and we are going to see that in detail, right, at a later point in time. But that DMA or that assessment, right, think of it like any kind of assessment. From migrating from a source system to the target system, that assessment will tell you whether you can migrate as it is, or whether you have to do certain amount of code changes. And whenever you do some code changes, that means there is inherently testing will be required to make sure that whatever code changes that you are doing, it is working fine. So you have to do integration testing to make sure that because of the new code changes that you have introduced, nothing else is failing, right? So the deployment time frame may increase, right? And with every code change, then sometimes customer also have a hard deadline, right? For example, I talked about hardware refresh. So your customer realizes that, okay, today we are in February. By the month of June, I have to refresh my older hardware. So they are in rush, they are in hurry to take a decision that rather than refreshing that hardware or renewing that hardware in the month of June, why don't I quickly move to the cloud? So if they want to quickly move to the cloud, they want to not do any code changes. They want to move as is. So infrastructure as a service becomes very quick and easy choice for them because they can do a lift and shift. On the other hand, they will also they might also assess. Okay, let's check how many code changes are required. Now, do I have the time, money, and team resources that can do these code changes, test these code changes, and deploy in time to the cloud? Then they might also go for PaaS service. So the decisions are decided based on how quickly you want to migrate, whether you as a customer want to involve or indulge into any code changes or refactoring of the code and application, right? And these code changes may not be only on the database side, right? There may be also code changes required on the application side. And for depending upon the complexity of the application, you may, as a customer, you may or you may not want to touch the code, right? Or test the code and touch the stability of the software or application that has been running for years for you. So you may first want to just migrate as is. And when you do not have any timeline or deadline pressure, at that point in time, you may want to pick up any code changes. So these are different factors that help customers to determine whether they want to go as to IaaS option or a PaaS option as a first choice when migrating. So why it is still a modernization, I will tell you, right? Let's think about some of the benefits that you have in infrastructure as a service over maintaining this in on-premise, right? Number one, let's say that was the only application that you were running in your on-premise. Now you have migrated that application to the cloud. Although it was migrated as a lift and shift infrastructure as a service, but no more you have to maintain your own physical infrastructure, right? Right from the security guard who was guarding that infrastructure or that site for you, you can start saving cost, right? Now you do not have to manage any security, any network infrastructure, any hardware on your on-premise. You can get rid of that. So that is modernization for you. Number two, because you are kind of going away from all of those responsibility and starting to save cost. Number two, imagine it was still a very business critical application. That means you cannot afford any downtime on that. But what was happening in the on-premise world, you had limitation, right? Then you can manage only so many data centers. So you were still a big customer, or big company. So you were managing a data center in Chennai region. You had another data center in Pune region. You were maintaining whole you are spending cost on the networking between the two regions, replication between the two regions, managing these two different sites. But you still had limited choice, right? If there is some large scale disaster in Pune and Chennai and affecting both the regions, then you are still gone, right? You do not have to you don't have a choice, or you cannot keep it running. You modernize to the infrastructure as a service. Now you first of all you get rid of both the sites, physical sites. You on a click of a button are able to not only create a replica of your virtual machine in Pune region, Chennai region, but if you want a better security, better resilience, you can even go and create another replica in US region, right? And for that you did not have to go and buy any site in US. Just on a click of button you were able to do that. So that is why it is still a lot of modernization. So when you modernize your data to Azure, right, essentially that is like moving from either on-premise to adopting more of PaaS services, and or moving from IaaS, infrastructure as a service, to adopting more and more of PaaS services, so that you are actually getting true advantages or maximum advantages of running it on the cloud. That is the idea of modernizing. So when customers typically start modernizing their databases and applications, the next step that they typically do is now they want to do cloud scale analytics, right? So they know that, okay, they have adopted the best of the offerings of the cloud and their services are running maintenance free or at a very low maintenance in the cloud. Now they want to bring in data from various data sources and build an analytics platform, right? Again, this can happen in any order, right? Some customers may say, okay, I want to first build an analytics platform. My applications are running fine on premise, but I want to build analytics platform on cloud. That may also happen, right? So the order of number 2 and number 3 may change, but I'm talking about a typical customer journey. Okay, so once they start using cloud, they want to now start doing cloud scale analytics. Here they would want to bring data from various data sources. Think about any small organization think about a manufacturing use case, or think about an IT services organization, or think about, let's say, a banking customer, an insurance domain customer, or a retail customer. Every customer has lots of data, right? Data about their employees, data about their customers, data about products, vendors, data about their supply chain management, data about their finance department, whatnot, right? Profit, loss, etc., etc. So they want to bring all of these data together, and they want to be able to do cloud scale analytics, right? And that's where their journey continues. So there are a number of Azure services that are available that will allow you to bring this data into a data lake, build a data warehouse on top of that, and be able to do big data processing. So I'm going to touch upon some of those in the upcoming slide. But cloud scale analytics follows next, right? And once you start using, data modernization, cloud scale analytics, what you start looking at now is also leveraging artificial intelligence, right? So you must be hearing a lot about OpenAI, ChatGPT these days, right? And how easy it is becoming to deploy or embed these AI innovations into your day-to-day applications, right? Be it an Excel file, or be it Bing search engine. I don't know if you guys are following all of those, latest updates from Microsoft and other companies. Artificial intelligence is becoming part of our day-to-day life, whether we know it or not. But a lot of AI is coming into play, right? So that is the thing. That is next things that typically customers have start looking at as to how they can embed more and more of AI into their applications and take advantage of this great capability. So this is how a typical data estate modernization journey of a customer looks like on the cloud on Azure Data Services. You start, going from on-premise to IaaS to PaaS to start doing cloud scale analytics, embed more and more of artificial intelligence in your application. So and thereby become much more matured users of data on cloud. Now let's understand this is okay. So next slide, as I start building this slide, right, towards the end of it, there will be on this slide. Okay, so I don't want you to get overwhelmed by this slide. Think of it as a very high level understanding of Azure Data Platform. Okay, so I'm going to list down important Azure data services on this slide. A number of these we are going to double click and understand in very detail in the subsequent sessions that will follow. So don't worry. Even if you are able to just catch the names, even if you are not even able to remember all the names that will come up on the slide, do not worry at this point in time. We are going to pick up, one at a time and deep dive into it at a later point in time, so that this whole thing will be clear. But before we get into thick of things, it is important to understand things, let's say, from a bird's eye view or a very high level understanding of what Microsoft's intelligent data platform is all about, right? So when we talk about data services, you will see cloud services that are databases on the cloud, or there are some services that allow you to implement cloud scale analytics or big data processing on the cloud. There are services which are AI, artificial intelligence, machine learning, and IoT, Internet of Things related services. Then there is BI, business intelligence related services. And then there will be a little number of more services that go kind of across all these services, or more fundamental in nature, right? So let's first get started with the databases. Now somebody was just talking about, right, if is Azure SQL DB, is it a general PaaS service to run all databases? No. So before I talk about this, right, what are different databases that you have heard of, or what are different databases that you have used? SQL Server, Oracle, let me start with those two. What else? Which other databases have you heard of or have you used? Okay, so we talked about a number of databases, right? Why do we use these databases? These databases we use to store our data, right? To be able to query on this data, right? There are two main categories. One is a SQL. So, see, why do we use various databases, right? Databases help us to organize the data in much easier way. We can build application where a database can help to be a backup or a backend for that application. So all of these are the benefits of running databases. I don't want to go into details of these things because that is not what I am here to teach you as to a database technology from scratch, but rather I am going to focus on how to run these databases on Azure and what are different choices that you have available on Azure when it comes to running various types of databases. So those are the things that we are going to focus more on. Now, when it comes to databases, there are two main types, SQL and non-SQL databases, right? And at this point in time, I will not even go into details of what is a SQL and what is non-SQL, NoSQL, right? But, and we will cover that at a later point in time. But when it comes to PaaS service, right, we realize that a PaaS service is better than IaaS service, right? Now, you talked about a number of databases, right? For example, Microsoft's out of all of these, which one is the Microsoft proprietary database? Can anyone tell me?
SQL Server.
SQL Server, correct. So SQL Server is Microsoft's proprietary database. That means Microsoft has created this, and Microsoft has commercially made this database available for all the customers to use for a long time now, right? For decades. So let's say, first of all, when Microsoft was creating these PaaS services, they realized that the two most popular databases that are available was SQL Server and Oracle DB, right? Most widely used databases. So SQL Server being Microsoft's own proprietary database, they created a PaaS service, which is Azure SQL DB, right? So whenever a customer is running SQL Server on the cloud, on-premise, sorry, SQL Server on-premise or SQL Server as an infrastructure as a service on a virtual machine on cloud, if they want to migrate to a PaaS service, their choice is Azure SQL database, right? So Azure SQL DB is a PaaS service, fully managed, and PaaS is also called as fully managed, right? Or database as a service. Why do we call it fully managed? Because it is fully managed by the public cloud provider, fully managed by Azure for you. And what is it that they fully manage? The security upgrades, right? No need to upgrade version, right? No end of support, any patches to it, high availability of that. So all of these are easy scalability. All of these are easy managed for you by the cloud provider. So they are called as fully managed service or PaaS service. So whenever you want to migrate from SQL Server to a PaaS service on Azure, your go-to option is Azure SQL DB. Okay, so that was very natural choice for Microsoft, because they were providing this on-premise software. So they said, okay, this is the PaaS service, come and start using it. But then they also realized that there are other popular databases such as open source databases. So a number of customers are also using open source databases like PostgreSQL, MySQL, MariaDB, right? So and customers wanted to come to Azure, but they were looking for a PaaS service, right? A fully managed service. They said, okay, we are using these open source databases, but we don't want to manage these ourselves, right? We want the similar benefits of a PaaS fully managed service. So, hey, Microsoft, can you give us a PaaS service? So Microsoft said, yes, more than welcome. I will create a PaaS service for open source databases such as MySQL, PostgreSQL, and MariaDB. So that is your option, open source databases. Okay, so you can run a PaaS service on Microsoft's cloud for these three databases. Okay, now some customer says that I am also using Sybase, I am also using HBase. Can you give me a PaaS service? So Microsoft will say, okay, we have not seen a lot of ask for, let's say, Sybase or HBase, so we do not have a PaaS service for this. So now customer will say, okay, what is my option then? Then Microsoft will say, okay, your option is you can still run it on cloud, but run it as infrastructure as a service. Getting it? So you can run absolutely everything that you are running on the on-premise infrastructure onto the cloud, onto Azure cloud, either by adopting or by using the PaaS services that are available from Microsoft side. That means you can use a fully managed service where your maintenance on you or administration tasks reduce significantly. You get maximum benefit, but for some services or some databases where they are not available as a PaaS service, then your default choice becomes to run it on the same machine on the cloud as infrastructure as a service. Okay, that is on the SQL side of things, right? Now, on the NoSQL databases. So similarly, let's say customer said that we are running a lot of NoSQL databases such as MongoDB, Cassandra, we have CouchDB, or we have Gremlin, we have number of other databases, key value pair databases, or column store, column family store databases that we are running. So Microsoft created one-stop solution for all these NoSQL databases or different types of NoSQL databases. What is that solution called? It is called as Azure Cosmos DB. Again, it is a fully managed service or a platform as a service database. Now, Cosmos DB comes with different types of NoSQL APIs. Now, it comes with a SQL API, it comes with a MongoDB API, it comes with a Cassandra API, it comes with Gremlin API. For now, only understand that Cosmos DB is your NoSQL database, PaaS service on Azure. So whatever NoSQL you are running on the cloud, you can more likely than not migrate it to Cosmos DB. And if at all you are running certain NoSQL database for which you cannot migrate to the Cosmos DB, then what will be your choice to run it on Azure? Not SQL DB, it is a NoSQL database. Let's say a very particular NoSQL database which is not so popular, but and migration to a fully managed service like Cosmos DB is also not supported, but you still want to continue to use that database, that NoSQL database that you are using on premise. So how will you migrate that to Azure? So for those kind of services, you will have to go by infrastructure as a service option. That means you deploy that same database software on a virtual machine on Azure, right? But what you run inside a virtual machine, you will have to manage. So any software that you are running, whether it is running fine or not, right? Whatever configuration that you have to do for that, or if there are 10 different things running on that virtual machine, because of which, let's say it happens on our machine, right? On our laptop, we install so many different applications. And because of which, if you are running those 10 different applications, one application starts running slow. So you go to task manager, you end other processes so that this one process can get more resources and it can run better. So likewise, you have to manage it on your own laptop. That way, you will have to manage it on that Azure virtual machine as well, right? So all of that responsibility becomes your responsibility when you are going infrastructure as a service. But what will Azure manage for you? Azure will tell you, okay, you are secure, you are taking this virtual machine from our side. We will guarantee you that this virtual machine will be up and running for, let's say, 99.95% of time, or whatever that SLA is, right? That they will guarantee you. That if you want to create a backup of this virtual machine, we will make it very easy for you. On a click of a button, you can make, create an image, backup image of this machine and store it in completely different region altogether. So that benefit you will get from infrastructure as a service, but the internal, right, whatever happens inside that machine will be your responsibility. If whatever database software or whatever application software that you are using, if there is a security upgrade available for that, it will be your responsibility that you apply it inside that VM, right? So typically what you can do is you can discard that old old technology stack, and you can also adopt a newer stack where you have better database available, which is available as a PaaS service. If you are keen to take full advantage of cloud, you may have to do certain code change, certain migration effort, but you can do that. But let's say in the interim, you do not have time to do all of that, and you just somehow want to still migrate from on-premise to the cloud as it is, then you can run it for some time on infrastructure as a service. on the cloud and still get rid of your on-premise. So all of these are ifs and buts, right? A lot of questions every organization has to answer in the context of every single application migration that they are looking, right? There will be a checklist of questions that they will try to address, and that is how your migration strategy will be clear as to how you want to migrate. Now, all of these things we are going to go into details when we talk about the specific service. For example, I'm going to talk in detail about Azure SQL DB, OSS DB, Cosmos DB, right? So let's hold on to those generic questions at a later point in time. For now, what you need to take out of this slide today is, okay, what all is there on Microsoft's intelligent data platform? There are databases, there are cloud scale analytics services, and etc. etc. That much high level understanding is good enough, right? Because we are anyways going to go into quite some details of each of these at a later point in time. So let's stick to very high level details. Let's understand what are various options, and then that should be enough, right, for today. So now you know, when your customer or when you want to migrate different databases to the cloud, these are your options, right, on the database side. Now you also want to, you may also be running some data warehouse workloads on the cloud, right, which could be Oracle Exadata workload, which could be SQL parallel data warehouse workload, etc. etc. So when it comes to data warehouse, right, or a big data lake on the cloud, Microsoft's one-stop solution or one flagship offering is called as Azure Synapse Analytics, right? It is a combination of data lake plus data warehouse brought together, wherein you can bring both a big data lake, right? That means you can bring in structured and unstructured data, plus you can create an MPP architecture, massively parallel processing architecture, wherein you can store your data into tabular structure, and you can use both SQL queries as well as Spark code to analyze your data, and thereby Synapse Analytics is also such a service that natively integrates with a number of other services. So when it comes to cloud scale analytics on Azure platform, Synapse Analytics is your one-stop solution, right? For now, just understand that much, and we will go into details at a later point in time. But that is Microsoft proprietary. Okay. However, how do customers do big data processing today? Right? What all different technology stacks? So like I asked you, which all databases you know. If I ask you which all cloud scale analytics or which all on-premise analytics services that you are aware of, you will probably talk of Informatica, you will talk of Oracle Exadata, you will talk of SQL data, parallel data warehouse, you will talk about Teradata, you will talk about Snowflake, right? All of these different services. And if I ask you, what are the big data processing services that you have used? And of course, with the kind of experience that you guys bring to the table, you would probably take a few more names. But in general, the answers that I will definitely get is Hadoop, right? I will hear Spark, right? I will hear Apache Storm, Apache Kafka, all of these open source databases, right? Or data services, big data processing services. So you may have a combination of some data services, right? Some big data processing services, some data lake kind of services that you are using to do analytics, right? On the databases side, this is more of OLTP, online transaction processing. When we come to cloud scale analytics, this is more about OLAP, online analytical processing. Okay, so transaction processing is more about creating database for your application, serving millions of users, right? Online applications such as, think of it like banking database, think of it like retail database, right? A retail portal where your product vendor order information, all of that. On the other hand, what is analytics? Analytics is like running large queries on your data, on your orders data, to understand, okay, what is my total number of orders that were processed during the day, right? Here I'm not talking about one or two individual customer order. Here I'm talking about total order volume, total order quantity, total order net revenue of today, so that my CEO can understand this by using by using this data. My CEO and the key stakeholders are able to understand the health of the business. right? In a banking transaction, in the banking world, what are my total credits, total debits, how many FDs got created today, how many loan accounts are becoming non-performant assets, right? Non-performing assets, NPA. How can I keep track on various ratios in the banking world that you keep hearing of? Is this more about individual transaction? In my account, what is the balance, or in your account, what is the balance? No, this is at a bank level. This is aggregation, and that is why it is called as analytics. So you need different systems to run this kind of analytics on data, and that is done by this category of services, cloud scale analytics. So if you were as a customer using Azure SQL data warehouse, you will migrate, and you want to now migrate to the cloud, you will go to Azure Synapse Analytics, default choice, right? Even if you were using Oracle, Exadata, Teradata, Snowflake, etc., you may consider migrating to Azure Synapse Analytics. That is Microsoft's proprietary service. Okay. On the other hand, let's say this is a PaaS service that is available. Now, do you have a PaaS service available for Informatica? Do you have a PaaS service available for Teradata on Azure Cloud? No, there is no PaaS service. But then does that mean you cannot run those? No, you can continue to run those as infrastructure as a service. Okay. And that kind of limitation you will see with every public cloud, right? Whether is it GCP or AWS, they will all have their own PaaS services that they support as a fully managed service. And anything that is not available as a fully managed service, you will have to run as infrastructure as a service. In more cases than not, customers adopt to migrate to a fully managed service. Now, that's about a proprietary data warehouse and data lake that you have on Azure. What about big data processing, right? And what about similar to these open source databases? There are Hadoop ecosystem, which is open source. There is Spark ecosystem, which is open source, right? So if you want to migrate your open source Hadoop cluster, open source Spark cluster, open source Apache Kafka cluster, etc., then what is the alternative? That alternative is Azure HD Insight. So there is a service called as Azure HD Insight, in which you can migrate your big data open source engines such as Hadoop and Spark. Let's keep it to that for now. Okay. Now, what is Azure Databricks? Azure Databricks, you will choose as a customer. It is also a PaaS service. You will choose that when you want a highly optimized Spark cluster. So Databricks is equivalent to optimized Spark. If you want an open source Spark, you will go for HD Insight. You want a proprietary, highly optimized version of Spark, then you will go for Databricks. For now, understand just that much. Now, similarly, there are other services. So this is about analytics, right? Big data processing. But there are in analytics, in cloud scale analytics, you also need some services that will help you to do streaming data analytics. Right now, what is streaming data analytics? Streaming data means real-time, near real-time data processing, right? For that, typically customers use Kafka, Apache Kafka on the on-premise environments, right? So if you are using Apache Kafka and you want to continue to use Apache Kafka, then you can use a Kafka cluster on Azure HD Insight service. Okay, that's one option. But if you are building it new, or if you are okay to use Microsoft proprietary service for this, then you can also use Azure Event Hub. Azure Event Hub is a service that allows you to ingest millions of records per second, right? So that is like ability to process millions of records and ingest them into your data lake every second through Azure Event Hub. That is one service. Now, that is about just ingestion. Now, if you want to process this data, right, then you can use Azure Stream Analytics for real-time analytics. And for near real-time analytics, you can use a service called as Azure Data Explorer. Okay, like I mentioned, this will start getting little overwhelming, but don't worry. For now, just understand this much. If I were to simply put it, these are databases. Talk to our SQL set of databases. Underneath, Cosmos DB is a NoSQL database. Cloud Scale Analytics, Azure Synapse Analytics is a one-stop solution for data lakes plus data warehouse. Then the HD Insight is for open source big data processing. This is for specifically optimized Spark. And these are streaming data services, as simple as that. Let's now very briefly touch upon AI, ML, and IoT services. Because we will not be touching on this at a later point in time much, because this is more part of Azure AI Engineer certification, which is a different certification altogether. But because AI, ML kind of sits very closely to the data processing, I wanted to give you a very high level overview of that. And what is bot service? Bot service is all about ability to create chatbot. You go to any website these days, on the bottom right corner, you will see a chatbot saying hello and hi to you, right? Or how those chatbots are built. These chatbots are built using a service called as bot service on Azure. Now, cognitive services. What is cognitive services? Imagine if I tell you to create and even I think at this point in time, you don't even have to imagine that because if you have heard of Chat GPT and have started following this AI innovations, you would know that there are pre-trained models, right? These are what is cognitive services. These are pre-trained, pre-created AI ML models for you that will help you to do image analysis, that will help you to do text translation. You use keyboards, right, to translate from English to the vernacular languages like Hindi, Marathi, etc., right, or Telugu. N number of languages are supported. How all of this is happening? These are all cognitive services which are pre-trained to take, let's say, English as an input and translate it to a different language, or take speech as an input and translate it to text, vice versa, right, or do image processing. So cognitive services are ready-made APIs, ready-made pre-trained ML models that come handy for you to implement any ML or AI processing. Now, when it comes to machine learning, you have two options. You can create Azure Machine Learning Service, which is a fully managed service, PaaS service. Similarly, you can also create a ML server, right, like a virtual machine, and you can deploy whatever software like R, Python, whatever you want. You can deploy on a readily available ML server, and you can do your machine learning experimentation there. The other services that are available is Azure Search. Azure Search is a service which is knowledge mining service, right? One example, very simple example of this service I can give is this service. Let's say you are a recruiter, okay, and now you want to recruit for certain jobs, right? And you are getting hundreds of resumes, right, that are applications to a particular position. Now, out of those hundreds of resumes, there may be some resumes available as doc format. There could be some PPT format, some PDF format. There could also be some available as a JPEG format, right? Nowadays, some people may even create some GIF or video, embedded video, audio kind of a resume. Let's say there is all these different types of file formats, and you want to extract key information from these resumes, right? You want to extract key skills of each resume, number of years of experience. You want to identify, let's say, if there is a career gap. You want to identify, the location of the candidates. All of these data will be useful for you to be able to do very quick searches and quick filtering, right? So imagine you get a data knowledge mining service wherein you can feed all those raw input across of different data formats. And this service is able to create an indexing for you, right, for the key set of information that is most important to you, right? So automatic indexing will happen, and now you are able to run very quick filters to search all the candidates who have more than 10 years of experience without you having to scan through individual resume. Imagine you are a recruiter and you are looking at thousands of resumes, and you want to quickly do this. So imagine automation here, where you can filter all the candidates with certain amount of experience, certain mandatory skills, certain non-mandatory or good to have skills, location of the candidate and whatnot, right? All the criteria, and you can do so all of this is this kind of use cases can become very simple when you are able to do knowledge mining using Azure Search, because your searching will become very efficient, and a lot of automatic indexes are created by scanning those varied data formats for you. So that is one example of Azure Search. Now in the IoT space, right, these two services, IoT Hub is very similar to Event Hub, but IoT Hub is a service specifically for IoT devices streaming data. Now, what is IoT devices data? IoT is Internet of Things, right? As you can know, there are smart factories, there are connected cars, there are smart vehicles that are available today. Just today, I used a vehicle, right? I used an electric bike. I'm just giving today's example, right? How I use that electric bike, and I'm sure at least you would have heard of it, or some of you would have also used it. How I used it is I unlocked that, I downloaded an application, I went close to the bikes where they were parked, I selected a bike, it started beeping, right? And then I unlocked that bike using app. I used that bike and I dropped that bike to another location. If I was trying to, wherever I was trying to drop it, that was not the proper drop location. So it pointed me, the beeping was not stopping. So the vehicle automatically pointed me in the app. It gave me notification to search for, the proper drop zone. And then I had to take it to the right drop zone. And that's when the bike was successfully, my trip successfully ended. Whatever was the payment, I paid that, and I used that. And that is a connected vehicle kind of use case. How the bike was sending or getting all of this data? There are IoT sensors available, right, that are continuously sending the longitude and latitude, right, the GPS location of the bike, basis which the bike app is able to understand if I am, as an end user, whether I am dropping that bike at the right place or not, right? Or whether I am trying to move that bike without authorized, without unlocking it in an authorized way. So even if you just take some, let's say you are not downloading any application, you just take that bike and try to move that into a different place without unlocking it, it will start beeping. So as a security feature. So how all of these things are being made possible? Because there are IoT sensors and that are feeding data. So imagine there could be millions of IoT devices, in factory floors, in connected cars, and where not, right? That are sending millions of records per second. IoT Hub is one such service that helps you to ingest those records into Azure. Now, IoT Central, on the other hand, right now, just imagine the use case that I talked about, right? You have to map all different locations, right? For this application where they have put bikes, you have to see, how many bikes are available at what locations, what is the battery remaining, right? Battery percentage remaining for each of these, so that you are able to, as a company, manage this whole logistics, right? To charge these vehicles properly, or to do the maintenance of these, any breakdown. So if you were to quickly build application, IoT centric applications, IoT Central is a service which is more like software as a service that allows you to quickly build IoT applications using readily available templates. So there are industry specific templates, such as a template for retail, template for healthcare, template for manufacturing, etc. So you can quickly start building your own application from a template, and then you can further customize it as you want. So that is on the IoT side of things. Sorry. On the BI side of things, right? So now that you have collected all this data from the OLTP databases, you have done all the massaging of the data, transformation of the data, processing of the data using the analytic services. Now you want to show this data to the key users, right? You want to show it in the form of dashboards. You want to show it in the form of visualizations, right? For that, you will use these dashboarding services, and Power BI is one-stop solution when it comes to Microsoft, right? Like SQL Server is their bread and butter, like Windows is Microsoft's flagship operating system. Similarly, Power BI in the BI side is one of the services that Microsoft is well known for. So that is their PaaS service, right? Or fully managed service. And Azure Analysis Services is also used in the BI domain to build some of the data models, right? Or multi-dimensional cubes into the analysis services when you want to do a lot of pre-processing of the data that will feed to the Power BI. So you can create a lot of data or create your multi-dimensional cubes And don't worry if you don't understand that, that is not necessary at this point in time. And you will load those cubes or load those heavy data models into analysis services from where you can easily display or use that, consume that through Power BI layer. That is the BI side of things. Now, let's see some of the services which are more generic in nature and which go all across these, right? What are those services? Because without which, this Azure Intelligent Data Platform will not be complete. So most basic of these, right? Storage. When we talk about storage, there are two important services, Azure Blob Storage and Azure Data Lake Storage. So these two, Azure Blob Storage and Azure Data Lake Storage, are the two services. And this is where we will start. Next time we meet, we will go into details of storage service, understand storage, create blob storage, create data lake storage, and understand the difference between the two, etc., etc. We will do step by step. But when it comes to storage, these are the two services, blob storage and data lake storage, right? And these are not the only two. There are more storage services that I will cover in the next time. But these are like important key PaaS services that you are seeing on this slide. When it comes to data integration, right? You have a storage service. That means now you can store data on this. But how do you bring data onto this, right? For that, you need some kind of tooling, some kind of integration service. That means it should be able to connect to some other data store, copy data from that place and bring it into your data lake, right? Typically, we call it ETL, right? Or ELT in the cloud world. So which service will help you to do that? So Azure Data Factory is your data integration and orchestration service on cloud, right? Again, PaaS service that helps you to connect to number of data sources, bring data, do the transformation of the data in low code, no code way, and dump that data in various destinations, right? Which could be blob storage or SQL DB, Synapse Analytics, etc., etc. We'll learn more about Data Factory also at a later point in time. For now, just understand the data integration service is Data Factory, like the main data integration service. And alongside this, there is also a data governance service available in Azure that is called as Azure Purview. And what is Purview? It gives you data classification. It gives you ability to define metadata for your different data sets across different data services, right? So this is again one service that can, scan SQL DB, OSS DB. It can scan Synapse Analytics. So it can scan your data objects that are stored across various data systems that you have, data stores that you have, and it can create an end-to-end data lineage, or it can create an end-to-end data governance layer that will help you to better protect your data. For example, if you have PII information. Now, for some of you who may not be aware, PII is personally identifiable information. It is responsibility of every organization to properly secure PII information about their customers or about their employees. And these are all standard regulations which every organization has to follow. And some of these regulations are that you would have heard of are GDPR, then there is private data protection law. So by laws and by regulations, every company has to properly handle PII information. And for that, Azure Purview will help you to easily identify, classify this data, and also understand how this data is moving across various data stores that you have within your solution architecture on Azure. So that is the data governance service for you. And this is at a high level, your Azure or Microsoft's intelligent data platform, right? And these are the important PaaS services that are available on Microsoft Cloud.
Let's have a quick quiz question, guys. Which Azure service is designed for large-scale data warehousing and analytics? Azure SQL Database, Azure Cosmos DB, Azure Data Lake Storage, or Azure Synapse Analytics? Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
what is a blob storage service, right? So let's understand that in a little bit more details. It's Azure's object storage platform, right? What is an object storage? That means you bring any data object and store it, as simple as that, right? You can store and serve structured and unstructured data from that blob storage. For, you can build your applications and web scale data, right? Be it your backup or archive data, be it your big data coming from IoT devices, genomic sequencing, DNA data, and data from any industry, right? So absolutely anything and everything, to simply put it, all kind of data you can bring into this blob storage. There are 3-4 different types of blobs, right? Again, I'm showing these not to confuse you, but just to help you understand different types of blob storage. But there will be one input that I will give you, only that you have to remember. So there is something called as blob, right? Most object storage scenarios. That means for most scenarios, without worrying too much, without thinking too much, you can simply choose blobs. When you are creating a blob storage on Azure, by default, your choice should be blob. Okay, you don't have to worry too much about the other types, right? But still, there may be certain specific use cases, certain specific application where a different type of blob storage may be more efficient. And again, I'm not saying your blob will not be efficient, because like it says, in most scenarios, your blob will be default choice and it will work. And that's the one thing that you need to remember. But I will also explain you those specific scenarios now. There is append blob, right? Multi-writer append only scenario. Now, what could be an append blob? And these are all depending upon the type you choose, the internal organization of the data or internal storage organization of the data will differ, right? The hardware on which the data sits might also differ, because some hardware may be more efficient for most scenarios, but some specific hardware may be very efficient for this append blob scenario. Now, what could be an append blob? I will give you an example. Now, let's say you have an append only requirement, right? That means you require certain storage in which you are only going to keep appending the data. You are never going to, modify any existing data or even delete any data, or you don't have to update, anything that was previously created. You just keep on appending. What could be an example of that? An example of that could be, let's say, some kind of logs, right? You are creating a data blob storage account only to specifically store log. Now, log is such a thing. It could be application log or any other log, right? Whenever these logs are being generated, you are just storing the log, right? And every new log gets appended at the end. You are never going to modify any previous log, right? Because logs by nature are such records that are never meant to be updated. So whatever log got generated at a specific point in time, that has to show the state of the application or whatever as of that point in time. So you will never have a requirement that you want to go and modify a log, right? Because if you do that, if you try to do that, it will be like trying to destroy some evidence, right, or something from how it exactly happened, and you will never want to do that. So if you have that kind of a specific scenario where you know that the storage account that you are creating is going to be used specifically only for append only scenario, that means only continuously keep adding data and never update any of the previous data, then only you can choose append blob. But if you are creating a storage account where you are not sure whether it is append only scenario or there could be different scenarios that are possible, just go for blobs. Close your eyes and go for blobs. You will not have any trouble. Your performance will be best. Don't worry. Now, what is page blob? Now, page blob is more useful for scenarios which are page aligned or random reads and writes are happening. Okay, now what is random read and write? Now, to simply understand it, this is how you access your hard disk. Now, imagine if I am creating a blob storage account for my personal use, right? I am going to store various pictures, various document files, and n number of details like I store on my hard disk. I am going to put it onto a blob storage account. For that case, I might create a page blob account, right? Because why page blob? Because I know I am going to do absolutely random read and write. Now, what is random read and write? When you access your hard disk, right? Let's say you are accessing your computer at a leisure time, right? You are not you don't have a specific task in mind. So what you will do, you'll for a moment go to your audio files. You will play some music. Right now you are getting bored. You will come back. You will probably go to a picture file and you will start seeing some of your old images. Now that reminds you of something, you go and open a text pad and create an entry something, right? You suddenly go and open a PowerPoint, suddenly go and open a Word document and you want to start reading through that. That is all random access, right? In a programmatic world, when your program is accessing the data, it will never do these kind of random files, right? It will not switch from PPT to a JPEG to MP3 to, a Word document. When you are programmatically processing the data, right? That means you are working on, let's say, employees records, or you are working on e-commerce orders, or you are working on banking transaction, then you will only be, that program or that algorithm will only be looking at that banking transaction data. It will not suddenly jump and want to look into a JPEG file or listen to some music and mix and match, right? So, and most analytic scenarios, right, are like that. You are not doing random read and write, but the scenario that I explained of a personal use, that is more of a page blob, right? So again, for most of your analytic purposes, you will not need page blobs because you don't need that random read write. Once you get into a folder, you want to process all data inside that folder. You would rather not want to bring different data formats like a human does. Your program would not want to do that. So that's where it is good to understand all of these, but you know that your default choice is going to be blobs because it will work in most scenarios. You have flexibility to update even in this. So even in page blobs, if you create, right, you would want to, you can update it, right? Blobs also, I will check, but as far as I'm aware, you can even update in append blob. But the problem is, you are not choosing the efficient storage then, because those updates are going to be slow, because by nature, by design, the append blobs are expected to work for append only scenario. So if you are trying to do multiple random updates to an old existing data, the data retrieval time for an older record is going to be much higher. See, it's like let's say it's like buying a hard disk. You have to decide which type of hard disk you want. Do you want to restrict yourself to a hard disk which performs best only in case of append blobs, append only scenario? If you have that kind of scenario, that I know that I'm only going to generate statement and keep that statement one after the other, keep appending more and more statement for each customer, where statement is statement. Once generated, it never gets changed. So you know that it will never change, or I will never have to update any statement. So I can keep appending, but I will use my hard disk only for that purpose. If that is the requirement, then only you will select append blob. But by default, most scenarios, just close your eyes and select blob. When you are specifically working on certain scenario, and when you realize that oh, my storage is not working, performing in the most optimized way, or I want much faster performance, I have a very specific use case, that time you will anyways realize. And then when you start investigating, you would realize, okay, probably creating another storage account with append only blob style type, and then moving all that specific data into a different storage account will help you. I'm sure you will never hit such use case. I have never come across any customer needing to do that. And that's why just understand it for the purpose of being aware as to what is possible. But blob is your default choice. So key technical consideration, right? It supports a top level directory or isolate structure. So when you create your storage account, you create a top level directory. It is called as containers. We'll see that into Azure portal practically, so you'll understand better. Then it supports parallel multi-part uploads and range gates, right? So somebody talked about S3, right? So essentially, when you are creating a blob storage on cloud, you also want that I should be able to utilize parallelism, right? For example, when I'm copying, let's say, a 1 terabyte of data from on-premise and I want to put it into cloud on blob storage, can I use this storage to do multi-write? For example, if there are 10 files that I'm copying from one place to the other, can I copy all those 10 files in parallel so that it works more efficiently? So yes, it does support parallel multi-part uploads, right? That means not only 10 different files being copied parallelly, one file also can be split into multiple parts, and you can parallelly copy one file into 10 different parts if you want that, right? So all of that is possible. Some of these we will see as we get into some hands-on demo of data factory, etc. Blobs are mutable. What is meaning of mutable? That means you can update that. Let's say you wrote some data, you can update that file. You can change or modify the content of that file or that particular record that you are putting on the blob. That means it is modifiable. And it supports lock, right? That means when one process is processing a data or accessing a particular blob storage data, you can take a lock on that. That means you can ensure, like a database, that no other process is trying to override that or access that or modify that. And that happens in your laptop also, right? So one process, let's say you have opened a file, right? And you try to delete that file, right, by going to the drive, and then you get an error message that no, there is a process which is reading that file, so you cannot delete it, right? Similarly, you cannot modify it. So that kind of locking, a time-based locking, right? Lock it only for 5 minutes, lock it only for 10 minutes, that kind of thing, or an infinite locking unless the other process has finished. All of that is possible. So, think of it like normal standard features as you have in your hard disk also. Now, Blob sits in a center, right? Because it connects with all these set of services. So Blob is being a foundational storage service. The beauty of that is it natively connects to all other Azure, or most of these other Azure services, which could be database services, which could be application services, which could be security services, analytics services, IoT, compute, whatnot, right? So it kind of very seamlessly integrates with other services and helps you implement different types of scenarios. Now, the openness, right? Open accessibility that we talked about, right? So let's say this is your Blob service, and on the above, what you see are different types of services. So on the ETL and ingestion and monitoring services, you have Data Factory, right, which can connect to Blob storage. You have Application Insight, Log Analytics, Monitor, Azure Monitor. They all use Blob storage, right? They all can connect to Blob storage. In terms of streaming, you have Event Hub, IoT Hub. These services, they also seamlessly talk to Blob storage. Now, this slide is only talking about the native integration, right? So that that when you are using Blob storage, your other compute services are also going to very seamlessly talk to this Blob storage, right? Or access the data available on Blob storage. Now, and this is the laundry list of services. Again, this is non-exhaustive list. This is just an indicative list. Bitstream Analytics, Azure Batch, Data Analytics, Machine Learning, Azure Functions, Synapse Warehouse, then Power BI service, Azure Search service, CDN service. Also, Azure HD Insight provided all the open source big data processing services like Kafka, Hadoop. You don't have to remember all of these, right? In the simplest term, if you want to understand this slide, is all other, or most of the other Azure services will seamlessly integrate with Blob storage to implement different scenarios, right? To implement analytics scenario, to implement IoT scenario, data warehouse, data lake scenario, etc., etc. Yes, because that is one of the cheapest storage service, right? Think of it like your hard disk in the simplest possible term, right? Think of it like your hard disk storage, right? So whether you are building a simple application, that application storage will be there. You are building something, you want to do some AI ML experimentation. Again, all the raw data that you need to train the ML model can also sit on Blob storage, things like that. So it unblocks different types of data scenarios or data solution scenarios for you. So let's continue. Why you'd Blob storage, or why is it an ideal PaaS service, platform as a service? Because it gives you limitless scale. That means you can start with 1 GB of storage and you can scale it to even petabyte of storage. you're always build on pay as you go, right? What is pay as you go? That means if you are using 1 GB today, you will only be billed for 1 GB. Unlike in an on-premise world, if you want, let's say whenever you order some disk, you will order it based on the capacity, right? And you will pay accordingly. So you order 1 terabyte of disk, you will pay for 1 terabyte of disk, right? Here, on the other hand, you can use 1 GB and you will only be billed for 1 GB. So, your pay as you go model. And that's why it's cost efficient and it's globally accessible. So like I had mentioned earlier, it is available across all Azure regions. And what are the scenarios, right? Some example scenarios. It is your live data repository. You can bring your data. It is for your big data analytics, for your storing your IoT or sensor data. You can store your active data as well as deep archive data. Now, what is active data? Active data is a data, let's say, of last month, last 6 months, last 1 year, last 2 years that you want to do some processing on. What is deep archive data? Deep archive data could be data of last 10 years, right? Which you are not going to use, but you, as a regulation, you cannot delete that data. You want to still keep that data. Should there be an audit, should there be some kind of inquiry, as part of which you need to access that historical data. So you want to for such kind of scenarios, there is an archival tier. So there are more slides coming specific to address archival data requirements. But the idea is you can build with different types of scenarios to store your data onto blob storage. Storage is classified as platform as a service because the core benefits, right? You do not have to buy, you do not have to scale, you do not have to worry about buying it. So for example, when you create a disk, right? For example, you have a virtual machine. In that virtual machine, you add disks, right? You procure disk, which is infrastructure as a service. Now, when you are saving your data on the disk, now you have to make sure that if you want to take backup of that disk, you have to take individually, implement a backup solution for that, or you have to take the complete VM's backup, right? You do not have, but that VM's backup would mean that the complete application code, everything is being backed up, right? But if you want to take only your storage backup, then you have to use your own backup solution for that. But on the other hand, when you are using PaaS service, it becomes very easy. On a click of a button, you can take your PaaS backup of your data. Again, when you are using disks, you are actually using those in the context of some other, right? So what makes a storage service a PaaS service, right? Ease of deployment, ease of replication, ease of creating a redundancy across various regions, across various zones. I will come to that and you will understand that, right? So all of these, for example, durable and available, and all of subsequent slides will tell you how a PaaS service differentiates from a infrastructure as a service, right? How it reduces your maintenance. Even in case of IaaS, when you are procuring disk, you will have to specify how much disk you want, right? So you will say, I need 500 GB disk. That means you are already paying for that 500 GB disk, even if you are storing only 1 GB data in that. That is the another differentiation. In case of PaaS, you are just creating a storage account. In that, if you add 1 MB, you will be charged for 1 MB. Tomorrow you add 1 TB, you do not have to go and tell Microsoft that, hey, I am going to bring 1 TB of data. On the other hand, if you had disk, you know that you only have 500 GB of disk. You cannot add 1 TB of data tomorrow on the fly on that. You will have to, on your virtual machine, you will have to procure another disk. So again, that will be simple because it is on cloud, but you will have to do that. In case of PaaS, no need. It's a limitless scale. Just keep bringing your data and you will be billed accordingly. So that is how blob storage is your PaaS storage.
Jayendra, since it is not mandatory to purchase a VM when we are buying storage, that's what making it as PaaS, right?
Not just that, right? So the other benefits that I talked about, the limitless scale, ability to just bring in as much data as you want, ability to easily replicate your data, which you will realize over next set of things, next set of slides. So let's continue. Azure storage, blobs, durability and availability, right? So how does Azure ensure that your data that you are storing on your blob service is durable, right? So it does that by creating 3 replicas. So whenever you create a small file or one record onto your blob storage, Azure will automatically create 2 more replica of that. So there are always 3 replica and you are not charged for those other 2 replicas. Okay. So you will get 3 replicas by default. Now it will also do its own checks, right? So CRC checksum, it will use its own MD5 hash algorithm or whatever internal algorithm which you don't have to worry about to make sure that those 3 replicas are consistent and healthy. Whenever Azure will internally detect that okay, one of the 3 copies of your data is corrupted or is inaccessible, it is inconsistent, it will automatically discard that copy and create a new replica. That means it will internally make sure that there are 3 healthy copies of your data that are always available. Now, it helps you to do disaster recovery or business continuity by giving you ability to replicate or create these 3 different copies of data at 3 different geographical region. That is called as geo-redundant storage, GRS. Right? I will come and talk more about GRS in a moment. Because there is not just GRS, there are different redundancy options that are available. High availability, right? So by default, your high availability is guaranteed. You get 99.9% of availability SLA, service level agreement, which are financially guaranteed by Azure. That means for 99.9% of the time of the year, of the month, whatever, your service is going to be up and running. That means you will be able to access the data that you are storing on Azure storage. And if those SLAs are not met, for example, there is actually some problem in the Azure region in which, let's say, you have created your data and you are not able to access that, you can raise that concern to Microsoft, and Microsoft will financially guarantee, or they will reduce your Azure service usage cost, or they will financially compensate you, right? So all of those rules are defined on their documentation. So when you are not going for GRS, for example, when you are going for LRS, which is the default option, in LRS also Azure creates 3 replicas which are free for you, right? And when you want better redundancy, better resiliency, that's when you go for additional options, different options, where you get better availability or better service for a better price or a more price. And you can get 99.99% SLA, high availability SLA with RAGRS. What is RAGRS? Let's see in the upcoming slides. Okay, LRS, right? This is the default option. Now, what it protects you against, right? It protects you against disk failure. For example, you are storing a data into Azure Data Center on this blob storage, right? Essentially, it will go and sit into some kind of hard disk, right? Azure will make sure that the 3 copies that Azure is creating for you, they will not keep all the 3 copies on the same hard disk, right? So that, if that hard disk fail, then you'll lose your data, right? Even if there are 3 copies. So they will say that we will not keep it onto the same hard disk. We'll also not keep it into the same node, right? Or same machine. And we will not keep it into the same network rack. So they will tell you that within the same data center, we are going to create 3 copies of your data, but they will be on separate network racks, separate disks, separate nodes. That much they will guarantee for you. Okay. But now just imagine a scenario that what if that complete building or complete data center has a problem, right? Then your data, until that problem is solved, you may not be able to access your data with LRS, right? So but customers may be running some business critical applications, right, for which they would want that even if there is a data center level problem, I should be able to access my data, and I am willing to pay extra cost, but give me the facility, give me the capability. For that, you can go for GRS. Now, what is GRS? GRS means there will be 3 more copies of your data. Where will these 3 more copies be? They will be in the secondary region, right? For example, if your primary region is Central India, when you choose GRS, Azure will automatically create 3 more replicas of your data into a completely different region, which is a paired region. So in case of Central India, its paired region is South India. So let's say, just imagine, like, one copy of your data is sitting in Central India region, wherever, in whichever city that data center is, and the other one is minimum 300 miles apart, typically 300 miles apart, right? And this asynchronous replication will automatically happen internally. So now you can imagine, right? So even if there is a citywide problem in your primary region, you still have access to your data, because your 3 more copies of your data are there in the another region. And for these additional capability that you want, the price will double, right? So if you have a business critical application which needs this capability, you will have to pay for 3 more copies, right? Here also 3 copies are still free, but the 3 more copies that you are storing in completely another region, that will be charged. Okay, so in GRS you have 6 replicas and 2 regions, right? Now, what is RAGRS? RAGRS is, now before that, right, let's understand this. In case of GRS, this is your primary, right? That means, let's say this is your primary region in which you are able to write the data, and that whatever data you write, it will automatically synchronize in an asynchronous way to secondary. And you will also be able to read the data from the primary. So your secondary is just for a backup purpose. So when there is an issue in primary, if there is some disaster, then you will fail over to secondary. And then in case of disaster, you will start, using your secondary will become primary, and then you will start using it, right? But if you pay slightly additional cost, right, with that, what you will get benefit is, instead of GRS, if you go for RAGRS, which is read access GRS, read access is your secondary will also have read access. That means you can read and write from primary, and you can also read from secondary. You can't write to secondary, but you can start reading the data from secondary. And what could be the useful scenario for this? For example, let's say I have some processes which are reading and writing the data from the primary, and I have a number of other processes, number of analytical queries which are trying to read the data, right? These are some processes which are trying to read large amount of data, and if I'm running those read queries also on the primary, then it is slowing down my performance, right, of the write, because it is consuming a lot of resources, lot of bandwidth. But let's say if I decide that a lot of read queries, right, lot of read requests, if I can serve from secondary, from this replica, which could be, let's say, a few milliseconds or few seconds older than the primary, because the synchronization may take some time, right, a few seconds or so, although it is very fast. But if I can use this secondary to serve all those read requests, right, whenever somebody wants to read data, and that scenario is okay with some lag between the primary and secondary, then I can reroute all my read requests on the secondary. And those scenarios will help from this RAGRS use case. And there is also something called as ZRS, right? Now, what is ZRS? So I told you, right, there is Azure region. So look here, this outer box represents a region. Outer box represents region. Inner boxes, zone 1, zone 2, zone 3 represent 3 different zones. What is a zone? Zone is a different fault domain, right? That means each zone may have a separate electricity connection and separate backup. That means even if in the region some electricity failure is there, that will not affect all 3 zones simultaneously. That means you have more redundancy within a region. So you have different 3 zones. In each of these zones, there will be different data centers. So when you create a ZRS, right, this is better than LRS, lower than GRS. So in between solution, right? That means you don't want to pay additional cost for GRS, and your application is not so critical that you need to maintain a 3 more copy of your data into a physically completely away location, right? But you still want that, I don't want immediate disasters. I want some better resiliency than LRS. then you can go for ZRS. What is ZRS? It will store 3 copies of your data in 3 different zones. So here you are not only ensuring that they are in 3 different racks, but you are ensuring that they are not in the same data center. They are not in the same building, but they are in completely 3 different zones within a region. That is ZRS for you. And this is how it is, right? LRS is the bare minimum. Then you can go for ZRS for a slightly additional cost. Then for some more cost, right? A double of the LRS cost, you can go for GRS. And you want better than GRS, that means you want your secondary also to be available for reading. Then you can go for RAGRS for slightly additional cost than GRS. This is how it works. Now, is this clear? So all businesses use it today, right? So, and they all have different types of scenarios, right? So all of those scenarios can be served with what you have today. Okay, so don't worry. If you want to bring a specific scenario, I can tell you how to implement with whatever we have, right? But you don't necessarily need.
No, just on a high level, I am asking, if there is no point of having right option, then how business will flow, right? Business would get stopped, right? Because of this.
Not stop. That is what I'm trying to tell you. There is no scenario that is unserved with the available options, right? If you ever wanted that you want to write, because you will have to come up with a use case as to why do you want multi-write across 2 regions. By right, I am asking, I'm assuming that you mean that in case of, let's say, like RAGRS, you should be able to synchronously write between any region, right? As a multi-master kind of environment, right? Or even updated, right? So whether you want to update data, existing data sitting on Blob, or you want to append new data, that right is no question. You can do right. Okay. So very region, right? In that, like, see, this supports, right? Here also you are doing read and write. So this bottom arrow is incoming data, which is right. Outgoing arrow is like reading. You are reading from the storage. So yeah. If there is a failure, if there is some kind of outage, right, or Azure has some issue in the data center, typically those issues are quickly resolved, right? Because Azure wants to make sure that there is good service that they provide you. So they will detect those failures, and those events of failures are very rare. But still, if at all, right, if that event happens, and if it is affecting all the disks and nodes in which your data is created, then you can assume that, okay, your data will not be accessible until Azure recovers from that event or from that incident. Until then, your data will not be accessible. Now it is up to you, right, to choose the right redundancy for your application. Now, how do you decide that? For example, let's say I am an individual user, right? I am storing my photos backup, my CCTV backup, or whatever, right? Some data I have and I want to keep it on the cloud. Now, does that matter to me, right? If this region is not available, and let's say for 2 hours, I am not going to have access to my data, I'll say I am fine with that, but I don't want to pay any extra cost. This is good enough for me. Give me my data after 10 hours also someday. That is also fine, right? I will not spend extra money. But on the other hand, think about some businesses, right, who are actually using this data, and their users may get impacted, and they will say, no, even 2 hours disruption is not acceptable. I would rather spend more money and get GRS, right, or ZRS or RAGRS, whatever. So it depends upon the criticality of your application. I have not seen regional level disaster ever happening in my career, but there could be some disasters, some outage, here and there, which typically cloud services or cloud companies will try to recover as quickly as possible from, so that their customers are least impacted. Cool. Let's continue. So how is it secure and compliant? So we saw how it's durable, how you can take advantage of redundancy options. Let's see in terms of security and compliance and manageable and cost efficiency of that. So the data is also protected, and you can also enable soft delete, right? That means, what is soft delete? It's a setting, simple setting, right? But it helps you to recover if you have accidentally deleted a data, right? That means you can, on your Blob storage account, right, or on your Blob, or the data that you insert into your storage account, you can set up a soft delete. This is something like recycle bin, as simple as that, right? So you delete something, it goes into recycle bin, and you can recover it up to certain number of days that you specify. You can say that, I want to keep it for 7 days, so that if I think, I accidentally deleted it and I want to recover from it, I should be able to do it. So in simple word, it is a recycle bin, which you can configure to keep your data from 7 days to, let's say, maximum 365 days. So that's the thing. And you can do it at a blob level, right? That means, what is blob? Blob is an individual data element or individual file inside your storage account. So you can, recover the data. Like in recycle bin, you may find 100 items, but you can go to one item and you can undo that delete, and that item will come back. So that's how essentially that works. So gives you more flexibility. Then tiered object storage. This is important, right? Why this is important? Because this can greatly save cost for you. So in a blob storage account, you get a life cycle management, or you get 3 types of tiers. One is a hot tier, right? One is a cool tier, and one is archive tier. So your cost of storing data goes from hot to cool, it becomes lower, and from cool to archive, it becomes significantly lower. Okay. Now, and why so, right? So by default, imagine you are storing data onto cloud because you want to also access that data, right? So you will, by default, you will keep it into the hot tier. Now, but then you are continuously bringing data, there is year after year, you are bringing data into the cloud storage and you are storing it onto hot storage. Now, some of that older historical data, that your organization is never going to require, but you don't want to completely delete that, right? You want to store that for some purpose or for some regulatory purpose, because government regulation says that you have to maintain last 10 years of historical data. You cannot delete before that. But for all practical purposes, you will never use that data. So why spend so much cost on that, right? So you can move that data, let's say, for the last 2 years of data, which you want to actively use, actively query, etc. You will keep it onto hot tier. Then there will be some scenarios that, that run query against, let's say, last 5 years of data, last 10 years of data, every quarter, every month. So those queries are not frequent. But intermittently, once in a quarter, once in a 6 months kind of scenario, you do require those access to, let's say, last 5 years of data. So from 2 years up to 2 years, you will keep it into hot tier. Next 2 years to 5 years, you will keep it into cold tier. And anything older than 5 years, which that you will never either never access, or only rarely, in case of some incident, you will access that. So you will keep all of that data into archive tier, and you will greatly save cost on all of that. Okay. But what is the access time, right? Whatever you have on the hot tier, you can directly start reading, right? For example, think of it like your hot tier is available in your computer's hard disk. Okay. Cool tier is like, you have a data available in your pen drive. So you need some more time to connect that pen drive, and then you can start accessing that data. And imagine archive tier is like you have taken a backup on the hard drive, some kind of hard drive, which you have logged into a secure locker, right? Whenever somebody tells you that, okay, I want to see last 10 years of data, you will tell them that, okay, if you want that data, I cannot give you that data immediately because it is kept into archive tier to save cost. So to get that data, I need to first bring it from archive tier into hot tier, which will take, depending upon the size of data, let's say a few minutes to few hours, and only then I can show you that data, right? That means you will open your locker, you will, bring back your hard disk, you will connect it to your laptop, bring it to your hard disk to, efficiently work on it, and then you will show that data to anybody. That's an analogy, right? So, and that's why, you are able to save great amount of cost also on archive tier. Almost, I think, more than 80% lower cost compared to hot tier, but it takes longer time to access. And the simple assumption is you are never going to require to access that, or in rare events when somebody asks you, let's say you have a CBI raid, right, on your on that customer's office, which should never happen. But if so happens and they ask you, okay, give us 10-year older transaction, you will tell them that, okay, we don't keep it in our system, but because you insist, we will, somehow try to make it available, give us 10 hours. And then they will say, okay, 10 hours is fine. And you will, bring that data from archive tier and then show it to them. So if waiting for 10 hours is acceptable, then you will put it to archive tier. If not waiting for, not exactly 10 hours, right? So don't, keep that figure in mind. It, depending upon your size of data, it can be anywhere between few minutes to few hours. All right. But the beauty of that is you use the same APIs, right, for all storage tiers. So it's not that, you have to access. So it's not literally like I mentioned that you have to actually go open some locker, bring that hard disk, connect it, and then show it. You will access the data in exactly same way, like you access hot tier, cool tier, and archive tier. It will be same. It's just that it will take more or less time depending upon which tier it is in. Cool. And this slide just talks about some of the archive storage scenarios, right? What now, if you want to really put it into practical context, so some long-term backup, disaster recovery data sets, you can keep it into archive. Original data retention, you want to retain all the original data as it is. Healthcare medical records, right? In a hospital, there could be hundreds of, thousands of records for customers, and that too for years together, x-rays, ultrasounds. You just want to keep them for whatever reason, that can go into archive. Security camera footage, right? You will rarely see 10-year-old footage, but what if, there is some case which requires that, you can just keep it, things like this. Okay, and again, how it looks like on Azure portal, right? When you are looking, so this is, this you can do for individual blob. So, and the beauty of it is you can also create a policy. For example, you can automatically create a policy on your storage account wherein you will define that after, let's say, 2 months. So whenever I create a new data element or I modify a data element, after that, after 2 months, it should move from hot to cold or hot to cool. And after, let's say, 3 years, it should move from cool to archive. And if you set that policy, you will not have to do anything after that. Every element, every data that you create in your data storage account, it will automatically keep moving from hot to cool to archive without you having to do anything individually. And you will be able to see what is the current access tier of each of these files, right? And if you want to, let's say, hot and default is essentially the same. And when you want to, let's say, this is in archive. When you want to change it from archive to hot, you can just, as simple as right click and try to bring it from archive to hot, or there will be options available to change the tier and if it is in hot, right? And you know that you're never going to use it and you want to save cost on that, you can just, change the tier from hot to archive and save cost on that. So you can manually also do it, and you can also set an automated life cycle so that it will automatically happen for you. If you think you can, whenever you want to see those and you want to, let's say, you are happy to wait, right? If you are happy to wait for a few hours or few minutes before whenever you want to see that, you will keep it into archive to save cost. But you want to keep your personal data onto, let's say, archive tier. And at the same time, you want that, okay, whenever I feel like watching my old video or old photo, I should be able to quickly do that. Then that quickly part will not work with archive, because you are trying to save cost at the same time get different benefit. You have to click on, you have to change the tier. So this data element, you will see, okay, this is the photo. This is my photo, my childhood photo, which is currently in archive tier. You will have to change the tier from archive to hot before you can access that. And sometimes to bring it from archive to hot, if let's say it's not a video photo, but it's, let's say, your grandparents' wedding video, for example, right? Our kids would want to see, our wedding videos, and that video file may be 2 GB, 3 GB. It might take just few hours to become accessible. That's how it is. There could be, the billing will happen as per their defined rules. So it may so happen that today you are storing 100 GB, and let's say immediately you are trying to move to archive. It may not, the billing may not, switch immediately. It may so happen that, okay, you will still be charged, let's say, for whatever days that they have defined or whatever hours that they have defined, you will still be charged to use that as a hot storage. So yeah, those rules will be available in Azure's documentation. Now, in terms of how do you access, right? Again, that open interoperability, how do you access these easily? So whatever storage that you are storing on cloud, you would want to access it in different ways, right? You should be able to write any Python code, Node.js code, Azure, access it through mobile programming. So the idea is your storage should be accessible, and it is accessible. So, different developers can access it using different types of tools. You can access, you can visually browse it right through your storage browser. You can programmatically scroll through different files and scan those files, work on those files. Similarly, you can use various programming languages as well as CLI languages, right? That means a command line interfaces you can use to access your data. So all different types of access mechanisms are supported, which makes it, easy to work with. Essentially, that's the idea. So now let's start, moving a little bit from core blob storage to what makes a good data lake, right? So in terms of data lake storage, we talked about a blob storage, which is like more general purpose, bring anything and everything, right? But here I'm bringing anything and everything, but I'm still bringing, let's say, some different types of data. I may be bringing storing some video feeds, right? Some CCTV footage, right? I know this CCTV footage, I'm not going to programmatically scan them, right? I'm not going to run any algorithm on them. So I will put it onto blob storage. On the other hand, imagine I have an e-commerce business or a banking business wherein I want to bring customers' data, right? On an everyday basis, I want to bring every new customer data or any updated customer data, store it into a data lake, then work on this customer data, transaction data, vendor data, product data, order data, all these kind of data, right? I want to analyze this data to find, let's say, maximum order value, average order value, total order value over month, over historical periods of data, find trends in the data, whether my orders are increasing or decreasing, whether customers are creating more amounts of fixed deposits, what are different financial instruments in case of banking that customers are investing into. For doing these kind of analytics on your data, Azure recommends that rather than storing it into plain blob storage account, you store it into ADLS Gen 2 account, Azure Data Lake Storage, right? And Gen 2 is just the latest version of that. So Azure Data Lake Storage account is the account which creates an optimized version of Blob, right? And how it creates that? It gives you an HDFS, like a Hadoop distributed file system that you would have worked on, right? Possibly. So it gives you an endpoint, a distributed file system endpoint, right? Which is based on HDFS as a core technology. And with that, it becomes much easier to manage or organize your data in a hierarchical way, right? In a folder after folder kind of a way. And it becomes easy to process that data as part of analytic processing. So what you get is massive scale. Of course, you can scale to petabyte, just like blob storage, because it's the same foundational blob. Then granular multi-layered security, right? So your data lake should also be able to give you security for your data, right? Right from authentication and authorization to being able to secure it in a different way through role-based access control, etc., etc. That we will see at a later point in time. It should be optimized for maximum performance. This is important because this is what differentiates blob storage from ADLS Gen 2 storage. Integration friendly, that means because now you are intending to use this storage for analyzing your data, so it should be able to quickly integrate with various services, big data services or analytic services that you are going to use to analyze your data. And it should be, of course, cost effective, right? That is, storage service being the plain storage service, it should be cost effective. So these are the this security, scalability, integration friendliness, cost effectiveness are features of a great data lake. Right now, why Azure Data Lake Storage Gen 2 is a great data lake? Because it kind of addresses all those requirements, right? Ease of management, ease of the security. It should be fast. It is scalable. It is cost effective. It is integration ready, right? It's a no compromise data lake it's secure, performant, massively scalable. You can scale it to petabyte scale, and all the features of a great data lake are available in that, and it is by default optimized for big data processing. So how it works, right? So this is Blob API, this is Gen 2 API, right? It is, if you see, it is built on common blob storage foundation, right? That means this object tiering lifecycle management, that means your hot tier, cool tier, archive tier, it is applicable to both. Azure Active Directory integration, role-based access control, storage level security, again, that is applicable to both. Your high level and DR, that means your support for LRS, ZRS, GRS, RAGRS, etc., that is also applicable to both of these. But what is differentiated between the two is blob storage is more like general purpose storage, object data, server backup, camera backup, archived storage, anything, right? Anything and everything. Here, what will you bring? Here, it gives you a Hadoop-based file system. So you get a distributed file system endpoint. What kind of data you bring here? You bring your organization data. You bring your line of business data. You bring the data that you want to run analytics on, right? So you pay slightly extra cost because you are getting an optimized big data storage compared to a blob storage, but you are also getting benefit for an additional cost of an optimized storage where your big data processing is going to happen much faster compared to storing it on a blob storage. So this is to address your both kind of requirements. Azure has created a blob storage and an ADLS Gen 2 storage so that you should not, be charged more or less, right? For example, imagine if they had just created an optimized storage ADLS Gen 2, and in that ADLS Gen 2, you are storing your archive data, you are also storing your image files, document, video files, etc., which you do not actually need to run any analytics on. So it will be not cost effective. So they created blob storage also. So keep all your non-analytical storage onto blob. All your data where you want to do analytical processing, bring it to ADLS Gen 2. That's how it is. Okay. Now let's see demo, right? Let's go to Azure portal and let's see how to create a storage account, right? How to create a blob storage account or ADLS Gen 2 storage account, and how to access the data, right? How to put some data into that and access it through storage browser. So let's go to Azure portal for that. So simple address portal, whenever you search for portal.azure.com, you will go to Azure portal. It will take you to Azure portal. Now, obviously, some of you may not have created your Azure account, right? So there are two ways. Intellipaat team, right? Of course, they will give you guidance on how to access your Azure subscriptions if they have created for you. Otherwise, you can always create a free account for yourself. So how that free account, you can search on Bing or Google that Azure, create free Azure account, and it will take you to Azure sign up page where you can provide basic details, and you will also have to use a credit card. It will not be charged for the free credits. So you will get about $150 or $200 of free credit. And unless you want to go beyond your free credit, your card is not going to be charged, right? So for a free credit and for these basic exercises or practice that you want to do, you will be able to do it with your free account also. But you may not necessarily need that. So you just check with Intellipaat team if they have a lab environment available for you to try these things. Yeah, let's continue. Now, how do you create your Azure storage account, right? Or any Azure service? Now, this is Azure portal. Okay, so let's do a very quick walkthrough of Azure portal. Okay, when you log into your Azure portal, here you will see some number of Azure services shortcuts that you can create, right? You can go to cost management to see the cost or billing details of your Azure subscription. Now, these are some of the services that you may have used recently. Then you can create a resource right from over here. So any service that you want to create, you will click on create a resource. Okay, now let's click on create a resource. Now, what I want to create a storage account. So in this, I can either go to, let's say, Azure storage from over here. I can click on the left hand side. There are categories that are available. So I can go to storage from over here. So I get this storage account I can create from over here. Or if I just want to search in this, right? So I can also search for this like storage account. So if I search for this, I can click over there and it will give me some options that are relevant. And here is our storage account. So I can click on create storage account. So when you want to create a blob storage account, you have to go to storage account. Let's create one. Now, how it works in Azure is you will have a subscription, right? You are an owner of a subscription. So this is my subscription, okay? And whenever you are creating any resource, that resource has to be part of some resource group. Now, what is a resource group? It is a logical grouping of all the resources. Now, what could be the use of resource group? Now, I will tell you the simplest use as to how I use resource group, right? Now, for example, as part of these demos, right, I create many resources. I create some storage accounts. I may create some databases. I may create some, data warehouse services. But all of these are demo services. All of these will eventually be charged to my subscription, right? They will cost me something. So if I want to, let's say, logically group all of these resources, which I'm creating only for demo purposes, I can create a separate resource group for that. Let's say I'll create a separate resource group. Let me call this as demo resource group, and which I'm creating on 2nd of February, now 18th of February. Okay, so I'm going to logically create all the resources for our batch into this resource group. And one day I will go and completely delete this resource group, which will delete all the resources that I'm creating for them. So it's like logical grouping of your resources. How organizations may use this? Organizations may create different resource group for different environments. So there could be one dev resource group, there could be one test resource group, there could be one production resource group, right? Or on the other hand, there could also be other use. You can use business division specific resource group. For example, there is a resource group that finance team uses. There is a resource group that HR team uses for their resources, right? For whatever applications that they are building on Azure. There could be another manufacturing department that they are using their own resource group, right? So there could be different ways as to how people use resource group. But essentially, what is resource group? Every resource that you create on Azure is always part of a subscription, and inside that subscription, it is always part of a resource group. These two are mandatory fields, mandatory properties of any resource. Okay. Now, so I have selected my subscription. I have selected a resource group. So for this time, I wanted to create a new resource group. Otherwise, I have many existing resource group. I can create a new service in any of these existing resource groups. Okay. But what I did is I created a new resource group, and then maybe next time onwards, whatever we create together, I'm going to just use this resource group to keep adding my services to this, right? It's up to me in which resource group I want to put any service. Now, I also want, okay, now I have to create or specify, configure some of the properties that are associated with my storage account. For example, what is the storage account name? You will also see whenever you are creating anything on Azure portal, you will see this icon, information icon, right? Here it will give you information about how to configure this line item. It says this is the name. It must be a unique across all existing storage accounts in Azure, right? Because this storage name will give you a uniquely identifiable URL or resource using which you can access your storage account over the internet. That means across all Azure accounts, this has to be some unique storage account name, right? So let's say I give it a JK Demo storage account, or JK Demo Blob, and I will call it, let's say 0218. Okay. And this is the region, right? In this region, I have where do I want to create this service? I want to create it in East US region, Central US region, or I want to create it in Central India region. I can choose my region. Okay, so let's say I'm creating it in Central India region. Now, what is the performance I want, right? Now, this is the this is the storage account, right? Now, if I click over here, right, or hover over here, it will say determine whether you want to have a premium performance for your blobs, or you want a standard performance. So by default, you can keep it to standard because it says recommended for most scenarios. But when you know that you want a very highly efficient or highly performant storage account, then you can go for premium. Obviously, there will be better hardware, better hard disk that will be used. It's like, choosing, let's say, Intel 2.5 gigahertz processor over Intel 1.2 gigahertz processor, something like that, right? So essentially, a better hardware will be deployed for your storage account, and at a premium cost, of course, and that's how you will be charged. Now, redundancy. What do you want, right? So whether you want a GRS or you want LRS, ZRS, or GZRS. Now, what is GZRS? This we did not see in the slide. But what could be GZRS? Tell me. What could be GZRS? That means geo-zonal redundant storage. What could be geo-zonal? Yeah, I'm choosing 2 regions, but I'm making sure inside those 2 regions also, my data should not sit in the same data center. All these 3 copies, all these 6 replicas are actually sitting in 6 different zones across those 2 regions. That means I am further ensuring high availability or better redundancy, better resiliency, because probably I have that kind of a critical application or storage. This is best of the breed, right? Because this is better than GRS. Within GRS also, you are ensuring that so you have data in, for example, what I chose Central India, right? The paired region for Central India is South India. So I am by choosing GZRS, it will make sure that my data is in Central India, 3 different zones. Also in South India, 3 different zones. Something like that. Okay. So this is best of the breed, right? This is the best you can get. But of course, my data is not going to be that critical. So I'm going to choose LRS, right? To save cost. I don't want extra cost to be done. Now, these are the basic things, right? All the fields with star are obviously the mandatory fields. Once you have configured that, you can quickly click on review. So there are obviously additional. So for example, these are the basic details that we have provided. If I click on review, it will do some quick validation and it will start to create our storage account. It will enable a create button and then it will do that. But additionally, you can also provide some additional details like advanced networking, data protection, encryption, tags, review. So it will be set to review is like just reviewing your data, the inputs that you have provided, right? But for every service, you will see that there are some additional information that you can configure beyond the minimum required as you may require it. And feel free to, whenever you are creating a storage account, right, feel free to go through these additional tabs to understand what are those input parameters. And with that information icon that you will see next to each of those configuration element, you can learn more about it, right? In some cases, it will also it will also give you a hyperlink, which you can click and it will take you to Azure documentation to better understand that concept, right? So you should try all of that. But it's very basic. So with bare minimum information, you can try and create a storage account with just this much inputs. I'll click on review again, and it will just do a final validation, quick validation, and it will enable this create button. As soon as I click on create, it is initializing the deployment of that resource for me. Okay, so it will take a matter of few seconds to few minutes, and once the deployment is finished, we will be able to go to our Blob storage account and start using that. So now just imagine if you wanted some kind of a storage in on-premise, you have to first order that, order some kind of machine, order a disk, and then only you can access it. And think of on-premise like your personal use as well, right? So if you wanted a hard disk, you have to go and order it from somewhere, and only once that hard disk gets shipped to your home, then only you can start using it. On the other hand, on cloud, and this is a PaaS service, you can directly create this within a matter of minutes. Our resource is created, and I can start adding my data here. Now this will be available across internet. I can access it from anywhere. I can scale it to the demand I want, from 1 MB to hundreds of petabytes if I want. Okay. Now when you click on go to resource, after that resource is deployed for you, it is available like this. So there will always be this overview page, right? This is information, basic information about this resource. This is your resource group. This is your subscription. This is the region in which Central India is the region in which you have created that, right? What is the performance level you have selected, standard or premium? You selected standard. What is the replication you selected? You selected LRS. Account kind was storage V2. This is like default, the latest version, right? You should never think of, so when you create a ADLS Gen 2 storage or blob storage, anywhere if you get an option to choose V1 versus V2, you should by default close your eyes and always select latest version, unless you know why you want an older version, right? Which you will never have a rationale for. So you should never go for any older version. They may be available only for some backward compatibility use case, only for some customers who are already using it for whatever reason, right? And have not yet migrated. So always use latest versions. Now, some of the other properties are available over here, right? So here you see this property hierarchical namespace, it is disabled, right? This is important property, and that's why I'm kind of highlighting that. So by default, your storage accounts access tier is hot, right? Block public access is enabled, etc., etc. Right? Some of the other configuration setting. Now this hierarchical namespace, this is one setting which will make a blob storage or ADLS Gen 2 storage, right? So if I were to create a blob storage account, I will keep this disabled. When I enable this, it becomes a ADLS Gen 2 storage, right? And I will show you that. So don't worry. For now, this is disabled. That means this is our blob storage account. Okay. Now, how do you access this? Here you can go to storage browser. And in this storage browser, now you can create blob containers.
Let's have a quick quiz question, guys. In Azure Data Factory, what is a linked service used for? Storing data, running data pipelines, establishing a connection to external data stores, or data transformation? Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
When you browse the file to upload, so actually that file to be uploaded, it takes some time. For example, if I were to put some, this file, hands-on command. So as soon as I put it over here, sometimes this enabled too quickly. Right. So this time it took some time, right? But if you are facing the similar errors like we were facing yesterday, what you should just do is don't click on this upload button immediately. Maybe, wait for a couple of seconds or 5 to 10 seconds and then click on upload, and then you will not face any challenge, right? Or that fetch error that we were getting yesterday. So now see, it says fail to fetch. So rather, sometimes a refresh helps. So let me refresh the page once. And this time we'll wait for a little longer time. So this does not always happen, but sometimes if that issue is occurring, I figured out that waiting helps. Waiting for some moments helps. I'm just going to the third directory, same directory in which I had copied yesterday's file, right? So here, upload. It's a bit slow today. Let's see. Might be my internet issue. Okay, this file I'm uploading, and I'll rather, let's give it some more time before I click on upload button. And hopefully it should work. Because that's how I was able to easily upload files yesterday on this one, as well as on this is the blob storage, and we had also created an ADLS Gen 2 storage. So on that also I was able to upload the files. So what I read somewhere is this upload button is getting enabled too quickly before the file is actually uploaded, and that's where sometimes that error is happening. And it did work for me. Let's see. Yeah, so now you can see the file got uploaded successfully. So you have now 2 files inside this. And the same is applicable to your ADLS Gen 2 account also. So I'll not add any new file, but I'll just show you the file which I had uploaded there yesterday, just for a quick reference.
General.
Now next up is Azure Data Factory. So today we'll learn much more about Azure Data Factory. So what is Data Factory? Okay, so Data Factory is productive because it makes it easy to build data pipelines, right? It gives you drag and drop UI interface to build your data pipelines in a visually intuitive manner. You don't have to be a very tech savvy person to be able to build data pipeline. You don't have to write code. You can create code-free data pipeline, right? And also, if you prefer to write your own code, you can also create code-first kind of data pipeline, right? So it gives you both for a tech savvy data engineer as well as for a data analyst, BI engineer who may not be the most efficient data engineer, but they can also easily create data pipelines. So that way, it makes it very productive for developers. Now it is hybrid, right? What is hybrid? It gives you ability to connect and bring data not only from the cloud-based data sources, but also from the on-premise data sources, as well as the data sources that are hosted on other clouds. For example, with the 90 plus, or I think 95 plus now connectors that are readily available in Azure Data Factory, it can allow you to connect to your on-premise SQL Server, on-premise Oracle, think about on-premise file systems or on-premise SAP HANA, Salesforce, all these databases, as well as think about other cloud databases like Amazon S3 data store, Amazon's Redshift, DynamoDB, etc. Right, so it has got a good set of connectors that will allow you to connect to various data stores and bring data into Azure. Also, Azure Data Factory can be considered as a cloud version of SSIS, SQL Server Integration Services. So because of that, right, if you are a SQL Server customer and if you have already created some SSIS packages on premise, then it is easy for you to migrate them to Azure Data Factory, because first thing you can do is you can simply lift and shift those packages to Azure and run them without much of a code change required. Now that's about SSIS. It is scalable because this service is serverless. That means you are not deploying any compute, any virtual machine for this data movement and data transformation operation, but it gives you a serverless Spark cluster using which all your data transformations will happen. So there is no infrastructure for you to manage, this being a serverless and fully managed system. And of course, it is trusted because Microsoft Azure platform is compliant with a number of security certifications, as well as the data movement is done in a secured and certified manner on Azure platform using Azure Data Factory. So that's in essence some of the key features of the service. Okay, so when I say it is hybrid and multi-cloud integration, right, essentially it can connect to all these set of data sources, right? On-premise data sources like SAP, Oracle that I mentioned. It can connect to SaaS applications like Microsoft D365, Salesforce, Adobe, Workday, etc. It can also connect to data sources that are available on public cloud, such as Azure, Google, Amazon, etc. Right? And all of this data, Azure Data Factory can connect to these different types of data stores and use that data, right, to create data-driven applications, data science and machine learning and analytical dashboards, and using Power BI, right? So all of this data you can bring into Azure and then do all of these, in terms of data science or applications or analytics. Now this slide is slightly older. It says 90 plus connectors, but as I believe there are more than 95 connectors that are now available. Now, what are these connectors, right? So you can see any popular data source system that you can imagine, you would probably see it on this slide, right? And this is also not an exhaustive list. For example, in Azure ecosystem, Data Factory is able to connect to all of these different types of data stores that are mentioned. Similarly, when it comes to databases, be it Amazon's Redshift or DB2 or Sybase or Phoenix or HBase, Impala, whatever, all of these have readily available connectors. There are a number of different file storages, different NoSQL databases, different services and applications such as D365, Salesforce, Marketo, HubSpot, Magento, etc., that you can directly connect to and to bring the data into Data Factory. And there are also some generic connectors that are available, such as HTTP-based, API ingestion or OData connector or ODBC kind of connector. And there are different file formats also that are supported, include CSV, Avro, ORC, Parquet, and JSON. These are all popular data formats using which typically organizations do analytical processing in their data warehouse environment. Just checking, if people have joined in lately to allow them to talk. Okay, so on this page, what you are seeing is a very quick copy data pipeline, right? What this pipeline does is it gives you ability to connect to any of these data sources. Now, in Azure Data Factory, it is very easy to connect, to build a pipeline, data pipeline to connect to any of these data stores, right, as a source. Then once you connect to these, for example, to Cosmos DB database or to Amazon Redshift database, then you can select the data set within that database or that data store. And that data set could be as simple as a table within that database, right? So you select your connection, then you select your particular table. That becomes the source data. Then you further, if you look at these steps on the left-hand side, then you further configure the destination, right? That means you will copy data from the source and you now have to put it onto destination. What could be this destination? This destination could be, let's say, Azure Data Lake storage, Azure Blob storage, or it could be a SQL server or SQL DB that you are creating on Azure, or Cosmos DB, or Azure Synapse Analytics, where you are building a data warehouse table. So it could be any of those destinations. And there also you will select, the destination setting, whether you want to copy that data into a particular table on the target, or whether you want to create a new file, or whatever file format, file name you want for your ADLS Gen 2 folder in which that file should be created, etc., etc. And you will add some more settings. You will review, in summary, you will review all your configuration setting, and you will deploy, right? That means that pipeline will be created for you, as simple as that. And we will create couple of such pipelines so that you get an end-to-end understanding of that. Azure integration runtime, right? So because this is a serverless service, that means you don't have to provision any compute environment, right? Any compute cluster or compute server for the data movement activity or any data processing activity. But Azure will provide it for you. And that is called as that compute engine which you require to run the pipeline, to orchestrate the flow of the pipeline, right? After first step is completed, go to next step, then execute step. So all that monitoring, all the data movement, right? Yeah. The integration runtime, as I was talking about, the integration runtime gives you the compute environment that you require for data movement and various data processing or activity processing as part of your Azure Data Factory pipeline runs. Now, there are two types of integration runtimes mainly, right? So there are actually three types, but mainly two types. One is self-hosted integration runtime, and there is Azure integration runtime, right? Now, what is this? So, and you can see what integration runtime is doing in Azure integration runtime, which is also called as auto resolve integration runtime. You don't have to remember all of this. When we see Data Factory, these things will be much clearer to you. So there is data movement and activity. All of this is done by this integration runtime. So this is the compute environment for this. Then dispatching, in Azure public network or SSIS VNet. It says SSIS VNet coming soon. This SSIS is already available. So this is probably slightly stale slide. And then self-hosted integration runtime is also used for data movement and activity dispatch from on-premise, cloud, and virtual network. Now, what is this? Essentially, the easiest way to remember what is integration runtime, it is compute required for various data movement and data processing, as simple as that. Now, which integration runtime will you choose when? Now, to address that question, you will choose Azure integration runtime, which is also the default integration runtime whenever you want to connect to any cloud-based data sources. Okay. On the other hand, when you have to connect to any on-premise data stores or on-premise data sources, then you will use self-hosted integration runtime. It is also called as SHIR. So, and the next slide will make it a little bit more clear. This is exactly what I already spoke about, what ADF compute environment is used, right, for activity dispatch, etc. So your CPU that you require, the memory power that you require. So compute is a combination of processing unit, which is CPU. Then it is in addition to CPU, it has certain memory, which is, think of it like RAM memory, and certain IOPS that are supported, and some storage, right? Storage is typically different from compute, but memory and processing power, that is essentially what is compute. Okay, and to do any activity, any task, right, you need compute. So that's what the compute is all about. Now let's understand, how Data Factory connects to this on-premise set of data stores. And these are all cloud-based data stores, right? So if you have to connect to cloud-based data stores, you will use Azure integration runtime. On the other hand, when you want to connect to on-premise data stores, you will use SHIR. It says installable agent. Why it says installable agent? Because self-hosted integration runtime is nothing but a deployable piece of software or agent, right, that you install on one of the on-premise or virtual machine that is available on Azure cloud, right? So essentially, see, what you have to do is you have to connect to these on-premise data stores. This Azure Data Factory is running in Azure cloud. But when you want to connect to these on-premise data stores, what you have to do is you have to install a component called SHIR, self-hosted integration runtime, on one of the machines which can talk to these on-premise databases. That means this SHIR machine or SHIR virtual machine should be in the same network or same virtual network in which your data sources are available, right? So that your communication between cloud and on-premise will happen through this virtual machine. Okay, now let's go to Azure Data Factory demo. So see, there are some data sources. So CDC it will depend upon whether the original source of the data, that source system supports CDC based ingestion or not, right? For example, let's say SQL Server, SAP HANA, or whatever that database may be. If that database supports CDC based data ingestion, then that is available. So Azure Data Factory does have some of the connectors that can ingest the data using CDC mechanism or CDC technology. So yes, that is supported for some data sources, right? For exactly which data sources it supports and which it does not support using CDC as a ingestion mechanism, that you will be able to transparently see anytime on Azure documentation. So if you just search for Azure Data Factory connector and the Microsoft documentation page that you will land on, you will get the complete details, which all connectors support CDC based ingestion and which do not support. So if you have those virtual machine, see, if you already have a virtual machine, right? Now, if it is already on the Azure cloud, then you may be able to access it using Azure integration runtime itself. Okay, that's one. Otherwise, you can always deploy a small SHIR component on your virtual machine, and from that you can connect to that virtual machine. So either ways, it should be possible depending upon whether that virtual machine is there, whether it's available public for public access. So it will depend upon your networking for that. But one way or the other, you will be able to access it directly through integration runtime, or by installing a SHIR component on that same virtual machine from where you want to copy, and from where you want to bring the data, like copy and paste. The same virtual machines compute will be used. So imagine that's like copying data from one VM to the other, right? So typically when you copy data from one computer to the other computer over LAN, both computer use their respective CPU power, right? CPU and compute power to copy the data and transfer the data and copy it on the destination. So you will not need any additional separate if you are going by the SHIR way. So you don't need a separate third virtual machine to do that. See, the question was, he wants to copy data from one virtual machine to the other virtual machine, that he wants to do using Data Factory. Okay, now his question was whether I should use SHIR, self-hosted integration runtime, or whether I should use Azure integration runtime. So I said, depending upon how that virtual machine is accessible, if those both are on Azure, then you might just be able to you do it using Azure integration runtime as well. Of course, do it using SHIR. So now again, as usual, we will come to Azure portal, which is portal.azure.com. You have to click on create a resource. As you click on create a resource, this time you want to create a data factory, right? So I will search for, let's say, data factory. So this is your Microsoft Azure data factory. I'll click on create. Again, as usual, you have to provide a subscription name and resource group. So I'll provide my resource group name, which I created yesterday, and I'll give it some name, right? So JK Demo ADF. This is the name that I'm giving to my data factory resource, and I will, let's say, create it in Central India region. Version by default, I'll keep it to latest. Okay, so I will, it's only V2 here. But even if you see V2, V1, right, for certain region, you should always default to V2 only. Now let's click on review and create. It says validation has passed. I will click on create, and it will create Azure Data Factory for us. And this is Azure Data Factory for you, right? Now you can click on this quick start. It will, point you to some tutorials or some documentation page where you can learn more about Data Factory. Let's see where it takes you. And it says get started with Azure Data Factory. Some, some video details, some try your first demo with one click, right? So you can always try this in a very simple way. You can learn more about it. Essentially, this video will just summarize what I have, how I have explained to you the data factory so far, and we don't have to do it exactly. You can always try this. These are very simple to follow tutorial, how to create data factory and all, right, which we have just done. So very screenshot by screenshot kind of environment. So now once you can always go through that. Then there are some tutorials. If I click on this, there will be, it will take you to some tutorials which you can try. And there are a number of different tutorials that are available, right? Copying data, what is copy data tool, copy activity, and a number of other things. CDC copy pipeline, somebody was asking, right? So all of these you can try whenever you get a chance. However, we will also try some of these simple things, right? So there is some template gallery, training module, etc., etc. You can explore all of these on your own. So that's overview page. Now here further, if you go down, you will get some monitoring details, right? Remember, monitoring is also important aspect of being a data engineer. Then you can get some high level statistics about your Azure resources, right, within the Azure portal. So right now in our data factory, there are no pipelines running, there are no activities. you don't even know what activity and pipeline is so far, right? Some of you. So trigger run, what all of these, right? So, but when we start creating data pipelines, when we start running those data pipelines, then you'll start seeing, the utilization of your data factory, how many pipelines are running daily, how many activities are running, etc., etc. All of those statistics will be readily available over here. Now, to actually go and create any pipeline in data factory, you have to click on this Launch Studio. So when you click on the Launch Studio, it will open the data factory into a new browser window. Okay. So now that it has loaded, you can see there is some pop-ups that are coming up. I'll talk about them at some point in time. Now, let's understand this environment, right? So there are some quick access tiles. What are these quick access tiles? So for example, you can create on this ingest and you can quickly create a copy data pipeline. We'll come back to this, right? Then you can also click on orchestrate and you can create a code-free data pipeline from using orchestrate. Then there is transform data. You can create data flows, mapping data flows within data factory. Now these data flows, by the way, somebody was also asking about data flow. These are not same as the Power BI data flow, etc. Right? So don't confuse between them. These are the mapping data flow within Azure Data Factory. And you can also configure your SSIS. So for example, I talked about this, right? Azure Data Factory is a cloud service. You can think of it like a cloud version of SSIS, because earlier in on-premise world, you would have used SSIS along with SQL Server. But SSIS on the cloud is nothing but Azure Data Factory. And it is not just SSIS on cloud, but along with a lot of other features which are not available in SSIS. But when you want to migrate your SSIS packages to the cloud, then you can quickly lift and shift and you can configure your SSIS details over here, etc. Now let's understand these left-hand side tabs. Right here you have, this is the home page or home tab that you are on. Then this is author, right? In this, when you click on author, here you can create your pipelines, your CDC pipelines, which is currently in preview. You can create your data sets over here. And I'll talk about what a pipeline is, what CDC, for example, is, data set, data flow, Power Query is more related to Power BI, right? So whenever you create any of these, you can create those in this author tab. You can click on this plus sign and create this, create a new pipeline, create a CDC, create a data set, data flow, Power Query, etc., etc. Okay. So we will come back to this in some time when we have created our first pipeline. So that's authoring tab. Then next is monitor, right? In this monitor tab, whenever you are running pipelines, those pipelines you can monitor from over here. Okay. All your trigger you can monitor from over here, right? When your trigger ran successfully. Now, what is a trigger? What is a pipeline? I know you have all those questions. We will come back to that, right? And then we will come back and understand more over here. I'm just giving you a high-level walkthrough. And next is manage tab, right? In this, you will be able to manage your linked services. What is a linked service? It is a connection, but we'll learn more about it, right? Your integration runtime. What are integration runtimes? You can see by default, your integration runtime, your Azure compute environment is ready. What is it called? The type, note the type here. Type is Azure integration runtime. What is it called? Auto resolve integration runtime. This is your default. It is already running as soon as you create your Azure Data Factory. I can click new over here and I can create, let's say, SSIS integration runtime or Azure self-hosted integration runtime, right? So all of that I can create from over here. But let's continue. Now Azure Purview, right? Because what you are doing in Data Factory, you are creating data pipeline. What does a data pipeline do? Data pipeline does ETL, right? Extract, transform, load kind of activities. That means a data pipeline connects to a source of the data, brings that data into, let's say, some intermediate store, right? Then, or it brings it into in-memory. then you will do some kind of transformation, data cleansing, data processing on that data. And finally, you will load that processed data into some destination, which could be ADLS data lake storage, or it could be some kind of Synapse table or some data warehouse table or database table, right? Typically, these are the locations where you will put your processed data. And because a data pipeline does that data processing, data ingestion, so it is actually moving data from one source system to another destination system. And in between, it is also processing the data. What is Microsoft Purview? Purview is your data governance and data lineage service, right? So you can link your Purview account in Data Factory, right? So if you have created a Purview account, you can connect your Purview account within your Data Factory, and then Microsoft Purview as a data governance service will be able to scan your Data Factory account. It will scan your pipelines so that it will internally understand which pipeline is connected to which data sources, what that pipeline is doing with that data, and where that pipeline is putting your data. So it will be able to show you an end-to-end movement of your data or end-to-end lineage of your data, right? So this is how you can link your Purview account. Also, you can link your GitHub account, right? Why do you need a GitHub account? Essentially, you are creating pipelines or ETL. Think of it in other environments or in terms of other tools. Think of them like ETL packages that you are creating, right? Now, what is this? These data pipelines, whether you are writing a code or whether you are creating a code-free data pipeline, but this is essentially some code that is being generated for you, right? Or you are writing on your own for data processing, for data movement from one place to the other. And these are the pipelines that when you create these pipelines into dev environment, right, you would want to deploy these from dev to test to UAT, UAT to prod, right? So you would want smooth deployment of your code or your data pipelines from one environment to the other environment. And how do you do, this kind of code management and code propagation from one environment to other? Typically, you do it with CI/CD tools such as Azure GitHub repo, or you do it with Azure DevOps kind of repositories, right? So you can also connect your GitHub repository from over here by configuring your GitHub account, so that whatever data pipelines you are authoring or creating within Data Factory, all that code will be exported and stored into your GitHub repository, so that you can quickly and easily migrate from one environment to the other environment, right? Similarly, there is something called as ARM template. What is ARM template? ARM. It's called Azure Resource Manager template, right? That is more of infrastructure as a code service, right? So again, not specific. GitHub, ARM, these are not specific to data engineers. These are more like DevOps or Azure administrator, infrastructure related services. But essentially you can store, but essentially both ARM template as well as data pipelines are some kind of code. So to store that code or to import export that code from Data Factory, you can link or you can use this manage tab. Similarly, there are triggers, global parameters, etc., some of the other things that you can manage from this manage tab. And finally, you have something called as Learning Center, which gives you again this access to this quick start tutorial videos, templates, etc. Some of these ready-made templates that you can start working on to quickly build your Data Factory pipelines, right? So let's go back to home now, and let's create a data pipeline from scratch, right? In a very simple and easy way. Now I am going to click on ingest. When I click on ingest, it opens a copy data tool for me, right? It says, and I have to, configure a few quick settings, and then accordingly, I'll be able to quickly move data from one place to the other. Now, what are the properties, right? So it says, what is the task cadence, right? So by task type, by default, is built-in copy data, right? So I'm saying I want to use a simple copy data task. I'm keeping most of the settings to default. It says run it once now, or I can schedule it to run on a specific date and time and on a specific window. And I can also schedule it to run on a tumbling window. That means, I can specify that it should run, let's say, over every 2 hours, every 4 hours, or whatever, right? But I'll keep it simple for now. You can do different types of scheduling. For now, because it is our first pipeline, I'll just choose run once now. Okay. Now click on next. Now it says you have to configure some source data store, right? So you have to specify what is the source of your data. So I will select all the source types, right? Do I have any of the source connection available? If I see the drop down, there is no connection available, right? The connection is nothing but linked service. So what is connection? Connection is your credentials, right? Or connection details to your source data store, right? Now, whenever you configure these connection details, at the end of this pipeline, these connection details will become a linked service. Linked service is nothing but is same as connection. That means that linked service is pointing to a particular data source. So I don't have any, so I will click on new. Okay. Now in this, you can see these are all the readily available connectors. Okay. Using any of these connectors, I can connect to all of my Azure data stores, right? Or if I want, I can connect to Oracle database, right? It is either whether it is on AWS cloud or whether it is in Oracle cloud. I can connect to Google's BigQuery or Google AdWords, Google cloud storage S3, or I can connect to, let's say, AWS S3 storage. I can connect to Netezza database, or Teradata database, or be it any other SAP HANA, Salesforce. Just imagine any popular data store and you will have a connector that you can use. Now what we have created a blob storage account, right? So I'll create blob storage account as a source account. What we will do, we will create a simple data pipeline that connects to our blob storage account, which we created yesterday. It will copy the data from blob storage account and it will put that data into ADLS Gen2 storage account. Okay. So what we will do, let's configure source system as our blob. Now it says new connection, right? That means this, with this name, a linked service will be created at a later point in time. So
Jayendra, when you select that source data store from all those choices, does it matter whether that source reside on-prem or in cloud? It can reside anywhere, right?
It can reside anywhere. If it is on premise, this is how you will have to, this is my auto resolve integration runtime, right? If it is on premise, here you will have to first create SHI
integration
runtime, which can connect to that on premise data store. Otherwise, this connection will not succeed. Okay. So you are doing connection, parameters over here. So continue and you will figure out further. Now,
Jayendra, so you talked about the link service. So link service should be registered, right? And that is done through this new connection?
Yeah. So whenever in as part of copy data tool, whenever you are creating this pipeline, and even if you create a new connection over here, it will automatically create linked service.
Okay.
Yeah. At the end of it. Now, I am not, I'll just keep a default name to it, or let's call it, JK blob that we created on 218, right? This can be any name. It doesn't have to match exactly with your blob storage account name, but you will give it some reasonably familiar name so that you can know this connection is to which source database, right? Now it is already connecting to auto resolve integration runtime. I'll keep the other settings default. It is from my subscription. So where is it? How do I want to access from my subscription? So I'll select my subscription. All this will show all the subscription that I have access to. In your case, you might just see one. Now storage account name, again, it is by default populated. So once I select my subscription, these are all the storage accounts that are available within my subscription. So this is the JK demo blob 2018, 0218 that we created yesterday, right? Now I have provided this. Now I can test my connection. So it will see if, with all the details that we have provided, whether it is able to connect to that. Now,
what about the authentication type? What are the different options we have?
So by default, authentication time, you have account key. You can use SaaS URI, service principal, depending upon, various mechanisms that you want to use. But for cloud-based data stores that are available in your Azure in your own subscription or in other subscriptions that you have access to, you can keep to default, which is account key. There is, because this is in our subscription, right? This is in my subscription. I am able to, I have all the access and everything, right? So for if some other source connection and whether your user has an access to it or not, right? Accordingly, there may be some access settings that you may have to do for that user, right? Similarly, how we do it for on-premise is that's why use SHIR, right? So here, instead of auto-resolve integration runtime, you will start using your SHIR, self-hosted integration runtime, and that's how it will be able to. So then that's how Azure will know, or Data Factory will know that okay, this connection is going to on-premise via secure gateway called SHIR. What you can do, right? You may be able to add restrictions of only your organization, right? So users of only your organization, right? So these things, these access managements, typically your Azure admin team will take care of, right? But then as a data engineer, what is important is how to just configure those settings, right? And then making sure that you are able to test your connection to that database. Once you are able to test it, then you can go to next step, which is data set. Now that we are connected to this blob storage, it can, because this is a native connector that is available, we can now browse this storage, right? So it will, without having to go through Azure Data Factory, you can access the storage from, Azure portal, you can access your storage from here itself. So within a dir container, I have a directory called dir1. There is another directory dir2, and there is another directory inside this. And then there are these files that we had seen, right? There are these two files that are available. So I will not select a specific files, but I will select a directory level. Okay. So dir3 I am selecting, I am clicking OK. So I have selected a dir. If I want to copy a very specific file, then I can also select that file name, by the way. Okay. For example, if I do like this and click on OK, that means this is going to run only for this file. Okay. Again, when I select directory, I can mention that if there are directory inside directory inside directory, whether I want to recursively copy all, right? So some of the other additional settings we can do, but others we can keep it to default. There are settings with respect to performance. For example, how many concurrent connection you want when you are bringing a large amount of data from on-premise or from data source to data target, right? Then you might want to take advantage of parallelism. So for each of these, right, you can just go through these information icons and understand these in details. Otherwise, you can keep it to default. Okay, now in the destination, again, now you would see there is one connection may be available, right? This is blob storage connection. So if I want to copy it from one directory to the other directory into the same blob, that also I can do. But I will, rather than doing that, move it to ADLS Gen 2, right? So this time I am selecting ADLS Gen 2. And this is, let's say, JK ADLS 0218. And I will select my subscription and the storage account name. This is demo ADLS 0218. And in that, let's test connection. Let's click on create. So this connection is created. Now I can specify the folder in which I want to bring it, right? So I'll say inside the dir container, I will say this directory is good. I will try to copy it over here only. So now, right now, just notice that there is only one file, input emp2.txt, right? So I'll keep it to default. We created this yesterday, na? ADLS. You're not creating a source or destination from here. You're just creating a copy data pipeline. Now, copy behavior. It says flatten hierarchy, merge files, or preserve hierarchy. So we will keep it to default behavior. Again, maximum concurrent connection, some block size if you want to specify how the file should be copied, etc. These are more useful when you are copying large amount of data, and you can always experiment with these. Now, compression time, we will keep it same. If you want to specify any file name, prefix, etc., right? Most of these are optional settings, so we can keep them to default. Let's click next and let's see what happens. Right now, this some other settings, right? So this will also create a pipeline. So let me call it copy pipeline blob to ADLS. Some of the other settings you can keep it to default. Let me click next. Now, as you can see, it just shows you summary that this is the incoming blob storage. This is the final. This is source. This is the target. Right. This is your pipeline name. This is your source. These are the settings that you have chosen. This is the destination. This is the copy setting. By all the default settings. And if I click on next, right, it will first of all create this pipeline. And then we had selected to run that pipeline once. So it will also go ahead and try to run that pipeline. So the pipeline run is also successfully done. So let's go to Azure portal to see what happened, right? So this was the ADLS account, storage account. It had only one file. Now let's see what have we got inside that. Now, let's go to storage browser. And in that, you will see both the files got created with .txt, right? So the default setting that got applied to both the files. But both the files have been copied just now. As you can see from the timestamp, about a minute or so ago, this have got copied. Now, so this is how you moved data from one storage to the other. Let's go back to Data Factory to understand more. Okay, now I'll finish this pipeline. First of all, to see the pipeline that you ran, you can go to monitor, right? You can refresh from over here. It says it is right now on triggered runs, right? So we have to see our pipeline runs. So you can see the pipeline that just got run, right? That is copy pipeline, that the pipeline that we created, right? Now, if I click on this, you will be able to see the details of this copy data pipeline, right? So this is the copy data pipeline that ran. And from over here, you can see the details of it. What are these details? These details tell you that, okay, how many files got processed, what are the total number of records, peak connections, then some of the other information like the total data processed, again data written, total data written as part of second file, etc. So you can understand, and there is this is something important, right? DIU hour. So this is the copy duration, right? About less than 8 seconds or 8 seconds. And there is a construct called as DIU hour, which is, let me show it where, let me check where it is. That runtime is your compute for doing this data movement, right? Copying data, and in between, if you wanted to do some data movement, right? As part of some pipeline activity, all of that will use some DIU, right? Data integration units. So if you look over here, this is the effective data integration units during the copy, right? That means it used 4 data integration units. For how long? For 8 seconds, right? So your copy duration was 8 seconds. That means your billing will happen for 4 DIUs for 8 seconds. Now, what is the billing, typical billing price, right? The billing price is configured for $0.25. That means 25 cents for 1 DIU hour. So when you use 1 DIU for 1 hour, your Azure Data Factory compute billing is 25 cents, right? Here you have used 4 DIU for 8 seconds. That means even if you do 1 DIU into, let's say, 8 seconds into 4, that means your total one DIU has run for, let's say, 8 into 4, 32 seconds. So if 25 cents was a billing for 1 hour, accordingly, you can calculate what will be your bill for 32 seconds, right? So it will be negligible. But when you are doing large data, let's say you were copying, 1 GB of data, and let's say that pipeline ran for, or you were copying 1 TB of data and that pipeline ran for 1 hour. That means, and if you used 1 DIU, let's say you were using only 1 DIU for 1 hour, that means your billing is going to be $0.25. That means 25 cents is going to be your billing for that run of a data pipeline. Okay, now all of these is detailed, available in detail on Azure documentation as to how sizing and pricing works, right? How to determine as part of each activity, how many as part of each pipeline, how many activity runs that happened, how many DIU hour got utilized, and you don't have to do these minor calculations. You just have to do some estimation, right? Because billing is always going to happen on actuals. Okay, so, but why this understanding pricing and sizing is important? So that you can estimate that, okay, my Azure Data Factory billing is probably going to be, let's say, $100 in a month, or few hundred, or let's say 5,000 rupees per month. But to be able to do that, you need to understand some benchmarking as to how many DIU hours every day you are going to require for your processing, whatever data processing that you have to do, and accordingly you will come to some estimates. And I will also guide you through some of those estimates and pricing guidelines in some time, but just to learn more about it. But that is how it works, right? Now let's understand.
Jandra, I have a actually follow-up question on the same thing. So when we have spinned off basically this Azure Data Factory ADF itself, if even it is not working, is it not also incurring some cost over there if it is just standing alone and running?
No, I don't think that will incur much cost. If at all it incurs, it will be very negligible.
Okay.
Yeah, but only the major cost will come when you are actually running your data pipelines. And as those pipeline runs, that is where you will incur the actual considerable cost.
Okay. Okay. Thank you.
Jendra, we have this Azure Blob storage and ADLS exist in only one storage account, right?
No, these are two different storage accounts: Blob storage account and ADLS storage account.
And basically, we need to have two different storage accounts got created in that Microsoft account, Azure account.
No, hang on. So Microsoft Azure subscription you will get. In that subscription, it is up to you what services you want to deploy. So like we discussed, there are two types of storage that you can use. One is a blob storage, one is a ADLS Gen 2 storage. We also saw the differentiation, why to use which, right? Now, I created those two storage accounts to demo it to you yesterday. So I used those two accounts. Okay.
Okay. So right now, source and destination do exist in different storage accounts, right?
Source is a blob storage account. Destination is a ADLS Gen 2 account. That's
so just for clarification, we have two storage accounts here, right? In this example.
Yes, we have two storage accounts. I'll come to that, right? So, so this is the monitor, right? This is how we monitored our batch run. Now let's go to author. Did we create anything by going to this author tab? No, but we created using this ingest, this shortcut, right? Using a copy data tool, we created a copy data pipeline. So that got automatically created. So we had, if you remember, we had given this name, copy pipeline blob to ADLS. And in this, you have this is the copy data activity. Now from here, you can further modify this if you want. Now here, if this is a copy data activity, it will have source, it will have sink. Sink is nothing but destination. Okay. So now if you look at here, this is the source data set. Okay. Now what is a data set? So you will see there is also a data set that got created. Now what is this data set? And you will also see, by the way, so let's first see the data set and then I'll go to link service. So you also got, some linked service that got created, right? These are nothing but connections. If you remember, I had used these names for connection. Now, if you look at this data set is pointing to this linked service, this connection, which is my Blob storage account. It is pointing to this directory, right? This is the container. This is the directory 1, 2, 3, and it has not specified any file name. Okay. Now, and these are the some of the other details. Now, this is the schema. It says import schema. I can import, or I can keep it to default. If I want to create any parameter for that, we'll go to that at a later point in time. Now, destination, another data set. This data set is obviously pointing to the ADLS Gen 2, which I used as a destination, and this is the directory, right? So there is only one container that is got created, and inside that container we are landing our data. I can also preview, by the way, all these data sets I can also preview from over here, right? So this is a great feature where you don't have to go to these data sets. You don't have to go to Azure portal and then see what is there, but I can click on preview, and that will show me that, okay, it says there is no preview to show because this is not a specific file, right? This is not pointing to a specific file, and that's where it is not bringing the data. But if for a moment, if I just modify it, try to modify it, right? Let's say if I'm clicking to this this particular file, and from that file, so it is actually loading first few records of that file and showing me a preview of that. So I will keep it back to how it was for a moment. This is my ADLS Gen 2 account, ADLS in the name you can see. Okay. In this account, I have directly pulled those files or copied those files into the parent container, which I have named as dir. See, there is this container. This is container level. This is the container called dir. You can see it is a container. I have directly copied it inside this container. I have not copied it in any other directory. Output is now visible over here, right? So if I select it to output, and if I click OK, you will see now when I run this pipeline next time, right, it will actually take this change into account. And next time, if I run the same pipeline, it is not going to copy the files into this container. It will actually copy inside this new directory called output and then copy the data. Okay. Now, one thing to notice, right? As soon as I made this change, you will see it says publish. That means any changes that I make, I have to publish them. That means to save the changes, I have to publish them, because if I don't publish them and try to run this pipeline without publishing the changes, then it will run on a previous code. But when I publish this code that or change that I had made, then it will run on then it will take into account this new code. It's like compiling your code or saving your code. For now, let me just change it and keep it default. So what else, right? So this is the source data. Now, if you go to manage hub, you will see some linked services also got created for you, right? As part of that copy data pipeline. Now, these linked services are pointing where? This is pointing to your ADLS Gen 2 storage. This is pointing to your Blob storage, right? What are these? These are essentially just connections. You can also manually come over here and create connections to any data store, any source data, wherever you want, right? And you can then, once you create those linked services, you can publish them and you can start using them into the pipelines that you want to create. For example, if you come back to author pipeline, you can, if I had created some other linked service, which we will do in due time, right, as we move forward, then I can even use that linked service over here. So for source, I can use another data set. So right now there are two data sets that are available, right, as which got created automatically. So if I want to create them myself, I can click over here, data set. I can select what kind of data set I want, and I can add my new data sets that will be visible over here. So if I am creating any new pipeline, if I want to reuse any of these data sets, right? For example, in this, I had some source files. Let's say I want to create multiple copy data pipelines and my source is same. I want to take the same set of files and maybe I want to copy it into 10 different places, right? In 10 different data pipelines. So I can continue to use this same data set. which is pointing to the same location, same files. So essentially, these become your code artifacts pointing to a specific data set in a specific data source. And if you want, you can continue to reuse them. Similarly, linked service, once created, you can continue to reuse them to connect to that particular connection, to that ADLS storage account or to that Blob storage account. Here you may have, in a production grade environment, you will see linked services to SQL database or Oracle database, whatnot, right? All your data sources, you will see linked services are created over time, which means once this is completed, next is this. Here again, I can provide source and sink. Here the source could be ADLS Gen 2 and sink could be another, next set of folder I want, right? Again, do I have to connect these two? I just remove the connection. That means if I want to do it in parallel, I can create n number of copy data in this activities in this pipeline. They can all connect to any data source and depending upon the configuration and any sink, right? Whenever this pipeline will run, all this copy data pipeline will start in parallel. Copy data activity will start in parallel, and then they will do their respective job, right? So I can do, one after the other, just by doing a drag drop, right? For example, like this, from over here, I can do like this, etc., etc. Okay. Now coming back to that error question. Okay. Now how do I track errors? I can also define, so there is something more to it. For example, what is this? On fail, right? On failure, what to do? So when this fails, let's say I want to create a simple Azure function, right? I want to create a simple Azure function. Now, at this point in time, I'm not going into what is Azure function, right? But I am telling you, on fail, I can do something. On success, I can do something else, right? Let's say when this is successful, go to next step. On success, go over here. On failure, call this Azure function, and then this Azure function will do whatever it has to do, right? Maybe do some logging, understand, capture the error, and understand, log it into somewhere. Then I can, create a logic work, some kind of trigger, some kind of workflow, which can be written in Logic app, and that workflow can trigger an SMS or email alert. So all of that can be done. So essentially, what you need to understand, how part is something. There is enough documentation available as to how to do. For example, you want to do how to trigger SMS alert or email alert, right? Whenever my pipeline fails. So there are, don't worry, I will also guide you to some of the documentation for all different scenarios. We will not be able to cover every single aspect in this course because, like I showed you, right, in the overview, there is a very large data platform services that we have to cover DP 203 certification point of view. But these are all things that you can do. And we are going to do a lot more than what I'm just showing, right? In Data Factory, there is next set of things that are coming, which will, as part of which we will learn and do more. Okay. It says 381 bytes and this says 353. Okay. This is really in bytes and KBs. So even I don't know why that changed. There is one change that I can possibly sense is probably, that CSV to TXT. So the file format specific, there could be some change. But why this one is showing 381 versus the other one is just showing 68 bytes. Let's check that. We'll try to compare the contents. Let's do that also. So good catch. Let's try to check this, why it has happened. So I'll try to download. First of all, you see, I have downloaded it from the Blob. So let's open and let's see what have I put in that. I don't know what is the content actually. Okay, there is some, 3-4 commands. Fine. I'll keep it minimized. Let's open the other one also. So this is the Blob storage from where we have opened that file already. Now let's go to ADLS Gen 2. So as long as content is okay, right? Frankly, I would not have an answer as to why those minor differences in the file size that it is showing. But at least what we have to make sure for sure is the content is all okay. And so if I download this one again, it has this bracket 1, right? So let's open this file to ensure that it has the matching content. Oh, okay. that copy somehow did not work. Let me, that means there was only one row. Let's see this. So it has only copied last record. Why has it not copied the other set of files? So let's see our copy settings if there is something in the setting. So very good catch, right? Let's see what could be the reason for that. Is there some set of data that is being ignored or whatever? Let's go to our copy data pipeline and let's try to debug that. Okay, so this is the source data. See, skip line count. By default, maybe we did not notice this. And there is this skip line count. By default, it is set to 3. If I change it to 0, you notice this, right? So there was some skip line count setting because of which it was skipping first 3 records, first 3 lines of that file. I am going to, for the source, right, from the source. So I am going to change it back to 0 and let's publish this, right? Publish. All the changes are being published. And let's try to rerun this. So copy data pipeline is published. Now what I'm going to do is, instead of keeping the same sync, let's change that sync destination also to output directory. So we'll keep our original data as it is. Inside this, this time, the new output is going to be copied in this output directory. Okay. So we'll try to, right now there is no content in the output. Oops. Here, let me click OK. And let's also publish this change. So this data set has changed. I will publish this. Okay, the change is completely published. Now I'm going back to my copy data pipeline. And now I want to run this pipeline, right? So either I can add a trigger or I can click trigger now. That means if I click on this add trigger, I get 2 options. I can, add a new trigger or I can trigger it now. So I will trigger it now. I will explain you what this add trigger is. But for now, let me just run it now. So it says the trigger pipeline now is using last published configuration, right? So we have published our new configuration. Let's click OK. And this pipeline will start running. I can go to monitor. And this is the pipeline in progress. Okay, in a matter of few seconds, it will finish. I can keep refreshing it. And once that pipeline run is finished, let's go to, in the meantime, our ADLS location, right? This is the ADLS. This is the output location, right? Inside output, you already have these files. And let's see, this is 381, this is 353. And if, by the way, since we already have the files over here, if I go back to ADF, you would see this is actually succeeded, right? So if I refresh this, the pipeline has actually finished, and that's why you see those files into the output directory. And if this is the hands-on data inside the output directory. Now, if I download this is again, if you can notice, this is the second download of that same file name. If I click on open file, and now it has exact same content. Okay, so whenever you notice, right, something is off, it is always to do something with the settings of your pipeline, either the source setting or destination setting. And likewise, you can check and confirm. So how you check that? In your pipeline, you can go to your actual pipeline and you can change any default settings, right? Your source settings, sync setting, whatever mapping settings, you can try all of these things. And DIU, right? This is the billing thing. So you can click over here to learn more. How it works, you will be charged on the basis of number of used DIUs into your copy duration, right? That means 4 DIUs into copy duration of 8 seconds into 0.25 DIU hour, dollars, right? 25 cents, as I had said. Now this is typically converted into your local currency for your billing. And if you want to learn more about it, you can click over here, open in new link tab. So hope your question got answered, right? That was the setting, and when we change that, the data has got copied successfully. But a very good catch. Thanks.
One quick question. That debug option, can't we use debug to run it?
You can use debug to run it. So we'll come to all of those options yet. Okay, I'll explain what debug is.
So Jendra, during this break, I was trying to copy from one blob to another, and it by chance failed. I don't know what is the reason, that I can check. So how can I check the log?
There is no log, right? Not everything will be by default logged. You will have to understand your error message and accordingly debug it, right? So but I would highly recommend during these sessions you pay attention to what I am doing, right? And for your labs, you can try at a later point in time and consult your lab faculty for that, because if you all start doing that, right, we will end up spending a lot of time in troubleshooting individual pipelines, and we will not be able to cover the actual syllabus. So go through the recordings, try to replicate, try to, you can run it along with the recording. Next time you are doing it, you can, do it along with the recording and follow the same steps, and it should work. Or there may be, some of the other things that you would have possibly missed, right? For that, and it's not just the recording, right? There are many readily available videos or resources, or step-by-step tutorials, right? One such tutorial we will also do right now in some time once we get to the next sets of data factory things. I'll show you, right, how you can yourself look for the right tutorial from Azure documentation and implement that tutorial, right? Implement that small program or some small pipeline on your own by following that the instructions. Yeah, by default you will only see error message, right? For logging, for any additional logging that you want to do, you have to do it yourself, right? So by creating a failure action and all. But by default, what you will get is the error message whenever it fails. And most of those could be common errors. If you just look up a search it or search engine, that will also tell you what is the most common reason of those errors and all. So you will be able to quickly debug and troubleshoot that. Now let me show you what is triggers, right? Now whenever we created and we ran this pipeline, just ad hocly, right? First, when we created, we said, okay, run it immediately. Then I wanted to run it one more time. So I went here and said, trigger now. Now, what if I want to schedule this pipeline? So let's say I will create a trigger over here, right? Do I have an existing trigger? Right now, there is no existing trigger that I want to add to this pipeline. So I can create a new trigger. In this trigger, I can say, okay, this is my daily midnight trigger, right? So here I can say run this on a particular schedule. That means starting with this date, whatever, right? 19th, I can, let's say I'll change it to start with 20th of February. Okay, what is the time? I can say every 15 minutes, right? Or every one day, right? What is the execution time? I can keep it to default, or I can say 00 hour and 01 minute. So it will always, run every day at this specific timing, right? So I'll click on OK. Now it says, if I want to add this trigger to the pipeline, I should publish the changes. Now click on OK. So I'll publish this change. So this daily midnight trigger is added to this pipeline. Now that means this pipeline is now scheduled to run every day at midnight. I can, change any timing, or I can schedule it to run every 4 hours, every 1 hour, depending upon my own requirements, right? So if you go back to manage, and if you look at triggers, there is this trigger created. Now I can create n number of pipelines and I can add the same trigger to it. So how the pipeline will run? Whenever this trigger runs, right? So if I go to monitor, there is pipeline runs and there is this trigger runs, right? So for example, let's say I am expecting one pipeline to run every day at midnight, and I have added my daily trigger to it, right? Now, what if someday that pipeline did not run? First of all, I can come to trigger runs and check whether the trigger ran or not, right? So if the trigger ran, that means the trigger will run and the trigger will satisfy the pipeline's dependency for that trigger, and that pipeline will also automatically run. So you can check pipeline runs independently and trigger runs independently. Why? Because there could be one trigger which you have added to n number of pipelines, and that's why it makes it modular, so that you can and that is the same concept applied to linked service and data set, right? Again, that is modular. There is one linked service which is pointing to one data store, which could be a ADLS or which could be some kind of database, and you can, inside that linked service, you can create n number of data sets pointing to individual tables or individual files or folders. So likewise, you can create different trigger runs, and you can schedule different pipelines by adding different triggers to those pipelines. That's how it works. So that's the funda of how do you schedule the pipeline. Now debug, we will come back to this. So essentially you can debug this pipeline, right? So if I click on debug, this pipeline will start running, and then I will be able to understand it step by step. But it is more useful when you are debugging a pipeline which has multiple steps, right? N number of steps. A pipeline with just one step, there is not much to debug, right? But when you have a pipeline which has got, let's say n number of steps, and you want to see how data is moving from one step to the other and from next step to the next step, whether it is doing the required transformation, whatever I am expecting to happen in each step, whether it is happening or not, or if something is going wrong, in which exact step it is going wrong. So I can debug all that. So as part of debugging, we can keep a watch on what is happening exactly in every step, and that is where debug is important, right? We will go to debug or understand more about debug when you understand mapping data flow. That's where it will be more useful. So now let's go to a next learning concept of first learn about mapping data flow. What is mapping data flow in Azure Data Factory? And then we'll come back to create some data flow and understand more about debugging. So let's first theoretically understand what mapping data flows are, right? Because this help you to create low code, no code data factory transformations or data factory pipelines to quickly build your business logic into pipelines and efficiently create very productive pipelines without having to understand technology or coding in depth. How it works? What are mapping data flow? Right now, as you can see on the screenshot, right, there is some kind of visual workflow that you can guess this is, right? So data flow is a new feature in Data Factory, which actually is no more new. It is there for quite a long time now. But probably this slide was created when it was newly introduced. So what it helps you to do is it allows you to build data transformations in a visual user interface, right? Simple drag and drop, and using which you can create different types of visual data pipelines. You can do the transformation at scale in the cloud, right? You can create code-free data pipelines, which do not require a lot of understanding of Spark, Scala, Python, or Java, right? So you don't have to understand the technology in too much detail. You can, even a business user can very easily create data pipeline, and not just creating data pipeline to copy data from one place to the other, but any business logic that you want to do, any transformation that you want to do, without learning the core technology to do that transformation, you can still do that transformation and very easily work with this. Again, it's a serverless, right? So there is a serverless scale out. That means you do not have to run this mapping data flow. You do not have to create your own Spark server, for example, right? So they use Spark code in the backend. So although you are not writing any code as part of your pipeline, but there is some code being generated, right? Although it is a low code, no code platform, there is still some code which Azure is generating for you, right? Which they will run on a Spark cluster. But does that mean you have to create any Spark cluster, or you have to manage the configuration of the Spark cluster, etc., etc.? No, it is serverless service for you and fully managed service. So you don't have to, worry about compute, where it will run and all. So you just have to create your pipelines and trigger them. Again, it gives you resilient data transformation flows, which are built for big data scenarios, right? So that means in the mapping data flow, there are a number of common scenarios that you will want to implement in a data lake, data warehouse world. The mapping data flows support for those kind of scenarios, and you can very quickly build and implement those kind of mapping data flows within Azure Data Factory, right? And you can operationalize data factory scheduling, control flow, monitoring, etc., right? So essentially, what do you look for in an ETL tool? In ETL tool, you want good features, good functionality to easily connect to source, right? To easily transform the data, to be able to orchestrate your pipelines. That means scheduling should be easy, monitoring should be easy, error handling should be easy, debugging should be easy, right? All of those. And most importantly, can you build code-free data pipeline? Can you use visual interface to do drag and drop kind of things? So all of those features are supported, and especially mapping data flows take it to the next level in Azure Data Factory. So what can you do with code-free data transformation? You can cleanse the data. You can do aggregation of the data. You can, convert data types, or you can, let's say, convert from integer to string, string to integer, things like that. You can do data preparation, and you can do data exploration, right? And all of that you will do in this way, right? In visual way, drag and drop way, and not by writing code. You don't have to necessarily write any code to do all of these things. Now, what is the modern data warehouse pattern today, right? Now that you have understood data factory to some extent, it is good time to understand how that data factory comes to play, right? In terms of an end-to-end analytic solution, right? Let's start from the left-hand side, all the way from the left-hand side. What you see in the left-hand side is different types of data sources. For example, you have some databases like MySQL, SQL Server, Oracle, etc. You may have some data in the form of unstructured data, which is, let's say, log files, some other files, some media files, which also you may want to, ingest into your data lake. And then there could be some structured data coming from the business applications. For example, Salesforce, SAP, right? Some kind of CRMs, ERP systems, etc., right? Some line of business applications. So you may bring data from all different types of data stores using Azure Data Factory. Here, Azure Data Factory is doing the function of data loading, data ingestion, right? Here it is doing orchestration and transformation, but I'll come to this part in a moment, right? So you are loading the data through Data Factory, and you are loading it into, let's say, data lake storage Gen 2, okay? Loading all flat files into ADLS Gen 2. And then that from ADLS Gen 2, you are using Azure Databricks. Now, I know we have not covered Databricks as a service yet, right? But here, for data processing, you are using Azure Databricks. That means, assuming in this architecture, you are using Spark technology, and that too on Azure Databricks cluster to do all kind of data transformation, cleansing, and other operations. So this is one path. Ingest from Data Factory, bring it into intermediate storage, then use Databricks for processing and put the processed data into Synapse, right? Now this Azure SQL Data Warehouse, this is an old name. So now the new name for this service is Azure Synapse Analytics, okay? So I'll change this slide, but remember this SQL DW was an old service. Now, the other way you can use Azure Data Factory is doing this end-to-end thing, right? So you don't have to bring it into intermediate storage like this, or you don't have to, do the cleansing in Databricks. You can optionally do that, but there is other way to do that is you can extract the data directly from source systems. You can transform the data, right? And you can finally load this data directly into final transform data. You can load it into reporting layer or serving layer, which is Azure Synapse Analytics, right? That means with the mapping data flow or with the transformation technology, or transformation features that are available in Data Factory, you can not only use Data Factory to ingest the data and do the transformation somewhere else, but you can use Data Factory to integrate, ingest, as well as orchestrate, right? Everything will happen within Data Factory pipeline. You will copy the data from the source. You will do all kind of data processing, transformation, aggregations, all kind of operations on that data, and the final reporting ready data you will put into serving layer, copy into serving layer. All of this will happen through one pipeline. On the orchestration part, the scheduling of pipeline, automatic running of pipeline, monitoring of pipeline, etc., etc. That also you can do within Data Factory itself. You don't have to use any other tooling for that. So that is the idea of this architecture diagram. When you do the transformation, see, this is where, right? So from this pattern, you will see a combined pattern where you are ingesting from Data Factory, and for transformation now you have two options, Databricks and Data Factory. Now when you are using mapping data flow based data transformation, that means you are preferring a low code no code way of doing things, right? You prefer to build using intuitive UI UX kind of technology than having to write your own code, right? In Databricks, you would be writing your Spark code to kind of do any kind of data processing, right? So that is how you will decide, right? What is the composition of your team, whether your team is willing to adopt a low code no code platform, or are they very good Spark developers who will prefer to write their own code for any kind of transformation that you want, and accordingly you will make a choice.
Okay, good.
Will be created automatically by Azure, and it will be terminated automatically when not in use. But for as far as but you do not have to necessarily know any Spark coding for that, because you are not managing that compute.
Right.
But just for information, or just to know how it works in the backend, that's why I shared that information, that it is Spark.
Actually, I had some misunderstanding that I was thought only Azure Databricks is based on Apache Spark and not Azure Data Factory, but that's why I asked that question. So that's good to hear that Azure Data Factory also is based on Apache Spark.
Yeah, it for the compute part of it, yes, it does use Apache.
Yeah, thank you, Jayendra.
There is so essentially this is just some of the screenshots. So next a set of few slides that will show you some screenshots with respect to how it works, right? So how a pipeline execution looks like in a data flow activity. So in that you can have number of activities. From one activity you can start multiple activities in parallel, and then again when both of these activities are finished, a next activity is being triggered, and after that another activities, right? So essentially you can add different types of activities. As you see, there is some copy data activity, then there is some data flow, and then there is some web process. So what are these different types of activities that you can add, that we will see on Data Factory Studio itself. Then some of the common scenarios, right, that it helps to implement slowly changing dimension, right? Now, those of you who have worked with data warehouse, right, you know that slowly changing dimension is one of the most common data warehouse scenarios, right, that you have to implement. Now, for others who do not know it, let me quickly explain, right, what is a slowly changing dimension and why it may be important to capture it in the data warehouse. Now, let me think of some examples for that. Okay. Let's say the status of the customer. Okay. Now let's say in a banking environment, you have a customer. Okay. Now in banking, there are different types of customers, right? Or one customer, let's say when you start banking with a particular bank, your customer record is created. And let's say you are a regular customer to start with, and I'll take a HDFC example, okay, because they follow these customer statuses. So they have a regular customer, and if that customer is maintaining good balances, that customer is creating FDs in their account, then they will change the status of the customer from regular to, let's say, a preferred customer. Okay, preferred banking. Then if the customer is meeting certain more criteria, then that customer may change from preferred to Imperia customer, right? And likewise, there may be additional better statuses for a customer, right? And why do they do that? so that they can accordingly offer better services, more privileged services, more personalized and customized services for those customers. For example, obviously, the kind of service that the bank would want to give to just any customer versus the kind of service that they would want to give to a high net worth individual, right? That will be different. So, and that's how they want to give some status. Now that is fine. Now, let's say in OLTP, so let's say you are maintaining a database, right, which is an OLTP database, online transaction processing database. Now, in that database, there is one record for each customer, and for that record, there is a column called status. That status tells you whether this customer is, let's say status A, status B, status C, or status D. Let's put it simply, A, B, C, D, D being the highest status. Now, however, let's say your CEO, right, or some business stakeholders who is managing the statuses, they want to understand customer's journey, right? A typical customer, how long does it take for them to, whether how many customers are going from status A to status B in 1 year, or how long does it take on an average for a customer to grow from status B to status C? If they want to see that kind of thing, right? They would want to see into the data warehouse when a customer status got changed from A to B, right? But can you tell that from the OLTP database? Because in OLTP database, there is only one record for a customer, and that will only always give you the latest status, right? Because the status value will be only one value. So customer ID 1, current status is B. You will never know what was its previous status, whether that got degraded from C to B or it got upgraded from A to B. You don't know. You can't tell that from an OLTP database, and you cannot keep that kind of a history into the OLTP database because it is not meant to do analytical reporting. Analytical reporting happens in the data warehouse. So it is best to keep all those status changes as to, from what date to what date the status was A, from what date to what date it got from A to B, B to C, or any changes that happened, that for that you will build some different kind of record structure into your data warehouse so that you can tell your stakeholders for any given customer how the status got changed, on what date it changed from what to what, and you can also do aggregation across all customers to understand on an average how long does it take to go from A to B, or what kind of other criteria needs to be met to go from A to B. Are you following the scenario? Because you cannot do that into OLTP world. In the online transactional mode, you cannot maintain multiple records per customer because your system will slow down. So if you were to find how a particular attribute, in this case status of a customer, how, and it could be status and it could be n other attributes, when you want to, and that is called as slowly changing dimension, right? It does not change every day basis, but it changes slowly, and you want to understand how it changed, right, from A to B, B to C, or whatever, right, for status and for n, for even let's say customer address or any other thing, right? That these kind of scenarios are very common in the data warehouse world, and that these are called as slowly changing dimension, right? And then to handle these slowly changing dimension, further there are different types of slowly changing dimension scenario like type 1, type 2, type 3. I will not go into details of that, but I just wanted to make sure that at least you understand a uber concept of what is a slowly changing dimension and why it may be required to maintain how a customer's data or how a particular record's data got changed over. Okay, so now coming back to data factory mapping data flow. So these are, because these are very common patterns and frequently required in the data warehouse implementation, data factory gives you way to implement slowly changing dimension kind of processing using simple UI interface, using simple drag and drop kind of pipeline in mapping data flow. So the idea is most common scenarios are also supported, one being slowly changing dimension, right? And you can implement a scenario using Azure mapping data flow in the data factory. In the OLTP world, I will have just one record. So there will be customer ID and there will be status, right? Just two things. But when I create that same customer record in the data warehouse, I will create it like this: customer ID, the status, the start date and end date of that status, right? Where the start date will be whenever that customer record got created with status A, and the end date of that record will be, let's say, 2099, right? Or 2199, something, or it could be null. Okay. Now, whenever I detect that in the source, in the OLTP, status has got changed from A to B, right? I will not come and update this record. So the original record got updated, right? So because that record got updated from A to B, I can never make out what was the previous value and all, right? Unless I am keeping some log, all of that is fine. But I can do analytical processing on that record because it will always keep showing me the latest value. But in the data warehouse, what I will do now is I will detect that, okay, there is a change in this customer ID status from A to B. So I will create a new record for B. And for that B, the start date will be today's date when it got changed, right? Or yesterday's date, whatever was the date. And the new end date of this new record will be, let's say, null or some future date. And I will update the end date of my previous record. That means the status A was effective from some previous start date, and that end date will also get updated by yesterday's date. That means from earlier date to yesterday, the status was A. From today to until it gets updated further to a future date in, let's say, 2099, up to that period, I am assuming the latest status is B. This is how, and this is one way of implementing slowly changing dimension. And then you can read more. There are different ways to implement these scenarios. For the purpose of this course, right, focus more on data factory and understanding that, right, because these are core technologies. Like data warehousing is a core, animal to tame, right? That's a different niche skill, right? Although that is like, that is one of the areas very close to my heart and I can talk hours, but I will be, very much diverging from the core content, right? So I want to restrict myself. But I explained that just so that, you should not feel completely out of the world, for people with no data warehousing background. And that's why. So, but the gist of this slide is you can implement slowly changing dimension using mapping data flow. That's the gist, right? Now, how to implement that? You will have to understand a lot of details as to how STD works, what are different types, and only when you know that you will be able to implement, right? So I'm not saying, this is like just simple, because you will need that kind of source data. You would know your scenario, business scenario, and then you would do that. You will know that, okay, when essentially you will run it on a set schedule. That means every day I have to extract all the changed records from my source system, which is my OLTP system. And now I want to bring all the data that has got changed into data warehouse to update, right? Either update or create new records. Now, if your question is how do I identify how my, which data had changed in the OLTP, then there are multiple ways, right? Depending upon your specific implementation. Typically, every table will have some column called as last updated date, right? So whenever you update any record, you update that, timestamp of that record. And on the basis of that timestamp, then you will create your data pipeline, which take into account or select from every table only the records which got updated or newly created within last 24 hour of window before which your previous batch had run for all the previously updated records, right? So every 24 hours, let's say if you are running it any batch in a midnight batch or everyday batch, then you will keep checking for last 24 hours and select only those records which got updated or newly created in last 24 hours. Take those records, and now when you are loading those records into data warehouse, you will see if there is a record exist already, then you will update the end date for that existing record and you will create a new record in our scenario of SCD that I mentioned, right? in other ways, there may be different ways to handle that, whether you want to update the same record in data warehouse, or whether you want to implement SCD and create different records every time you get an update. So depending upon your requirement, you will implement the scenario.
Okay, thank you.
Cool. So similar to that, there are also some other common patterns, which is deduplication. Now, for example, let's say my source system is getting updated multiple times. For example, that customer record, right? Let's say I am a customer, banking customer, same example. And let's say data warehouse is also capturing any changes into the customer address. So in one day itself, I go into net banking and I update my address. Then I realized within 1 hour that, okay, I updated it incorrectly. Let me make the correction. So I make another update to my customer address, right? And maybe I make another third, fourth update, right? In just one day. Now, this is a rare scenario. Nobody will typically do that, but I'm just taking hypothetical example. So some data element got updated, or some attribute of a customer got updated 4 times in a day, right? So sometimes what happens, when you are loading this data into a data warehouse finally, and let's say you want to, essentially what you want to consider only the record, the latest record, right? You want to take, let's say, only, this is not a SCD, let's say this is not a slowly changing dimension kind of a requirement. You don't need any historical address. You are looking for only current address, the latest record. Now, if you are depending upon various scenario, right? It may so happen that you are loading the data from the source system every 1 hour. So at 4 different hours, you will get same customer's record, but 4 different addresses, out of which now you have to identify. Now this is called as deduplication. Out of the 4 updated records for the same customer, you have to deduplicate to pick only the record which was the latest updated, right? Because all the other updated records are just duplicate records, are containing some other data, older data, which you do not want to consider. Your scenario is to consider the latest data about that customer. So what you will do, you will have to implement some kind of deduplication logic, right? That deduplication logic will tell you that, okay, for every customer, take only the data with the latest last updated date, right? And because these kind of deduplication are also a very common scenario in the data warehouse world, the idea is mapping data flow can allow you to implement deduplication also. That's the simple idea. Then, loading a fact table in data warehouse, loading a dimension table in data warehouse. Again, these are very common scenarios which you can implement using mapping data flow. What you could also do is, when you are using mapping data flow, you can also understand a lot of statistics about your data, right? Because there is a feature called as data preview. When you do data preview, it not only shows you the incoming data, but it also gives you some of the, when you click on statistics, it will also give you some statistics, right? Now, this can help you if you are a data scientist, and if you are trying to build some data science scenario, then these kind of statistics can help you to better understand that data, right? What could these statistics be? For example, let me think of some use case. Let's say I want to offer, again, I'll take simple banking example, right? I want to offer a personal, a better credit card, right? Let's say a bank has one of the best credit card, right? But that credit card has to be offered only to the customers who are meeting certain criteria, right? That means these customers should have very high CIBIL score, for example, right? Basic criteria that we all understand. Then that customer, let's say, should be having, a certain number of FDs, right? And some more criteria. So here there is a data scientist who is trying to identify what should be the criteria using which I should create a model, right? That model will give me, when I run that model, and when I provide customer ID as an input to that model, it should take certain other attributes, certain other features certain other features, as you call it in the data science world, and he wants to select certain features to determine or to build the ML model. That ML model will predict whether this customer is a good customer to be offered the best of our credit card, or this customer is not so good, right? That means now this data scientist wants to understand what could be those features. So he says, okay, CIBIL score is going to be a good feature. I want to use CIBIL score. Okay. So he tries to get into a table which has CIBIL score information. Let's assume this year, here you are seeing this year, right? Instead of year, think of this like this is a CIBIL score of a customer. Okay. Now, when you click on this year and when you click on statistics, right? There will be complete statistics that will be available, right? Whether your CIBIL, the customer's data is, pivoted, or the CIBIL score of, there are more number of customers with CIBIL score of 8, or there are less number of customers with CIBIL score of 10. Let's say you have chosen a very specific category of customer, and in that category, you will realize that almost all customers in this category are actually having more than 8 CIBIL score. Then you will realize that CIBIL score is not the right feature, right? Because whatever customer category I am looking at, they all have, above 8 CIBIL score. That means CIBIL score is not going to be the right feature for my ML model, because it will not make much difference. So if you were to understand your data better, and a data scientist will better understand this, the idea is data factory mapping data flow through this data preview feature and through these statistics can help you to quickly understand your data, right? What is the skewness of the data? What is the distribution of the data? Are there some, anomaly, or how many null values are there, right? For example, you are, looking to use a particular column as one of your key feature in the data science algorithm, right? Then whether that column is a good choice or not, how many null values it has, or it has all the not null values, right? Because depending upon that data quality or data statistics, your ML model's accuracy is going to change. So the idea here is, again, the point to drive home is Azure Data Factory mapping data flow helps data scientists in this way. Right? You can do quick data preview, you can understand the statistics of your data, and it will help you to do your job better, as simple as that. So that there is a holistic coverage. At the same time, there is detailed enough coverage for each service so that you are able to learn it on your own in great details, in as much details as you would want on the job, or just for learning. Cool.
Okay.
So data transformations, expression language, and debugging, right? Some of the other features. So data factory has a lot of, again, these we will see directly into the portal when we see, but essentially there are, these different types of transformations, right, that you can do. For example, in a copy data data pipeline, you can create a new branch, right? I showed you something, right? Running one activity after the other. So you can create that kind of control flow. Whether you want to run multiple activities in parallel, you want to create some conditions, right, on the basis of which the flow should either fork or the flow should join, all of that. You can join multiple tables or multiple data source. So those kind of activities. Then you can filter some records from the incoming source. You can sort the records in certain order, right? You can do pivot and pivot. You can add additional column using derived columns. So all of these different kind of transformations can be done in a low code, no code way on the mapping data flow, which we will see, right? Through a tutorial, we will try to replicate some of these so that you will get a better understanding practically of that. So there is something called as expression builder, in which you define your logic. For example, there is a case function that is being defined, right? So how you define that, how you work with that, that we will see next time in the expression builder itself. Step by step, understand how your data transformation are working, so that you don't have to run the entire pipeline and then see the result. And then if you have 10 activities in the pipeline, and at the end, if your result is not correct, you will it will be very difficult for you to understand where exactly you went wrong, right? For that purpose, you have debugging capability. That means you can debug it step by step, one step at a time, and you can keep validating whether you are getting expected output as part of that step or not, and only then go to the next step. So debugging is also available. And this data flow debug, right, can also show you the statistics and all. So you can, actually as part of the debug, right? For example, this is the pipeline that you are that is created. I am on this particular step of the pipeline. Here I can do the data preview, so I can actually see whether I am getting the output of this step as expect. For example, it says future years after 1950. Then I can actually check once this step has run, am I getting all the years which are greater than 1950 or not, right? Or am I still getting some year which with a value equal to or less than 1950? If I'm still getting one such year, that means my transformation or my filtering is not working properly. So I can validate it then and there so that I can ensure that my code is going to run properly.
Jayendra, can we get any, practical examples, like in which way in a company we are going to work on in a real time project?
These are very much practical, right? So these are like modular and a small scale implementation, which are easy to implement and easy to demo it to you guys, right? In case of a real world, the same, right? What if I'm showing you 4 transformations in real world, that 4 might become 40, right? But the way of implementing, way of debugging, way of creating a pipeline will become remain very similar. Also, in real, to take a real world use case, right, you will also have to do a lot of preparation with respect to bringing a real time data, right, real world data. Then to understand that data, there will be a session required first to just go through the source data, right, so that you guys all on the same page. So that is not practically doable in this kind of format, but whatever we do in a small scale conceptual way, that you will be able to extend to your real world use cases. So there is deep monitoring, introspection of data transforms. That means when you run the data flow, right, for each step of this data flow, after it has run, you can get a lot of information. When you go and monitor it into the monitor pipeline phase, the pipeline will also look like this. And in each step, you can see, okay, how many rows got processed, how much time it took, etc., etc. So, step by step, lot of rich metadata information is available to understand your pipeline better. There are also scenarios such as schema drift. Again, one of the ETL scenarios. So unlike slowly changing dimension or de-duplication, which are very common scenario, schema drift is also a common scenario, or let me call it a common problem in the data warehouse world. And there is no easy solve for any schema drift, right? But data factory mapping data flow to an extent give you some kind of pattern matching to implement schema drift, right? So schema drift in general is never an easy scenario or a straightforward scenario to solve. Azure Data Factory gives you some ability, and there are documentation available as to how to implement a schema drift kind of pipeline, or a pipeline which will work without failing even if there is a schema drift on the source. I know I will come back to the core concept of schema drift in a moment, but just understand. So in data mapping data flow, you can implement a data factory pipeline in a way that it will handle schema drift. So that is also available if you want to use it. Is it the best way to do it using mapping data flow schema drift? If you ask me my own experience and how customers and partners do it, I would say it does not give you 100% solution for that. But in simple scenarios, you can try and do it using mapping data flow also. Now let's understand what is schema drift in detail. Okay. Now you can read through this slide also, but I'll explain you the concept. Now, for that matter, just take simple example, how data warehouse works, right? How ETL world works. In ETL world, you create some data pipeline. What that data pipeline is doing, that data pipeline is reading or looking at some source data, which is changing every day, right? I'm taking an example of simple batch scenario, wherein you are querying the OLTP data, right? In OLTP, you may have certain tables, let's say customer table, transaction table, banking table, whatever, right? Orders table, inventory table. So all of these tables get lot of data updates every day, right? Customers place orders or customer records get updated. There are new account balances, etc., etc. And the idea of data warehouse is you will read all these changed data from the source systems. You will bring that data into data warehouse so that lot of reporting, lot of analytics can be done on that data in the data warehouse. And then you can generate lot of different reports and dashboards. So that is the core concept of data warehouse, right? So for this kind of data warehouse, you have, every team will create number of data pipelines, right? Those data pipelines are scheduled and all of those data pipelines are running every single day, right? Now, unless there is an issue, everything is going good, fine, everything is nice. Okay. Now, one day what happens, right? And that kind of one day happens many times in production world, right? What happens? Let's say you have created a data pipeline. That data pipeline is looking at table A. Okay, that table A has got 4 columns, column 1, column 2, column 3, column 4. So you extract data from table A. Let's say you extract that data into a flat file. So that flat file has got 4 columns and a number of records. And now you have created an automated pipeline that will load that flat file into a target data warehouse table, right? Very common, very typical data warehouse scenario. Now this file has got 4 columns. So you have done the mapping that column 1 of that file goes to, let's say, column A of data warehouse table, column 2 goes to column B, column 3 goes to column C, and column 4 goes to column D. Okay. And that is how your pipeline is working every single day. Now what happens on the source side, that table A, somebody changes that table structure. They create, there were 4 columns, but they are implementing some change. So what they do is they delete 1 column. So now it has got only 3 columns, 1, 2, 3. So when that file gets created today, you get only 3 columns, column 1, column 2, column 3. And now your ETL pipeline fails because your target data, that process is expecting 4 columns. So it cannot insert into target table because that file format is not matching. Why this happened? This happened because there was a schema drift. That means the schema changed somewhere in the ETL pipeline. That is called as schema drift. Now, how these things are handled in production, essentially, these become a breaking change, right? This breaking change happens because your pipeline has broken. Then what do? There will be some error. There will be some tickets in production. Some operations team will try to look into it. Okay, let me see. Why the pipeline failed, right? And somebody will try to do the investigation and fix the pipeline. So somebody will realize, okay, there are only 3 columns. So let's do some schema change or some code change so that our script will work and it will take only 3 columns and only load 3 columns of my target table. So you will do that code change in production. Again, there will be tickets, lot of problems. You will go back to source team. You will tell them that okay, we are your downstreams. We are dependent upon your feed. So how can you change your source table without informing us, right? Because ideally, these kind of changes have to be coordinated across all layers, right? So if source is changing, they need to inform you that, okay, we are changing. So you also change your code. And again, if you are changing your code, if you have your downstreams dependent upon you on your table, then you also have to, inform, right? But things are never ideal in real world. And these kind of things happen, which create a breaking change, right? And because of which your pipelines are failing. Now, if you were to handle this kind of scenario in a better way so that your pipeline is able to accommodate any of that changes, right, or some of the common changes, then you will create a pipeline that is able to handle schema drift. That means even if the source schema changed, your pipeline will not actually fail. Your pipeline will handle it properly and it will still be able to run successfully. Okay, so for now, let me keep it to only that, because that in itself, schema drift are commonly occurring scenarios, but they are a challenge to solve in ETL world, right? Because things do happen in production without communication and things fail and one has to correct it, but there is no easy solve. right? So I will not go into much details as to how mapping data flow solves it, and how exactly. But if you are you can, and I have seen it practically, right? That will, let's say I was working with a customer who was trying to use Schema Drift scenario, and they were trying to address it with mapping data flow, but their scenario itself was so complicated that we recommended them that no, Mr. Customer, you please handle it through some custom code. Schema Drift mapping data flow feature is to handle more simpler scenarios, right? That is how I ended up advising them. But still, you can explore. If you are facing this kind of challenge in your production environment, you can explore this feature. It can make life little easier for you if there are frequent breaking changes in your environment, and if you are able to apply some logic to handle it automatically. Cool. Any questions now? I think that's where we will stop today. We are already around our closing time, but I'm happy to take any questions, and we will continue in the next session where we will start with the implementation of a mapping data flow. So we'll try to implement a simple mapping data flow, and I will also show you so somebody asked for how a production grade data flow look like, right? So although we can't spend so much time in implementing those, right, because that will take hours together, but I will give you a flavor of how it looks like, right, through a demo that I will create, so that you will be able to, we will work on some simple scenario hands-on, and I will show you a lot of other complex technical scenarios.
Let's have a quick quiz question, guys. What language is commonly used for writing transformations in Azure Data Factory? Python, SQL, Java, or C#? Please mention your answer in the comment section.
Just a quick info, guys. Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
Like this site says, it is code free. What all you can do data cleansing operations, some kind of transformations, aggregations, conversions, data preparation and exploration. This is a typical modern data warehouse pattern that we had seen, where data factory can be used for ingesting the data, as well as it can be used for the orchestration and transformation part of that as well, right? And in the new world, right, with data factory allowing you to do low code, no code transformation, this is how the architecture will look like. That on here, the data factory is being used to ingest the data, load the data. On the other hand, the data factory here, along with data bricks, can be used for data transformation as well, once you understand mapping data flow. Now let's continue. Pipeline execution, right? So this is how your pipeline looks like. You can add mapping data flow just like another activity in the pipeline, right? That means if you see here, there are different activities in the pipeline. First is copy data, right? Then you have some kind of data flow, right? So you can trigger data flow one after the other, or include that as a, so once you create a data flow, you can, if you want to run that, you have to make it as part of some pipeline, because your executable is the pipeline, right? All other things that you are creating are mostly activities, or some of the other artifacts such as linked services, which is nothing but a connection to a source system, or a data set which is pointing to a specific table or file within the source system or within the linked service. Some of the common scenarios that we had seen, right? Slowly changing dimension. So how do you maintain a historical state of certain data? For example, how a status changed for a customer from active to inactive to, let's say, dormant, right? In case of a banking use case. So how do you maintain that in a slowly changing dimension scenario? For that, you can use mapping data flow, right? That is the understanding from this slide. but we also understood the concept of slowly changing dimension and why it may be useful, right? In an OLTP world, you only store one record for each customer, for example. But on the other hand, based on the changes of that customer's certain attribute, you may want to maintain a historical state changes, right? Historical changes to certain attributes so that you are able to do some kind of analytics. For example, in case of some mobile applications, you want to track monthly active users, right? So which are the users who were active in this month, again inactive in the next month, active in the another month, right? So you want to understand some kind of pattern. When most of my users are becoming active, when they are becoming inactive, which days of the month. For example, let's say a banking application, right? So I use my banking application definitely around the time when I get salary, right? That means around end of the month, at least I log in once to check if the salary is credited, right? And in between, I may use it for some kind of transaction. So if my bank wants to track how my customers are using, or what is the activity that we are doing day-to-day basis, you could do that using slowly changing dimension and other things. Then deduplication is another common scenario. If you have more than one record for a given primary key, how do you want to do duplicate? How do you select the record that you want? Let's say the latest updated record. That is the deduplication. Then how do you load a fact table in a data warehouse, right? So loading a fact table, dimension table, all of these simple ETL pipelines that we will see. Then there is fuzzy lookups. So there are different types of lookups that are available. Then there is data lake, data science scenario, right? So we saw how it helps data scientists. So when you are previewing this data using data preview, which we will do today, right? You are able to understand the data, different attributes, different skewness, so that you can select the right set of attributes as your feature. So this helps in feature engineering to the data scientists, right? Then some of the other things, we notice that there are these different types of operations that are available. We will see most of these in practical today, right? Then there are expression builder that also we will see. You can do debug mode, right? All of that are possible. Then we also talked about a schema drift scenario. What is a schema drift? Schema drift typically is a problem when your source system or your upstream system has made some changes which create a breaking change or breaking failure in your pipeline. So somebody changed, let's say, total number of columns from 10 columns to only 8 columns by dropping 2 columns of a table. But your data pipeline is expecting 10 columns, right? So your pipeline starts to fail because in the source data, you only have 8 columns today, right? So these kind of changes create problem and you have to fix them. It is difficult to address these problems in timely manner in production because they are essentially creating a breaking change, right? That means something is actually breaking. So how do you handle that, right? Those kind of scenarios can also be built using. So while that opens, right, there is also, so if I search for a tutorial on the Azure documentation, you have a lot of tutorials, right? So this is the documentation for Data Factory. If you just search for Azure Data Factory, right? Say what I searched for is ADF mapping data flow tutorial, right? Or if I just search for ADF documentation, it will take me to Azure Microsoft's documentation page. From there, I can search all the tutorials that I want, right? So if I want to go, let's say, to the overview, and in that I can see, click on tutorials. So this is just for your future reference, right? So you can try a lot of things that are available in these tutorials, right? These tutorials are very step-by-step, screenshot by screenshot tutorials, so that you don't get missed or you don't miss any step. So these are very well written, well documented tutorials. There is just one tip, right? One guideline to follow the tutorials. You should read every step of the tutorial. You should not try to jump ahead without properly reading it, because if you miss some step, then you will find yourself that, okay, somewhere, you are not able to follow the tutorial or some error is coming. But if you follow it carefully, read it carefully, then most likely you will not face any challenge. So let's do one such tutorial. So if you go on transform data, you can click on transform data using mapping data flow. Okay. So if I click on this, then you can select any of these data flow, right? So let me select this. Now, this is a very quick tutorial that will help us how to create a mapping data flow, right? And how to start analyzing the data. And we will have to read it, very carefully, step by step. So for the first time, right, I will do it along with you. But when you are doing following these kind of things offline, you will also see for example, there is this mapping data flow video tutorial. They have also, the best part about Azure Data Factory is, for all different types of transformation, they have created a small video to guide you about that transformation. For example, I think, let me find where are those videos. I will also share, find and share the link of that complete page where you have all the videos. Maybe it is in the how-to guides. Let me try to click here and see. Right, in the author mode, you will see you can create pipelines, you can create CDC capture. So this is a way to, if you are aware of change data capture, right? So this feature is currently in preview, but you can create a CDC pipeline to source data from a CDC based database, right? There are data sets that you can create. There is data flows that you can create, right? So this is the one thing that we are trying to create now, Azure or Data Factory data flow. Now I can create a new data flow from over here, or I can click over here and try to create a data flow, right? So these are the ways, but let's go and follow our tutorial first, right? Let's read through this. What we are trying to do is we are going to transform the data using mapping data flow. So we'll follow this tutorial and we'll try to learn how to create a mapping data flow and how to do some basic transformations in this, right? As part of which our concept of creating a mapping data flow and trying some transformations will be clear, and you will understand how you can do different transformation. If you want to try any other transformation, there are quick videos available, or you can follow the tutorial documentation and you will be able to follow that and do that, right? So let's get started. Now in this tutorial, what it will do right now, since I have read this tutorial many times, right? So I may be running it through a little faster, but when you are doing any tutorial, ensure to read it line by line and don't miss any step. That is the important thing. Now in this what we are going to do is we will use Azure Data Factory, right, to create a pipeline which uses a copy, right? We will copy and transform the data from ADLS Gen 2 storage, and it will keep it the transform data, it will put it back into ADLS Gen 2 as a sink, right? Sink is nothing but destination. Now let's do this. What are the in this tutorial you will do following steps: creating a data factory, which we have already created, right? Create a pipeline in the, with a data flow activity that we will do. Build a mapping data flow with 4 transformations, right? We will see what those transformations are, and we will build a pipeline with MDF, mapping data flow. Then we will run that pipeline and we will do monitoring activity, right? So we'll try to understand what happens in each step of the transformation. Cool. Now, so these are the things that we will do, right? Understand the prerequisite. We should have Azure subscription, which we already have. We should create a ADLS Gen 2 storage account. Okay, that also we have. It says there is a file that we are going to use for this transformation in this tutorial. This file is called as moviesdb.csv, which can be found here, right? That means from here you can download. For example, if you overread this step, you will come to the next stage and you will realize, okay, I don't have that file. So that's where reading it is important. Read it carefully one by one. Then it says to retrieve the file, whatever. We can download that file. I already have downloaded it, so I will use that. And it says upload that file into your storage account, right? Upload it into Blob storage account or ADLS Gen 2 storage account. Next is create a data factory, which we have already done. I'll just walk you through how these tutorials are created step by step, right? So you go to create a resource on the Azure portal, you select data factory. In that you type your subscription and resource group, right? Then you give name to your data factory and you select the region in which you want to deploy, right? It will create a data factory. Then you can launch the data factory. You can go to your resource and then navigate to data factory page from there, from where we launched this, right? So we went here, clicked on launch studio, and then your data factory opens. Okay. Now, once it is opened, you can click on orchestrate, right? It says now let's create a pipeline with a data flow activity, right? You can directly use this shortcut that is available over here. So let's try and use that. Let's go to home page, click on orchestrate. It says code free data pipeline. So click on this. Okay, what it did is it created a pipeline for us, right? We can give that pipeline some name. Let's say MDF pipeline. Okay, so I'm just giving it some name. You need to follow the tutorial, right? So if there are some specific, you see in the general tab, use this name, enter transform movies as the name for the pipeline. So right, rather let's just follow that. It will not make a difference, but it's best practice to just follow it so that you are not missing any step, right? So I'm giving the same name as recommended in the pipeline, right? But some of these things, as you can imagine, they will not matter too much. The more important thing are those steps that you have to follow. Then in the activities, right? So it says in the activities. So what we have created is a pipeline. Now to run that pipeline, right? Or run some code as part of, do some transformation as part of that pipeline, we need to call a mapping data flow in that pipeline. Okay. So we have to go to data factory. On this right side, right? These are all the activities that are possible that you can call in this pipeline. So I'm going to go to move and transform, and here is the data flow option. All right, I will drag it and put it over here. Okay, this is my data flow activity. It was for some reason it was zoomed out so much. I don't know why, but you can adjust from over here, right? You can see, for example, if you create a very big pipeline, right? It has hundreds of steps, for example, then you can zoom in, zoom out to see it visually how it looks, right? So nice interactive kind of UI. Now you can again maximize this to see it or minimize whatever, right? Adjust these things. Now this is the data flow. Now do we have any existing data flow? So you can go and in the setting you can select if you had any existing data flow. But do we have any existing data flow? No. So we are going to create a new. Let's go back to tutorial, do it step by step. And it says create a new data flow, right? So now some of these screenshots may be slightly older, right? But the product may have changed slightly here and there, right? So we will go to settings and click on data flow, that is new data flow. It will open this in this new, it is called data flow 1, right? We can change the name, whatever is mentioned in the tutorial. Okay, now this debug data flow we can turn on. For example, over here, we can turn this on. What it will do is it will create a cluster for us, right? A Spark cluster that will help to debug this data flow, right? And the time to live is, that means when I am using this data flow cluster, debug cluster to debug my pipeline, you keep it on for 1 hour. If I am not using that after 1 hour, if it is idle for 1 hour, then you can like close that cluster or terminate that cluster so that we can save cost, because it comes with certain cost, because now you are actually asking Azure Data Factory to create a Spark cluster in the background that will help you to do your data flow debug. Now again, that's serverless, so you don't have to follow it, right? You don't have to manage it or do anything with that, but you are just setting default time to live, that okay, let it be active for 1 hour after the idle time. So I'm just clicking OK, and it will create a cluster for us. Now build transformation logic in this, right? So we want to build a transformation logic in this. So we can, let's start with add a source. That means you want to add a source of the data. This is some kind of data transformation. So you have to first add a source to that, right? If you clicked on that. So this is a source icon, right? Now here I want to select a source, which is my file, moviesdb.csv file, right? That means this source has to be a data lake storage and that particular file location. Now, do I have a data set already created? If I had a data set already created, I could have gone to source options, no, source settings. And from over here, I could have selected a data set, right? Which is pointing to a particular file. But I want to create a new one, which is pointing to that file, moviesdb.csv. First of all, let me go to some of my ADLS Gen 2 storage to see if I have already copied that. So let's go to this ADLS account, right? Let's open this account. Let's go to storage browser. Let's go to storage browser again. And it's still showing overview page. Give me a moment. Open in Explorer. You typically don't have to do that. You can, I don't know, there is some issue with the Azure portal, because otherwise typically when you go to ADLS Gen 2 account and you go to storage browser, it opens right there. And it shows you your blob containers, directories and all, right? Oh, it's showing containers from over here. We can go from here also. Let's see. Okay, now we were going to do a data preview. So here you have a data preview. That means you have now pointed, you are pointing to this particular file. Let's do a quick data preview. Let's see if it can bring the data by connecting to that file in our ADLS Gen 2. So this data preview, right, like I had said, this is the option which helps data scientists also to better understand your data. It gives you some statistics about data so that you can understand, which columns can be are having good quality data, which columns you are thinking may be useful, but they have data quality issues. That okay, a lot of rows have that column as null, so you may not be able to better use that. So all of those kind of things. Okay, this typically doesn't take so long. Let's wait for it. Yeah. Okay, now as you can see, it says, these are the information: movie, title, owner, right? This is the first row, all the records that you are seeing from the file, right? This is the information that you have got, and first 100 records or a few starting records are available for you to understand the file format, right? What kind of data types you have, what kind of data do you have, right? Let me go back to source settings over here, and then in the dataset setting, if I click on first row as header, right? If I click on this first row as header and publish all these three things, it will not allow to publish because it says essentially when we are creating the data flow, right? You have to add a sync transformation to it. That means a destination, because this data flow is incomplete. It just has a source. It does not have a destination. So you have to add a destination to that, so that whenever you are pointing to or using that, essentially it has some source and then you are landing that data. You are ending it properly in some kind of thing. So I can click on plus and then add this sync. This is the bare minimum, 2 operations, but let's wait for that, right? So let's continue. In fact, because I want to use, I want to set that first column, right? In the data preview, you would have noticed that my first record is not being used as a columns, right? Column heading. So to save that, right? Just to kind of save that setting, what I'm going to do is I'm going to create a new data set, right? Change this data set to a new data set so that there are no further challenges. I'll tell you why, right? Then CSV file, I'll point to the same linked service and I'm going to, okay. So before you actually say, there is this first row as header, right? This we have to tick. Now I have clicked this. In the earlier data set, I had not ticked this box. And even if I had not ticked this, I could have done that later, but just to save time, right? I am just doing one. Let me browse this and point to this input directory. Click OK. Oops, I want to select that file name. Click OK. So it is pointing to our specific file. I have ticked as first row as header. Okay. So I have not given it any name. So it's like delimited text. I just kept it default name. Now if I do a data preview of that, hopefully our first column headers should be used as should display over here as column names. Okay, now you can see movie is a column, title, owner, year, rating, all of these are coming as a first row has been treated as a header row. Now, if you go back to tutorial, right? So it said, create this, and then I think we had done a data preview, right? We had clicked on data preview. If you notice in this screenshot, they have said, tick this box, right? So they have also clearly mentioned this. So this is what happens when you are missing some of the instructions. If you are not following properly, then, and if you miss to check this setting, I will tell you what kind of problem you can get into, right? I will also show you that. For now, I have just avoided that because I realized by doing the data preview, and that's what, right? You can also, this helps you to identify the problem in your pipeline then and there. Since you are able to preview the data, you realize that earlier I realized that my first row is being treated as a data row. So I have missed that setting, treat first row as header. So I was able to correct that because I could see this. Imagine I had built a complete data pipeline, and then at the end I'm realizing, no, my pipeline is not working as expected. Rather than that, you can solve it step by step. So our first step is done. What next? Okay, we went to data preview. We are able to see the data like this. Now, next, you want to add next to your source node, right? We can click this plus sign. Now, what we want to do, we want to do some kind of row filter operation. Okay, so let's do that. Now, here I will click on plus. Just see all the options that are available, right? Before we go back to tutorial. So you have multiple input and joins, right? Multiple input output. That means you can add, for example, you can add another source here, right? Configure this with the right data set. But then, and after that, what I can do, I can probably join, right? So I can do the join operation. I can join it with another data set. So let me reduce that. Then I can do a conditional split. That means from this point, I want to set some condition, and I can add a flow over here, and I can add another flow over here. I will show you all of these, right? Or some of these actually use in a production grade pipeline in some time, right? Because if we start doing every single thing, this timing that we have will not be sufficient, right? So let's see, right? So what are the other things? There is, I can use an exist operation. For example, if there exists and then certain criteria, and only then go further, right? Union operator, that means doing a union over two data set. So for example, I had two movies db.csv files, right? And I want to do a union. That means take data from this as well as take data from this. Then I can do that, right? Next, what I can do is look some kind of lookup activity on that. Then some of the other operations. What is schema modifier? Then I can add a derived column. That means there are some 4, 5, 6 columns that we saw in this. Using those columns, if I want to derive another column and make from 6 columns to 7 columns, I can do that. Or I can select some from certain specific columns. So I don't want all 6 columns to go forward in the pipeline. I want to pick only 3 columns and then work with it. I could do that. Then I can do some aggregation, add a surrogate key, pivot and pivot window, all of these, right? And the documentation link that I was talking about, right? That will give you a detailed video for each of these transformation activities. If you want to learn about any of these, or you want to try of any of these, you can follow tutorials, and I will share a link of the of that Azure documentation page, which has for every single transformation, you have got a nice video, quick 5-minute, 10-minute kind of video that Microsoft's product engineering team has created for this to follow and learn. Now, so these are like schema modifiers. What next? You have formatters. You want to flatten the file, right? What is the flattening operation? For example, if you are working with some kind of JSON document, right? I don't know how many of you are aware of JSON, but JSON is a key value pair, right? You want to flatten that. That means from a key value pair kind of a documentation, if you want to change that to a more structured or a flat file or a tabular structure, you can do that. You can parse, you can stringify some of the operations, you can check in detail. Then there is row modifier. That means if there are, let's say, thousands of records in this source, but I want to work on certain records and filter them. For example, I want to select records only for current year. then I can filter. I want to sort, alter records, or do some kind of assert operation. You can check all of these operations in detail. Then there is something called flowlet and sync. What is the mandatory after the source? Sync is mandatory. Without this, you cannot complete your data flow. And let me delete this another source. Okay. Now let's go back to tutorial. What does the tutorial says? Do a row filter, row modifier filter operation. So what I can do is go back over here, click plus, and I can quickly search from here like filter, or I can just scroll and click on filter. Right now, what kind of filter? We have to specify some filtering condition over here, right? And this is where you use expression builder. Now, what is that filtering condition? Let's check it, right? Now, name your filter as filter years. Okay, let's do that. Filter years. What next? Right now, click on the expression box, right? This is the expression where you will specify your condition, right? To filter on our and to open the expression builder. So we'll click on this block and it will open an expression builder. Let's see what that expression builder is. Open expression builder. Okay, this is where you will build your expression. Now you want to filter on some columns, right? So whatever columns that were available in your file, those are already available over here. For example, year, right? I want to filter on year. So if I click on year, you will already have an year over here, right? But what is our source data? The source data is a CSV file, right? That means those columns may be considered as a string data, right? So what I will do, we'll convert this and we will do, let's say, 2 integer. So we'll apply this function, 2 integer, and then maybe this value is year, right? So that means I'm converting my year to a number value first, so that if there are any data type issues or whatever, I can first convert into number and then do, let's say, year greater than 1950 or whatever I can do, right? And I can check whether this expression builder is working fine or not, right? If there are any error, it will kind of give you that error. For example, let's say if I do something like that, minus, and if I just do this much, right? So what it is doing, it is converting from this to this, which might also work, by the way, right? So if I have any syntax errors, right, it will point out that if I try to save and finish, there it says expression type could not be evaluated, correct the expression, right? That means I have some issue in that. Okay. Now, before this, we complete, right? Let's go back to transformation. Now, what are the transformation that we have to add? So data flow, right, lets you build your expressions using expression builder, right? And in this tutorial, you want to filter, you go through, please read through everything. Now, there are also number of built-in functions that are available. Okay, by the way, what is the language? What is the programming language that is used in this expression builder? The programming language is Scala. Right here on the top right corner, expression reference document, right? You can click on this documentation link, right? So you can understand there are documentations embedded everywhere, right? So how to use this expression builder, it will point you to the document where you can learn much more about that. Okay. How it works, what are the different functions that are available. If you wanted to take an absolute value, ABS is the function, this echos is the function to calculate cosine value, etc., etc. A number of functions that are available, all those are listed over here. If you click on those individual function, it will guide you through the syntax of that function, how that function works, how to do, right? Then all of this, how to list all aggregate functions, array functions, date and time function, conversion function, all different types of functions that are available and supported. Now, and these are the columns that you can work with. If you keep scrolling down, these are all the functions that you can use, directly select from over here. Now, let's go back to our tutorial. What does the tutorial says? It says we want to filter movies of particular comedy that came out between year this and this. As year is currently a string, right? Because you are sourcing it from a CSV file, you need to convert it into integer. So we'll use 2 integer function, and we can use greater than equal to or less than equal to operators, right? So essentially, this is how our command is going to look like. In the expression builder, in here, I will just copy paste this. Okay. Now, if I try to save and finish, by the way, there is no error in this, right? I can click on this and open again because I want to add one more filter condition. What is that filter condition? That condition is my genre should be comedy, right? So how you do that? We are using a R-like function, right? So these functions, these are simple string functions that you can see in the documentation and use. So I want to add one more condition. This is the condition, additional condition, to check only for comedy genres, right? Or at least it should contain comedy. So a movie may be a comedy plus suspense thriller, plus romantic, all of those kind of, but it should contain comedy. Now I'm going to add that additional filter over here, right? And save and close. Now let's go back over here. If you go to the debug cluster, now if you have a debug cluster active, we do have our debug cluster active right now, right? And if we go to that step and refresh, we will be able to see our data. Now let's go here.
Jay, the double.
So this is test data, right? That's why they have particularly put some kind of data in a way that you are able to test. For example, there is this movie 1902. This you should not see in the next step, right? Based on the filters that we are applying. So let's go over here now. And here, let's do a data preview. Let's do a refresh. We will be able to see if this step is working or not, step by step. So because the debug cluster is on, so it is actually going to run that for you, run that step for you and show you the result, right? So now you can see, okay, all the records that I have got, contain comedy, and the year range is also between the expected range, 1910 to 2000, right? More or less the data is looking fine. So let's continue. We know that our step is working. Let's continue, right? So data preview, we already done this. Now next, so what operation we did so far? We did a filtering operation. Now let's do an aggregation operation. Aggregation is what? Working on all the number of rows and doing some kind of count, average, those kind of things, right? So we are going to do some aggregate. Let's do that. Over here, click on plus and let's do aggregate, right? What aggregate we want to do? Let's click on this. Let's give it some name as per the tutorial. Now in aggregate, you typically use the group by clause, right? So how do I want to group it? First of all, let's understand our requirement, right? We want to do aggregate. What we want to do in the group by clause, it says select by year, right? And then we want to aggregations by the year. That in each year we want to see the movies that came out, right? So here we are going to say average comedy rating in the group by year. Okay, so let's go back over here in the group by column, right? How do I want to group? I want to group by year. And in the aggregate, what kind of aggregation I want to see? So I am grouping the records by year. That means for all the records which are in, let's say, 1 year, 1910, and on top of that I'm going to apply some kind of average rating. So what is the average rating of all the movies that appeared in each year, right? That kind of information if I want. Let's go back to this, right? What it says, use the average function, right? Go to expression builder and we will use this average function, and we will do that, apply that average on the rating column, right? So this is the average, and rating we are going to first convert into integer and then do an average of that, right? So how do we do that? Here, select the rating column, right? And here we can build the expression, open expression builder. So here, let's do to integer rating. And we'll try to just apply average function on that. Okay, let's do save and finish. Now, if you can see, now there are only 2 columns, right? Because we are, when I try to save and finish, it will say something is not wrong. Aggregate column, right? Some error is there. So you can go to expression builder and see what is exactly the error, right? And if you don't know the syntax of any of these functions, right? You can go to the documentation over here and learn it, right? So it's very quick and easy You can learn from over here what are the mandatory. For example, when I do 2 integer, right? 2 integer. Then it says first provide the value, then provide the format local, right? I know these are optional parameters, so I am not using those. All right, but any of these, if you don't understand, right, you want to learn more, you can go to expression builder and understand those functions in detail, right? So I've done average rating. I'll do save and finish. A wise interviewer would know, will expect that from you. And okay, if you don't know the answer, how will you find the answer? You will go to Azure documentation. There you will find, right? You know, you build this in expression builder. You know that, this data cluster, when you do the debugging, this is how you can debug and build your pipeline. The cluster that is created in the background is a Spark cluster, right? These basic you should know, and you should be able to guide them, right? You should know what are different options available to build different types of pipelines. So, it will be silly of an interviewer to expect, a syntax. I think those maybe early on for a fresher, if there is some written interview or written test, there they may, ask that, but definitely, you can't expect anybody. I mean, if I am an interviewer, right, which I've taken hundreds of interviews, right? I would never expect a candidate to remember syntax necessarily, right? You have lots of documentation to correct that. Your logic should be good. You need to know what you want to do or how to solve a problem, not exactly every single step of it. And while that comes, right, let's continue on the tutorial side. Now, it will give you average comedy rating and whatever, right? So now next what we want to do is add a sink, right? That means, okay, we have got all the transformation that we wanted, right? We selected all the movies, all the data in the movies file. We applied some filter to select only the records that we want between the certain year range and whatever additional genre comedy level input. So for example, let's say, your company had asked you to prepare this kind of thing. I want average rating of all the movies year wise, right? And that too only for comedy, right? The genre should include comedy, and do it only from year 1910 to 2000, right? And that's how you are doing. Now that you have done the transformation, you want to store that data somewhere, right? So you will add a sink, the destination of the pipeline. Here again, you will select a data set, right? That means that that output of this mapping data flow will be stored somewhere, right? That somewhere we will select, right, how to do that. And for that, what you are doing is you are creating another data set. This is another, let's say, ADLS Gen 2 storage account, and this is the kind of file you want to create. And you want to, let's say, you will select the location in the output directory, you will try to put it, and then you will debug or run the data flow to see if it is working fine or not, right? So let's do all of that. As you can see, I am already seeing the average rating of year wise, right? All of these. So that means my pipeline is already working. It's just a matter of putting this data into a destination file, right? A sink. Again, let's just do the sink setting. Sorry, here over, I can select the data set, right? Click on new. Let's say I want to store it into ADLS Gen 2. If you had a table, let's say if you had a database table in Azure SQL DB, right, which has 2 columns like this, year and rating, and you want to store it into a database table, you can also do that, right? From over here, you can select a database and then, select a table in which you want to load that, and it will directly load into that table, right? For now, we have not seen any RDBMS, any table, so let's not jump onto that. ADLS Gen 2, continue, CSV file or delimited text file, and I'll call it just that. And this is my linked service. This is the data lake storage. I'll try to select the directory in which I want to copy it. I'll select the output directory. I already have one. Okay. Now in this directory, I want to copy that. Okay. Now just remember, there is already some files that are available. Hands-on command, movies.csv. This is not the file that will be our output file. Okay. So these are already existing files. What I've selected is a file path where to copy this, right? Here again, I'll say, let's say first row as header, and I'll click on OK. Okay. Now my pipeline is ready to run. Okay. Now what I can do is, now this is a data flow. Can I run a data flow from over here? Do you see a trigger option? You don't see a trigger option. Why? because this data flow is an activity, right? This is the data flow. I have to just use this as an activity, and then any activity, right, I can add into my pipeline. So this is the pipeline. This is the data flow, right? In this data flow, we created the data flow and we created all these steps, right? So pipeline is something that you can run, right? I can trigger or I can do a debug, right? If I try to, it says trigger test runs from current pipeline without publishing your changes. Oh, I should have rather published my changes. But anyways, let's see what happens. Otherwise, we'll publish and do it, because I made all the changes. In between, I created some objects, some data sets, some linked service. Linked service we used existing, but these data sets got created, if you see, right? And I created a data flow. I created a new pipeline. So I should have published that ideally and then run it, but shouldn't matter. Let's just see. So this data flow is now running. I will click on these details. Right. When I click on this detail, I can see what is happening in each step. Right. So it has already progressed to the sync stage. Right. So what happened in this, right? So in step by step, we can see it's trying to load. Okay. So sync is already done, right? Total rows calculated 1 or whatever, right? Let's just see what happened. Once this finishes, we will go back and see what happened, right? If our data got copied into destination or not. So it is currently in progress. Let's give it some time. Shouldn't take too long. If I go back to our monitor runs for a moment, see in the monitor, you will see this pipeline. Oh, that was the old pipeline, sorry. Let's go back over here. We were doing a debugging of this. This is the data flow in the debug mode, right? So if I open what happened with this, you can see it has finished. Now I can click on each transformation and understand each step of the transformation and understand what happened, right? These were the total rows calculated. Then, in this step, what happened? What were the rows? So from 9,000 plus rows, based on our filter, we reduced to 2,000 rows, right? 2,000 plus rows. And then we did the calculation on year, right? So you can see some statistics over here, right? How the partition chart and other things look like. Then total, there are 83 rows that were selected, right? And then finally in the destination, all 83 records got copied. Okay. It also tells you, how much sync processing time. There is a processing time that, for everything. This stage, this much is the time, right? Then for next stage, how much time, right? So all of these things you will be able to note, and you will be able to understand how your data flow is working. Now, let's go back to our destination folder, right? And see how the data has landed over there. And it will be interesting to see how the data gets created. Now, okay, this is our place. Go to directory, go to output, and just see the number of files that got created. So there is this hands-on command file, right? There is this movie CSV file. These were the two existing files that I told you, right? These were the older files. But now, these are the files that got created as part of the output. Now you must be wondering why there are so many files, right? So there is by default some partitioning that got applied on this file, right? Why that got applied and where can you change that setting? Let's go over here. Now let's close this. Let's go to our pipeline. Okay. Now, this is our data flow. This is our pipeline, right? And in this is the data flow. Now, if I go back to this data flow, right, to understand it more. Now, let's check settings one by one. Now, in the destination, you realized that there are many partition files got created, right? So the total data that you had, it got split into certain partitions, correct? Now, why is that useful? First of all, let's assume that you are working on very large amount of data. You are working on millions of records, right? Now, is it wise to put all the millions of records into just one file? Typically, in production grade environment, you would not want to do that. Why you should not do that? Because if you are creating just one file, you are limiting the ability to do the parallel processing, right? Because let's say I created this data and I want to now read this data. I want to use this data to do some another processing, right? Now, if this data, let's say, imagine this final output was again millions of records, right? And if those millions of records, if they were in one file, that means I will have to just work on one file at a time, and I will not be able to do a lot of parallel processing, right? But on the other hand, all those 1 million record, if I applied some kind of partition technology or partition method to that, and on that basis, if I divided the total data into, let's say, n number of partition files, then by default, it did the partitioning, right? It identified some of its own logic and it did some kind of partitioning. You can see that, right? But you can change that also. You can apply your custom logic. But why it is important? You should do the partitioning so that when you are reading it the next time, you can read it from the folder at a folder level, and all those files can be can be used in parallel, right? To do the next set of processing. Now, how do you do that, right? How do you change that setting? In the sync setting, if you go to optimize, it says use current partitioning. That means whatever default partitioning it identified, it said, okay, let's use that. On the other hand, when you select single partition, right? When you select single partition, that means it will just go to one file, right? On the other hand, you can select some partitioning, right? So here you can select how many partitions you want to go it into. Round robin will be random, right? That means all the records will be evenly distributed. If you select 3 partitions, that means first record goes to first file, second goes to second file, third goes to third file, again fourth record goes to first file. That's how the records will be distributed, right? That means here in the output, you can expect 3 files, right? Then you can do some kind of hash partitioning. What is hash partitioning? You can select a column, right? You can select year column, right? And on that year column, they can apply. That means it will apply some kind of hashing function and it will split the data across 3 files, right? Or across, let's say, 2 files, 10 files, whatever. So that means there will be 10 files that will be distributed across by applying some hashing function on the year, right? And likewise, you can do dynamic range partitioning, fixed range, key range. Most commonly used partitioning is hash partitioning and round robin. Okay, when you have a right key to identify, if you want to split the records by year by applying some kind of hashing on year, you will use hash partitioning. By default, if you don't have that specific key to identify, then you can go for round robin, right? So, and you can specify the number of files in which the output should be distributed. Now, if I, let's say, for the purpose of simplicity, I know my pipeline is not going to generate, a lot of data. I want to keep it into, for example, if it was a dimension table, right? I can keep the partitioning to single partitioning, right? And I can now just create a single output file in which all the data will be loaded. In the settings, I can, check some of the other information. Do you want to clear that folder? So all the contents of the folder will be created every time the pipeline runs. Some of the additional settings you can check. For every setting, there is this information icon that is available that will give you some information about it. And errors and all other things you can check. For example, what is the error, right? If there are errors, where do you want to put it? You can log all your errors. Somebody was asking me that, right? You can log all your errors into some other file, right? Output to sync and output to a separate file, all of these things, right? How do you want to treat your failed rows, right? If any record fails to load into, this is a file, right? So everything will work. But if it was a database, and in your output, if you have certain column value, which is not meeting the, table definition, then that row will be failure row, right? And you can define what to do with it. So all of these things are available. Some of the mapping options, optimize is again that partitioning. You can inspect some of the things, right? How it is going to look like, how is the, input and output. Now let's go back to this. Now let's publish. We made a change to this, right? To use a single partitioning, we can go back over here and we can, let's say, publish all our data and click on publish. By the way, let me open this data set also for a moment. I will click open. let's understand the properties of this data set, right? This data set doesn't have any specific file name, right? So default file name will be created. Now, if I look at some of the other things, so it says default is a comma delimited file, right? And some of the other settings are default, because of which you will notice when this file gets created, it will be created as a simple delimited file, and the output could be .txt. It's I'll keep it to default setting, right? And let's see what happens. Let's rerun this pipeline now. So I'll just, not rather than debugging, I'll say trigger now. That means I'm triggering using the last published configuration, whatever I published. Click OK, and it is going to trigger that pipeline. So that pipeline is now going to run, right? So view pipeline run, I can monitor from over here. It goes into monitoring and pipeline run. This is currently in progress, right? The data flow activity is running. So if there were multiple activities in this pipeline, then you can see step by step which one is running. Or you can go to just monitor pipelines, select, refresh this, and this is the one that is currently running, right? In progress. Click over here and you will be able to monitor. Let's keep refreshing. Let's see what happens. I think it will do its default calculation of how to distribute the records or how to create partition, and it is never advised to keep it to default. You should use either round robin or hash, or you should use single partition if you know that there are going to be less number of records, right? Okay, it says part merge.csv. This is the new one that got created, right? All others are having timestamp of 9:07 p.m. This is the 9:22 which just got created, right? If I click over here, it just took its default name because we did not specify the name of the file, right? And now if I just download this, this is a single file where you will have all your data. We got this file got created. These are all the records, year-wise average rating of all the movies, and that too the movies were filtered on year as well as the owner. Okay, this is the output, and all the records have got landed into one single partition file. Now, see, there is some demo environment that I have got, right? In this, I have created, there are a number of pipelines that are created. Okay, so for example, if you see, these are all sets of pipelines, right? It says, so this is some kind of demo environment that I have, right? And there are a number of pipelines that are created. This is just a glimpse, right, into when you start working on real world projects, how these pipelines would look like. And in these pipelines, I may be calling different types of, using different types of activities, right? What are these? Let's check it one by one, right? So this is a data pipeline, right, in which I am connecting to SAP HANA source. This is my copy data pipeline. What I'm doing in this pipeline is connecting to some kind of SAP HANA database, bringing the data into ADLS, right? And then after that, I'm calling a data flow. Now, what is this data flow? Let's see this data flow. This is the, let's open this data flow, right? Let me go there only. This is the data flow. What is this data flow doing inside that pipeline? First, we are taking data from SAP HANA. Okay, let's say there are 26 columns that are available, right? This is pointing to this SAP data set and all. Then I'm filtering only on last 5 years of data, right? Some filtering operation. Now I'm doing, after that, what I'm doing is I'm doing some derived columns, right? So after 26 columns, I've added 3 more columns in this derived column, right? Or I have added few more columns. So these are my derived columns. Now after this, I am doing a fork, right? That means from this point, I am changing, or I am following 2 data flow, 2 parallel paths, right? In one parallel path, what I am doing is I am selecting only required columns. So this is select operation. Here also I am selecting some required columns. So here on the first path, right, what I'm doing, taking some data from SAP HANA, filtering for last 5 years of record, selecting some specific columns or deriving some additional columns, and all that data I am loading into a sink. What is this sink? It says load to Synapse. That means this is a table, this is a table in Azure Synapse Analytics that is created. If you see, this is the data set in Azure Synapse Analytics, and it is pointing to a specific table. If you want to see that, I can open this data set, and we will see this data set is pointing to a particular table over here, right? This is the table, dbo.customer sales HANA. In this table, the data is going, right? Just showing you some sample pipelines. Now on the parallel track, right here, what I'm doing, I selected a few columns. I'm running some aggregation on that. So I'm trying to find total sales by year and month. That's some kind of aggregation logic that I have put over here. And again, I'm loading this data into another table. So with the same data source, I did some filtering. I then started two parallel paths, and in one path I selected number of columns and inserted all records. On the other hand, I did some aggregation, right? And that I'm loading into aggregated table. What this table is, this is again another table into Synapse. This is aggregated sales table into Synapse. Okay, this is one kind of data pipeline, right? Now, and this was part of this pipeline. So this is being called in this pipeline. Let me show you some of the other samples. Now, there is a lookup activity. What I'm checking, if the Teradata marketing database exists, right? So here, earlier we connected to SAP HANA. Now I'm showing you how we can connect to Teradata as a source, right? If that database exists, then what I'm doing some kind of copy data. I'm copying from that Teradata database and bringing the data into ADLS Gen 2 in this copy data activity. After that, what I'm doing, I am not doing now any data flow. I want to write my own code. So I'm doing a notebook. So there is a Python notebook that I'm going to run, right, on the basis of this. So if I want to open the code of this Python notebook, I can go to settings and open it from over here, right? I will not go into those details right now. We will revisit this at a later point in time, but just understand what all is possible, right? And then I will transform the data using my notebook, whatever Python code, Python, PySpark code I am writing in that. And after the output of that code, we'll go load the data into Azure Synapse table. Okay, so again, it's loading into some of the Synapse table as a end result, right? This is another kind of pipeline. Let me show you some more samples as to what is possible. Again, this is a simple, it is connecting to an Oracle database, checking if that database exists, and then it's doing some kind of simple copy, loading from that Oracle table to a Synapse table. Then let's see some of the other. Now here, what I'm doing, this is a for each activity, right? So some of these activities like lookup activity, for each activity, you will see that you will use frequently, right? So you can learn more about this. Now for each activity, in this what we do, that this is a kind of loop. So and if I open this, right, if I open this, inside this for each activity, what I'm doing a copy data, right? That means the way I define my for each activity, for every data set in here, I will do that step, right? So one data set at a time. So that's for each for you. Now let's go to this, right? This is simple copy data, right? This is some IoT data coming from, let's say, in a Parquet format, right? So I'll specify some source. This is a IoT Parquet format data, right? And then this is a sync, destination is in some kind of Synapse table, right? So somebody was interested, table kind of, right, in a sync and destination. Again, there is another flow, data flow, right? So let me show you this data flow. This is also interesting, right? It will show you if I open this, right? This I have already opened it. So if I go over here, this is how that data flow looks like, right? So you are taking the same source data, but you are trying to do different kind of transformation and loading it into, say, a different sinks, different destination. What you are doing, you are applying, let's say, some kind of different filters, right? So that the source data goes into different places, right? Then you are doing some kind of get order status, etc. So you are doing some selection. So in source data, you would see there are 562 columns, right? Now you can imagine this is some kind of production grade pipeline, right? Then you are doing some filtering. You are filtering some records. Then you are selecting some number of columns that you want, 2 columns, 3 columns, and some of the other things, right? Filtering. Then you are doing some kind of aggregation logic, or here you are deriving some column, This aggregation is like some average. Here you are deriving additional column, right? So here you are defining some additional derived column, right? And on that basis, maybe some additional step, and to add one more derived column or etc. And then finally loading it into some kind of destination table. Now in this case, what is the destination table? It's some kind of database and the table. Okay. Again, what is other destination? Again, importing into this database, www importers contoso retail like DB, and this is the order status. This is the order payment. So just imagine you have all this information, order level information, payments information, order status information, and other order status type, and you are taking the same source but selecting different columns to go into different tables, right? So all of these you can do, and this is how you are you can imagine, you know, some production kind of or close to production kind of pipelines will look like. Could do is you can define some kind of things that should happen. For example, let's say this pipeline that we just created, right? After this step, let's say I want to run some kind of a Databricks notebook. Okay, we are yet to see that, but let's say I want to run a Databricks notebook. After that, let's say I want to do let's say another data, some copy data pipeline, right? Or another data flow. Now I click over here. By default, I will, let's say, connect these two. So this says this success, right? On success, go over here. On failure, do this. Here I can define some kind of, logic to, let's say, trigger an alert. Things like that, right? If my data flow, first data failing, then go over here. If this is successful, follow this, something like that. Okay. This is the data flow, right? This is not an activity. In data flow, you cannot create this, because in data flow, it will automatically fail if any of your step is failing. Understand, you cannot run this data flow independently. This becomes one of the activity inside your pipeline. For example, you have this data flow. This data flow is being called as part of this another pipeline. See, right now I am focusing on pipeline. If I go back over here, this is the data flow. Oh, not this. Give me a moment. Here, right? This is the data flow, right? I will not be able to run this directly. This becomes an activity, and as part of another pipeline, I will call it, right? So at a pipeline level, you can do what happens to each activity. But this is not independently run. This is always, you have to include this data flow as part of some pipeline. And in that, when that pipeline runs, this data flow, this entire logic will just be one activity. So if this all, if there is an error in any of these blocks, right? If there is an error in any block, that complete activity block is going to fail. Okay, in this pipeline, what I want to do is I want to add this data flow. Okay, wait. Which data flow? I already have an existing data flow. So I will select that data flow. Okay, I have created the data flow. Run this data flow. That's about it. Your pipeline got created. Now you wanted to run this data flow, add it to the pipeline, run this pipeline, it will run. Now schedule this pipeline to run every day, whatever trigger, right? Midnight, every 4 hours, every 1 hour, this pipeline will run. What this pipeline will do, it will just run this data flow. How do you do? Let's pick up some of the practical example that you want to come across. For example, let's say, how do we, in a typical data warehouse world, right? And I've done that enough. So what are typical dependencies that you set? You either set a dependency on some other pipeline. So that becomes success of one pipeline becomes a trigger for another pipeline, number one. Number two, a time-based trigger, right? That means at midnight, this should run, come what may, right? So that becomes another trigger. Third type of trigger is file watcher, right? File watcher dependency that you would want to say, because let's say there is some source system, and every day they will create a file and they will put that file into, say, your ADLS Gen 2. Now you have got the new data of today's data to process in your ADLS Gen 2. Now, only when this file is available, then you want to trigger a pipeline. Until that file is available, because it's not necessary that file will be available by midnight, right? And you may not have any data to process. Sometimes if the process gets delayed, etc., etc. So you don't want to set a time. You want to create an event when a file lands onto your ADLS Gen 2 folder, right? You can create that can be one of the events to trigger the pipeline. So think of any practical scenario, right? In your existing ETL kind of workload, you will have some way to implement that in the data factory. Create an event-based trigger, you will use a service called Event Hub and Event Grid, right? And then you will trigger your events through the event grid. So those are the know-hows you will figure out, right, on the job when you will do that, right, or when you want to create that. But in terms of ability to do all these kind of transfer orchestrations, those are all possible using Data Factory. Now, for example, on the failure of this pipeline, let's say I want to trigger an email notification. Now, what you will do for that email notification, you will call logic apps, right? So there is something called as Azure Logic App, right? You will call a Azure Logic App activity, and then that will trigger an email notification. So to do different things, there may be different services that you have to trigger or use. But net, you can do all kind of ETL orchestrations that is required. So essentially, between event-based trigger and time-based trigger, all your combinations or all your requirements can be served. You can write your Python notebook or Python code inside Databricks cluster, and you can just, on completion, on success, or on whatever, right? You can call like this. In this, you can configure where it should run, which Databricks cluster, which Python file, etc. Right? All those things are possible. So figure out, what are the activities that are available. For example, you want to run a stored procedure, right? And you have written that stored procedure in Synapse or some kind of database. So if, let's say, if I search for stored, yeah, you can see stored procedures also can be called. So there are different things you can do. Okay, search for these activities, explore these, and this is a C. Okay, guys, this just understanding ETL and just Data Factory alone itself can become a massive skill to learn, right? So each of these things have different things to offer. For example, how to call a HD Insight, Hive job, MapReduce job, Spark job, streaming job, all of these, right? There is just no limit to it, right? So how to do implement some kind of iteration. So this is looping, this is filtering, this is if-else condition, this is switch, until, right? You can do different types of things. We will unfortunately not be able to cover all of that, right? Because this will become a 100-hour course, frankly, to cover all of these, which we do not have a luxury, number one. Number two, that is not required and expected in DP203. You don't have to understand every single thing. You will not be asked such a complex kind of questions or scenarios to address or to answer in your DP203 exam. Go and create a Data Factory resource in your subscription. Inside that, create a pipeline. Inside that, include a data flow. In that data flow, do simple things. See, this is a certification exam. They are giving you some 60 minutes, 90 minutes. They cannot expect you to create complex pipelines within that. All of those things are meant to be learned on job when you are actually working on those scenarios. See, from certification perspective, can you tell you have a Data Factory skill based on if you are able to do whatever I showed you? Can you go and tell anybody that, yes, I can work on Data Factory? Yes. Now, if they give you a specific requirements, you can always figure out. But if you did not know even how to navigate, how to create a Data Factory, how to open Data Factory in Studio, what are pipelines, what are data sets, what are data flow, if you don't know all of that, then you are not ready for your certification or even appear for interview. But if you have got so much understanding, it's only a matter of time that you will figure out how to, let's say, call a Synapse thing inside this. If you had a Synapse notebook or a Spark job, how to call inside a pipeline, at least this much you know. What you have to figure out is only this thing, right? Setting mein kya karna hai, Synapse mein kya karna hai, all of these things. As simple as that. SQL DB, right? So one of the databases. Now we started working with storage. We understood Blob storage account, ADLS Gen 2 storage account, how to actually make this storage account in some use, right? In some practical use cases. For that, what we saw, we created some data pipeline. We saw some movement of records, right? Movement of data from one ADLS Gen2 folder to another ADLS Gen2 folder. In the earlier, we saw a copy file, copy file from a Blob storage account to a ADLS Gen2 storage account. Today, I showed you a number of different scenarios possible, right? What kind of different pipelines you can write? What could be the source? I showed you some pipelines where Teradata, SAP HANA, Oracle, these were the kind of databases which were input to a file, right? Then you can do different types of processing, code first, code free kind of processing. What was the code first processing? Code first means you are writing your own code. That means you are calling a notebook. In that notebook, you are writing your own transformation logic, right? What is code free? Code free is something like mapping data flow, wherein you are not writing any code, but using a drag and drop tool, you are building your transformation logic. And then finally, putting all of that into different destinations. That destination can also be a database table. It can be some kind of ADLS Gen2 folder or a blob storage folder. The destination can also be a Synapse table. Synapse is a data warehouse, right? So there are different possibilities. Now that we have learned so far, right, let's understand what are the different database offerings, right? So let's get into understanding other set of services, and starting with Azure SQL DB, right? What is Azure SQL DB? It is a PaaS service for SQL Server. If you want to run SQL Server on Azure Cloud, you will use this service that is called Azure SQL DB. Now, as a PaaS service, it gives you 3 deployment options, right? That means you can use SQL Server on Azure as a PaaS service in 3 different types. One is managed instance, one is elastic pool, one is single database. Now, it is important to understand as a data engineer which one to choose when, right? So understanding different types of use cases, and on the basis of the use case at hand, you should be able to determine what kind of database I want to choose, right? Let's say you want to choose a SQL Server database on cloud as a PaaS service. So you know you want to create a Azure SQL database, right? But in that you have got 3 options. So should I create a managed instance, or should I go for elastic pools, or should I go for single instance? How to choose these deployment options? That is important to understand, right? And there may be question. There may be a scenario-based question in DP203. They'll give you some hint into that, where they will ask you which is the more appropriate SQL database deployment option that you should select: managed instance, elastic pool, or single instance. So it is easy to understand that, and it is fairly easy to figure that out. So I will explain you that, right? Before that, some slides, right? What are the different databases? Say relational databases, Azure SQL DB, and then on the open source side, you have got these many: PostgreSQL, MySQL, MariaDB, and again, Synapse Analytics is Microsoft proprietary. It's not necessarily relational, but it's like tabular format, and it's a data warehouse workload. It's not a OLTP workload, it is an OLAP workload. But for this session, let's focus on Azure SQL DB. Now, what are some of the common features, right? Why all of these are being represented in this slide? You will see this slide again when I'm talking about PostgreSQL in the next session, right? So essentially, why, right? What this slide shows is, when you choose any of these databases on Azure platform, what you get is some platform level features, right? What are those features? Intelligent advisor. What is intelligent advisor? When you are running your database on Azure, it has intelligent advisor. That means it can identify your database workload. It can understand the queries that you are writing. And if some of the queries are not performing well, and for example, the intelligent advisor will see, can it improve any query performance by adding some index onto table, or by deleting some index, can it improve the performance of insert statement? All this kind of analysis intelligent advisor does for you, and it can do automatic tuning, right? That means it can automatically identify and create some index. If you have created many indexes on a table and those are not actually effectively being used and they are slowing down the performance, on the other hand, they can also go ahead and disable some index. So that benefit you get. Also, it is flexible. That means you can scale up and scale down very easily. It is trusted because it is enterprise ready. You can deploy your business critical application using these services. That means your high availability SLA is guaranteed, right? You get by default high availability SLA. Then you can easily set up your backup restore. Your security is given. You can implement audit and isolation, etc., etc. Now how this is built. This service is built on top of common Azure compute layer infrastructure, and storage is separated from compute, which helps you to scale up, scale down very easily. We'll understand this better in coming slides. The service is available in more than, let's say, 55 region, or there are actually total 60 plus regions that are available, right? So the service is globally available. Essentially, you can spin up these databases in as close to where your customers are. Now, what are these? So these databases being Azure service, right? They also natively integrate with a number of other services. That means they can very easily over Azure backbone of infrastructure efficiently communicate with other services like Data Factory, right? You want to connect to a SQL DB from Data Factory, you'll be able to easily do that. Or Azure Analysis Service, Machine Learning, Cognitive Service, Power BI, etc., etc. Right? So all of these being Azure services, when you create a SQL database on Azure, it is easy to communicate with other data services. That is what this slide talks about. Now, this is an important slide, right? Let's understand this in detail. Because I told you, right, when to choose what. Let me talk through some of the scenarios. Okay, let's start with a basic scenario. You want to create a new application, okay, which is born in cloud, right? That means completely new development, and you want a SQL Server kind of database for that. Then your default choice is to create Azure, and you want a PaaS service, of course, right? Because these are all PaaS service options. And you want a SQL Server as a PaaS service on cloud for a born in cloud new application, right? That means there is no existing SQL Server database from which you are supposed to migrate. It's like new, fresh, greenfield application you are building. By default, you will go for single database. Okay, number one. Number two, when you are, this is like default choice, right? And whether you should go for this or this or this, there are certain specific scenarios where you will decide that, okay, you can't go stick to your default choice because this is better, right? For certain requirement, or you should not go with single instance because this is going to be better for certain requirements, right? So simple way to understand, think about it. Can I go for single instance? That's my default choice, number one. Number two, okay, given my requirements, I think elastic pool will be better. So you go for elastic pool. Or given my requirements, I think managed instance will be better. So go for managed instance. That's how you should look at it. Now, what are those requirements, right? Before coming to elastic pool, let me address managed instance, right? You can read also, right? With high compatibility with SQL Server, and it's a full PaaS benefits, right? So these are all PaaS as such. Now, this is the key, high compatibility with SQL Server. Why do you need high compatibility with SQL Server? In this case, as you can see over here, this is best for modernization at scale with low friction and effort. This modernization, you can just, remove that word and think of it like migration. Best for migration. That means you have an existing SQL Server database, which you are running on premise, and you want to modernize that to the cloud, or you want to migrate that to the cloud. So you should managed instance, right? Easy way to remember a keyword is M for managed instance, M for migration. When you are dealing with a migration scenario where you are going to migrate from on-premise to the cloud, and you want close compatibility of the SQL Server features compared to your on-premise. So, and why would you want that close compatibility of features? So that you can migrate in minimum efforts. All your code, all your data should continue to run as is with lift and shift, right? So lift your data and code from on-premise, start running it on cloud, and it should happen in a frictionless, effortless way. If that is the requirement, then you will go for managed instance. Now, can you not go for single instance? Yes, you can go for single instance. What could be the challenge? Challenge could be this: compatibility with your existing SQL server. I'll tell you what, right? For example, you are running an older version of SQL Server. Let's say that version is 2008 version. Now you want to migrate that old SQL Server version to cloud. Let's say you choose single instance, right? Whenever you migrate, before migrating, you will do some assessment, right? What is that assessment? It is called as data migration assessment. So you will, that's a tool available from Microsoft to do the assessment, which is your right target, right? Now, there could be certain feature in older version of SQL Server, such as there could be some feature in 2008 version, but over the period, Microsoft realized that not many customers are using this feature. Okay, and there is now better features that we have added into SQL Server, so we don't need this feature in our PaaS service. Right? So likewise, there could be certain feature that you or your customer is using, but those features are not available in this single instance database, right? Now, what is your option? That means you will now require, there will be not compatibility. Your code is not going to run as is, right? Because that feature is not available, but a better feature may be available, right? So you will have to change your code or adapt or use the other feature that is available, use the alternative approach, use some kind of different solution, right? Now you can always do that, right? If you are ready to do that, then you can also migrate to single instance. But sometimes if your customer says that I don't want to make any code changes, my code is running fine in on-premise, please don't make me any do any code changes because I don't want to take that risk. I want to first of all just go to the cloud in a lift and shift way, and I want to minimize my code changes and I want to just run everything as is. Then what will be your best choice? You don't have some features here and you will just go for managed instance, right? Because there is very high chance that managed instance will support all those features. Why? Because it is almost near 100% compatible with your on-premise SQL Server versions, right? So you can expect to get similar features over here so that your migration is going to be frictionless. In managed instance, right, you will get a closely matching feature set, and I said near 100%. So I did not say 100%. That means there could still be some feature, right, which is not available in managed instance also, but that will be very minimal, right? And it will require minimal code changes. And that feature will be like such a feature that which very few customers are using, right? And if you happen to be one of those customers which is specifically using some feature which is not available in single instance as well as managed instance, that would definitely mean that that feature requires some minimal code changes. I have not come across many such cases, because most of the times if there are some this kind of compatibility issue, then customer realizes that okay, there was some old code somebody wrote and that code is not being used, right? Or there is a simple way to do it in better way with newer features available. So those kind of code changes, if at all required, they are also very minimal, right? I think I also have a link on this. Okay, I'll come back to it. There is also a documentation link which I will show you. That documentation link has all the list of feature differences, right? This is an on-premise feature. Is it available in single instance? Is it available in managed instance? All of that you have transparently available in your Azure documentation. Host all the infrastructure that is required for that for each customer. You also want to make sure that we are not storing all customers' data into same database, right? Because that customers may not like that. Also, so for that reason, what you have to do is for each customer, you have to create a separate deployment, right? You in their subscriptions, for example, right? Or in your subscription. Essentially, in a multi-tenant application, you as an application vendor or that software vendor, you will have your Azure subscription and you will make your application available to your customer as a SaaS application. That means all the infrastructure that is required for that will be available in your subscription, right? And others will be just the users of that. For example, I don't know, I may have given this example earlier. Think of a simple example, right? There is a transport management application, right? And this transport, I have built this transport management application, and I am the company who will sell this to more other companies, right? So I want to sell it to some company that has 100 employees, company that has 1,000 employees. There could be third customer of mine, which is using this transport management for, let's say, tens of thousands of employees, right? Now imagine I have a small customer, I have a medium customer, I have a large customer. For each of these customer, my code base is same, right? My code is same. The same application code I'm deploying in for different customers, right? For example, let's say I'm creating different application service instances, and in each of those services, I'm creating some different databases, right? 3 databases. Now, obviously, for a small customer, I need a small database. For medium customer, I will want to use a medium size database, and for, let's say, a large customer, I would need a large database, of course, right? So I have to manage those 3 databases differently, right? So I have to manage my code as well as my databases separately for each customer. Imagine I have hundreds of customers, so I will be managing those hundreds of deployments separately. Now, for these kind of multi-tenant application, let's first address, first things first, when to use Elastic Pool. When you have this kind of application, which is multi-tenant in nature, then you will go for Elastic Pool. You can go for Elastic Pool. You can, of course, use single instance. That means you will have created those single instance databases for each of the customer separately. That's also possible. But what is better choice? What is a choice that will save you some cost, that will give you more efficient way to handle multi-tenant applications? Elastic Pool is the way which is specifically defined or designed to better handle or optimize the resource utilization for multi-tenant application. Yeah, the more common scenario from Oracle migration that I come across is Oracle to PostgreSQL migration. Okay, now why people do that? Because PostgreSQL has very close compatibility with Oracle, right? In terms of different features, in terms of some of the other things. SQL Server, Microsoft proprietary, right? And you may require more code changes while migrating from Oracle to SQL Server. That means that migration may not be simple. That will rather be a complex migration. On the other hand, if you are migrating from Oracle to a PostgreSQL, maybe the amount of code changes that you have to do, or the kind of close compatibility between Oracle and PostgreSQL that you have, that will, let's say, if SQL Server is complex migration, then that will probably be medium complex. That's how I can look at it. But you can always do that, right? Essentially, what is involved in a migration? You have to migrate your data, right? That means you have to create same set of tables from Oracle to PostgreSQL, right? Now, in terms of table creation, there may be some differences between the 2 databases. So you will have to address that, right? Then you migrate all your data, and you have to migrate all your code, right? That means you would have written some stored procedures in Oracle, some triggers in Oracle, some functions in Oracle. Now, can you run that code as it is in PostgreSQL? Maybe not. All right. So there are some migration tools that are available, right? So when you want to migrate from Oracle to PostgreSQL, there is a tool called as Ora2PG. It's an open source tool. You can make use of that tool to automatically convert your Oracle code to a PostgreSQL code, for example, right? It will give you, let's say, 60-70% of your job will be done automatically using that tool. There could still be some corner cases where the tool may not work, right? And the translated code might still not work, and you may have to manually look at it and do some additional implementation, some additional changes, or let's say there is some function in Oracle which is not available in PostgreSQL. So you may have to do some kind of workaround on that. That is how typical migration takes place, because it involves both data migration as well as code migration. Hope that answers your question. Let's come back to this. I want to understand if you guys got this clear, right?
Yeah, thank you.
When to use Elastic Pool and when to use managed instance. Is that clear? Okay, I'll take that as yes, but feel free to ask. Okay, now what are different service tiers? You can create a general purpose service tier, as well as you can create a business critical. Now, for some of the application, general purpose is also production grade, and business critical is also production grade, right? Business critical just gives you better hardware, right? Faster performance for more cost, obviously, right? And there is something called as hyperscale. Now, what is hyperscale service tier? Now, imagine when to use hyperscale, I will tell you that, right? Let's say in an on-premise world, you have a database, all right? That database has a storage of 15 terabytes, right? And let's say it's continuously growing, right? Next year, you can expect that, that will grow from 15 to 20 terabytes or 20 to 25 terabytes, something like that, right? So you have a very large database. For hyperscale, the keyword is very large database, right? In on-premise, if you have that kind of a large database, your single instance is not going to support that, because in single instance, you have a limitation. Your database size has to be under 4 terabytes, right? Similarly, in managed instance, I think you will have some limitation. Probably, as far as I remember, it supports up to 16 terabyte, but not more than that, right? And you can see all of that in Azure documentation, right? Time to time, even if it gets updated, that is the best place to see that, right? You don't have to remember all of these limitations of each and all, right? You can just go to Azure documentation anytime and it will tell you. Now, hyperscale is used when you want to create a very large database as a PaaS service, right? One way is to do infrastructure as a service migration, right? That means create a virtual machine, add as much storage disk as you want, and migrate to that VM as an infrastructure as a service, IaaS option. But when customers want a PaaS service, all the benefits of a PaaS service, right? And they want to create a very large database, then they can go for hyperscale service tier, right? That means you will create a database as a hyperscale database. So you can create a single instance database, for example, and you can when you know that, okay, your database size is going to, increase and it will become very large, right? Beyond 10 terabytes, up to 100 terabytes you can go, by the way. So even beyond 100 you can go, but by default, Azure portal will allow you to add storage up to 100 terabyte, not more than that. But if you have a use case that requires more than 100 terabyte, then you can fill a form, contact Azure engineering team, and they will, do the needful for your subscription. But more than 100 terabyte is a very rare use case. You will rarely come across, that kind of a use case for a OLTP database. And then the other way to do the sizing is based on V cores, right? Which is virtual cores, which is CPU cores. Now, what is a DTU? DTU is an abstract unit of measure of computation power, right? That means that computation includes certain CPU processing power, certain amount of memory, and supports certain amount of IOPS. That means input-output operations. Okay. Now, how much is that certain amount, right? You don't know that. It is an abstract unit. Microsoft tells you, okay, go for 1 DTU, go for 2 DTU, go for 4 DTU, and we will internally manage, right? 1 DTU is equal to how much CPU. There is some guidelines that is available for that, but it is, let's say internal to Microsoft, right? Now, and it must be available in documentation as well, transparently, that 100 DTU is equal to how much CPU, but essentially it is an abstract unit. Now, where it may be useful, let's say you are creating some kind of database, and if you find rather than vCore based model, I am finding DTU based model is cheaper for me, right? So you can create a database using DTU based model. You can start with, let's say, 1 DTU, 2 DTU, 3 DTU, 4 DTU, right? And you will see as how it is performing for you. And on the as per the requirement, you can keep scaling it up, right? From 1 DTU to 100 DTU, etc., etc. Here, you will not transparently know that, okay, how much CPU power is being put behind it, right? On the other hand, specifically when customers were migrating from on-premise, earlier it was only DTU option, okay? But then Microsoft got feedback from customers. Okay, what was that feedback? So let's say I am an on-premise customer. I am running SQL Server database on my machines. I know what is the configuration of machine, right? I know that I need a 16 CPU core machine, right? 16 core CPU I have. I have, let's say, 256 GB of memory or RAM, right? And on this, my SQL server is giving me the right performance, right level of performance. So I am confused now, right? Microsoft says choose DTU. How do I choose DTU? I don't know. 16 vCore and 256 GB RAM will be equivalent to how many DTUs, right? So customer had these challenges, especially in the migration cases, right? Because they were used to understand the infrastructure or compute requirement in terms of CPU cores, in terms of memory, etc., right? So Microsoft, to make it easy for those kind of customers, also created another model, which is vCore based model, right? So here you can choose, by the way, one physical core, right? One physical core. That means if you are running, let's say, 16 CPU core, 16 CPU, 16 core CPU on your server on your on-premise. So one CPU core is equivalent to 2 virtual cores. Okay. So in terms of vCPU or vCore, how many cores you will select as an equivalent combination or as an equivalent infrastructure on cloud? Now it made it easy for customers, right? So customer who was running, let's say, 8 CPU core machine or 16 cores, 16 physical core machine. Now it is easier for them to configure their on cloud environment accordingly. Okay, so that's where Microsoft created that vCore based model as well. When you select Azure SQL, it will show you all 3 options now. Okay, now you will say I am seeing SQL database, single database. I am seeing managed instance also. I am seeing virtual machines also. Why am I not seeing elastic pool? Right, that is the option that is missing. I will show you how to create elastic pool. But by the way, if you click over here in the SQL databases, you see that, okay, single instance, single database, elastic pool, database server. Database server, I'll come back to it because it's just a SQL server typical concept. When you create a database, first you create a server and then you add a database inside that, right? All of that will happen when we click on create. What is managed instance, right? In managed instance, you can create a single instance or you can create that instance onto Azure Arc. Okay, now I don't want to confuse you guys a lot. Azure Arc is a service using which you can deploy some of these PaaS services. So PaaS service is a cloud benefit, right? We understood that why people migrate to cloud, because they want to take advantage of lower administration, lower management, high ease of flexibility, etc., right? But assume there is a customer who is an on-premise customer. Okay, and for example, this customer is let's say defense customer. Indian Army is the customer. They have very secure data, very confidential data, and they are concerned that they don't want to go to public cloud, right? But they want to take advantage of some of these great PaaS services in their private cloud, right? In their on-premise data center. So to make it available to run these kind of PaaS services into customers on-premise data center or customers private cloud, you use a service called Azure Arc is created. If you create this using Azure Arc, that means that you are creating this service in an on-premise data center of customer. Okay, so Azure Arc is that service, right? So that makes it possible. Now, what is SQL Server Virtual Machine? Now, this is a PaaS or IaaS. What do you think? Is it a PaaS offering or IaaS offering, infrastructure as a service? Different types of SQL Server offerings that are available on Windows. For example, you want to run SQL Server 2020 on Windows Server 2022, right? So, or you want to run, let's say, all the way to SQL Server 2018 on Ubuntu server. So you can exactly match how you are running it on premise, and you can create exactly same SQL Server version and that OS version, and accordingly you can that virtual machine will be automatically created for you. It will automatically have this version of SQL Server installed, whichever you select, and you can just do your lift and shift migration. See, there are 2 options, right, that we saw. Infrastructure as a service. In infrastructure as a service, how you create anything? You create a virtual machine on Azure, right? And in that machine, you can deploy any software, any application stack, including database software that you want. Okay, so but in infrastructure as a service, you will not get as many benefits as a PaaS service, right? Because whatever you deploy on that virtual machine, you have to manage that. So, but it helps you to do lift and shift migration, right? No compatibility issues at all, no challenges. You can, just select the same OS version, same SQL Server version, and you can bring your code onto cloud, right? In a quick and easy way. That's why sometimes customers, right? When I had showed that typical customer journey, that's when customer go for infrastructure as a service. So that is also an available option. So when you clicked on Azure SQL, you got all these options. If you want to create a virtual machine which already has a SQL Server pre-installed and the required operating system, you can choose from over here, and all the combination of SQL Server and Windows Server you will get pre-installed on that. If I click on create, for example, and let's focus on PaaS services. Let's create a single database now. Okay, if I click on create, okay, what I have to do is provide some basic inputs. Now, what are those inputs? Of course, my subscription, my resource group. I will use an existing resource group. Let's say demo resource group that I had created. Now I want to enter a database name, right? Let's say JK SQL Demo DB, created on 25th of February. This is how I want to name my database. Now, there is also a server component to SQL Server. Whenever you create SQL Server, you create a server. Inside that server, you typically add your databases. Now, if I have an existing server, it is asking me, do I want to use existing server of mine? I'll say, no, I don't want to use an existing server. Let's create a new server also. So I'll click on create new, and it is just asking me for a server name. So let me call it JK Demo Server. Okay, it says in which region you want to create. Let's say I will select Central India. Okay, and what is the authentication method? Do you want to use Azure Active Directory or SQL and Azure Active? I'll say simple password based SQL Server, SQL authentication using password. Right, I'll give it some username and I will give it some password. That means along with my single instance database, my SQL server is also going to be created. This is the name of the SQL server, JK Demo Server, and this is the name of the database, JK SQL Demo, right? And the date timestamp that I'm using. Now, do I want to create it as an elastic pool? I can choose from here also, right? I can click on yes, and then I can choose the elastic pool. I can create a new elastic pool, etc. Right? For example, for simplicity, let's click keep it no. Now, compute and storage, right? This is where I will configure. For example, you see here 2 vCore, right? So let me go over here. So it says what kind of service tier that I want, right? Do I want a general purpose or do I want a hyperscale service tier? You were asking me, right? So I can create a hyperscale database from over here, right? Or do I want a business critical? So this is the service tier I will choose. Now, does that mean if I create a general purpose, I cannot change it from general purpose to the business critical at a later point in time? No, I can always do that. So I can create a general purpose and I can migrate that service tier to hyperscale or business critical. But important thing to remember is once I go to, for example, from general purpose to the hyperscale, I cannot reverse. Okay. It will not be possible to reverse. I will have to do migration. So these kind of choices are to be made properly. Okay, so let's say I'll keep it general purpose for you.
Let's have a quick quiz question, guys. What does the acronym ETL stands for in the context of data engineering? Extract transform load, elastic transfer load, efficient transform load, or extract transmit load? Please mention your answers in the comment section.
Just a quick info, guys. Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
Now we notice that some of these common features, database service platform features such as intelligent advisor, which can help you to automatically tune your queries, is available across all of these services. Then flexible, so you can scale on demand and scale down when you don't have that much demand for resources. It is trusted because it gives you built-in high availability SLA, so you don't have to worry about high availability that is given. Then you can flexibly set up your DR based on what kind of redundancy or resiliency you need in your solution. So whether you want a ZRS, GRS, GRS kind of things, right? So all of that in terms of backup as well as in terms of actual SQL server or SQL DB PaaS service, you can configure that very easily. Then you have Azure Compute and Azure Storage, which are again separate from each other, which helps you to independently scale these services in a very quick and easy way. And the service is available in a large number of Azure regions, so 60 plus Azure regions. This slide is not most up to date. And the other benefit of running these databases as a PaaS service on Azure cloud is these services, when run as PaaS, they natively integrate with a lot of other data services, data or application side of services, so that you are able to seamlessly communicate between services, which include Power BI, Azure App Service, Azure Data Factory, Azure Analysis Service, machine learning, cognitive services, bot service. These are just few to name. Now let's continue. These three things that we had seen, right? Although the answers to the questions are already on the slide, I want to ask quick questions. So I will give you a scenario, right? And you tell me which among the three is the right deployment model that you will choose for Azure SQL DB. Okay. So I have a customer, right? First scenario, and the customer is running SQL Server 2008 on premise, and they are looking to migrate to cloud in an easy way, right? With minimum efforts possible. So, and they want a PaaS service. So they want to take advantage of a PaaS service. They do not want to migrate as a lift and shift in the IaaS mode, right? So they don't want to run SQL Server on virtual machine. They are convinced that they want a PaaS benefits. So which option would be more likely a best fit for this kind of scenario? Azure single instance database or Azure Elastic Pool, Azure SQL Elastic Pool, or Azure SQL managed instance? Use case number one. Number two, the company wants an easy lift and shift kind of migration, but they do not want to go for IaaS. They want to take advantage of PaaS benefits, so managed instance. And then second scenario is there is a company who is looking to build a new application, and they're looking for a SQL Server kind of a database, but on cloud as a PaaS service, right? So which option would you recommend to them? For that, your default choice would be to use single instance. Now, when single instance may not be sufficient, if that database size is expected to grow beyond 4 terabytes, if it is going to be a large database, then single instance might not support that. That's where you would either use managed instance or you would use something called as hyperscale. Okay, now before I go to hyperscale, let's also do a very quick review of Elastic Pool. You will use Elastic Pool when you have a multi-tenant application. And if you remember, I had given you an example of a multi-tenant application as a management application, right? Wherein you build an application and then you deploy that application for multiple customers, right? Wherein the application is typically getting involved in your subscription as a vendor provider for that software. And your customer, when you have a multi-tenant application, right? I gave an example of a transport management application, right? So what does a transport management application vendor do? They are creating the same set of code, right? Application code and database data model, and they are going to deploy this for multiple customers of theirs, right? In their subscription. So typically, what you would do is you would end up creating a different database for each customer, as well as different application stack, different, let's say, app service, etc., etc.
So for these kind of databases specifically, you can go for Elastic Pool, and Elastic Pool helps you to cater to unpredictable increase in the demand on some of those multi-tenant customers, right? So if one customer has an increased demand today, you don't have to necessarily go and scale up for that customer, because you have a shared pool of resources which you can leverage to cater to unpredictable increase in the demand or reduction of the demand. So and how that happens, I will show you further. These are these databases are available in general purpose as well as business critical service tiers. There is also a hyperscale service tier which we had seen. Hyperscale is for very large databases, right? So VLDB is the keyword that you should remember. When you have database which is going into, let's say, more than 20 terabytes, or up to hundreds terabytes as well, then if you want that kind of a database, and that too as a PaaS service, right, a fully managed service, then you will go for hyperscale service tier. Now, single instance managed, we saw all of this, right? So there is also this feature availability comparison. If I click on this link, it will take me to this page. I can share this link also. So in this, if you go down, right, this will tell you the difference between what is available, which features are available in SQL DB versus which are available in managed SQL instance, right? Because how you choose the SQL DB versus managed instance is more about, the compatibility with your on-premise database. So this page will give you always up-to-date information with respect to, which features are supported in both of these versions, SQL as well as managed instance. So you can refer to this. Now, Elastic Pools is a concept that you would want to understand a little better, right? And I have some interesting slides that show that helps to understand these concepts, right? So it's like multiple databases with unpredictable and intermittent usage patterns can be consolidated into a single server, right? And you can use Elastic Pool for better price optimization. Now imagine, rather than creating this single database for each of the customers separately, you create a pool of database which is called as Elastic Pool, which has certain shared resources available for everybody to use, right? Available for each of these separate databases within the Elastic Pool to be used, so that you are able to serve these unpredictable and intermittent usage patterns. How exactly it works, right? Let's understand this. Now it's this slide is more of just showing your DTU based model. So earlier when Elastic Pools were launched, so last time also we discussed what is a DTU based model versus what is a vCore based model, right? So I will not go into the same again. But earlier when Elastic Pools were launched, they were available only in the DTU based model, right? That means, what is a DTU? It's a database transaction unit. It is an abstract measure of certain amount of compute power, memory, and store IOPS. So earlier you could go for a 200 to 400, 800 or 1200, right? This is how you could scale your Elastic Pool sizes in terms of DTU. But as of today, Elastic Pool also supports vCore based model, right? That means you can also select your vCores with respect to how many CPU cores you want, right? Or how many virtual cores you want. So let's say I want 16 vCore Elastic Pool with 256 GB RAM. So you could select your vCore based configuration also now. Earlier it was not supported. Now how Elastic Pools work, right? So imagine these are the four different databases that you are created. Now this is so far not showing use of Elastic Pool. Okay, now if that is the case, how it works is, and you are, as you can see, these moving parts are showing the utilization of the CPU or memory of that particular database. So as the users start increasing, right, you will hit the limit with respect to CPU and available memory, and this database is not going to work, because your user request or the number of the usage pattern has suddenly changed, right? And there is no scope to scale further. Otherwise, until you come and scale this particular database manually, it will not automatically handle this additional traffic. So how elastic pool handles it, right? So now in elastic pool, you define certain minimum performance level and a maximum performance level. Now within that performance level, as you can see, each of these databases can independently scale. So you don't have to worry about, okay, what happens if one of those databases has an unpredictable usage pattern and suddenly has increased demand. So it will not be that you will not have to manually scale that database up, because up to certain limit that you are defining, that the database will be able to auto scale up, because you are keeping spare capacity in your elastic database pool, right? So that's how elastic pool helps you to optimize the price, and also optimize the management and administration of multi-tenant deployments, where you do not have to manually manage every single database separately, right? And there are some of the other advantages of elastic pool. Now what are those advantages? Elastic pool also helps you to create elastic jobs, right? So what is elastic job? For example, let's say you have 4 databases, right? Or let's say n databases, n number of databases. And in all of these databases, typically because it's a multi-tenant application, so your data model is going to be same, right? You will have same set of tables. Now, depending upon the customer, there may be 100 records in one table and there could be 1 million records in another table, right? But the table structure is going to remain the same. So uh, when you are creating certain code changes, right? Let's say you want to modify a table, right? And this code change you want to push for all customers. So when you want to push a code change to all the databases, you can create an elastic job. That job will automatically run and modify your code or a table structure across all the databases in the elastic pool, right? And there also you can pick and choose. So let's say you have 10 databases in your elastic pool and you want to push certain change to only 8 databases. So you can specify those databases and your single job will automatically orchestrate and run across all the 8 databases. There is also atomicity of the operation. Now, what is a property or called atomicity? Atomicity means when a transaction has to be either fully completed or fully rolled back, right? That means it should not have an intermittent stage that certain steps of the transaction have completed and certain steps have failed. So that is not an atomic transaction. So elastic jobs also give you an ability that whatever changes that you are, or whatever actions that you are taking as part of that elastic job, uh, you can specify that the job should complete only when those set of actions have been successfully performed across all the databases in an elastic pool. If even if one database has got has failed the job for whatever reason, then the job will roll back that action from all the databases, so that you can ensure that if the action is performed, it is performed across all the databases in that elastic pool, or it is completely rolled back. So these are some interesting features which not only help you optimize the price with elastic pool, but also optimize on your operations or administrative tasks. Those are some of the advantages. Now, in terms of some other advantages of SQL, right, or that kind of go across all different types of deployment options, single instance, elastic pool, as well as managed instance. So is intelligent performance, right? We talked about this scale on the fly. So you can change your service tier. For example, when you created a database, you created it as a general purpose database. So you realize that no, you want a higher, better hardware, right? Faster response. You can change from general purpose to business critical, right? Or from business critical to hyperscale. That can happen on the fly and in an easy way. Similarly, when you want to increase the storage, or when you want to scale up or scale down, that is also easily possible. Business continuity. So your high availability is given out of the box. You do not have to do anything for 99.99% or whatever is the guaranteed SLA. You do not have to take any extra step for that. It is by default given to you. It works in your environment, so that if you are, let's say, familiar with SQL Server, and if you are familiar with some of the tools and technology stack that you have been using to work with your SQL Server on premise, it will work. You will be able to continue using the same tools, so you don't have to learn or unlearn anything. Advanced threat protection. Now, advanced threat protection provides you protection against and very deep protection for your data and database across multiple layers. So it can enable a lot of different auditing so that if a user is trying to behave differently, and for example, if a user who is not authorized to access data of certain tables, and if that user is, let's say, repeatedly attempting to access the data, although the data is not being given, but advanced threat protection will also be able to capture these kind of incidences, right? So advanced threat protection is another important aspect that comes and that makes this service enterprise ready for you. And just to summarize, right, these are the three different types of databases that we saw, and I have also pasted this link into the notepad, which I will share after today's call. So let me now go to Azure portal for a moment. This is the SQL database that we had created. And in that we had also created a new SQL server instance, JK demo server. And inside this is our database. Now here, if I show you the overview page, you will be able to see the research group, subscription, etc. details, right? Then actual server name. And then from here you can go to the database connection string, right? For your ODBC, JDBC kind of connection. So if I click over here, you will get how to use or how to connect to this database using various different code snippets, right? So it will give you these kind of details. There is one more thing that you need to note. Now let's first, before I come to that, right, let's first try and connect to this database. Now you can connect once your database is created. Okay, bear with me, it's a bit slow today. So I'm in a query editor, right? And from over here, I can try to connect. So just see the error, right? It says an instance specific error occurred while establishing connection, and it says the deny public network access is set to yes, right? So why you are not able to connect to this database is because by default, when the database is connected, is created, you are not allowed to access this database over public internet. Okay, so I'll show you that setting. So if you go over here, set server firewall, by default, you will see that it says deny public access. So public access is disabled. So by default, whenever you create any database on Azure, by default, public access will be disabled. You can enable this for selected networks, right? And wherein we will add a virtual network rule, right? That means you can make sure that you are creating your database within your organization's virtual network. In that case, what will happen is only the applications who have access to that virtual network will be able to connect to these databases, right? Or users who are able to have access to that virtual network will be able to connect to that database. On the other hand, let's say if I want to access this database over public internet, right? Or then what I can do is I can whitelist some of the IP addresses. For example, this Azure portal has automatically detected my dynamic IP address, which is this IP address. And it says I can add a rule by clicking on this add your client. I can add this rule to set the IP address as a whitelisted IP address to be able to connect to my database. Right now that this server firewall rule has been updated, we will try to connect again to that. Okay, so this rule has been updated. If I go back to quick start now, or the storage query explorer, let me go to the database. Right now I'm on a demo SQL server. I want to go back to my SQL DB. If I go to query editor and enter my password, now it is able to connect us, right? So here you can start running some of your queries. For this, you don't have to, and by the way, this feature is a new feature. As you can see, it is currently in preview. So this feature helps you to start working with your database tables, create new tables, etc., or start running queries in short, in a quick and easy way without having to use any other SQL client, right? So here I can, if you remember, we had included this adventure work schema. So there are some database tables that are already there. So if I just do a select star from sales lt.address and run this query, I am already able to log into the database and access my table details. Okay, now if you don't want to work in this query editor, right? You want a better SQL editor. What you could do is you can log in from here. Any tool that you have, right? I have dbeaver, for example. So I have installed an open source tool called dbeaver, which helps me to connect to any databases, right? Be it a SQL database or any other database. So I'm going to use that tool. On the other hand, you can use SSMS or SQL servers, Azure SQL Studio, or Toad. There are many different tools that are available, which you can use. I'll just show you how to configure, your database connections, so that you are also able to, use or access your database that you will create through any third-party SQL client as well. Yeah, I'll open this again just so that you don't miss out on anything. Simply, I have a program or a SQL client called dbeaver already installed on my machine. Right, so you may be using any other SQL client. That's absolutely fine. But essentially, I'm just showing right now as to how to configure a connection to our Azure SQL database, which is created in cloud in our subscription, and how we can use simple SQL authentication to connect to that database and start working on that. So I've just connected. Now from over here, I will say, okay, it's asking me to download some drivers, which I will download. That's fine. I'll ignore those errors. Let's try to create a new database connection. Okay, now in this new database connection, I will, let's say, choose Azure SQL, click on next. Now it says add your host details, right? So I will, from where can I get my host details? I will go back to my database or overview tab. So on the overview, I have a server name over here. Let it load. So this server name I will copy, and that server name becomes my host name, right? Then which database I want to connect to? I want to connect to this JK SQL Demo DB, right? So I'll use that database. And then SQL Server authentication, I had used one username and I had set up some password for that. So I will use that and try to test connection. So it says, again, it's giving us some IP address based error, right? So we'll try to whitelist this IP also. Sometimes if you face this kind of error, I will give you a quick hack, right? This hack is only good for demo environments, but not good for any production grade environments, right? But what is that hack? I will tell you, right? So because we have dynamic IP addresses, right? So I'll say allow new IP, and this is my start and end IP. For now, it will work, and then I will talk about what is the hack that I was talking about. Okay, let's test this connection again. So this connection has succeeded, as you can see, and I will now be able to finish this and connect to this database. So this is the database, and I can just right click on that and let's say create a new SQL editor. And if you want, I can, click on here, go to databases. You will see that there are different schemas, DBO and sales LT. In this, I have those tables called address, etc., etc., right? And which I can now also query from over here, or I can create new tables, etc. So I have just run that query. Now, what is the hack that I was talking about, right? Sometimes you will see that you create a database. First attempt you try to make, you are not able to access because your current client's IP address is not whitelisted. So you come and whitelist one IP address. Tomorrow, because it's a dynamic IP address, you will have a new IP address, and again you will have to go and add it. Similarly, when you are trying to connect to this database from Azure Data Factory, also you may face a similar challenge because again there is some another dynamic IP address being used, right? Only for your practice purposes, right? What you could do is you can open a wider range of IP address, right? For example, let's say I am just doing like this 002.255.255.255. So essentially what I'm doing is I'm allowing all IP addresses to be able to connect to this database, as long as they have got my username, password, and other database details like server details, database name, port, etc. Right now, anybody will be able to, from any IP address, I will be able to connect, as long as my credentials are available, with the person who is trying to connect. This is literally a dangerous setting. No production environment will ever have this kind of setting, but while you are learning, just to get around, right, and you don't want to get into a lot of errors just for the connection purpose, so you can try and do this, so that whenever you are trying to connect to your database, because it's a pure demo database, no confidential data in it, nothing absolutely to lose, and that's only for that purpose you can try this setting, and you will never face any connection challenges. So that's one hack that I talked about. Again, like I said, in a production grade environment, you will never have that kind of a open-ended settings. So, but I'm giving you that tip only for your demo databases that you will create, so that you are not facing any connection issues. All right. So that is how you create your SQL database and how you access that database. Now let's go to something called as, okay, give me one moment.
Right, all of these are practical requirements, but in most cases than not, how production grade deployments work is your SQL servers, right, or your database server will be created inside a virtual network, which all your corporate employees have access to, all your application users have access to, so that you do not have to do any whitelisting of IP addresses at all in any of those servers. So you will give a virtual network level access. So whoever has access to the virtual network, only those people or your application or your database will be available only on through that virtual network, right? That means you are able to handle security at a virtual network level itself. So that as long as you are securing connections to your virtual network, your database connections are automatically taken care of, or your database network security is automatically taken care of. That's how it works. Right, I'll take it as no. So let's continue. We saw some of the relational database offerings that Azure has on its platform, right? So for people who have been using Azure SQL database, right, or SQL Server, which is Microsoft proprietary database technology, SQL Server on premise. For them, it is very natural choice to go to using similar technology on Azure as a PaaS service, right, which will be SQL DB for them. In that, we understood what are the three different types of deployment options for a PaaS service, which is single instance, managed instance, as well as
we saw different SQL PaaS deployment options, right? But there could also be customers who are running different types of databases on premise, and they are also looking to migrate to the cloud, right? Who could be these customers and what could be the different technologies that they are using? So there are large number of customers who are running open source database softwares on their on-premise environments. And what are the popular database options as an open source database? So what you see on this slide, right? MySQL, PostgreSQL, MariaDB. So PostgreSQL is very popular because it is very close with respect to its compatibility with the likes of Oracle and SQL Server, right? MySQL is another very popular open source, right? So for a long time in the open source database world, PostgreSQL and MySQL have dominated the open source database market share. Okay. Now, after Oracle acquired MySQL, then the original creators of the MySQL, they created another database which is based on the open source version of MySQL, and that new database was called MariaDB. Okay, so MariaDB provided a easy lift and shift migration from MySQL to MariaDB. So today you will see the open source database users, right, or the customers using open source databases are largely spread between either a MySQL, PostgreSQL, or a MariaDB database. And remember here, so far I am talking about only relational databases. Okay, so traditional RDBMS systems. That is what we are talking about right now. We are not even talking about NoSQL databases. Okay, so as far as open source databases are concerned, the large market share is taken by PostgreSQL, MySQL, and MariaDB only. Now, for these customers, they also wanted to migrate and start taking advantage of cloud, right? The PaaS service advantage, higher cost benefits, lower administration. But the challenge that they had in on-premise world was, what were their motivation factors to migrate? Number one, their challenges were they are having to manage right from installation of the open source software, right, to scalability, to ensuring that the backup and disaster recovery is taken care of. Every single thing had to be managed by them, right, because it's an open source software. Now when they faced any challenges, they had to depend on the community, right? They had to assume, or just hope that okay, somebody would also have faced a similar problem, and probably they would have posted a solution to that problem in some forum here and there, right? So people would have to actually go find those solutions and then deploy it for their own use case. So that was the other challenge with open source, right? There is no enterprise support. Or if the other way to address that was to go for an enterprise support agreement with some company which provides you support for any technical issues or challenges that you may face with the product. So in the open source world, although your software does not require any licensing, but whenever you need some support, you could go to some company who is providing you support for that, and you can create a ticket for them, and then they will solve your ticket. That's how the model operated. Now they wanted to take advantage of a cloud service where they do not have to worry about any issues in the product, right? Even if it is an open source product, they wanted somebody to manage this service fully for them, right? So that's where Azure came forward, and likewise other cloud service providers have also come forward to create a fully managed service offering for these open source databases, right? And the deployment may be differently created, right? The deployment models may be differently available on Azure versus on AWS versus on GCP. So we will not worry about that for now, but we'll focus more on Azure as to how these databases are deployed in Azure as a PaaS service. See, Microsoft, if you talk about Microsoft a few years ago, Microsoft was a company primarily known for two or three important products, right? One is, of course, their Windows, right? And MS Office. Then you had SQL Server and you had Power BI, right? So SQL Server and Windows and even Power BI, right? For that matter, these are all proprietary to Microsoft kind of services, right? So Microsoft was a very software focused, proprietary focused organization. However, ever since Satya Nadella took over, they took the charge of driving Microsoft forward, we have a much open source policy, right? And we can proudly say, or Microsoft can proudly say, that Azure loves open source, right? So much so that Microsoft today is the world's number one contributor to the open source projects, right? And the way they contribute to the open source projects is They will not only create the open source projects themselves and make it available freely for everybody else to use, but also they will contribute heavily to other existing open source projects created by other creators. So in either ways, right, Microsoft has been a number one contributor. Now let's understand this. On this slide, right, a similar slide that you will see coming up. Earlier we saw details in Azure SQL database, right? This Azure SQL data warehouse, this was an old name to the service called Azure Synapse Analytics. So think of it like a data warehouse workload, which is Synapse Analytics. We'll talk about that at a later point in time. But Azure SQL database we already covered, and there are similarly open source databases for PostgreSQL, MySQL, and MariaDB. Like we saw for Azure SQL database, you will see some of these things are common, right? So it's not that only for a Microsoft proprietary database you are getting these features such as intelligent advisor, right? Flexible on-demand scaling, or built-in high availability SLA, right? Or backup and restore capabilities, auditing capabilities, etc., etc. Or separate compute and separate storage, availability in multiple global regions, as well as native connectivity or native integration with other Azure services, so that your Azure services or application layer is able to seamlessly connect to the database layer. So all of these features are also equally available within the open source databases, which are available as a PaaS service or fully managed service. Now, why Azure is a good choice when it comes to migrating your open source databases, right? Compared to maybe some of the other clouds such as AWS or GCP, right? So I'll not talk what is possibly wrong in other, but I will focus on what is good on Azure. Okay. Now, see the nature of open source database. Why people who are using open source love open source? We have to first understand that they love open source because they are not stuck to a particular service provider. For example, if somebody was using Oracle database or somebody was using SQL Server database, then they are dependent on Oracle or Microsoft, number one, for providing licensing, right, which includes high licensing cost. Number two, for any updates or any feature additions, all of that they were dependent upon the vendor, right? Licensing being the major part of it. Now, in Azure, when you create an open source, right, or any customer who is trying to migrate their open source workload to the cloud, the number one concern that they have is there should not be any vendor lock-in, right? What is vendor lock-in? Vendor lock-in means when I'm migrating my open source workload to run on Azure, it should not become proprietary to Azure. So that tomorrow, if I want to, go back to on-premise for whatever reason, or I want to run the same thing on other cloud, I should be able to do that, right? I don't want to get into some kind of lock-in where I am able to run my code only on Azure. Because if that happens, then the whole beauty of open source will go away, right? I will get stuck up with just one vendor, and then I will have to depend on them, right? So open source customers will never appreciate that, right? So for that, what Microsoft does is Microsoft makes the plain simple open source version of these softwares, right? PostgreSQL, MySQL, MariaDB. They make the community edition of these open source databases available on Azure as is. They will not make any proprietary changes to that, so that your open source remains truly open source. Tomorrow, if you want to, let's say tomorrow you migrate your database from on-premise to the Azure cloud, and you are running it fine on Azure. But whatever reason, if you decide that no, I want to go back on-premise, right, or I want to go from Azure to some other cloud, you will be able to take your code, deploy it to other same community version on either on premise or on any other cloud. It is going to run without any error. So that is the thing. And that's where Azure tries to keep it as open source as possible, so that you can do easy lift and shift, number one. Number two, You do not have to, start using any new code or any new, programming languages, etc. You can continue to use whatever you are using on premise. Now, along with that ease of, along with the ease of.
Quick question. Sorry to disturb you. So
No
how
problem.
this
Please
data
ask.
gets synced like from the on-premise to the
Yeah,
Azure?
I will come to that migration part. Okay, in a
Okay,
while.
thank you. Yeah, no problem.
Yeah,
Thanks a lot.
no problem. Yeah. So, so I'm still talking about some of the features, right? So easy lift and shift is made available, and along with that, when you start running your open source workloads on Azure, the what you get is an enterprise ready software, right? That means you are able to use now built-in, scale in, scale out in a matter of seconds, right? Or matter of minute. You are able to take advantage of unparalleled security and compliance of Azure platform, and you are able to get access to an industry global reach through 60 plus global regions that are available in which you can possibly deploy these databases, right? So all of these advantages you get. Again, the supported versions, these numbers are not most up to date, so it would have gone to a couple of versions further. So MySQL, the slide just talks about which are the latest supported community edition. I'm sure these have all gone up by one or two next versions that were released as an open source community version. And of course, there is also a service tier hyperscale, right? So there was a service tier available as a hyperscale for Azure PostgreSQL, which now has become Cosmos DB distributed PostgreSQL, right? So I will talk more about that in the later part of the session, where I'm going to show you a demo of how hyperscale actually works, right? Because I talked about hyperscale for a very large database kind of use case, right? In the context of SQL. There is also hyperscale service tier that was available for PostgreSQL, right? Which I just told you that now it has got combined with Cosmos DB as a PostgreSQL distributed database. So I don't want to confuse you right now. Let's wait for the demo, and that's when you will understand what is hyperscale much better, and then we will touch upon it again when we cover Cosmos DB, because that's just some internal realignment on Azure side or Microsoft side. Okay, I think we are very well aware of this slide by now, right? What are the benefits of PaaS, right? Here in case of PaaS, you don't have to worry about purchasing hardware management, etc., high availability implementation, protecting backups, ensuring compliance, right? All of these things are built in and easy to use. Monitoring, troubleshooting, managing at scale, rolling out updates and upgrades, then tune and maintain your predictable performance. All of these features you get out of the box, and that's where why this slide comes back again, right, is because your open source databases are also now available as a fully managed service or a PaaS service on Azure, right? You get three basic tiers, which is basic, general purpose, and memory optimized, right? Wherein you will notice that in case of general purpose, while basic is only for, let's say a development kind of environment, but for any production grade environment, you will either use general purpose or a memory optimized service tier, wherein a memory optimized service tier gives you double the memory. For example, here for every vCore, you get 5 GB memory in general purpose. On the other hand, in memory optimized, you will get a better hardware with more memory. So that you can accordingly choose whether you need a CPU optimized hardware, or you want a memory optimized hardware. So you get multiple options. Security comes in built in, so that you get security across multiple layers, right? From authentication and authorization through Azure Active Directory integration, to a network level security, to a database level security, such as threat protection or native authentication, like I talked about. You can control access. By default, you notice that whenever you create a database, it does not have any public access, right? So you have to enable it by securing or creating a server level firewall rule, right? Or you can put your database inside a virtual network, so that only the people or only the applications who have access to that virtual network only will be able to access the database. And similarly, you get protection against any kind of data leakage or any kind of data threats, because your data is always encrypted at rest when it is just sitting on the disk at that time, as well as when this data is in transit, right? So let's say when it is being replicated from one disk to the other disk in another region. So even during the transit, nobody can intercept this data and decrypt this data and read what that data is. So the data is encrypted both at rest and in transit, and so are the backups which are also encrypted. So this slide just talks about some of the compliance certifications, right, that are applicable to various industries or various domains, which Microsoft Azure Cloud has certified on. Just a few small list. Okay, hyperscale service tier. Now, and by the way, those compliances and all, for example, this kind of slides, right? You don't have to remember. Nobody will ask you, because these things are always available on Azure's documentation as a most up-to-date thing. And from exam perspective or otherwise, nobody's going to ask you all of those. But I'm including just for the larger understanding. Now, Hyperscale is the service that was that is available for Azure SQL DB, that was introduced for PostgreSQL DB, and that service still remains for PostgreSQL DB. It is just renamed to Cosmos DB for distributed PostgreSQL. Okay, but for until we go to Cosmos DB, for now, you just assume that you have a hyperscale service tier, which is available for two databases. One is Azure SQL DB and other is PostgreSQL DB. And here, as you can see, for MySQL, it is yet to be in public preview. So this hyperscale service tier right now is not available for MySQL. But what does hyperscale give you? First of all, it gives you ability to run a very large database. As we talked about earlier, right? It so that if you have a storage requirement that runs into multiple terabytes, let's say 16 terabytes plus or up to hundreds of terabytes, you can use PostgreSQL or SQL DB hyperscale. And to kind of just put things into perspective, right? Microsoft has an internal use case, right, which they have publicly published. That use case is for their Windows team. Right now, you can imagine there are multi-billion users of Windows operating system, and for every Windows operating system user, Microsoft continuously sends you some updates, right? Updates to your operating system, which you install, and then you sometimes have to restart your computer, right? So all of those updates are continuously pushed, right? Some of those updates contain some security updates or some feature updates or whatever, right? But Microsoft uses Azure PostgreSQL hyperscale database to manage a petabyte scale database, to manage all these updates that are pushed for their Windows operating system. Now you can imagine, if it works at a petabyte scale for Microsoft, it will also work for your customer, at a much lesser scale, like 100 terabyte or whatever, 50, 20, 30 terabytes, etc. It is reliable and available. It is scalable, up to 100 terabyte. You can just scale it yourself. If your use case requires going beyond 100 terabyte, then you can reach out to Microsoft engineering team, and then they will work with you to understand your use case better. And then they will enable your subscription to go beyond 100 TB for this service. So all of that is possible. You get high performance, and most importantly, it is a hybrid, right? You get best of the both worlds. You get a good distributed database. At the same time, you get a good OLTP database. That means you are getting a sweet spot between a transactional data store and an analytical data store. And that's why it is also called as HTAP, hybrid transactional and analytical processing. So when you have those kind of requirements, and as we go to the demo, it will become much easier to understand. But those kind of requirements, hyperscale gives you a good ability. And by the way, hyperscale is also something that differentiates Microsoft from other competitors, right? They do not have a similar matching service offering that Microsoft provides with its hyperscale service tier. Now, how hyperscale works, right? It gives you ability to scale out horizontally, right? That means your database is created in a way that it consists of multiple nodes, right? There is one master node, like you can see here, there is one master node and then there are many worker nodes. So when you create a database, you will select some configuration for a master node as well as worker nodes, and your data will be distributed across all these worker nodes, right? And what is a node? Node is nothing but some kind of compute, some kind of think of it like a virtual machine underneath, right? So your data will physically reside or be distributed across all nodes, so that whenever you submit a query through master node is able to take advantage of a MPP architecture, massively parallel processing architecture, to run that same query parallelly across all different worker nodes. And then whatever is the individual output of the query from each worker node, that master node will combine together to give you the output of the original query. So that is how it takes advantage of MPP processing. Again, I'll repeat, it's called massively parallel processing, MPP. So it takes advantage of MPP architecture to distribute the queries to run on smaller amount of data and give you faster performance, blazingly fast performance. The architecture is simplified. Why it is simplified? Now I just told you that you are going to have a master node, you are going to have a worker node. Now as a developer, do you have to worry about it? No. As an end developer, it does not change anything for you. Like the way you would connect to a single instance database, you will also connect to a hyperscale database in exactly same way, right? So from an end user perspective, from a developer perspective, these things are kept abstract so that you do not have to worry about learning or unlearning anything while working with a hyperscale database. And the other aspect is stay current with PostgreSQL innovation. So the way hyperscale service tier was created, again with that, Microsoft wanted to keep their commitment to open source, right? That means, what if one of my customer is migrating their open source on-premise database to Azure PostgreSQL on cloud, right? And if they migrate to hyperscale service tier, would that mean that they are locked into, using it on Azure? Probably not. Why not? Because in an open source world, how things work is you have a community edition, right? Which gives you basic software, baseline of a software. And on top of that community version, there are number of external extensions that are available, right? So these extensions are things like plug and play, right? You can plug and play an additional extension. For example, let's say you plug in a USB device to create an additional storage within your computer, right? You will use the USB device only when you need. Similarly, think of extensions, or in case of PostgreSQL, think of extensions like a piece of software or piece of programming that somebody created and that is available for you to plug and play within your community edition of the PostgreSQL. So Microsoft keeps it that way so that the open source PostgreSQL remains open source and you are able to take advantage of all the innovation that is happening in the open source community, even when you are using PostgreSQL hyperscale. Now that's about hyperscale. Now let's understand the way Microsoft implements these open source databases within Azure and how it helps them to ensure that these databases are highly available, right? That means they are able to guarantee that their databases will be available for, let's say, 99.9 or whatever percentage SLA that is there. How do they, what is the architecture underneath that, right? So what you see here is this is, think of it like Azure Fabric, right? In this Azure Fabric, you have Azure Storage, right, which contains 3 copies of your data, right? Then there is a MySQL or PostgreSQL or MariaDB, right? Think of it like any of those open source database engines or database server. So there is some server that you are creating. So your compute is separated from storage, right? There is Azure Database Management Service, right? An overarching layer which manages this whole infrastructure, right? And how your applications are connecting, right? So your PostgreSQL application or MySQL, MariaDB kind of application is connecting to this server, right? Server component of MySQL, MariaDB or PostgreSQL. And this server in turn is talking to the actual database storage. Now, whenever let's say a copy of your data is corrupted, Microsoft will automatically check, Azure will create another copy of the data. Now what if your server is not available for any reason? So if there is any issue with the server, they will create another server. So and they will repoint your application to the new server instance that they created. So if there are any challenges with your server, they will automatically create a new server and immediately just point that server to the same data storage, so that they don't have to move or migrate any data from one place to the other, because they have already kept the storage separate from the compute, right? This is how they manage or are able to give you built-in high availability. Now, let's also understand the scalability part of it, right? So high availability is one thing and scalability is another thing. So again, in terms of storage and compute, right? So because they're independent, you can, easily scale. For example, you were running on a 4 vCore compute, right? From a 4 vCore, you want to go to, let's say, a 16 vCore machine. So how it works is, you will first create that new server, right? And only once the new server is up and running, after that your old server, your connections from the old server will be pointed to the new server. Your new server will point to the same database, and everything will be seamlessly migrated to the higher version or a scaled up version of your Postgre or MySQL or MariaDB database, and it will point to the same storage. So with this kind of technology or implementation, they are able to do scale up and scale out much easily and without any downtime. So that is the easiest way to scale up, scale down your MySQL. Okay, some of the other benefits that you get, right? Backup and restore. So because these are available as a PaaS service on cloud, so you do not have to worry about these things. So you get backups, right? And you can choose between LRS or GRS. That means you can keep your backups either locally redundant or geographically redundant across completely different Azure region. Then you can restore from geo redundant backup. So there is also a service called as point in time restore. As you can see here, PITR, right? So, but before I go to PITR, your backup is also available at no extra cost, right? That means if you had 100 GB of storage for your database, then that much amount of backup storage is available for free. They will not charge you for that. If you want to create an extra copy of backup in another region, then you may have to pay, right? But otherwise, for one copy of backup, you will not be charged. That's one thing. Now, what is PITR? Point in time restore. Now, point in time restore means, and by default, it is set to 7 days, and maximum you can set it up to 35 days. Point in time restore means you can restore your database to the state at which it was at a particular specific point in time. That means, let's say I am working on my database and I ran some script which could have possibly corrupted some data. Now I want to go back to a previous healthy state of my database, right? I want to undo all of what I did, let's say in last 2 hours. If I were to do that, right, I can just go try to select the restore option in the PITR pane. And from that restore option, I will just have to provide a specific point in time, as of which point in time I want to restore my database as of that point in time. A new database instance will be created with exactly the state of the database as of that point in time. Now, if you see some of these screenshots just show that, how you can restore to a specific, restore point in time, and it will be created in the new location that you provide, right? So you can create that restored database into altogether different region. That's how it works. So the screenshots just show you, some of those options. I will show you these options also as part of the demo and as part of uh, the Azure portal when we create these things on Azure portal in some time. Okay, what is monitoring and alerting? So you get built-in monitoring, right? You get configurable alerts your built-in monitoring is available through Azure portal itself, right? A number of key metrics or key parameters of your database service you will be able to monitor without having to write any code or without having to query any of your metadata of the database, right? You can configure alerts, so you can set up rules that, okay, I want to auto scale my database up whenever the CPU percentage goes beyond 80% utilization, or whenever the memory utilization goes beyond a threshold of, let's say, 90%. So you can, create alerts that will send out notification. You can even, create scripts that will automatically scale your database up and down based on certain, important metrics. So all of that is doable, possible. This is just showing an example of an email, right? It says CPU greater than 20% in last 5 minutes. So maybe I've set up a alert whenever CPU causes, utilization is more than 20%. Then this is the kind of notifications that you can generate as an example. Okay. Now, when you go to PostgreSQL, right? So you will in PostgreSQL or in some of these open source database as well, you will see multiple deployment options, right? One is a single server deployment option, right? Which was an old way of implementing these databases on Azure, right? But single server is not no more recommended by Microsoft, right? Because they initially created that service option, and as they studied the customers who were using the single server, there are number of things that they improved compared to the single server deployment option into the flexible server, right? So now Microsoft's recommended option, right, and the one that you should remember for all practical purposes is the flexible server, right? Whenever you are talking about PostgreSQL, MySQL, MariaDB on Azure, you are possibly talking about flexible server option, right? This is again a PaaS service. You will also see single server option, but you may, and you can try and create that also. Nobody stops you from doing that. But Microsoft's recommendation is to go for flexible server whenever you are creating a new database. But if you do want, let's say you are an experienced customer, you know that single server works fine for you, right? And whatever new features, new changes that Microsoft has brought in flexible server, they are probably, you don't need those, and you still want to consciously continue with single server, then as an end customer, you still have that option. But Microsoft's recommendation is to go for a flexible server. That is how you should look at it. Now, why flexible server over single server, right? Because it's both the services are being offered by Microsoft. They started with single server. At some point in time, they introduced flexible server. So they are also telling you what is the rationale, right? What are the changes that they made with flexible server? What were some of the issues that were reported by customers when they were using single server, right? So what are some of those things that they newly created, right? Or what is it that they fixed with the flexible server deployment option? So here they are giving you maximum control for your database, right? So see, who are the customers using this? They are the customers of open source databases, right? So primarily customers who were managing these open source databases on premise, they were right from the installation of the software, they were managing every single thing, right? Every damn configuration of their own the open source database they were managing. Suddenly you come to a PaaS service and you realize Azure has started managing a lot of this for you, right? That means as a database administrator, you would feel that, okay, something has been taken away from you, right? You are no more able to control certain server parameters the way you would want. Rather, Azure is controlling those for you, right? So, but there could be some important controls that you would want to keep with you as a customer, right? So those kind of feedbacks were shared with Microsoft. Microsoft took those feedback and then they created a better version of a PaaS service of these open source databases with flexible server. And then they said, okay, we are giving you back some more controls so that you can better tune your database for the performance level that you want, right? Also, they are giving you more options to let's say manage when your server should undergo upgrade and when not, right? So you get better maintenance window. So it's not that the maintenance of your database will automatically happen when Microsoft wants, right? They'll give you larger notification window, ability to postpone, prepone, or whatever, right? So some of the additional settings, access. Now build resilient applications across availability zones. So there is a concept of availability zone that I have explained to you, right? So there are different types of redundancies that we can create: a local redundant, zone redundant, geo redundant, right? Within the single server kind of a deployment, zone redundant availability was not possible, right? So with a new deployment option, which can take advantage of availability zone, that is available with flexible server. And similarly, third one is simplified developer experience, right? So in case of single server, there were some peculiar nuances which were not, or some ways, right, in which the way developers would connect to the open source database in an open source world compared to connecting to the same database in a same open source database on Azure, right? There were some differences with respect to how you provide your database name, because in Azure you would always provide it as your database name @server name, right? However, in case of an open source, you just provide database name. You don't provide @server name, right? So those kind of small minor changes were there, which were kind of hitting productivity, because an open source developer, when he tries to connect to that service on Azure, they would first of all face some error, right? Because they have not use the database name as database @server name. Then based on that error, they would realize that, okay, in Azure we have to add that @ and server name also inside the database name, and then they would be able to connect, right? So some of these things were not seamless, or they were not consistent with how these developers used to work with open source databases. So Microsoft kind of changed all of that, and created a much simpler developer experience with flexible server. And that is where they say, okay, this is our uh, recommended option, or recommended deployment option to you, but it is up to the customer what to choose. How flexible server architecture works, right, with availability zones. So let's say in a flexible server, this is the region in which you are deploying in availability zone 1, right? So let's say you are running your application on a VM, you have a PostgreSQL database, you have, let's say, a Kubernetes cluster, app service, all of these are running. So you have a Linux virtual machine on which let's say your PostgreSQL is running, and then this is a separate storage, right? So when you are going for a zone redundant architecture, you will have 3 copies of your data. This is how zone 1 will look like, right? And similarly, there will be another zone 2, another zone 3, in which you can create a replica of the same zone, right? However, your backup storage, as you can see, it will be available across all 3 databases. So zone 1, so whatever you see in this zone 1 picture, same thing will be available in availability zone 2. Same thing can be replicated in availability zone 3, and all of these 3 will connect to the same backup storage, which is replicated across all 3 zones, right? Now, in case of how disaster recovery or how high availability is managed, right? So this is zone 1 architecture, right? From zone 1, let's say zone 1 is your primary. So you are doing read write to zone 1. Whenever you are making any changes to your database, those are synchronously replicated to another standby database or a secondary database in the second availability zone. Okay, so that means these are being synchronously replicated, and both of them are accessing your storage from this common zone redundant backup storage. So all your backup storage is also zone redundant. Your data or your transactions are being synchronously replicated. That means you are kind of having an active, or active, always on primary and secondary database, where you can very easily fail over to a secondary in case of a disaster without losing any data, right? Because this is giving you synchronous replication. So for business critical application that require synchronous replication, and they want multiple copies of their databases which are active, for them this availability zone is a boon, right? On the other hand, in the single server, because it cannot take advantage of a zone redundant setup, you have to create a geo redundant setup, right? In case of, if it was, let's say, if these were not two availability zones, if this was a region 1 and region 2, this replication will not be synchronous, it will be asynchronous replication. That means there will be some time lag when the transaction is replicated from one region to the other region. And in case of a disaster, there is always a chance that you may not get zero RPO. What is RPO? RPO is recovery point objective. That means how much data loss can you afford, right? So if a customer wants zero RPO, that means what they are saying is they do not want any data to be lost. The data loss recovery point objective should be zero. That means all of my data should be recoverable, right? I should not be losing any. So RPO of 1 minute means I am okay as a customer whenever disaster happens. If you are, if I'm not able to recover last 1 minute of data changes, that is acceptable to me. So then that would mean that customer is telling you the RPO is less than 1 minute, right? So every customer, depending upon their business, the criticality of their application will always define some RPO and RTO. Since we are talking about RPO, RTO, let me also talk about what is RTO. RTO is recovery time objective, right? So in case of a disaster, how quickly, within how many minutes my system should be up and running, or my failover from primary to secondary should happen and my application should continue working again. That is called as recovery time objective, right? So typically you will say my recovery time objective should be under 15 seconds, right? Or for a very business critical application, or under 30 minutes if it was not so business critical. And if there is a disaster, within 30 minutes I should be able to recover from whatever disaster, and I should be able to continue my business. So depending upon the criticality, customers would typically define what is the RPO, RTO that they want, and accordingly you will make a choice as to whether you want a zone redundant or whether a geo redundant will work for you, or if it is not a business critical application at all, then do you really want to create any redundancy and increase cost? So there are different considerations that you have to take in to address or to create a right solution architecture according to the requirements. Now again, this slide talks about a little bit more about what are some of the improvements in flexible server that Microsoft has brought in. It has with the new flexible server, they implemented this PostgreSQL internally on a Linux based virtual machine over Windows based virtual machine, right? They reduced noisy neighbors, so there is a virtual machine isolation boundary that they have improved. Then there is predictable storage performance, all of these things, right? Good to know. And you can always read from the latest Azure documentation. Nothing to remember, nothing to by heart from an exam perspective. What you should always remember is what is Microsoft's recommended choice: flexible server, right? So if they come ask you in an exam and give you multiple options with a scenario, which one will you go for, a single server, flexible server, hyperscale, etc., you should be able to choose the right one. So that is more important. Okay, some of the addresses some of the challenges that single server. So this is something that even I have practically faced, right, with one of the customers. I know it's about break time also, so give me like 2 minutes to finish this and then we will go on a break, and I will also come back to participants who have any question. Okay, so give me some time, give me 2-3 minutes to finish this, right? So uh, so I was once working with one of the India's biggest telecom company, right? I'll not take the name, but you can probably imagine. And I'll not say biggest. I'll just said one of the biggest, right? One of the larger telecom player in India. They were facing some challenges, right? They were running Azure PostgreSQL single server database, right? And what was happening is suddenly at certain point of the times during the week, the usage of their mobile application users was suddenly increasing. Maybe those users were trying to do some kind of bill payments or recharges, etc., etc. But there were certain patterns where or maybe they were running some offers or whatever for whatever reason, there was sudden spike that was happening in the uh, in the traffic that was coming on the application, right? And the end result of that was that traffic was being denied and the application was failing, right? So as we were going through the root cause analysis, we were trying to fix this because the application was actually facing issues, and the end users were reporting that back to the back to that company that, hey, your application is not working, I'm trying to do recharge, I'm trying to check my balance and whatever, right? So it was actually affecting end user directly. And what I'll now cut to the chase, right? And I'll directly tell you what was the challenge that we figured out, right, after a lot of investigations and deep dives into that. So what we noticed, right, there is a component called as gateway. So the way it works in Azure, or the way single server works, is single server as a database is sitting behind a gateway. Now, what is this gateway? Gateway is a component that manages all the traffic to the single instance, right? And Azure was also using this gateway to make sure that there is protection against distributed denial of service attack, right? So if there is a DDoS attack, this gateway was supposed to block that attack, right, and secure the database server. So what was happening, because there was sudden spike in the number of users, right? So whenever the connections were suddenly going beyond 5,000, right, suddenly going above the normal average, the gateway component was thinking that this is actually some kind of DDoS attack that is happening, and it was trying to, in an attempt to or in a bid to protect database server, it was rejecting those connections. Although those were legitimate connections from the legitimate users, because gateway component thought that it could be a DDoS attack, so those connections were being rejected. So we worked with Microsoft engineering team, and they fixed that problem, right? But ultimate solution to that was further, at a later point in time or at a future point in time, we recommended that to the customer that please migrate to flexible server, because in flexible server, there is much better connection pooling, a flexibility that is available, and these kind of challenges are resolved that customers used to face in single server. So there is maintenance window, right? Here customer can control when maintenance of your database server will happen. You get availability zones, right? So resiliency with zone redundant high availability. It's a Linux based deployment and improved out of box performance. So out of box 4 week or flexible server is going to be better than in terms of performance than a 4 week or single server, right? So flexible server. So whenever they release a new version, right, they will also tell you as to why you should use a newer version compared to an older version. So let's first understand as to why PostgreSQL, right? PostgreSQL is an open source database, right? It has been there for decades together, right? For multi-decade, customer have been running their business critical databases on PostgreSQL. It has got a very large developer community, and it is extensible, right? So I was talking about hyperscale as an extension. So you have got a base community version of PostgreSQL, but there are a lot of plug and play kind of extensions that are available to solve specific problem, right, in a different way. Think of it like there is a problem to solve, which you create a user defined function, right? So you were doing something and you faced a challenge and you created a user defined function to solve your problem, and after that you made that function generally available for other people also to use if they want to reuse your code. That becomes an extension, right? And it becomes a plug and play for somebody else who is trying to solve the same problem. So that is the beauty of open source. So there is a large developer community that is out there, right, supporting and making PostgreSQL grow. It is a proven and resilient database, and it's stable, right? The kind of uh, production grade and business critical workloads across various industry verticals which are running PostgreSQL today speak volume of how stable and how resilient it is as a database technology, and that too an open source one. And it has got a rich feature set because it is able to solve multitudes of problem for you, right? What could be one example of trying to solve different types of problems? So imagine uh, it being a traditionally relational database, right? A relational database would mean that it works on a tabular structure, right, which has rows and columns, right? But while it is able to give you a good relational database, it also gives you ability to work with a differently structured data, right, or a semi-structured data in the form of JSON documents. So it has got different rich feature sets for which we are selecting PostgreSQL kind of data for our demo use case, right? So let's further understand what is the demo use case and what this demo will show you. The demo is in three parts. The part number one shows you how to how PostgreSQL accommodates differently structured data within the same database. Part two, in this you will see how to create a PostgreSQL database on Azure. It is very similar, right? You would see that we are taking the same set of steps, right? Create a new resource and then create a PostgreSQL database. More or less, it is very similar. But we will also understand the performance of PostgreSQL, and after that, we will try to relate a single server performance with a hyperscale service tier to better understand the offering of hyperscale service tier as to how it can really change game for customers who require database that should support very large data storage, right? So we will see all that. But to put things into perspective, let's understand our use case better, right? So let's say we want to create a database, be it PostgreSQL or any database, right? Our use case is simple. We want to create a database for an application like GitHub, right? As you all may be aware, what is GitHub? GitHub is a portal, right, in which you as a developer come create your account, right, and you can share code with each other, right? So you create your own GitHub repository. For example, even if you want to access the code for PostgreSQL, you can go to PostgreSQL repository, open source repository, and in that you will be able to see who all are using my PostgreSQL database, right? Or any other open source database or any other GitHub code repository that is made publicly available to everybody, right? So it's a large, it has got 28 million plus kind of users, active users that use GitHub today. So in this kind of if for this kind of a portal, if we were to choose a right database, and let's say we are saying we will use PostgreSQL database, then understand what is it that this database has to do. So let's say I come over here in this portal and search for a repository called PostgreSQL, right? It gives me out of 28,000 all these results, right? Ranked in any order or whatever right, relevant order or best match basis, right? So I searched for something, I got 28,000 plus results, and they also were quickly sorted based on the best match with respect to my input. And let's say I've found the PostgreSQL code repository that I was looking for. So I will click on this repository. I may have different kind of users here, right? Some users could be more transactional user. As an individual developer, I would want to come, contribute to this code repository, add new files to it, right? On the other hand, I may come in as an administrator of GitHub, right, and understand, okay, how many code repositories are being created on this, who are the larger contributors of of different code repositories, what is the average number of commits that are happening on across various different code repositories on GitHub, to understand how well developers are engaging across different communities on the GitHub, right? So or repositories on the GitHub. Now let's say here I am now looking at this data, and what I want to do is I want to create a new file, right? So for example, I will go here, click on create a new file. It will open this place. I will provide the name of the file, okay, and then I will add some sample data to it, okay. So whatever data that I want to add, and propose the new file name and create that file, right? So essentially, adding a new file could be one way that a user works on this portal, right? The other way is to go to the insights and try to understand who are the top contributors, right? So that this kind of visualization. Now you imagine, I'm right now showing you two types of processing, data processing. Number one was transactional data processing, wherein a user is coming, trying to contribute a new file to this code base or to this repository, right? That's more of a transactional thing. Now I am showing you analytical processing. What is analytical processing? I am coming over here and I'm trying to understand some analytics, right, from year 1998, when probably this was first created, all the way to latest years, right, by the time this demo was created. who is the top user who is contributing to this repository, code repository, right? Who are my other top users? How are my users contributing, right? For example, if I look at this user was very active initially in terms of their contribution. They have made 13,000 plus commits to this PostgreSQL repository, right? But off late their engagement is not as much, right? On the other hand, there is this other user who is active recently, but this user was not active earlier. I can get a lot of different insights of this kind from analytical processing of my database. So there could be different types of users who are trying to use this database, which is a backend for this kind of application, and there are different types of user trying to do different types of things on that. So in this scenario, right, what is important, right, in terms of requirements is it should allow developers to ship their code fast, right, create new files and save their repositories, provide administrators with insights about developer activity, right? How is the developer engagement level across different types of repositories? What it will require a data store which can store the event or activity data, right? So whatever events, whatever activities are happening on those repositories, we need to capture, and that requires both structured and unstructured data. You want to add or modify the data, for example, whenever a new user comes, right? You want to, let's say, create a new user record for that, right? Or whenever you want to create a new file or modify an existing code file, you would want to do those changes. Or you want to build dashboards, right, on the basis of this data that is available to you, that will show you the information in the form of graphs, right? All of these we saw on that portal. Now then there are real-time analytics, right? For example, take a count of total sum of the contributions of a particular user, right? Or total contributions to a particular a repository. Or on the when we search for PostgreSQL repository, it also showed that there are 28,000 results, right? So that means the count of the results, matching results, also needs to be done in real time, right? And showcased or displayed onto the portal. So there is real time, and non-real time kind of analytics that may be applicable, which require some summation, counting, averages, these kind of aggregate functions to be run. And of course there will be operational and transactional queries. That means updating something, inserting something, modifying something, and accommodate. And the most important part, right, which will not be very evident the way we saw the demo, right? So far we talked about what are different ways in which and different types of users will interact with this system. But there is always something called as non-functional requirement, right? What could be a non-functional requirement? That this architecture, this database should be able to scale to the growing demand, right? If my users increase from 28 million to, let's say, 100 million tomorrow, right, what will I do? So will this database be able to support that kind of a scale or grow at that kind of a scale? That is another important aspect to consider the data store. Now let's say PostgreSQL, right? We will try to see how PostgreSQL answers each of these different types of requirements. So PostgreSQL is able to accommodate differently structured data, right? That means it does not give you only a row and column kind of a data store, but in terms of columns, it also gives you some columns called as JSON blob, right? For example, these are the two tables that are used in our use case, right? And they are based on the real GitHub use case. So there is something called as GitHub users, and there is something called as GitHub events, right? Here you will have your user ID, which is a primary key in the GitHub users. The same user ID becomes a foreign key in the GitHub events table, right? So these are all the events associated with this user, right? So I log in as a user, and whatever activities I do, those will be created like a event. So if I'm adding a new file, right, the content of that file and all of the other things that I'm trying to do, all of those activities will become events. Now, if you take a look at the structure of this events table, you will notice there are three columns, right? A payload column, repo column, and org column, right? These columns, the data type of these columns is JSON blob, right? JSON B, JSON B, JSON B. That means this is a blob. This is a character blob in the form of JSON document, right? A JSON document, and I think I also have an example of that in the coming slide. This is how an actual JSON document looks like, right? So what it has is it has a key value pair, right? Now, and these key value pairs can be anything, right? So it doesn't have to follow exact same structure, right? So some documents may have these commits information. Some documents may completely not have this this block, right? Some documents may not have this push ID, or if it was not a push request, if it was a pull request, then it will probably have a pull ID, right? So you can bring in your unstructured, semi-structured data in the form of another column, which is given a data type as JSON blob. So this shows that PostgreSQL is not able to work only with the structured data, right, which is split into rows and columns, but it is also able to handle JSON data, which is semi-structured or unstructured kind of data, right? And so far I'm just showing you, what kind of data it is, right? As we progress with the demo, you will realize as to how it is able to efficiently query through this kind of data, right? Or update this kind of data, or run aggregates on that. So let's come to that. What is the part 2? Now, how to provision a fully managed PostgreSQL database on Azure, right, within just few clicks. Now, let's see how it works, right? So by the way, as part of this demo, right, so all of these are canned kind of demo, right, that I have access to because I am a Microsoft certified trainer, right? There will not be many trainers who can show you this kind of demos. Or the kind of things that I have access to, but for the purpose of better understanding, I am using these. Now, how do you create a database, right? You see, this is and by look and feel, you can imagine that this is not the most latest look of Azure portal, right? So you are logged into Azure portal, but this is as of the time when the demo was created. So on the Azure portal, when you want to create a new database, what you will do is you will go to the databases, right? And maybe select a PostgreSQL from over here. And then you can create either a single server or a hyperscale. Now, today, if you go to Azure portal and search for PostgreSQL option, you will get more options than just a single server and hyperscale, right? And probably that hyperscale option will not be here because the hyperscale is now called as Cosmos DB distributed PostgreSQL. Okay, but essentially, in the essence, in the nutshell, it remains the same hyperscale product, and that's why I'm showing you the demo of hyperscale. The same will be applicable to Cosmos DB PostgreSQL, but we will come to that, or we will touch upon that when I come to Cosmos DB. Let's first finish this. So let's say I'm creating a single server. Again, I'll click on create. The basic details that I have to provide is my subscription resource group. Then I have to enter the server name, right? I have to enter some administrator username, password, and then confirm that password, right? And then I can select the location in which I want to create. Let's say I want to select US West 2 region or West US region, whichever, right? And I will click on review and create, and it will automatically, when I click create that database for me. Okay, so this database is being created. Let's say it got created and I go to that resource and I want to, let's say for the purpose of demo, I have both single instance database as well as a hyperscale database created already. So I will go to my single instance database. Now here you can see some of the, in the overview tab itself, some of the key important metrics of your database are readily available to you, right? That means what is the resource utilization, right? In terms of CPU, in terms of storage percentage, how the utilization is looking like. Then you can try different number of other different things. For example, replication. If I go to replication, currently I don't have any replica, right? Or sorry, there is one replica already available. So my primary database is in West US region. In the West Europe region, there is one replica that is available. Or this is a master. If I want to add replica, I can just click on add replica from over here, and then I will be able to add replica. Now, if I were to restore this database, I talked about some of the features such as point in time restore, right? If you were to do a point in time restore, all you have to do is click on the restore option and select a specific point in time from over here and the database. So you will have to give a new server name and select the region in which you want to create that server. And when you click create or click OK, the new server will be created in exactly the way that it will have the data as of this specified point in time of your original primary database. Now, let's look at some of the other options with respect to other configurations. Let's connect to this database, right? So let's click on connect, select the single instance database, click connect, and let's run some queries, right? Just to understand. Now what I'm doing is I'm just doing a count check on one of the tables. So there is a table called as GitHub events 10x right? This table, I am just checking a count, a row count. It has got 1 million records. So if you exactly see, there is 1,146,625 records exactly in this table. So this is a table with 1 million plus records. Okay. Now let's see another query that we are running on this. What is this query? This query is a join query. It tries to find the top 10 users who created the most number of repositories in GitHub, right? And for that, as you can see, the GitHub events 10x table is our driving table, right? So this is the main table. This table is getting joined with GitHub users table on this user ID column. And we are saying that, okay, we will apply some where conditions that event type should be create event. And on the payload column, right? If you remember, this payload column was a JSON object, right? It is not a straight character string column or a date type or numeric column. It is actually the data type of this column was JSON blob, right? For JSON B kind of a data type, what we are doing is we are further going inside this and we are selecting a specific key value pair, right? So we are saying reference type of payload column, and in that this key reference type should be matching to repository. So this becomes our where condition. So this is how PostgreSQL makes it easy to work with differently structured data, right? And we don't stop there, right? What we are doing is we are also doing some group by, we are also doing some finding some counts, and we are doing some aggregations. Further, we are doing some order by to order the results in a descending order, and then limiting the records to output to only 10 first top 10 records. So if I run this query, you will see this query has run in about zero point 0.3 seconds. So this query has a driving table, which is GitHub events 10x table. Okay. And for a driving table with more than 1 million records, the query has finished in just about 0.3 seconds. Now this query is an example of an analytical query, right? This is not a transaction that as an end user, I come in and I try to create a file or I try to create a new user. This is rather some kind of analytics where you are trying to find who are your top 10 contributors who created most number of repositories, right? Now let's complicate this further and let's find the number of commits to the PostgreSQL repository on master branch per hour, right? So how just understand the kind of filters that I'm applying, right? Which is my driving table. GitHub events is my driving table. I am filtering on event type should be equal to push event. Then I am doing further filter clause on two of my JSON blob columns, right? So repo and payload. In that, I am selecting specific key value pairs. That name should be equal to this Postgres, and reference should be equal to either refs, heads, master, right? That means I am creating this push event on the master branch. So, and I am further doing a group by and order by, right? So if I run this query also finishes on a 1 million record in about 2 seconds, 2.8 seconds, right? So remember these numbers because we are going to completely change the scale of the events or scale of the data, and then try to understand how hyperscale can help us with the in accommodating to growing demands, right? So far what I showed you is how to create a PostgreSQL database, how it accommodates differently structured data, how it is a performant database for both analytical as well as transactional kind of requirements, right? So we saw these analytical queries. Now let's also see an example of a transactional query, right? For example, this next query here, if I click on this, what is this query doing? Let's say it says insert into GitHub users and it is inserting a new record. That means if I come to GitHub and if I'm creating a new user, that means as part of that operation, I will be inserting a new record into GitHub underscore users table, and that is a more like a transactional operation, right? So how quickly that runs, that is also important, right? So this got completed in just about 9 milliseconds, right? So what it shows you is you have got a good performance on a transactional kind of queries. Also, you have got a reasonably good performance on an analytical kind of queries, right? But what is the scale of data right now? We are working at a roughly 1 million kind of a record in a driving table. Okay. Now let's take the scale up and let's understand. But before we get into the hyperscale and next set of things, let's understand some of the other features that you get. Because now these PostgreSQL, MariaDB, MySQL, whatever you get, this is a managed service for you. This is no more an open source. So you get some enterprise ready features that are available that you can take advantage of, right? For example, here, if I were to go to this query performance insight over here, right? Here, as you can see, in the last 24 hours, whatever query that ran, you are able to see it, right? So if I go to past week, so I can see what are my top running queries from past 1 week, right? So these are my top 10 queries. For example, it's currently it shows top 5 queries. I can change it to top 10 queries. Right now, these are my queries. This is exactly the query text that I can see, and I can now search this text inside my application code to figure out from which part of the code my query is being called, right? How much duration is my query taking. So I can come over here, try to understand different parameters of my top running queries, and accordingly figure out what I want to do with it, right? So this is how you can very easily and quickly understand which are your top performing queries or which are the queries that may require further performance tuning, etc. I can go to the pricing tier that is shown over here, and I can easily scale my database up and down, right? So I can, let's say it is currently running on 4 vCore machine, right? If I want to change it scale to further, let's say 8 vCore, all I have to do is go to pricing tier and just drag and drop, right? If I want to change the database storage and increase it, I can increase. If this is the point in time restore, right? Backup. By default, it is 7 days. If I want to increase it to, let's say, 14 days, I can do that, 15 days, whatever, right? And I can click on OK and it will be saved. So scaling up is very flexible and very easy. I can easily just with a drag and drop and a click through experience, I can change all of that. Now let's understand how PostgreSQL will come into picture when it comes to growing your application data size, right, and performance using a hyperscale service tier available on Azure, right? Again, it's a differentiator which only Azure has today compared to their competitors. Now, instead of single server, right, you would create a hyperscale service tier. So when you want to create a hyperscale service tier, rest of the details remain same, right? You will provide some basic information like resource group, server name, etc., etc. The key important is this configuration over here, right? Here, what you do is you select a worker node as well as a coordinator node configuration. So in hyperscale, always remember it is a distributed architecture, right? Or an architecture which takes advantage of MPP, massively parallel processing. That means you will have a master node and then you will have a parallel worker nodes in which parallel query can run, right? So you can select what is the configuration that you need for your worker nodes. Let's say you want a 16 nodes for how many worker nodes. You want 16 worker nodes, right? For each worker node, how many CPU cores? Let's say if the default is 4 CPU cores. If I want to change it to, let's say, 32 vCore, or here also if I want to change it to 1 TB of storage for each worker node, right? Accordingly, I can select my configuration. It will transparently show me what is the cost going to look like, and it will accordingly create a hyperscale PostgreSQL for me, right? Now, for the purpose of demo, we already have a hyper scale PostgreSQL already created, right? How it looks like when you go to overview, it shows you a coordinator node, and it shows you, let's say in this case, we have 4 worker nodes. So it will show you all the worker nodes, right? It will also show you the configuration. Our coordinator node has got a 4 vCore machine with 16 GB RAM and 0.5 TB of storage. Similarly, each of the 4 worker nodes are of this configuration: 8 vCore, 64 GB RAM, and half a TB of storage. So this is the kind of storage structure or a database structure that you have got. Now let's try to run these similar queries by connecting to a PostgreSQL hyperscale instance, right? So if I were to connect to this, and let's run this query, for example. So now if you notice this query, which had taken roughly 2.8 seconds, right? This query had taken 2.8 seconds in the PostgreSQL single instance, right? The same query now ran in 0.2 millisecond, right? Now, what is the big deal, right? Because it's still running on 1 million records, right? The same table, GitHub events, and we are running it on a MPP architecture, so it is performing better. No wonder in that, right? But if we want to check the hyperscale, okay, so see, for the, if we are talking hyperscale, then why not talk a bigger scale of the data? So why run on a 1 million records table? Let's run these queries on uh, a table which is 100 times having more data, right? So if you look at this record count of this GitHub events 100x, it has 114 million 662,500 records exactly. So precisely those many number of records, which is like 114 million plus records, right? And I am going to run the same query, find the number of commits to the PostgreSQL. This query had taken, I think 2.8 seconds. Sorry, the earlier query had taken, I think, I don't remember exactly how much time, but I think as far as I remember, this query had taken 2.8 seconds in the normal single server. Now let's see how long it takes. Now it has run so fast that it took only 0.6 seconds, right? So where it took 2.8 seconds to scan 1 million record table, now we have changed our driving table from 1 million to a 114 million table, right? So it is able to scan records across 114 million rows of this table, do the filtering on, efficiently do the filtering on these differently structured data, which is JSON data, right? Identify and filter records based on the key value pairs that we have specified, do the group by, do the order by, do the summation, aggregates everything in a matter of 0.6 seconds, right? So see, every database, right, it has its number of concurrent query slot. So there is every database can run concurrent queries, and each query can get certain dedicated resources. So right, based on the concurrency limitations of a database, for multiple users also you will be able to get certain level of performance. But when you are multiple users are accessing the database, right, and let's say one user is running a query which runs for a longer time. That means whatever resources were allocated to that query is taking longer time to release those resources to be used by other queries, right? To release that CPU power or the memory that it is using. So until that becomes available, that is when you start seeing more latency, right, or a slower performance for other users. Here, what we are trying to compare, right? We are trying to keep the field level, right? So the field is level. We were accessing when we created this demo, we are running on a single instance database. Let's say one user is querying a data, right? How fast you are able to query the data? You are able to query data where your query scans 1 million records, because the table has 1 million records. Query is able to complete, with all these kind of operations within, let's say, 2.8 seconds, right? Then we said, okay, if we want to really see the difference, if hyperscale can really bring any difference, then we should not see it on the same amount of data. We should rather increase the data also. So we increase that data from 1 million to 114 million, right? 100 times increase in the data. And we said, okay, now let's see if hyperscale is really, taking advantage of that massively parallel processing, because hyperscale, because it has a coordinator node and multiple worker node, it is obviously costlier than single server, right? So with an additional cost, am I able to meet requirement of my growing data? That is the point that is being tried to showcased in the demo. So what the demo shows is, when they increase the data size, so imagine this was an actual customer, right? And their data actually grew from 1 million to 114 million. The demo's point is they will still be able to get equivalent or better performance with PostgreSQL hyperscale, because and they are kind of demonstrating that performance through these same, by running same queries on 100 times more volume containing tables. That's the idea. Okay. if I were to do some transactional query and update records only for a specific user 85, right? So, and set this event public value equal to false, right? So I want to set some attribute out of 114 million record. I want to touch only a few records which are specific to certain user. I want to see how fast is the performance of this kind of query, right? And you'll see within 90 milliseconds, that query also runs, right? So what it shows is you have excellent performance for both analytical queries as well as transactional queries, and that is what hyperscale gives you, right? A HTAP kind of workload, hybrid transactional and analytical processing workload, to serve all those different kind of user requirements that you saw in the demo use case. Now essentially, this part of the demo shows how PostgreSQL and these kind of open source database, when used as a uh, first party service, or when used as a fully managed PaaS service on Azure, how they natively integrate, right? How quickly you can integrate these databases with the BI side of things, right? For example, this is a Power BI dashboard, right? Here you can search PostgreSQL and you will see, these kind of filters get so easily applied onto Power BI, right? So whatever filter you are applying, everything on the Power BI dashboard will be filtered accordingly, right? So these kind of things work hand in hand. So this just shows how native how you will as an end user be benefited because of the native integration available between different Azure services, right? So the quick takeaways from this: PostgreSQL accommodates differently structured data. You can provision how you can provision PostgreSQL database, right, on Azure cloud, that we saw, and how to scale your database with the growing requirement of your data size, right? So with PostgreSQL, hyperscale has a hidden answer in it, right? When you need that kind of a hyper scale, right? And what is that hyper scale? That means you need large amount of storage, VLDB, VLDB and HTAP, right? So if you spot these words in the question, you would know that this question is taking you towards hyperscale. What is VLDB? Very large database, right? That means you want a very large database where the storage size will be in terms of, let's say, 10 TB, 15 TB, 20 TB, and it can grow up to 100 TB, right? These kind of databases, because you do not have any other PaaS service that supports that kind of a database. So PostgreSQL single server or PostgreSQL flexible server, they will not support beyond 16 TB or 4 TB. But when you want, let's say, more than 16 TB, more than 20 TB of data, and when you are expecting that kind of a data growth, you will need PostgreSQL service tier. Okay, that is how you should look at it. Number one. Number two, now because PostgreSQL gives you both transactional abilities as well as a good analytical processing engine, right? Hybrid engine. So then should you choose PostgreSQL over a Synapse? Right, because these are both based on MPP architecture. Synapse is also a traditional data warehouse which is used for massively parallel processing, uh, and it gives you an MPP based solution, while PostgreSQL hyperscale can also do that, right? Now again, in this case, the answer to your question will lie in what you have in question. For example, is the question looking for a plain data warehouse kind of data store, then you will go for Synapse. If is the question looking for some kind of a hybrid solution where it wants a good transactional scale as well as a good analytical processing, then you will go for PostgreSQL hyperscale, right? Because what will be the challenge in Synapse in terms of handling transaction is, because Synapse is meant to be a data warehouse solution, right? Or a data lake plus data warehouse kind of a solution. That means pure analytical solution. It is not transactional. Your PostgreSQL hyperscale is HTAP, hybrid transactional and analytical. I have not yet covered the topic of Synapse, so I will not go into details, right? But it is pure analytical engine, right? So that is how you should determine what does your requirement say, and on that basis you will determine whether Synapse is the right solution or a PostgreSQL hyperscale or a PostgreSQL flexible server. By by no means you should end up in answering that PostgreSQL single server is my right choice, right? Because Microsoft themselves are recommending that for all practical purposes, go for flexible server, right? So they will never ask you a question for which the right answer will be to create a PostgreSQL single instance, right? So you can forget about that. So flexible server, hyperscale, and Synapse is altogether only an analytical service. That's how you will differentiate. Okay, now let's click on creating PostgreSQL database. And although I am stressing and focusing on PostgreSQL, rest assured that you can follow the same steps for MySQL as well as for MariaDB, and more or less it will all be same. Okay. Now just see what are different options that you have got, right? It says Azure database for PostgreSQL. See, recommended is flexible server. Like I told you, Microsoft recommends you to create flexible server. However, if you want, you can still go ahead and create single server, right? When I select single server, it will, give me some information. It will tell me that, hey, do you really want to create this? Probably. Let's see. Maybe when I click on review and create, that's the time it will tell me, or it will give me that, okay, our recommended option is to create a flexible server, right? Oh, I directly went to a flexible server option. So let me go to more generic PostgreSQL option so that you get to see all those 3-4 different types of things. Go to databases and select for PostgreSQL, click create. Okay, now see the options, right? Flexible server is of course one option which is recommended. Single server is the option. Third option is Azure Arc enabled, right? Currently in preview, right? So this is the service in preview, so I will not talk much about that. However, what is this, right? I think I have also explained at some point in time. Azure Arc is a service that allows you to take the PaaS advantage of public cloud to your on-premise, right? That means, let's say you are a customer who is not willing to take their data to the cloud, right? But you still want PaaS kind of a service experience on your on-premise. So Azure Arc is a service that will enable that. And for that, PostgreSQL, Azure Arc enabled PostgreSQL server is currently in preview. So that means it is not publicly released or available for everybody, but it is in preview. But that feature will help you to get the same experience of PaaS service on premise. That much is what you need to know. Now, the other option is, now this option was supposed to be just let's say a month ago or 2 months ago. This used to be PostgreSQL hyperscale. Okay, now this thing has got renamed and the PostgreSQL hyperscale, because hyperscale works on a distributed database construct, right? So that Microsoft has rolled this service under Cosmos DB set of databases, because Cosmos DB is a multi-model database service wherein you can create different NoSQL services, and now this will be a relational service, a hybrid transactional analytical process service which rolls under Cosmos DB as an umbrella of Azure service. So otherwise this, see, as you can see, right, formerly Azure database for PostgreSQL, hyperscale Citus. Now what is Citus? Citus is a company that Microsoft had acquired, and this Citus company had actually developed this extension for hyperscale. Okay, so Microsoft acquired them and then they renamed that to Azure database for PostgreSQL hyperscale, and that is further now renamed to Azure Cosmos DB for PostgreSQL. So you can create, your single servers or flexible server or PostgreSQL hyperscale from over here, right? The steps will be more or less very same. You provide your resource group, like I showed in the demo, right? You provide your other information such as server, etc., right?
Let's have a quick quiz question, guys. Which Azure service can be used for building and managing data pipelines for big data processing? Azure Data Factory, Azure Data Lake Storage, Azure Data Warehouse, or Azure Databricks? Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
NoSQL databases on Azure. And for that, let's start with Azure Cosmos DB. So in terms of understanding Azure data services, we started with an high level overview. After that, we learned about different types of storages. The mainly Azure Blob storage and Azure Data Lake storage Gen 2, right? And the difference between the two, that ADLS Gen 2 is more optimized for big data processing, whereas Blob storage is more of a generic purpose storage, right? And then we started looking at the database options, right? Or database offerings that you have on Azure platform. So in that we saw Azure SQL Server, which is the most common or Microsoft proprietary kind of database and available as a PaaS service, that too in 3 different PaaS deployment options: single instance, managed instance, and the elastic pool. And then we looked at what are the other options with respect to the open source databases running on Azure as a PaaS service. In that we saw PostgreSQL, MySQL, MariaDB, right? And we also understood what is a hyperscale service tier, right? So in case of SQL, Azure SQL DB, as well as in case of a PostgreSQL DB. So how a hyperscale kind of service tier, or what is available as a Cosmos DB distributed database for PostgreSQL, how it can help to scale for a very large database, VLDB, or HTAP workload, hybrid transactional and analytical processing workload, right? With that, now let's understand Azure Cosmos DB for NoSQL databases. So from relational databases, now we will look into what is Cosmos DB and how it can help you to create different types of NoSQL databases, and what are the different databases supported, and how it implements those NoSQL databases. Let's understand that in more detail. I'm just going to take a minute to allow everybody to unmute before I go to the next slide. Okay, so let's continue. So before we jump into understanding what is Azure Cosmos DB, right, it is important to first understand what is a NoSQL database, right? So a NoSQL database, like you would imagine, it does not mean that you will not run SQL query. It means not only SQL, if you were to think about it in that way, in terms of full form. But what is it beyond not only SQL? So NoSQL is a non-relational database which stores and accesses the data using key value pairs, right? In a most generic way to call it. These are mostly document oriented or non-structured and distributed databases. Why do companies move applications to NoSQL, right? So any thoughts about anything you want to add, any one of you, in terms of what is a NoSQL database and why do companies move applications to NoSQL? Or if you want to talk about some of the challenges that you have faced in a traditional relational database for which NoSQL had a solution. Anything? Yeah. So schema drift, or ability to accommodate differently structured data, right, without having to continuously keep changing your data model, right, or keep rebuilding your tables to suit the structure of the data. That is one of the challenges, and I'll try to explain that in a little bit more detail. It allows for a rapid data growth and scalability. That means your data can grow rapidly and it will be able to scale. So essentially, with the traditional SQL databases, they scale vertically. They do not scale horizontally. Now, what is a vertical scaling versus horizontal scaling? When you want to scale up your database, when do you want to first scale up, right? Because you need more CPU power, you need more storage, you need more memory requirements. That's when you scale. When you need more CPU or more memory, you add, essentially you change your hardware, or you increase the number of CPU cores in your compute hardware, and that's how you scale up. Now, on the other hand, when you need to add more storage, so what you do is you keep adding more and more disks to your server, database server, and that's how you keep scaling the storage. However, this is vertical scaling and it will one day hit the floor or hit the ceiling with respect to, you know, how much you can scale, right? Because the hardware starts becoming very expensive. On the other hand, horizontal scaling means you are creating a distributed architecture. That means your database and storage is not running on just one machine, you know, and where you are keep increasing the CPU and the storage size of that machine. Instead of that, you have a distributed architecture where one machine becomes a master node, and then the other set of machines become your worker nodes, right? And you can keep adding as many worker nodes, right? Here, every worker node is comparatively of a smaller size, right? That means you do not have a challenge with the hardware or any hitting limitation with respect to the hardware. And you can add as many number of nodes to that distributed net environment so that you are able to grow you know, to the scale that you want and in a very easy way. Now, concurrent performance is the another thing wherein if you are building an application that requires low latency and very high concurrency, that means there are very large number of users of this database. That's also where NoSQL databases perform better compared to the SQL database, because they provide you ultra low latency guarantees or strong SLAs with respect to being able to, you know, build applications which can serve at a very low latency. That means very highly responsive applications, right? So let me talk about the flexible storage for a moment, right? To explain that in a simple way. Let me see if I can use pen. Okay, for the purpose of this example, let's take a simple example of a e-commerce business, right? And imagine you have a products table. So if we take example of, let's say, Amazon, right? Hypothetically, Amazon started as a online book selling business, right? So they were only selling books, right? So imagine how they would have created their first products table. So there will be a products table, right? And this products table will probably have some columns that say prod ID. Then they would have, let's say, price, right? ISBN, and sorry for my handwriting, because book is uniquely identified by its ISBN number, and etc., right? Author and some other attributes. Now imagine this is their products table, which was working fine until they expanded into another category, right? So along with book, let's say they started selling CDs. Okay, I'm just taking hypothetical example. Okay, so now for a CD, you have one more, some few more attributes, right? And those attributes say size or data size, right? Which could be like, let's say 700 MB, etc., etc. Then let's say they started selling DVDs. They got into completely new category. So essentially, they kept adding more and more columns. They kept modifying the table to start adding more and more columns into this table. Okay, that is how it works in your relational databases. However, now imagine they are getting into a completely new category, which could be apparels category, right? Or which could be jewelry category. Now for this kind of e-commerce business, now just imagine what kind of different attributes you will have to keep adding into this table, and this table will become very large, will have, you know, very large number of columns, right? And it will one day hit the database limits where you cannot create any more columns into this table, right? One other challenge with this table is, for this record, let's say this first record is for a book B1, right? This is the product ID. Then for that, price is an applicable column, ISBN is applicable column, but all the other rest of the 100+ columns could just have null value, because they are not relevant to book. They are probably related to CD, related to DVD, related to some jewelry, laptop, you know, shoes, and some other category, right? And likewise, for every single record, there will be few attributes that are related to them, and there will be large number of other attributes which are non-related. So if you imagine in your mind this what you call the data structure or data volume of this table it will be very sparsely filled, right? That means this table will have for every record few not null values and a lot of null values, right? And these kind of sparsely filled tables are not good for query performance, right? So that is one challenge. And the most important challenge is just how do you manage putting in so much different type of data into one table, right? Because over a period of time, you would yourself realize that probably I'm not doing the right thing by putting all different types of products into one table. So you will end up, you will start creating different products tables. So this is for jewelry category. This is for apparels category. This is another products table for, let's say, laptops and electronics, another for mobile devices. And now your data model starts becoming very complicated, because now even in case of a laptop, let's say you add some more different electronics in this, let's say mobile phone or some kind of let's say router or these kind of other kind of electronics, you will have to keep adding. Now you are having to modify multiple different tables for every time you add different types of products. Now you can imagine what is the challenge with the traditional SQL databases. Whenever your business was growing or whenever business required any changes to the data model, it was very difficult to accommodate those changes into an existing data model, number one. Number two, each of the changes, because they are changing the table structure, some of the changes require proper planning to promote this change into production, because one change can affect a number of other pieces of code, right? So you change the table structure and there could be some other downstream queries which are doing a select star query on that table. So until yesterday, the tables, the select star query was returning 10 columns. Now today onwards, when you make this change, that select star query is going to return 12 columns. Let's say you add 2 more columns. So will that query and the subsequent code work fine, or will that code fail? So you have to do a lot of code management, lot of change management to make sure that every single change of this nature is well managed, right? And that made it very difficult for businesses to evolve in an agile way, right? So it is very difficult in a traditional SQL world when you have these continuously changing requirements that you may have to keep adding more attributes or modify your data model on a regular basis to as per the need of the business evolution. It was very difficult to manage in SQL world. So how NoSQL solved this problem, right? So let me clear this a little bit. Yeah. So how NoSQL solve this problem, right? So when in case of a NoSQL, think about a data structure or a table structure which can accommodate an unstructured or semi-structured data and which can contain any kind of key value pair, right? So with the NoSQL, with introduction of NoSQL, this product table got defined in a way that every row in this product table is inserted as a document. Okay, now imagine there is this document which starts like this, with curly brackets. You have a product ID and its corresponding value, right? Then you have, let's say, if it was a book, then you have ISBN, right? Then let's say you have author, then you have price, etc., right? All the related attributes. Now in the same products table, I can have another record which has again product ID, which has let's say laptop details, right? Such as CPU, memory, and all other attributes that are related to laptop. And you are able to save the key value as a column name and the key as a column name and value as actual value of that attribute, right? Now you can imagine if I was able to store a document kind of format in a relational table or in a NoSQL table, then I will be able to store all different types of records, all different types of products within the same table. And because you are storing it as a document in a document form, so it does not matter in each document whether you are creating 10 attributes or 100 attributes or just 2 attributes. So your data structure now becomes flexible, and you never have to change the schema. Let's say in this product table, you have just one column, right? And this column says column 1, right? And every time you read for column, row 1 result is this, row 2 result is this. And now you can, select on product category, you can apply filter on product ID, product category, or any of these attributes, and you will be able to get the records that you want out of this table. So now it becomes very easy, because for any changing requirements for an e-commerce business that we took as an example, tomorrow you want to launch a new category, you do not have to change this product table. You just have to insert new record for new products as per the requirement, right? As per the attributes that are relevant to that product. So now you can imagine, from managing the change, which was so difficult to manage in the data model, now you just don't have to manage that change. Your data model is accommodative of all different types of changes that you have to do in your table to accommodate new launches, new product launches, or any other changes to the product. You just have to insert new records. You don't have to change anything. And so you are because you are not changing data model, so there is no question of changes to the downstream extracts or etc. So your dependencies are not broken, and you are able to better handle your requirement. Now, is this the only way NoSQL allows to store your data? So NoSQL has different types of flavors. So one is most commonly occurring is a document database or a key value pair database, right? That's one. And then there are other NoSQL databases such as a large column family store, or there is a graph database, right? Or a Neo4j. So Neo4j and Gremlin are example of graph databases. So there are different types of NoSQL data stores for different types of purposes, right? For example, how does a graph storage works, right? So in case of a graph, you are storing the data in the form of a graph. So here, these are nodes. All these circles are nodes, and these are edges, right? That define the relationship between the node, right? And what kind of data will you store in a graph kind of database, right? Or graph kind of data store. So imagine you want to build, let's say, some kind of relationship between different objects. For example, let's say you are trying to create a simple database which will show you all the dependencies or all the data lineage of your ETL workload, right? That means, let's say these are all the nodes represent all the ETL jobs. Okay. And you want to represent that what is the dependency of one ETL job over other. So that, let's say, what this will tell you is this job N1 is is at a root level, let's say, right? So after N1 finishes, only after that N2, N2 is dependent on N1, then N3 is dependent on N2, and in turn it is also dependent on N1. Likewise, let's say N4 is dependent on N3, and N5 is also dependent on N3. So I'm just taking one hypothetical example, but the actual graph use cases could be something to do with, let's say, data or use cases such as, let's say, ride sharing or ride hailing use cases, right? Wherein Uber or Ola like companies may want to save some of the information in a graph database to be able to quickly identify a shortest path, right? Because we know shortest path kind of algorithms would work better on a graph or tree-like structure as compared to storing that data in a tabular structure as a row and column. So this is how it works, right? For different kind of, or it could be also useful in a social media use cases. For example, let's say you work on Facebook, you work on, you use Instagram and other LinkedIn kind of sources, right? So if you were to, if for a company like WhatsApp, for example, or Instagram, if government asks them that there is some sensitive message that is going around and they want to find a origin of this message, right? So to find origin of a particular message that is being viral and being circulated, if they are able to trace it through a graph like structure, they will be able to trace it much quickly, right? Because they are maybe literally, having to search millions of messages, right? So just imagine one person started it, he forwarded it to $100 others, and those 100 others in turn are forwarding it to let's say 10,000 others, and likewise it is going on and on. But if you look at it, there may not be too many levels, right? If you look at it from a tree structure or a graph point of view, there are maybe just about 10, 15, 20 levels that a message has got forwarded to. However, in terms of exact messages, the number may be in terms of millions or billions, right? So to identify an origination of a particular message, you may not have to scan through all the million messages and try to do something. You may just pick one message and go to its parent, and up to likewise reach out to the root and quickly give that information to whoever wants it, right? That this message got generated from this ID. So again, a hypothetical use case, but very relevant to where graph databases may play a good role, right? So depending upon your use case, you may want to create a different type of NoSQL database to help address the challenges of a SQL world. Cool. So let's now take a look at what is Cosmos DB, right? Azure Cosmos DB is a multi-model, multi-master database. And this database is also globally distributed. So let's understand it one by one. Globally distributed means you can create a database where your users are. This is one of the services like storage service, which is available in every single Azure region. So if there are 65 plus Azure regions, in every one of them, you will have Cosmos DB as a service available, right? There could be other services which may not be available in certain regions, right? But Azure Cosmos DB will be available in all regions. What is the purpose of that? To create or to give customers ability to create a globally distributed database. And what could be the reason for that? Because by nature, the NoSQL applications are supposed to be distributed databases, right? So if you want to create a distributed database, you should have an ability to create a database which can distribute data across different geographical regions, so that you are able to better serve requirement of each user from the nearest data center, right? So imagine some businesses that may be running across various geographies. For example, let's say WhatsApp, right? Or any other mobile application, popular mobile application, which has users in India, Europe, Americas, Japan, and across different continents, right? Now imagine what if they have only one central server, let's say sitting in United States, and all of your request or all of what you want to do on application on your mobile has to go all the way and communicate with that server sitting in United States. Then you will obviously face a lot of latency issues with that application, right? To avoid that and to help create efficient and performant globally distributed applications, you need a globally distributed database that can serve the users from the nearest possible Azure region, right? So that is why it is called globally distributed. Now, that is what the turnkey global distribution is all about. It provides you elastic scale out of storage as well as throughput. That means you can horizontally scale out for both your storage as well as CPU, right? That means you can horizontally scale your performance as well as the storage size. Now you get a guaranteed low latency, right? Because for these kind of applications, low latency is very important. So you get a guaranteed less than 10 milliseconds of low latency, which is guaranteed by Microsoft. Less than 10 milliseconds. Okay, now there are 5 well-defined consistency models. Okay, I will talk about what a consistency model is in some time. Because it will require some explanation. So we'll talk about that. and comprehensive SLAs, right? What is comprehensive SLA? So these are different SLAs, right? Guaranteed low level, low latency of less than 10 millisecond, right? Then guaranteed throughput, all of these, even a guaranteed consistency model. So whatever is being guaranteed by Azure, they will be backed by comprehensive SLAs, and these will be financially backed, right? That means if they are telling you that your service is going to be up and running for 99.9% time, or 59 kind of a availability, 99.999 kind of availability, if they promise you that, and if by any chance due to any issue, if that service is not available, right, up to that projected benchmark or SLA, then they will financially compensate you, right, as per the rules defined in Azure documentation. But that is what this comprehensive SLAs mean. Now, what are different types of databases? We already talked about some of these. There is key value pair, column family, document, and graph databases, right? So the which are the APIs? Now, why is Cosmos DB called a multi-model API, multi-model NoSQL database? Why is it multi-model? Because it supports multiple different models on the basis of APIs, right? That means when you create a Cosmos DB database with a default or core SQL API, it becomes an efficient key value pair. Similarly, when you create it with a Cassandra API, it starts working like a Cassandra. Likewise, when you create it with a MongoDB API, it starts working like a MongoDB. You create it with Apache for Apache Storm, or you create it with Gremlin API, it will start working like Gremlin. You create it with etcd kind of API, and it will start working like etcd. And you create it with table API. Table API, by the way, nobody will create it with table API, because I have also told you, if you remember, this was as part of the Blob storage session. So this was an old NoSQL approach, right? When Cosmos DB was not even there, Microsoft had come up with something called as table API, right? With table API, they provided you ability to store key value pairs. But now if you want to create Cosmos DB for a good key value pair database, you will choose SQL API. So table API, for all practical purposes, you can forget. It is available only because some customers may be using table API from a very old time, and that is why it is just available. But for all practical purposes, you should just create SQL API, a Cosmos DB with SQL API by default. Or when you know that you want a Cassandra kind of a database, or you are migrating from Cassandra, you are migrating from on-premise MongoDB, or you are migrating from, let's say, Apache Storm or Apache Spark based NoSQL database, or Gremlin or etcd, etc., right? Then you will create a Cosmos DB with those respective APIs. And then that Cosmos DB will start behaving like those specific NoSQL databases. Okay, now the next set of slides just talk about that. I already explained that to you. It's available in all Azure regions. Elastic scale out of storage, right? So your compute and storage is separated. So you are able to scale both the storage as well as compute independently. It gives you, you can scale your throughput from 10 to 100, hundreds of millions of requests per second, right? So it can allow you to handle millions of requests per second, and it's you have to pay only for throughput and storage as you need, because they are both separated from each other. Guaranteed low latency, we talked about this, less than 10 milliseconds of read and write request at 99th percentile. Okay, now what 99th percentile means? Let's say here is a total graph, here is a time, and here is a number of requests. Oops. Okay, so let's say this is 0, this is 5, this is 10, and these are all in milliseconds. Okay. Now, let's say my first request was served in about 5 milliseconds, then 6, 7, 8, up to 10 milliseconds. And then this is how hundreds of requests are being served. There could be one request out of 100, right? So if this was 100, there could possibly be only one request out of 100. That means essentially what 99 percentile means is 99 out of 100 requests will be served at in less than 10 milliseconds. And that is what is Microsoft's guarantee in terms of low latency applications built on top of Cosmos DB, that if you are properly creating a Cosmos DB with a globally distributed Cosmos DB, right, where you are serving the user's request from the closest region possible, right? In that case, you will be able to get less than 10 milliseconds of read-write latency at a 99th percentile, right? I will also show this to you through a demo that I have available. Okay, now let's understand consistency model, right? This is something interesting. Now, okay, can somebody tell me what is the consistency property of a SQL database? So in SQL database, there are whatever you do, right? It happens in the form of transaction. Let's say you created a record, you deleted a record, updated a record. All of these are transactions, database transactions. And these database transactions follow ACID properties. So as in ACID property, A stands for atomicity, C stands for consistency, right? I stands for isolation, and D stands for durability. Now, what is that consistency? Before we understand the consistency of NoSQL databases, let's understand what do you think of consistency in case of a SQL database. So can you guys explain, maybe take an example? So both of you, I think you are putting a right point forward, but it's not very easy to understand, right? For somebody who does not know what consistency is all about. Correct. Correct. Okay, that's much better. And thank you for sharing that. So let me try to explain that with a quick example. Okay. And to understand it better, right? Let's just take a banking example. Let's say I am trying to update, or let's say I'm trying to withdraw some amount from my ATM. Okay, so I know that I have an ATM, and in my account I have, let's say, 10,000 rupees. Okay, now what I'm trying to do is I'm trying to do some experimentation and see if I can try to take the amount out of the ATM, right? At the same time, do some online shopping transaction, and at the same time, do some, let's say, net banking fund transfer. And in each of those, try to do a transaction worth of 10,000 rupees and see if bank gives me 30,000 rupees, right? So because I'm going to try and time it in such a way that it happens simultaneously, right? Exact in the same 1 second that I send my, enter my PIN on an ATM machine, and I, authorize my transaction on a net banking as well as on some e-commerce portal. All of that I'm going to try and time, right? So I do that, and as you would know, right, that will be a foolish attempt because only one of those transactions is going to succeed. The other two will be declined, right? How does this work? Because in the backend, the databases maintain consistency, right? And this in such case, banking case, the database is expected to be highly consistent, right? Or have a strong consistency. That means whenever one transaction takes control of a particular record, or let's say in our case, account balance, right? So one transaction, one of the 3 transactions has taken a lock on account balance, right? Until this transaction finishes, the other 2 transactions are not going to go forward, right? So one of the 3 transactions has got a control. After that transaction finishes, the account balance will be updated, right? Let's say account balance became 0 from 10,000, and now the other 2 transactions which were not able to read the account balance because somebody else was trying to update it, now the other 2 transactions will read the account balance consistently as 0 rupees, and that's where the other 2 transactions are not going to go through because they will say that you do not have enough account balance, right, for that net banking fund transfer as well as for that e-commerce purchase order. So that is the strong consistency, right? And I'm sure you all understood that, but I just wanted to take an example, because once that is clear, now that will now help you to I understand now these 5 different types of consistency models that Cosmos DB has to offer. So you understand strong consistency and a kind of use case where strong consistency will be useful, right? In case of a banking use case, right? You would want strong consistency. Now, before I jump to consistency, right, there is something else you should understand. And that is very important to realize why even we are discussing 5 different well-defined consistency models. And that construct is called as CAP theorem, because a CAP theorem is very useful to understand NoSQL databases. So what is CAP? CAP theorem. So CAP theorem of a NoSQL or distributed databases, right? Big data bases which are distributed. The CAP theorem says that out of consistency, which is C, availability A, and partition tolerance P, out of these 3, you can only achieve best of the 2, but you cannot get best of the 3. That means you cannot create a NoSQL database which will be here in this sweet spot, right? Offering you best of consistency, best of availability, and best of partition tolerance, right? That is not possible. That is what says the CAP theorem. And why is that not possible? Because according to CAP theorem, you can only get, best of the 2. Either you can get a good consistency and availability, or you can get a fairly good consistency and partition tolerance, and you can get a good availability and partition tolerance, but in that case you will be doing some trade-off with the consistency. So you always have to do a trade-off with one of the 3 properties of a distributed database, so that you are able to create the database which is performing as per your expectation with respect to consistency, availability, and partition tolerance, right? To make things simple now, let's focus on consistency. So I'll, maybe in one line explain you what each of these mean, right? And then we'll focus more on consistency and availability to better understand these 5 well-defined consistency model. So what is consistency? We already talked about it. Consistency means how you want to define different sessions, right, or different users to read same data, right? For example, one particular account and its account balance, right? This is a data element. So how different sessions, right? So like I talked about 3 different sessions. One was a net banking, one was ATM, one was, let's say, some other e-commerce thread. These were 3 different sessions trying to read the same data, right? So whether they should be able to read this data in a consistent way or inconsistent way, right? What is the expectation or requirement of your application, right? That is called consistency. And that will define whether your database is highly consistent or eventually consistent, right? Which could be the last stage of consistency. But we are not discussing that in detail yet, what consistency means. Now, what is availability? Availability means my database should be highly available. That means all the different transactions, if there are 3 sessions trying to read one data element, right? I should be, whether that data element is going to change in a matter of moments, I don't care. Whenever any session is requesting to read that data, that session should get that data, right? Get the information. That means in my case, in my previous example, all 3 sessions should be able to read account balance, right? What happens after that will be a different thing, right? And how I want to control at a later point in time, how I want to discard the other 2 transactions. Let's say I will manage that at a later point in time. But when I am sending a request, at least to read the account balance at the beginning of the transaction, I should immediately get it. I should not find any slowness, in that request, right? Otherwise my user will get frustrated. So I will probably handle any other error scenario. That means account balance has actually become 0. I will handle it at a later stage of, let's say, checkout, or final step of confirming the net banking transfer, right? But when initially it is being requested, don't put a lock on that, or don't keep my application waiting. Just quickly give me the result, right? That is what high availability means. High availability means you want your application to be super responsive, and your data should be always available to read. That's high availability. What is partition tolerance? Partition tolerance means in a distributed database, right? Typically you have multiple, let's say, data distributed across different distributions or different nodes, right? So can your system continue to work even if there is one of the data partitions is not available, right? How will you recover from these kind of situations? So, and what is the expected behavior, right? If let's say your data is distributed or partitioned, so there are 100 million records, and let's say you create 10 partitions or 100 partitions, each partition containing 1 million records. Okay, now imagine total 100 million records are actually physically sitting on 100 individual partitions. Now, what kind of requirement do you have for your data store or for your project? If one of the partitions is not available, then do you want to completely stop your application, or do you want to continue with other partitions that are available, right? If you say that my database or my application should continue to use the data from remaining partitions that are available, that means you are saying your database or your application is high partition tolerant, right? That means even if some part of the data is not available, you are still continuing. On the other hand, if it is not partition tolerant, that means if you need all the data to be available, and if any of the data partition is corrupt, that means you want to stop the application because you may be doing something wrong. Until you recover that data, you do not want to continue. Now in that case, you are saying your database is very sensitive to partition tolerance and it is not tolerant at all. So you cannot tolerate any corruption of the data or any unavailability of any of the partitions. To put it into example, right, to make it simple to understand, think about this. Let's say I am an e-commerce portal, okay, and I have 100 products listed on my website. Okay, now you as a customer log into my website and you are able to see some products. Okay, now let's say all those 100 products are sitting in 10 different partitions. In each data partition, I have 10 products. Okay, now what if my one of the data partition is not available? That means at that instance, until I recover that partition from whatever failure it is, you will only be able to see 90 listings on my website. Now, is that acceptable for me as a business? Yes, it is acceptable, because for you as a user, you will never imagine or you will not be able to know that there is some problem going on and you should have actually seen 100, but you are only seeing 90 products, right? You will never, as an end user, you will probably never realize that there is some problem that has happened in the backend, maybe for a short while, right? Or maybe for a few moments, or up to, let's say, 1 minute, 30 minutes. As an end user, it does not matter to you. You have 90 products to buy. Out of that, you can buy anything, right? After 30 seconds, if I add 10 more products and that partition becomes available, you will say, okay, now 100 products are available. If you want to buy, buy. If you don't want to buy, don't buy, right? For me as a business, what is more important? When one of the partition is not available, should I completely take down my site until I fix that data, or should I be more tolerant and should I continue the business, right? So what will I prefer in this case? I will prefer availability, or will I prefer partition tolerance? What would you prefer if you were running that e-commerce business? Availability for your user, or a better partition tolerance? you will realize that, okay, you have to choose between, availability, consistency, and partition tolerance, and you cannot get best of the three, right? So you have to always do a trade-off on one of these properties. Now let's understand consistency and availability in a little bit more details, so that we are able to understand these 5 well-defined consistency model better. Now, what each of these means, and for that matter, let me give you an e-commerce example. Okay, in an e-commerce, let's assume that you have so let's take 2 bank examples. One is a banking example. We all know that it is a no-brainer that strong consistency is the right option for all of us, right? Because we don't want to mess here. We don't want to give away more money than that is available in the account balance. So strong consistency is very easy to understand from a banking example. Now I will take an example of extreme right side, which is eventual consistency. What could that example be? Now imagine in an e-commerce website, you have a products table, right? And you also have product reviews, right? A lot of us buy products only after seeing the reviews, right? So we try to see, okay, how many reviews, how many star ratings are available, and we try to read some of the reviews, right? Now imagine for a particular product which is available on a big e-commerce portal. Okay, there are, let's say, 10 people trying to simultaneously submit review for this product. Okay, out of these 10 people who are submitting the review, right, and their reviews are to be updated. So essentially, in a distributed database, you have multiple replicas of your database, right? So let's say this is replica 1, this is replica 2, and this is replica 3. Okay, so R1, R2, R3, and bear with my handwriting. So, and these are users who are trying to read the data from various replicas. Okay, now imagine I have a product review kind of information, right? Let's say a user updated a product review. Oops. Sorry, my digital pen is actually not working, so I am having to just manage it with my mouse pointer somehow. Okay, so a user committed one review over here, right? So this got updated in one replica of Cosmos DB, and now a replication is yet to happen to this another replica and this replica, right? So these are the 2 replicas where whatever you wrote in this database replica needs to be replicated internally, right? Synchronized between the other 2 copies of the data store as well. Okay, but what happens is somebody is also trying to read from this table, some replica, right? Somebody is also trying to read from this replica. So before your so this was, let's say, 100th review. Okay, this was 100th review that got added. But while this got added to R1, what happens is if a user is reading this product review from R1 replica of Cosmos DB, then they will see 100 records, or that for a particular product there are 100 reviews. Let's say another user is reading from another region for the same product, and they see that there are only 99 reviews, right? There is one more region, one more user trying to look up the same product, right? And let's say that in that region, let's say this was India region, the other R2 was Europe region, R3 was US region, and this other guy is also seeing that there are only 99 reviews. Okay, so because there is this replication delay, right? This is asynchronous replication from one replica to the other replicas of Cosmos DB, and because of which you are seeing inconsistent data. Now, would you agree that all these 3 users are actually reading inconsistent data, because actual, that actual updated records or updated reviews are 100 at this point in time, but the other 2 users are reading 99. So it is actually inconsistent. But as a user, as a e-commerce business owner, you are making this conscious choice that you are choosing availability over consistency. You are saying, even if this user in the Europe region sees 99 requests, if he is not reviews, if he is not seeing that 100th review, it is fine. I am okay as an e-commerce business to show him just 99. Similarly, in the US region, if it has some 1 second of delay or 1 minute of delay before this guy can see 100th review, I am fine with that as a business, because this customer still has enough information to make their decision. On the other hand, if I go for a strong consistency in this kind of use case, right? So what is eventual consistency? That means eventually, after some point in time, when this replication is over, this will also show 100, this will also show 100, but not at the same point in time. Okay, it will happen eventually. That is what eventual consistency is all about. Similarly, now just imagine same use case, the attribute that is in question is also a review, total number of reviews, and if I put it as a strong consistency. Okay, now what will be the challenge? The challenge will be, whenever I am creating this 100th record in this replica 1, right, then it will take a lock on this table, okay, that it has added one more record. Until this record gets replicated to R2 and successfully replicated to R3, this user in Europe, this user in US will face delay. Their reviews, their product review information will not load on the website, because let's say that information has a lock, a database lock, right? And until it gets synchronized with the latest updated information, let's say because you have a strong consistency, you do not want to show any inconsistent information. So the available information in these databases is invalidated, and you are not able to show that until this replication is successful and every copy or every replica of Cosmos DB is showing 100 reviews now, right? That means maybe this Europe user is facing 2 seconds of delay in loading product information. This guy is maybe facing 5 seconds delay. Now, would you, as an e-commerce business owner, would you want your customer to see these kind of delays on the portal? No, because that attribute is so trivial that customer do not have to have most up-to-date information about how many total reviews are there, because even if you show them incorrect information, they are never going to make out that what they saw was incorrect, right? But what matters most is responsiveness of the application, because if the application is loading slowly, if the pages are not loading smoothly, then there is high chance that the customer will not come back to your business or your portal at a later point in time in future, right? So now you tell me, would you choose a strong consistency or more like an eventual consistency? While you don't know what are these 3 options yet, but between the two choices, if you had a strong consistency versus eventual consistency for product review information, which one will you go for? Would you choose availability over consistency, or would you choose consistency over availability?
I think availability or consistency.
Yeah, because now that you know your requirements, the nature of your business, the nature of the transactions, the criticality of the attributes, right? You understand, you are able to make informed decisions that for my application, I need better availability, and eventual consistency would also be fine, right? Likewise, now Cosmos DB gives you 5 different well-defined consistency level, right? Starting from a very strong consistency level to an eventually consistent data model, wherein as you go from left to right, from strong to the eventual, your latency or responsiveness or availability starts increasing, and you start compromising little bit on the consistency. That compromise does not mean that there will be no consistency. Eventually, everything will be consistent. If there are 100 records in one replica, there will be 100 records in all replicas eventually, but they will not guarantee that it will happen at the same time, or you will not be guaranteed that no other user will be reading an incorrect information about that attribute at some point in time, because the replication has not successfully happened. So as long as these things are acceptable to your business, you will select between one of these consistency model, right? Now what Cosmos DB guarantees to you, whatever consistency model that you select, it will guarantee that it will work in exactly the same way. That means if you are selecting strong consistency, then it will be strong consistent. You will never be able to. So as long as in one replica, you have added one more record, you will never be able to get an incorrect count of records from any other replica, because those replicas will not be readable until that record gets consistently replicated. So whether it is strong or eventual or consistent prefix or bounded stateless, etc., all of that will be guaranteed whatever you choose. So now let me explain to you with a very nice example that we have on Azure documentation portal to understand. So you can also, by the way, go to this documentation page and you just have to Google or Bing search for Cosmos DB consistency levels. Okay, now you have these 5: strong, bounded, staleness, then session level consistency, consistent prefix, and eventual. Let's understand what each of these. Now that the concept of consistency is understood by you, hopefully it will be easy to understand. What is a strong consistency? Let's say these are 4 replicas, right? So this is your write region. That means in West US2 region, you are writing the data, and you are trying to read the data, same data, from 3 other regions, right? So one of that includes the primary region. So as you start writing the data into West US2 region, and if you are trying to, let's say this is account balance, for example, okay, for strong consistency, let's assume that this is account balance. So whenever account balance gets returned to US West 2 at a particular point in time, you will always be reading exactly consistent account balance, right? Let's say it changed from red to blue to purple to dark blue, likewise. But every time, whenever you read it at a different point in time through any replica, you will always see a consistent value of that. Okay. Now, what is bounded staleness? Bounded staleness means you are defining that your data can be stale. That means an older version of the data may be read from some of the replicas, but not so old. That means you are defining how much old can my data be, or how much old can my read be compared to the latest information available or latest write. That means you what you are specifying in bounded staleness is the number of versions of the item. That means, let's say if one item gets updated from color brown to blue to purple, etc., etc., if you define this k to be, let's say 3, that means at no point after, let's say this gets updated to a yellow, this green color, if somebody is trying to read this data at a point of time when it has got updated to green, nobody will be able to read this brown or blue, right? At the in the worst case, they will be reading this purple, because this is like last third last version. But you will not be reading from any of the replica a 4th last version or a 5th last version, because you are saying my item cannot be much older than k versions or 3 versions in our case. Or you can say define that in terms of time interval, right? Give me a older value of the data, if at all, but it should not be older than 5 seconds, or it should not be older than 2 milliseconds, whatever you want to define, right? That means you are defining for when reading from another replica of the database, you are constraining how much can be the maximum lag, or you are constraining how much of an old data I may be able to read. So see that through an illustration. When you are writing in some region and when you are reading it from the same region, you will obviously be getting the same updated information. But when you are reading it from some other region, let's say in US region, when East US2 region, you are reading the value as red, but actual value has got updated to this color, dark blue color, at this point in time. Similarly, for the other Australia East region. So you are actually reading older data, but not much older data. You are defining, you are constraining that at a given point in time, there should be maximum delay of, let's say, 100 versions or a 5 seconds delay, whichever is smaller. Getting it? Any questions? How you are able to constrain the staleness of the data that is being read from another replica? Okay. Yeah. I'll take it as no. Okay. Now session level consistency, right? This is most commonly used, by the way. Okay. So session level consistency is a, I would say a good, sweet spot between eventual consistency and strong consistency, right? Because in a distributed environment, if you are going for a strong consistency, then what is the point of, creating a distributed environment? Because with a strong consistency, your latencies are going to shoot up high, right? Because if every time I update something in one replica, if it has to update across all replica and only then somebody can read it, then what is the point of creating a distributed database, right? So what happens in a session consistency, your data can be consistently read in one session, right? For example, there is one session, okay, that let's say there is one programmatic session, right? And that programmatic session may read data. Let's say it is session A is writing the data in this region, West US2 region. Then session A is reading the data from that region, and session A is reading that data from another region. That means as long as the program is in same session, same user session, for example, they will be able to read the consistent data. But when you are reading it from another session, then you may not be able to, the data may not be most consistent. That means at this point in time, actually the data value has got updated to purple, but you are reading as, let's say, red or brown. But you are in.
What do you mean by session? Sorry to interrupt you. Is it the time frame? We are talking, say, 2 minutes or 3 minutes?
No, it is not time frame. Session means a programmatic session, right? So for example, your application, I log into my net banking. Okay. Now through my net banking, let's say I am doing different kinds of applications. So that becomes like one session, right? And let's say in that I transferred some amount of money from, let's say, one of my account to another account of mine. Okay. And in that same session, let's say I go to, check the account balance of that other account, right? There may be two accounts I have in one bank, right? One is saving account, one is current account. There could also be a pension account or provident fund account, something like that, right? So within that same session, if I'm going to check through another, I'm switching between, different parts of the application, right, where I'm seeing the current accounts balance, saving account balance, etc. I will see consistent information in that same session. It may so happen that so that means through that same program logic, right, I may be reading data from a different replica as well, right? For example, let's say a bank has defined the application in a way, right, that on the front page, it is showing account balances from, hypothetically, right, account balances from Cosmos DB replica available in the primary region. Okay. To enhance the application, right, or to enhance the performance of the application, let's say there are several tabs, right? And in one of the tabs, the application picks the data from another replica of the database. Okay. So let's say account balance is shown on the different tabs of a net banking portal through different replicas, right? That means as a user, when I am updating my account balance in one replica, and if I go to another tab at the same time, and if I try to see that specific balance, if that is not updated in the East US replica, for example, as yet, because I have just made that change. So typically, after I update that account balance or do my transaction, and by completing that transaction to go to another tab to see the account balance, that will also take, let's say, a matter of half a second or so for me. In that meantime, there is very high chance that the transaction would have got replicated across the different replica also. But if at all that has not happened, then session level consistency would mean that the account balance information on that new tab may take a while to reflect, right? It will probably show me that, okay, that screen is loading because that screen does not have up-to-date information, and I will be able to see the account balance on that screen only after it got updated in the East US region also. That means that is what is session level consistency. Although it is the same user, right, looking up the account balances at two different places within the application, and both of these places are sourcing the data from two different replicas. But if everything is within one session, that means end to end it has to follow consistency. That is session level consistency. On the other hand, right, some other user was trying to see the same information, and I'll deliberately avoid taking account balance as an example because balances are typically a use case for strong consistency. But let's say if it was some other information such as, let's say, address, right? So it may so happen that, let's say, whatever address you update, that same address is going to be updated across all three accounts of yours: saving account, current account, and PF account as your permanent address when you update it. But let's say when you go to a current accounts screen, right, and let's say current account, in the current account screen, that permanent address is being shown from another replica, East US replica, right? While on the saving account screen, the address is shown from the West US replica. Now, please don't ask me why somebody would create it like that. I am taking a hypothetical example. Let's say to improve performance or whatever reason, right? You did it in that way. Okay. Now, in this case, right, if I am, let's say I am a user, I updated my permanent address through a saving account setting. Let's say it has to be replicated and reflect across all those tabs. It may so happen that if I try to log in simultaneously through a separate, let's say through a mobile application now, and I try to go to current accounts tab, which is showing my address from, let's say, another replica, East US replica, but here I am in another session. So it will show me older address that is available. And in a matter of minute, right, it might just refresh as soon as that, synchronization is completed. But for a while, it may show me older address. But because it is not as critical as an account balance, even if it takes a while to reflect my change from one session into the another session, it is okay for me, right? Because the nature of the attribute is like that. And where this kind of things are acceptable, I would go for session level consistency. Hope that is clear. And from the illustration also, it will make it clear that across different sessions, you may read inconsistent data, but in a given session, whether you are reading it from one replica or the other replica, it will always be consistent because here it is more at a session level. Okay, now consistent prefix, right? Now, what is consistent prefix? It says it updates are made as a single document. These are essentially asynchronous replication. If you look at this, right, you will be able to better understand that. Let's say in US West US 2 region you are writing, and when you are reading from the West US region 2 itself or any other region, consistent prefix would mean that you may be reading inconsistent information, right? That means at this point in time, you are reading an older version of the data, but what it guarantees is the order of the updates, right? Order of the read request will be, or order of the versions will always remain consistent, right? So because it says consistent prefix, that means although you will be reading different version of one particular data element, right, or different value of that at different point in time across different replicas, this order will be maintained. That means if it changed from red to blue to purple to black to green to yellow, you will always read in that sequence, in that consistent sequence. On the other hand, to better understand this, also understand eventual consistency. Eventual consistency would mean that whatever writes that you are doing on this primary region, all those writes will be replicated to this all the secondary replicas, but those may also be replicated in any order. So what eventually consistency mean that, let's say you updated this data element from 1 to 2 to 3 to 4 to 5, right? Let's say latest value is 5. So all the records or all the updates will happen, but they may happen out of order. That means, as you can see here, right, out of order updates are happening. So every replica is being, whenever you are reading from different replicas, you may be getting different value, which is not necessary in the same order. Now, if you ask me, what could be the example of this, right? Where, possibly where can I use eventual consistency? You will use eventual consistency when you have a scenario that you prefer availability and partition tolerance completely over consistency, because consistency does not matter to you. And what could be such use cases, right? For example, let's say there is, let me take example of the same product reviews, right? So let's say for a particular product, I keep adding reviews one after the other. So let's say there are 10 customers or 10 users who created 10 different individual product reviews for same product with product ID 1. Now all these 10 products reviews are to be posted, right? So these 10 reviews need to be posted for this product. Now tell me, does it matter that whether I, the sequence in which these reviews are posted, which review gets posted as, let's say, if there are 90 reviews already present, and these are the next set of reviews from 91 to 100. Does it matter which customer's review gets posted as 91th, 91st, or, whose review gets posted as 95th versus whose review gets posted as 100th review? Because they are all essentially trying to, simultaneously or within a short span of time submitting these reviews. And let's say on one replica, you store these reviews in this order: customer 1 91 or customer 10 100, right, in this order. On the other replica, these reviews get created as, customer 1's review got created as 92nd review, customer 10th review got created as 95th review. Does it matter, right? Because those reviews are reviews. So you know that, the content of review is what matters. The rating given inside the review is what matters. The sequence in which those review get added into my system do not really matter, right? So that can be an example where eventual consistency you would prefer over, you would want to go for eventual consistency. That means you are giving minimum importance to consistency, and you are preferring partition tolerance as well as availability over your consistency level. Any question before I continue again? So Cosmos DB, the beauty of Cosmos DB is it gives you ability to select any consistency level according to your choice. So that's 5 well-defined consistency models. Then this we already talked about, Cosmos DB starts working like, Cassandra or MongoDB or Gremlin, depending upon the API that you choose. That's why it's called multi-model. I talked about this. These are all guaranteed SLAs, right? That means Microsoft is in return guaranteeing these SLAs if you provided you are following the best practices for implementation. And Cosmos DB is one of those databases, right? Very few databases which can provide 5 nines of availability. This 99.999% availability is called as 5 nines. As you can see, there are 5 nines in this, right? So 5 9 availability is supposed to be the industry leading or industry's best standard for availability of any system or database. And Cosmos DB can, guarantee that, provided, you are setting up your Cosmos DB according to best practice guideline of Azure. And I think we talked about this. I gave an example, handle any data with no schema or indexing required. For example, now indexing part is important. That is new. I will explain that. But essentially in Cosmos DB, because it supports multi-master, right? All your regions support distributed databases, right? That means your regions are no more working like a secondary backup, right? Or a disaster recovery kind of a thing. These are very much active available for your users to start reading from those respective regions, right? So here you have applications, right, which are, let's say, an application like Uber. So which customers in US are also using, customers in Europe are also using, customers in India are also using, right? And there is no point when you are logging into your mobile application of Uber from India, there is no point to connect you to a Europe-based database, right? So they will connect you to an India-based database. Okay, so even if whatever changes that are happening in the Europe are also to be replicated to India and are also to be replicated to US, but those changes may take some time to replicate in your respective region. But that does not mean your application's response will be slow. There could be two scenarios, that you as an end user don't even need that data, or even if you need data, what matters is even if you get an older version of that data, that is fine, because they don't want to compromise on the availability. Okay. Here, when you are choosing availability, it's more about responsiveness of a particular application. Okay. And on the other hand, when you are choosing consistency over availability, that means you want to make sure that, let's say, if it was a banking application, and whether the same account is being accessed from US or Europe or India, because you as a customer may be traveling, right? But whenever you access, you must always get consistent information, because there is no way that you can get an inconsistent account balance when accessing, let's say from three different, if you tell your friend in US also to log in, if you tell your friend in Europe also to log in, and let's say for the purpose of serving those two users also in a low latency way, in a highly responsive way, let's say this bank is creating replicas in respective regions, and they are serving the users in each region using that region's replica. But would you like that your friends are also logging into your account with your permission, you are also logging in, and all three of you are seeing different account balances at same point in time with those three different logins, right? Hypothetically, you would still not want that. What you would like is when you are doing a transaction, two of your friends, even if they are saying that, okay, that page is taking time to load, that will be acceptable to you as an end user. You will say, that's fine, but you should never see information, right? That will be more acceptable to the user. The slowness over inconsistency.
Thanks.
Welcome. And I know I took some hypothetical examples, but as you start working with your real world examples, you would be able to better figure this out as to what will work best in your particular use case. Now, oh, sorry, is there any other question? I see some hands raised. If there is a question, please feel free to ask. So that is what I'm going to talk about now. So wait for a moment. Now, let's say, see this. This is again an example of an e-commerce portal. What they are saying, they're selling a laptop, they are selling a mug, different types of mugs, right? So this is a geek mug, this is coffee mug, this is, let's say, Surface Book as a laptop, and you can't really store, all this kind of information in a tabular format, in a relational SQL table, right? Because this microwave safe is not applicable to your Surface Book, right, or your laptop. You don't want to say that, by default, yes, laptop is microwave safe, and somebody goes and puts it into microwave, right? You wouldn't want that. Or what is the liquid capacity of your laptop, and somebody tries to pour in water in that, right? So these are obviously not applicable to a product like laptop, or a Surface Book, and vice versa, right? A CPU size, memory size are not applicable to a mug kind of a product. Right, so that is where I already explained, right, how NoSQLs help, right, so that you will end up creating a product record in a way. Oops. you will create a product record like I had showed before, that you will create these as separate documents, and in this you will have your product ID and all relevant attributes for that product. Similarly, you will create another document, and in that you will add all the relevant attributes. Now, as you start doing that, you can imagine that you can have millions of records in this same product table. And each of these millions of records, right, or a large number of these millions of records will follow different format or different structure, right? Because let's say there are 100 records for mug kind of category, right? That means that for these 100 records for associated with mug kind of product, there are going to be only 3 attributes in that. On the other hand, there are another 100 records for laptop kind of product, and then there are 7 attributes defined for that. There could be another 100,000 records for jewelry, and then there could be, let's say, 7 or 8 columns defined for jewelry, right? Again, not every jewelry item is having all those 7 attributes. Some of those items are having only, let's say, have 10 attributes, and some have only 6 attributes, right, as applicable to that piece of products. Now, for this kind of differently structured data sitting in just one table, right, how do you do indexing, or how do you ensure that Cosmos DB select queries on this kind of table will be performant or will be efficient, right? Typically, in a relational table like this, in a SQL world, what you do, you identify certain patterns of your queries, right? You notice that, okay, I am going to query the data on the basis of product category, or on the basis of, let's say, some of the other columns, let's say on the basis of memory, etc., right? Whatever you identify, you will go and create an index on that, right? On your more frequent search criteria or more frequent join criteria, you will create an index on that particular column for that table, and you will see that, okay, your query performance is increasing, or your queries are performing as required. But how will you create and just how many indexes will you create in this kind of NoSQL databases? So Cosmos DB makes that job very easy for you with an automatic index feature. Okay, what is automatic index? That means for every single type of attribute that you add in any kind of product record, right? And not just product, but just any other record, right? For every single attribute, Cosmos DB will automatically create an index, so that whenever you are running any query on these tables, and even if you use one particular attribute, let's say out of 1 million records, only one record has got an attribute that says, let me take some random attribute name, let's say RAM, right? So let's say in most of the other laptop related products, I'm calling it as memory, but in one particular product entry, I have called it as RAM. Okay, so if I were to search for one product or all products where RAM is greater than some value, right? But I know that RAM as an attribute is available only in one record out of millions of records, but it will still, because an automatic index gets created even for that one record and one attribute, my query will be running equally fast and equally performant. That is how auto indexing works, so that you don't need any secondary indexes or any additional schema changes to be done, and it works across every data model. So that is the beauty of secondary index auto indexing. And the kind of product or kind of database service that you are getting is enterprise grade, right? So because you are using this globally distributed database on Azure, you are already taking advantage of some of the platform level security, right? Some of the compliance certification that Azure has on its platform, right? And that's how Microsoft says you can trust this database, because it automatically protects you against any unauthorized access. It provides best of the authentication and authorization mechanisms. It provides best of the RBAC controls. It provides best of the, let's say, DDoS protection at a platform level, encryption of the data at rest and in transit, all of that, right? Okay, now let's see a quick demo of this. I know we are already 8 minutes over our regular break time, but we will go through the demo after the break. So at this point in time, let's take a 10 minutes break. And after that break, I will show you a demo of Cosmos DB, right? That will help you to understand how to scale and how scalability and throughput works, how that, less than 10 milliseconds of guaranteed latency can be achieved, right? So with geo replication and low latency, and how flexibility is there with Cosmos DB database with auto indexing. So we will try to learn that through a demo, which takes a specific use case in the count, and accordingly we'll try to explain some of these features. When you create a Cosmos DB, right, to understand various features of Cosmos DB, right, and some of the properties through a particular use case, let's assume that you have a use case of a connected car kind of a use case, right, wherein let's say electric two-wheeler company or an electric, and I'm specifically taking that electric keyword. It doesn't have to be electric for that matter, but let's say this new age automobile industry, right, or vehicle manufacturers want to capture a lot of information about their vehicles, right, running on the road, some telemetry information through IoT sensors about, let's say, engine performance or vehicle speed, and all of other things. If they want to capture, they want ability to ingest large amount of data in this Cosmos DB database, right? And obviously they want to create an unstructured or semi-structured kind of information to load this data. Now, when you create a Cosmos DB in Azure portal, right, this is how your overview page is going to look like, right? You have your Cosmos DB database. You can further check this database by going to your data explorer, right? This is where you will, let's say this is a Cosmos DB database created with a SQL API. Okay, now in this you can see the vehicle collection data. Let me show you some examples of the data. For example, right now if I go and check in this data, there is a collection called collection. Okay, now before, for some of you who may be new to the Cosmos DB or NoSQL world, right? In a SQL world, in a SQL relational database, you store information in the form of rows and columns of a table, right? So table is where you store information. So you create a database. In that database, you create as many tables as you want, and inside that table, you store information or your data. Parallel to that, in a NoSQL database, you create a database, and instead of tables, you call them collections. So you create collections, because you are not storing data in the form of rows and columns, rows of a table. You are storing data in the form of, let's say, different documents which are part of one particular collection. So in this collection, if I look at these documents, right, and if I just write a new query on this. So here, if I write a new SQL query to just check a count of the data query, you will see there is 0 records right now available in this collection, right? So as part of demo, what we are going to do is we are going to add some data into this collection. Okay, for now, let's go to scale and settings. Now, what is the unit of measure of a compute or throughput power of Cosmos DB? Now, for example, in case of database, you saw DTU, right? Database transaction unit. In case of, let's say, or you saw that you can measure your compute in terms of vCores, right? How many vCores, how much memory, etc., etc. Similarly, when we look at data warehouse, or when we go to the Synapse, which is our next topic, you will see that Synapse compute is measured in terms of DWU, data warehouse units. Similarly, Cosmos DB also has its own measure or own unit to measure the throughput, and it is called as RU per second, request units per second, right? So this RU per second is request unit per second, right? So every RU per second or every unit of this measure gives you certain amount of CPU power, processing power, that will help you to provide the right level of throughput for your requirement. For example, if you want, let's say, if you want to ingest 1 million records in 1 minute, then how much throughput is good enough, right? So you will have to do some kind of benchmarking. So let's say for in our use case, this throughput is set at 50,000 RU per second right now. Okay. And similarly, now if I go and try to record some information, right? For example, this is the document structure, an example document structure, right? There are also other settings available in scale and settings, but I will come to those settings in a moment as we progress through the demo. For example, the auto indexing setting, right? But we will come back to that. For now, let's understand the nature of the data that we have. So this is some telemetry information coming out of from vehicles. So what is this information? For every set of data that is coming in, it will have a unique ID. So this is the ID. Then this VIN will be some identifier. Then there is some event name called airbag deploy. And then there are some attributes associated with that event and that particular ID. So if this is the kind of data, essentially what you will notice that these are all key value pairs, right? So everything in blue is keys and everything in brown is their corresponding values, right? And that makes one document. And we want to, let's say, ingest millions of such documents into this Cosmos DB database through some kind of application program, right? So what we are going to do is we are creating a program, and once we run this program, it is going to insert these kind of JSON documents into our collection, right? And how many? We are defining that total number of documents to import is set to 1 million records. Okay, so it is set to 1 million records, and we are going to run this kind of, let's say, document ingestion into our Cosmos DB table, in a programmatic loop, so that we keep inserting data. And if I run this program, so you'll see that, okay, some records are getting inserted into Cosmos DB, right? And a total of 1 million records get inserted as this program completes. So as of the creation of the demo, right, at 50,000 RU per second capacity, right, what the program trace shows you is 1 million records got inserted in 110 seconds. Okay, and the capacity utilization or throughput utilization was to the tune of 50,000 request units per second. Okay, and at 50,000 RU per second throughput, it took 110 seconds to ingest 1 million records. Now let's say this kind of performance is not acceptable for your requirement and you want further better performance, right? So how you can improve the performance? You can change the throughput, right, to use a higher throughput level so that your inserts become faster, right? So how do you do that? So again, you can go to scale and settings right here instead of 50,000. Now, but before we do that, let's actually check whether something got inserted or not, right? So here you can see that, your vehicle data information is inserted. And now if you query the data actually, so if I do a select new query and try to check the count of the record from this collection, you'll see that there are 1 million data already available. Now, but I want to, redo this by changing the scale and setting, where I want to change from a 50,000 RU to, let's say, 4 lakhs RU, right? So that is 400,000 RU. So from 50,000, I am changing the RUs to 400,000, right? And after that, I'm going to see if I go to the same program and if I try to reinsert the records into the same table, how long does it take? So with the new RUs, right, you can see that the resource unit utilization or throughput utilization has significantly increased, and my total time has come down from 110 seconds to 21.8 seconds, right, for 1 million records. And what you will notice is the resource unit or request unit utilization per second utilization is to the tune of somewhere around 230,000 RUs per second. Now you would be wondering, why it did not use full 400,000 RU per second, because I had provisioned for 400,000 RU per second of a throughput, Cosmos DB throughput, right? And if it would have been able to leverage that full capacity of let's say approximately 400,000 RU per second, it could have done this job in even lesser time than this, right? So it is not actually a Cosmos DB limitation. You have to understand that your program or your database is not the only part of the puzzle or of the solution, right? Now, why I say that? Because let's say you have a virtual, you ran one particular application. We ran an application code. That application code, let's say, ran on some virtual machine, right? So from that virtual machine to connect to the database, right? And to be able to ingest millions of records, right, per second, or 100,000 records per second, you need certain network bandwidth, because here you are trying to take data from one place and try to insert it into database. Although your database will support a higher bandwidth or higher throughput capability, you will not be able to do that if your entire end-to-end network does not support that kind of throughput. To make it simple for you to understand, let's say you have an older desktop machine, right? You have a very old laptop, to make it easy, right? Your laptop has got very, let's say, you have your old photographs and old videos kept on that laptop, but that laptop CPU is very old. It is already not performing well, and you want to copy all this information from your laptop onto a brand new high speed hard disk that you have got, right? This is an SSD hard disk, absolutely brand new. It can support very high data transfer rates, right? Now you connect this new hard disk to your old laptop, and you see that in every 1 minute, let's say, you are able to copy only X amount of data. Okay, now you think that, okay, this hard disk is not good enough, but you don't realize that it is not the hard disk. It is actually your end-to-end network that is the bottleneck here. It is actually your CPU of the older laptop, which is not able to copy as much data as the hard disk can support. On the other hand, when you plug in this same new hard disk, external hard disk, to a brand new laptop, you notice that, okay, it is able to take full advantage of the maximum data transfer rate that the hard disk can support, and the laptop is also able to support that, and you are able to copy the data much faster, right? So this lesser resource unit utilization is not attributed to Cosmos DB challenge, but it is the challenge of your end-to-end network bandwidth that is supported within your environment. And that is why you were not able to fully leverage 400,000 resource units. Otherwise, you would have been able to do the same job in much lesser time also. Any questions on this? So let's continue. Now, if you go to replicate data globally, right? That means because Cosmos DB is a globally distributed database, so you can create additional replicas in different regions, right? As you can see right now, there are 3 replicas already created. So these are all different regions where you can create replicas, right? And then you can, if you want to add a new region, right, new replica, I can just click, select one of the regions, right? Or click to add replica in that region. For example, I can click on add new region and accordingly select a new region and add a replica. So if I go back here, if I want to add Australia East as another region, I can go over there and I can try to save that, and it will try to start creating one more replica in this new region of my database. Now, assuming that it is doing that, and let's say these are the 3 replicas that are available right now: West US 2, South Central US, and Southeast Asia. And these are the 3 different Cosmos DB replicas that you have. Now, to understand the concept of low latency, right, and how Microsoft is able to provide that less than 10 milliseconds of latency for both read and write operations, let's understand that concept. For that, what I'm doing, right, as part of the demo, we are making simple scenario. Let's say we know that there are Cosmos DB database. Our Cosmos DB database is available across all these 3 regions, right? So to to create a scenario that a user, right, an end user is trying to read some data from this Cosmos DB database from different regions. What we did is we created virtual machines, right? We created these virtual machines in these 3 different locations. That means there is a virtual machine running in each of these locations where you also have a Cosmos DB database replica available, right? That means when I'm trying to connect to a Cosmos DB through an application that is running on this region, on this virtual machine in, let's say, West US2 region, naturally, if I'm running a virtual machine in West US2 region, for that virtual machine or for application running on that virtual machine, the nearest Cosmos DB replica should be in the same region, right? So what we are going to do is we are going to see what is the latency that we are getting when we are connecting to a Cosmos DB through the application running in the same region versus through an application running in another region, right? So for that matter, right, let's open one of the VMs. So let's say I take a remote login into this virtual machine in the South Central US region, right? Let's say this is my application program, and this application program wants to connect to a Cosmos DB database to fetch certain information, right? To write some query and give me output of that query, right? Now, important part to note here is this. So what I'm saying is, this is the region South Central US in which my virtual machine is there. That means my program is going to run from this virtual machine in this region. So I'm saying my preferred connection policy is to, as a first preference, I should connect to the Cosmos DB database in this location, South Central US, same location from where my user is trying to access the database. For whatever reason, if this region is not accessible, then go to another region. If that is also not accessible for whatever reason, then go to the third region, right? So always access my database in this order when my user is coming from this location. So if I were to follow that, right, and if I further go down and what I'm doing, right? So essentially, as part of the program, we are creating a query and we are running that query inside a loop so that we are, we keep selecting some information from the collection that we created. Now, if I run this, you will see that, okay, my database that I'm connecting to is in the same South Central US region, and I'm able to get, fairly all the requests, or under at 99th percentile, I'm able to get the request served in under 10 milliseconds. Okay. Now, if I go to another region, so this is same program running from another region, West US2, right? But if you notice in this case, I have changed my connection preference because my user is connecting. And by the way, in real world application, these things will happen dynamically, right? So this connection policy, it will not be hard coded it like that, right? So the way it works in a larger solution is you have another set of components which are more like networking and load balancing components, right? So those load balancers understand from which region, from which IP addresses your request is coming, and accordingly it will reroute, right? Or it will load balance the request to go on to different types of databases. So, but for the purpose of simplicity, because I know that my application user is trying to access the database from application program running in a virtual machine hosted in West US2 region. So as a first preference, I want to connect to my Cosmos DB replica available in West US2 region. And if that is not available for whatever reason, then only go to the second and third preference. So if I again run this program, again, you will see that it is also running and giving me less than 10 milliseconds of read-write latency. And in this time, you will say that it is actually connecting to West US2 region. Now, if I go to my third region, which is Southeast Asia region, and if I try to run the same program, right? Now you will see that suddenly the latency has actually increased, right? So it is not happening in under 10 milliseconds at all. But one of the other things that you will notice is it is not actually connecting to Southeast Asia. It is actually connecting to West US2, right? And that is why there is an higher latency that you are getting. So let's check in our program, why is it connecting to West US2? While if a program was, if a user was available in this region, and if we also have a Cosmos DB replica in this region, ideally we should have connected to a Cosmos DB replica available in this region. And that's how we would be able to guarantee, low latency. So we notice that in our program, this line has got commented. So your first preference actually became this West US2, and that's why it connected to West US2. So if I uncomment this, right, and if I save this and rerun this, that means now if you see, my first preference is to connect to Southeast Asia Cosmos DB replica, and the program is also running in Southeast Asia virtual machine. And now if I rerun this, you will see that, okay, now it is started connecting to the Southeast Asia document or Cosmos DB database, and it is able to fairly, serve the request in under 10 milliseconds kind of latency. So this is how Cosmos DB works. Now, one of the other important aspect is automatic indexing, right? So I told you that for every data attribute that you add as part of documentation, for every key value pair, or for every key to be precise, it will automatically create an index. So let's say I want to update one of the documents, and let's say we have been, so here I will add a new attribute, a particular document. I will add one more attribute called speed. Okay, so here speed is equal to 100, right? Or speed is the key and 100 is the value. So I update only one of the 1 million records, right, manually. So you can see that the speed attribute is actually available only in one record out of 1 million records, right? So naturally, if you now try to query or use this attribute or new key in your filter or in your where clause, right, it is in a otherwise SQL world, it would not have worked as fast, right? But with automatic indexing capability of NoSQL databases such as Cosmos DB, your performance even for any attribute, right, whether it is occurring frequently in all the documents, or whether it is only sparsely occurring in some or very few documents in the collection, it will still work in a performant way. So now to check that, right, let's change our query. So let's comment this line and let's uncomment this line where we are adding this speed, the new attribute inside a where condition, right? So for this to work, this query also to work in a performant way and give you output in under 10 milliseconds, you really have to have a very good indexing capability, and there should be an automatic index created on c.speed, because we have not manually created anything. So now if I save this program and try to run this program again, so you'll see that it is still able to serve me, my request in under 10 milliseconds at 99th percentile. That means, if the query is running fine, let's see, why it is able to do that even for this new attribute added in the where condition. You will see that there is an automatic indexing created for that. So if I go to scale and setting, and if I scroll down over here, you will see that automatic indexing policy is set to true for this collection. And that is how we are able to, keep adding newer attributes and directly search on those attributes through where conditions. And it is performing equally well in under 10 milliseconds kind of a latency. So that is, what the Cosmos DB is all about, right? It's a multi-model, multi-API database with turnkey global distribution, right? Because it's available across all Azure regions. It gives you limitless or virtually limitless elastic scale around the globe, right? Because, you can scale it across all different geographical regions. Multiple and well-defined consistency models, right? Those 5 different consistency models. And you may definitely expect a question on in DP 203, let's say on the concept of consistency model, right? Or they will give you a scenario that, let's say you have a banking use case, or if you have a specific product related use case. So you'll have to judge the business criticality of the kind of data that is being talked about, and what kind of what will you give preference essentially to the availability or to the consistency, those kind of questions. Then guaranteed low latency at 99 percentile, and Cosmos DB, by the way, is a database that can give you.
Let's have a quick quiz question, guys. In Azure, what service is primarily used for data ingestion and preparation tasks? Azure Stream Analytics, Azure Data Lake Storage, Azure Data Factory, or Azure Synapse Analytics? Please mention your answer in the comment section.
Just a quick info, guys. Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps, and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
Be it a document database like MongoDB, or be it a Cassandra kind of a database, or a Gremlin, which is a graph database, you can use different types of APIs available with Cosmos DB, which essentially work with a wire protocol. And then your Cosmos DB created with a respective API starts working like that particular NoSQL database. Then we saw, we just had a very quick introduction to Synapse Analytics. So let's continue with that. We saw these, basic statistics that most organizations and most industry leaders have a priority that they want to create analytics workload and to unleash the value of their data, but they struggle to become a mature user of their data because their data is available across various silos, right? So silo means their systems are not talking to each other, they are disconnected. So if you if some of you have not heard of this word silo is essentially that equipment that you would have noticed around the highways, a stone crusher or a cement kind of manufacturing unit, wherein a silo is called a unit where it is standing uniquely away from all of the other elements of that plant. So that's what silo is called. And data silos essentially would mean the data systems that are not talking to each other, right? So their data is spread across various disparate systems, and essentially to meet their data analytics requirements, organizations so far created two different types of systems: a data lake, right, for their big data processing, and a data warehouse for their relational data, operational data, so that they can create a tabular structured data warehouse. But Synapse brings both of these worlds together, right, to give you limitless scale and capability. So in Synapse, your data lake and data warehouse come together, and you get a one-stop analytics solution, which can not only build a data lake, data warehouse, but it can provide you two different types of technologies together, such as a SQL-based runtime engine or a MPP data warehouse. And the other one is a data lake, right, which is optimized for big data, and you can use technologies such as Spark to do the big data processing. To kind of put it into a definition, one-liner definition of Azure Synapse Analytics: it's a limitless analytics service with an unmatched time to insight that delivers insights from all your data, right? Different types of data across data warehouse as well as big data analytics systems with a blazing speed. So if you recall, I would have said this: Azure Synapse. So there was, before Synapse, there was a data warehouse service that was available within Azure ecosystem that used to be called as Azure Data Warehouse. Okay, so, or SQL Data Warehouse. So Azure Synapse Analytics is Azure Synapse Analytics is an evolved version, right? And evolved from the ground, completely evolved, I can say, version of same SQL Data Warehouse that was available. And how it is evolved: SQL Data Warehouse was a plain data warehousing workload. In Synapse, you have got a same data warehouse plus a lot of additional capabilities. What are those capabilities? You have data lake, you have Spark engine for big data processing, you have ETL built into this. What is our ETL tool that we have been using in Azure? So you get data warehouse plus data lake plus also data factory embedded within Synapse. So you will see that is called as Synapse pipelines in Synapse. So that, you buy one product or you buy one service from Microsoft and you get end to end, whatever you want to do with your data, bring data from any source system, do the transformation of that data using Spark as well as SQL technology, build end-to-end data pipelines, that to low-code, no-code data pipelines, and build transformations using data factory UI, like mapping data flow, all within Synapse. And then not only that, you create a data warehouse, right? Bring your data into a data warehouse tabular structure and also build Power BI report, right? So right from ingestion to visualization and also doing machine learning, AI and ML within that. So end-to-end analytics can be done within Synapse, right? And you will see, as I show you Synapse, you will see how it is natively integrated, across all these services. Okay, so we are not seeing these things in detail. So let's understand each of these aspects, right? What a limitless scale means, what is powerful insights, unified experience, and unmatched security. So by limitless, we mean that, from a data warehouse as well as big data perspective, you practically get, you can scale up to a limitless capacity, right? You can build petabyte scale kind of data warehouse and data lake. Now, this is important. Why this is important? Because it gives you a perspective of how Synapse fits into or fits across various competitor data warehouse or data lake workloads, right? Now, this comparative study was not done by Microsoft, but it was done by a third party, right, called GigaOM. And whenever there is a data warehouse workload, the data warehouse workloads capacity and performance, right? Capability and performance rather, is determined by an industry standard benchmark. That benchmark is known as TPC-H. Okay, so what is TPC-H? TPC-H is a certain set of queries, right, that are run against a certain data model, predefined data model, which has very large amount of data, right? For example, you can do the TPC-H benchmarking of various data warehouse workload, let's say at a petabyte scale, or let's say at a 500 terabyte scale. So essentially, when GigaOM compared Azure Synapse, Amazon's Redshift, Snowflake, and Google's BigQuery, right? All of these to achieve same, let's say, against certain amount of data, right? Certain volume of data to get the same level of query performance. For example, to get, let's say, TPC-H defines 30 odd queries. For each of those queries, if you were to finish against the same set of data, same tables, if you were to finish that queries, let's say in 10 seconds, right, across each of these workloads, right, then what they noticed is the kind of compute capacity that you have to put in Synapse, right, versus Redshift, versus Snowflake, and versus Google's BigQuery, to finish each query in the specific time, you need to spend much less money as a customer on Synapse Analytics for the same level of performance. So this is called as price performance analysis or benchmarking, where lower the price, the better the workload, right? Because at a lower price, you are getting the same performance. So this study found out that Synapse in certain cases can be as cheap as, more than 94% cheaper compared to Google's BigQuery. And similarly, it is also cheaper compared to Snowflake and Redshift for the same level of performance. And that is where customers find it very attractive value proposition with respect to running their analytics on Synapse, right? This is pure price performance comparison right now. But the other technical comparison that I like and that I love is the sheer capabilities that Synapse provides, right, with respect to a lot of native integrations, because none of these tools that are listed over here, right, which are seen as a competition to Synapse, for example, Redshift, Snowflake, and Google's BigQuery, none of them can do what Synapse alone can do as one service, right? Because Synapse gives you ETL, ingestion, transformation capabilities, that too, data lake plus data warehouse together, SQL plus Spark pool, as well as what you get, and also a serverless engine. So all of these I will come to in detail in a coming slide, but also AI ML capability, native integration, also Power BI. So visualization capability, all under one hood or all under one umbrella, and that none of the other services gives you. You can of course do all of this in other cloud as well, but you will have to stitch together a number of different services to achieve the same result. In Synapse, everything comes under one umbrella, very beautifully, very natively integrated, so that your development experience becomes none like other. Okay, and you will realize that as I show you the demo and as we understand this better. So let's continue. And by the way, all of these statistics, right, are also publicly available on GigaOM's portal, right? So I would otherwise not show you any such comparison, but because it is done by a third party and publicly available, so you can also, search for this and you can find it. Now, unlock power. And like I said, right, my job today here is not to sell you Microsoft Azure platform, right, or Synapse as such. Just focusing on learning more about Synapse. Oh, so that I anyways do as part of my day job. So I don't have to, be a very strong advocate of Microsoft here, but rather of technology is what I will focus on. So what you also are able to unlock is, powerful insights from your data, because as you can see, integrated business intelligence, machine learning, it drives insights for all users, right? So it becomes easy workspace for data scientists, data analysts, data engineers, all of these different types of data users to collaborate. You can build end-to-end analytics, right? I have already spoken about this with a unified experience. So you get, very ease of development, and you can build an end-to-end analytics platform just using one service. Okay, now let's understand this, right? A high-level architecture or, a view of what this service is all about. Let me build the slide. Okay, at the core, right, foundational layer is your common data model layer, which is powered by Azure Data Lake Storage. So whenever you create a Synapse account, it has a data lake storage, which is your common foundational layer. Now, for integration, there is something called as Synapse pipeline. Okay, now what is Synapse pipeline? Synapse pipeline, simply put, is Azure Data Factory natively integrated within Synapse. And you will see that as we start seeing the demo, you would realize that, okay, this is exactly what we used to do in Data Factory. Now it is also available as part of Synapse Studio. Okay, so it's called Synapse pipeline. So within Synapse, right, you can connect your data lake, right? Once you connect to your data lake, you can very easily move data between, your SQL pool, Spark pool, data lake. All of that integration becomes very easy. Also, you can, because you have your data factory integrated within Synapse, you get all the capabilities of data factory, such as being able to connect to any source system with 90 plus connectors that are available out of the box, then doing low code, no code, low code, no code transformations, etc. Now, to do the data transformation, you get two types of runtime engines. One is a SQL engine, and then the other is a Spark engine. So you can use Spark engine for all your big data processing, right? And transformation, Spark based transformation, PySpark based transformation, etc. And you can use your SQL pool. In SQL pool, again, you get two types, provisioned and on demand. Now, what is a provisioned SQL pool? Provisioned SQL pool means your data warehouse workload, right? Wherein you are creating your fact and dimension kind of a data model within your dedicated SQL pool, which is called as provisioned SQL pool, right? So in that dedicated SQL pool, you will go for certain provisioned capacity. That means, let's say you are running your data warehouse on 100 data warehouse units or 200 data warehouse units. Now, what is data warehouse units? I will explain in a minute, right? It is also a simple unit of measure of compute and memory. But essentially provisioned or dedicated SQL pool means that is your provisioned data warehouse. Now, what is on demand then? Now, on demand means you can also use SQL capability so you don't necessarily have to provision the pool at certain capacity. When you have ad hoc requirement or ad hoc query requirement, you want to scan large amount of data and you don't have to necessarily provision a SQL workload. You can also work on it in a serverless manner. So in a serverless way, you can use a serverless SQL pool, which is called as on-demand SQL pool, which is a shared set of resources available within that region and using which you can query the data. So what it does essentially is when you try to query, because it's a serverless SQL pool, so there will be no tables that you will create in that pool, but you would want to use SQL to scan some of the data from the files. So let's say in your ADLS Gen 2, right? In your ADLS Gen 2, which is your data lake, let's say you have a CSV file, okay? And this CSV file has lots of customer information, okay? Now you want to run some queries on this CSV file. Typically what you have to do is first you have to load this file into your some of the SQL table, and then you start running SQL queries. With serverless SQL pool, which is shown as on demand over here, what you can do is you can connect to that file on the data lake. You can quickly bring that file into an external table. So build an external table on top of that and directly query that using the serverless SQL pool. And also, now you may be wondering, okay, how do I do this, right? How do I build an external table? I don't know the syntax, or I don't know how to do that. You don't have to learn any of that, right? You can, I will show you when we create a Synapse Work Studio. It is very easy. You don't have to write any line of code to start exploring data that is available in the file. And that is also a big differentiator, because I have personally used a lot of other data warehouse technologies, and it is not as flexible to start working on directly on the files without having to write your own code. So that ways Synapse makes it very easy to work with your data, and for all different kinds of data users who may not be, who may not have the same level of technical expertise. Okay, now we saw SQL and Spark pools, right? That too as a provisioned and on demand, which is dedicated SQL pool and serverless SQL pool. And by the way, Spark cluster is also always on demand. That means you will not provision a Spark cluster and it will not continuously keep running. So Spark cluster will be used only for the time period you want to run the Spark workload. And after that, you can define a time to live parameter. So what is time to live? You will say time to live is, let's say, 120 minutes or 15 minutes. That means once the Spark cluster is idle for 15 minutes, it will automatically terminate to save cost. So this on-demand technology or on-demand compute also helps customer to save cost a lot. Now, what are the languages supported? So all the popular languages that you use in the analytics space, right? Like SQL, Python, .NET, Java, Scala are supported. And all of this whole experience, right, of managing your data, securing, monitoring, creating a meta store, right? All of this becomes a simple kind of use case. And this whole experience comes together in a one umbrella workspace called as Synapse Analytics Studio. So it makes it very developer friendly, because end-to-end analytics experience can be built using just one service, which further integrates with artificial intelligence, machine learning, IoT, intelligent apps, business intelligence, etc., etc. When a company is looking to build analytics platform, they will have different types of data, right? So some of their data will be coming from their various applications, right? Typically applications have some databases, right? To put it into context, let's take a simple e-commerce example. Okay, so now I am an e-commerce company. I want to build my analytics platform, right? Now, what all different kind of analytics I would want to do? I would want to understand, okay, how many orders, right? I am processing every day. What is my order volume growth, month over month, year over year? What is the, my customer retention, right? What is the total number of customer complaints or queries I am getting? What is the volume of my return orders on a day-to-day basis? Is it growing or is it decreasing or whatever, right? I want to understand my order sales average selling price, right? For every order, what is the average selling price of order, right? These are all different types of KPIs that an e-commerce company would want to track, right? Customer satisfaction, product reviews, which are my top selling products, which are my bottom selling products, where I have a lot of inventory but the products are not selling, which could be a dead stock, where I need to bring more inventory. So I am talking about simply lots of different types of analytics scenarios, right? Now, what is it that my customers want? Now I'm trying to switch a little bit. Okay, so you just hear about the scenarios that I'm talking about now. What are my customers talking about? What is trending on social media? What is my customer liking? In what mood my customer is, or what my customer might buy next, right? So a lot of other queries, earlier queries that I talked about, such as order related, returns related, inventory related, product rating related, all of this information you have in your system, right? Somewhere you will be storing all of this information in some databases. So all of that becomes your operational data that you will bring from your databases into your, let's say, data warehouse, right? By building ETL pipeline. Now, the other set of analytics that I talked about, right? What my customers are talking about on social media, what is trending with my customers, right? Now, all of that are external data sets, and typically these are unstructured data, right? For example, Twitter feed, social media feed, something, external data coming from, let's say, Adobe Analytics. So there are a lot of third-party data sets that are available. You want to, along with your operational data, which is your own data, you also want to bring in this unstructured or semi-structured data from external data sources. Now, to process these different types of data, you cannot use just one technology, which is a traditional data warehouse. You also need a data lake, so that you can bring all these different types of data into a data lake. And then from data lake and data warehouse together, you can process this data and transform it in the way it is required, so that you are able to do the reporting on top of this or build your KPIs on top of this. That is where data lake becomes very essential part, right? Or for example, talk about the logs, right? You want to see, so doing business level analytics is one thing. The other set of analytics that large companies have to do is how their IT infrastructure is working, how their app is performing, what is their CPU utilization of, whatever their servers, what is their data. So all these different logs, or any incidents or any IT glitches, they need to analyze that. For that, what they will do is another set of information that they capture to do analytics is application logs. And then there could be IoT streaming data. So you can imagine a lot of this data is unstructured or semi-structured data. So for bringing all of this data to do analytics, your plain structured data warehouse is not going to work. And that's where you also need data lake, so that you can get one system that has a data lake plus data warehouse, so that you can do all kinds of analytics. That is the relevance of data lake over here. Let's say you have your data into data lake as separate files, right? So it is not very easy to work with files, right? Although you have capabilities like Synapse, it is easy to query those. But on top of that, there is a concept called as delta lake, right? Which was first introduced by Apache Spark. So house is nothing but the same concept of delta lake of Apache Spark, right? Which is building a semantic model of tabular structure on top of data that is available within files in a data lake. Okay, so essentially your data is still residing in the data lake. It is not residing in a database storage. So imagine there are two types of storage, right? One is your normal hard disk storage, right? Wherein you can call it like a data lake storage. There is also another storage, right, which is database or data warehouse storage, right? So the data that you keep in your data warehouse, you are running SQL queries on that, right? And that is always going to run fast compared to the data that sits on a data lake, because now you are hitting a file system, right? Not a database kind of a file system. So because there is difference, right, between how your data is organized. So lake house construct or delta lake is a construct which sits in between. So you get query capabilities like a database or data warehouse, so that you have predefined tables which are created on top of the files sitting in your data lake, right? And at the same time, you get flexibility or ease of use, because you don't have to always refer to files as files. You can now start referring to files as a database table. So you are directly writing a query on a lakehouse table, and that query will internally know that, okay, this table is not actually created inside a database storage. That table is actually created on a data lake. And these are the files that constitute to this table. And then that lake house construct will automatically decode the query to run onto that set of files and give you the output. So lake house is, just a construct created to easily work directly with your data sitting on a data lake. Is a plain storage. Whenever we talk about database or data warehouse, that is not a plain storage service. It is a compute and storage service. Because for any database, to put it simple, think of a SQL Server database, think of an Oracle database, or any other data warehouse like Teradata if you have worked on, right? With that always comes with a compute engine, right? Using which you can query the data, and it comes with its storage. So because a data warehouse database kind of workload always comes with a compute and a storage, it is a costlier service, right? Data lake, on the other hand, is a plain storage. So because it is a plain storage, it does not give you any compute. So the compute that you will use to access your data from this data lake storage is this SQL engine. So here, what they have done is, they have separated this storage from this compute, right? So that you can use the data available on this data lake storage either using the SQL pool or using the Spark pool, or either ways, right? So your compute part will be charged over here and your storage part will be charged over here. That's how it works, to give you more flexibility. So unstructured data will come and sit on the data lake, and so as even structure can sit here. But typically when you start putting after transformation, so essentially all the raw data, right? All the raw data, whether structured or unstructured, first as a standard practice is landed onto data lake storage. Once it is landed onto the data lake storage, you will start running some kind of transformations, and all your transformed data, right, will finally make into some of the structured tables on the dedicated SQL pool, which is provisioned, or think of it like your data warehouse table. So as you start processing, transforming your data and create a reporting ready layer, then it will sit onto the structured tables. Now from source, let's say using Azure Data Factory, okay, which is called Synapse pipelines here. Using ADF, you are building this data and you first bring it into data lake. This is called as raw. Again, you can create another folder in data lake. This is called as, let me call it as bronze, silver, and this is called as gold. So these are all data lake, but this gold layer, you typically also move it into a data warehouse tables, tabular structure, right? So that you can do reporting. See, ultimately you would want to do reporting on this. Some report and dashboards built on Power BI. So it may not work as efficiently to directly run Power BI queries over a data lake, over this gold layer. So what you do is you typically create a data warehouse layer, right? A final reporting ready data warehouse layer, which are like dimension and fact tables, a data model created, and your Power BI will run queries on or source data from the data warehouse. Okay, I think I might have a solution architecture. So see, sometimes you build a data warehouse, but only for smaller use cases. So it's not ideal. So I will tell you, the best suited model, if you want to use Databricks, is essentially to build a transformation layer into Databricks, and then final data warehouse layer you should build on Synapse. So a lot of architectures that I see practically day in, day out, where they will typically have ADF, right, or Synapse pipeline to ingest source data. Then they will land it on ADLS, right? This is your common data lake storage. From here, you will use ADB, which is Azure Databricks, right? This will use this you will use for transformations, or this data can also be directly consumed for SQL-based transformation into Synapse. Right? And after ADB, you will bring it here on Synapse. Here you will use Power BI, and your user will work on dashboards. This is the kind of very common data warehouse or data warehouse plus data lake kind of solution pattern that we observe. And I'll tell you why not just Azure Databricks, right? Because the data lake construct, and I know we are jumping a little bit over here because we have not yet covered Azure Databricks, and we'll come to that. But this data lake, right, like I mentioned, although it is a lake house kind of a construct, but essentially this is not a database storage. This is not a DB storage. This is still sitting on data lake, which is, let's say, ADLS Gen 2. So running complex analytical queries, which has a lot of aggregations, and where you have to join large number of large tables, you will not be able to run the queries on the Delta Lake as fast as they can run on Synapse. Why? Because Synapse takes advantage of MPP architecture. This is a massively parallel processing distributed architecture where your data is by default distributed across 60 distributions. Okay, so I don't want to jump guns. We'll explain the concept of what is 60 distributions and all, and then probably all of these things will automatically become clear. And then as we look at Databricks, things will further be clear. Now, what you see here is just a screenshot from the Azure Studio, Synapse Studio. But anyways, we will see that in much detail. But as you can see, you find it very familiar because you have seen Azure Data Factory Studio, which looks very similar.
Yeah, it's very similar to that.
So what you also get with Synapse is enterprise grade security, right? So you can see you get your, it's a defense in depth kind of a approach, wherein your data is secured across all different levels, right, of network as well as data. So in Synapse Analytics, you have different technologies or different ways to secure your data, right? You can put your data inside a virtual network, then you can manage it with access control, authentication, network level security, also automatic threat protection. So all of that gives you enterprise grade security so that you can run this workload, analytics workload on Azure with confidence, right? This gives customers confidence that yes, the data that they are going to store in Synapse or on Azure platform is going to be secured. It will be encrypted at rest as well as in transit. It will have platform level DDoS protection. It will have platform level firewall or VNet kind of protection, RBAC, and all other security measures that are available. And beyond that, right, to further control access to data that is sitting in Azure Synapse Analytics, there is also something called as row level security, column level security, which we will cover at a later point in time to further secure your data even from the authorized users. Right? For example, the user may be authenticated, right? That means it is the employee of your organization. It is also authorized to access certain data, right? But maybe that user is from certain department and is not expected to access data of other department, right? So it's a valid, legitimate user supposed to access some part of data and not the other part of data. That also you can secure using features such as row level security, column level security, etc., which we will cover at a later point in time. Again, this is, you can relate it very well to Azure Data Factory, because in Synapse, when you integrate Data Factory within Synapse, it is called as Synapse pipelines, Okay, and because it is essentially the data factory integrated, you get those 90 plus connectors out of the box available. Okay, now this is important. There is also a construct of workload importance. Okay, now what is workload importance? Now I'll tell you that in a very practical context. Okay, so when I was working with Amazon, okay, in Amazon, you can imagine the kind of scale of operations, right? And some of the use cases that I talked about, right? As a business stakeholder, I want to understand, how am I doing as a business, right? What is the health of my business? What is the total order volume? What is the total revenue day by day, right? What are some of the top selling products, etc., etc., etc. So there used to be a report, and I was part of their big data processing team, right? So there used to be a report that needs to be ready every 5 a.m. in the morning, right? So 5 a.m. used to be our target, so that even if it is late on some days, right, by 1 hour, 2 hours, 3 hours, maximum by 8 a.m. PST, right, which is Pacific Standard Time, when Jeff Bezos, right, the then CEO of Amazon, whenever so the first thing that Jeff would want to see in the, and I'm being very conscious to not reveal any specific details, and you can apply it to any other CEO, any other company, but because I have seen that, so I'm giving you that example. So Jeff would want to see a report, right, which will give him the health of the business, right? Now imagine there used to be millions, literally millions, and this is not an overstatement, by the way. There used to be millions of jobs that would run every day, every night, right? So overnight, there used to be millions of jobs that will run. These are like typical data warehouse, ETL kind of jobs that process this data, right? And you can imagine the scale of operations. They process literally terabytes of data every hour. So, and multi-terabyte of data every hour for some pipelines itself, like for some specific tables. So there are like thousands of tables. Imagine there are pipelines running on all these data pipelines running across all these tables, out of which there are certain set of tables which are very important, right? And these are the important set of tables on which certain report is created every day, which is most critical, and your boss of the company wants to see that report every day morning. Now you can imagine how I am coming back to workload importance, right? Because not every workload, not every job of those millions of jobs that run every day, every night, are not all of equal importance, right? So you have to have a mechanism to make sure your important jobs are taking first priority, because you always have limited compute, right? You cannot go for infinite compute and spend infinite amount of money on your data warehouse, right? So within the resources that you have available, you need to have a mechanism so that you can give higher priority to more important jobs and lower priority to relatively lower important jobs, right? Because sometimes we used to face a scenario that somebody just ran, let's say, an ad hoc query, and that query is so bad that it is scanning lots of tables, large tables, and because that ad hoc query somehow started acquiring a lot of resources, our important jobs are pending for that resource, right? So we had to implement a lot of mechanisms so that there are no such bad queries or bad jobs coming in, and we had to make sure that none of the non-important jobs or ad hoc jobs are taking over our important jobs, right? And that used to be a very high priority thing. You can imagine, right? If the top boss of such a large company is always waiting to see that report first thing in the morning, how important that report must be. And likewise, take any business, any scenario, you would have these kind of important jobs that need to finish first, right? Because the business is dependent on them. So workload importance is important in any data warehouse workload. Synapse gives you ability to tag your jobs, right? To create your jobs in a way that you can attach an importance to it, so that let's say a CEO has submitted a query. I have some other data analyst has submitted a query. Some business intelligence guy has submitted a query. And just imagine that because there are limited query slots, you are, your data analyst query is running, intelligence engineer, BI engineers query is running, and CEO's query is waiting continuously. So he's getting frustrated. So your top priority is whatever query that CEO has submitted, that should take first priority, right? So you attach a workload importance to that. So the moment the next query slot becomes available, irrespective of, who all are in waiting, that CEO's query or the CEO user's query will get precedence, and it will acquire required resources to run that job. And only after that, for the remaining available concurrency slots or query slots, the other queries will start running. So that is important. What is workload isolation? Now, workload priority and workload importance is not enough, right? Why? Because in workload importance, like I mentioned, right? So there is a CEO who is trying to run a query, and there are about, let's say, 10 other users. And let's say you can run only 4 queries concurrently. So CEO's query takes a slot, and then there are 3 more queries running, right? Now, all these queries are competing for the resources. So 25%, 25%. Happening is your CEO's query is also running slow, and then the other 3 queries are also running slow. And the moment the other 3 queries finish, again 3 more queries are coming and taking that. Can anybody tell me what is the problem here and how would you want to solve that? Your CEO's query got a query slot. It got a it started running, but because there are also other queries running, so it is taking long time. So how would you want to solve that? Or compute it is 100, just give it some number, right? So out of 100, you would want to give, let's say, 60 to your CEO queries, right? Or topmost queries, so that once those queries are taking those 60% of the resources, let those queries first finish, and after that we'll make those resources available for other queries also, right? So that means, let's say, if 10 queries can run simultaneously, each taking 10% of the resources, you are saying 60% resources I am going to keep blocked for the queries that are most important, right? And that is called as resource class. So that is called as workload isolation. That means you are creating, let's say, 4 resource classes here, right? One resource class is containing 60% of the resources. The other 3 resource classes contain 10% each of your total resources, right? Or whatever other distribution. And then when you are running a query, you are attaching that job or that ETL pipeline to that specific resource class, so that it runs on that set of resources. And you are in a way isolating the workloads, more important workloads from the low important workloads. And you are also isolating them in terms of the resources available to utilize. Now, with both of these capabilities of assigning workload importance and workload isolation, you are able to address the important aspect of any ETL workload, which is ability to meet the SLA, service level agreements, for the important jobs, right? So these are typically called service level agreements. So that means the scenario that I mentioned, that we always would use to, all our eyes and focus, and our operational team would just be every single day focused on one table, right? Which is the last table of the complete set of tables processing on which that report is created. That table must finish by 5 a.m. right? Now, what is 5 a.m. PST? That 5 a.m. PST is an SLA, service level agreement, that we have as a big data warehouse team with the business, that we will make this table available by 5 a.m. Likewise, in every business, every scenario, there will be such SLAs that you have to guarantee, and to be able to meet those SLAs, you need workload isolation and workload importance kind of capabilities. All right, so now let's understand that through a demo. But before we go to the demo, let's go and create Synapse workspace. So to create a Synapse Analytics workspace, again, some basic details that we have to provide. Select our resource group. Then you have to, other important is you have to specify a workspace name. Let's say JK Synapse workspace. Then you have to select the region, which is again mandatory. Okay, now whenever you create a Synapse Analytics workspace, you have to attach to it a data lake storage Gen 2 account, right? Because if you remember that diagram, there has to be a associated data lake storage account to a Synapse workspace, so that you can bring all your structured, unstructured data into that data lake storage, which is connected to Synapse. Now, for that, you can use from one of the existing data lake storage account from your subscription. For example, if I have a subscription, from my subscription, say this is my subscription, and from this I can use one of these available ADLS storage Gen 2 account. Or if I want to just keep it separate, I can click on create new. So it will create a new ADLS Gen 2 account also for us, and I can give it some file system name, let's say. Okay, so it is going to create an ADLS Gen 2 account also for us within our same subscription, and that's about it, right? So simple basic details. Okay, on the security, let's see, maybe some more mandatory information needs to be provided. Okay, so it says, what is your password that you want to use? All right, the validation is successful, and let's go ahead and create the Synapse workspace. By default bring in, but you can also link, so it does not necessarily, so whenever you want to bring your data or build your raw, right, or curated and final reporting layer, right, bronze, silver, gold that I talked about, right, and analytics that one can build in Synapse, right? What is the art of possible, right? And in terms of art of possible, because I've been talking so much about Synapse, right, you can build end to end from ingestion all the way to the consumption through Power BI, right? So how does that work within Synapse? To understand that, we'll take an hypothetical use case of a retail customer, right? That retail customer has lots of data, right? But what they are struggling to do is they want to bring their data is stored in various disparate source systems, right? Some data is, let's say, sitting in Salesforce, some data is sitting in Teradata data warehouse, some data is coming from Oracle system. So these systems are not talking to each other, so they want to bring all this data into a common data model, and so that they are able to gain real value out of their data. That's one. Their customer information is also coming from various systems. So they want to gain a complete 360-degree view of the customer. That means when they pick up a customer, they should be able to understand across all different businesses that this company runs, what is this customer profile looking like? This customer is a high value customer for us, or is it a low value customer? This customer is on the verge of going to competition, or this customer is a very loyal customer, right? This customer has been, what is their buying trend? So how frequently do they buy? Do we know these customers preferences with respect to brand, with respect to let's say a buying pattern? Do we know what this customer is probably looking for as a next thing to buy? So all of these things, right? Just imagine if a company has all of this information, how better they can serve their customer, right? How well this customer's last experience has been with our customer service representative, right? Has this customer returned some items, or they typically just buy and retain their items and don't get into a lot of returns. So all of these information, a 360-degree view of customer is very important. And they want to use all of their data, right? Combine this data that comes from their own systems, bring a lot of external data from third-party agencies, social media analytics data, Twitter data, etc., to completely understand their customer. So that, for example, if their customer is talking highly about some products that they bought, then can you tap into that as a lead, and can you show them, for example, customer is very excited that they bought a new car, right? Possibly can you sell them an extended insurance warranty, right? Or can you sell them some car accessories as an upsell? But only when you know that this customer is very excited about on the social media about buying a new car, and only when you know that you will be able to make them any cross sell or upsell, right? So you don't only want to keep information about your customer, what is coming from your systems, because you don't sell car, so that data will never come to you. But if you tap into their social accounts or social media feeds in an authorized, in a legitimate way, then you will be able to better serve your customers. So a lot of these kind of use cases which are very useful in the retail world, right? And I just gave you some use cases out of like just imaginary use cases, but very relevant if you think of it. Now, for this, what this will have to do, right? What kind of system you will have to build? You will have to bring your operational and big data, right? Your data engineers will bring this data from your line of businesses, your, let's say, customer relationship system, your CRM, your ERP, your ordering system, etc., right? Plus there will be big data. Now, what could be this big data? This big data could be like data that I talked about, right? This data could be coming from IoT devices that are fitted into your stores, right? This data could be big operational data. This data could be external data, right? On the other hand, there is also D365. Now, what is D365? D365 we will not focus much for the purpose of demo, because D365 is another suite of services that Microsoft has to offer. It's a CRM system. Okay, so D365 is a customer relationship management system. It has customer insights. So this demo is created like to showcase a value of D365 and Azure Synapse Analytics coming together. So some data will come from D365, some data, operational data will come from your operational systems or your database, various databases of different line of business systems. And essentially all of this will sit into common data model. And then what kind of different data and you will build, right? So this is your common data model. This is how your analytics workspace is going to look like, wherein you bring your sales, marketing, finance, streaming data, etc. within Synapse. And some of the other data that comes from D365 could be, your point of sale information, your support, that means customer experience or customer service kind of information, or some of the web app or let's say Adobe analytics data, some external data that you bring. So once you bring all of this data together, how you can do analytics, that is all about this use case. And we will see what is the art of possible with Synapse in terms of doing end-to-end analytics as part of the demo at a later point in time. But and what will be the demo scenario? I think it's more or less what I talked about, right? This company wants to build a 360-degree view of their customer. They want to gain insights into their historical data, real-time data, and also data to be able to predict for future, right? So what is past trend, what is happening now and here, and what will happen in to be able to predict what will happen in future. They want to also enable their business analysts, data engineers, data scientists to create a collaborative workspace so that they can all use a single golden source of the data, right? Or they are all able to utilize their data analytics platform, a common analytics platform essentially. So if you see, all of these things got created. Sorry, these are the things already available in my resource book. So what got created just now is this Azure Synapse Workspace 0311 and this ADLS Gen 2 account associated with that. So if I open this, this is my workspace. All I can do is simply open the Synapse Studio. This will open a studio similar to Azure Data Factory. We will go there in a moment. Let's first understand what all do you see here, right? Now in the overview tab, you see your, this is the resource group, this is firewall setting, etc. This is your ADLS Gen 2 account, right? Primary ADLS Gen 2 account, which is associated as a connected account with your Synapse. Then this is your Active Directory, etc. Some of the other dedicated SQL dedicated endpoint, serverless dedicated endpoint, some of these things, right? Don't worry too much about this. We are going to go into the studio and learn more. Now, there is different things called as SQL pool, right? Right now, you see only built-in SQL pool available over here, which is serverless, right? This is your on-demand serverless SQL pool, right? That means you always get bare minimum this built-in SQL pool so that you can log into Synapse and you can start exploring your data without having to provision a dedicated SQL pool. Okay, when you create a dedicated SQL pool in which you want to create your data warehouse table, which you want to persist, right? That means once you load the data into your data warehouse table, your data warehouse should always be there, and you should anytime be able to query those tables. That is called as dedicated SQL pool. You can create a dedicated SQL pool from over here. You can also create Apache Spark pool from over here. You can also create, this feature is currently in preview, but you can also create something called as Data Explorer pool. Now, because this is in preview, that's why I had not included those into the slide. And we will, when we cover what is Azure Data Explorer, then you will be able to better understand this. And that is coming up, so don't worry. Now, let's open this Synapse Studio. You can give it a source, right? Here you have source setting, destination setting. You create a linked service. When you create this workspace, right? This is by default showing connecting to my ADLS Gen 2, right? Showing, okay, do I want to go to my ADLS Gen 2, bring some data from there, etc., etc. So source setting, destination setting, and when I click this, finish this, you know that, you know, it will take the data from the specified source, copy that data into the specified destination. Simple. My pipeline will run. I will close this for now. Then explore and analyze, right? So if I click over here, it will take you to a documentation page where it will point you to a number of tutorials, right? Explore and analyze data lakes with serverless SQL pool, right? I can do a quick tutorial that will help me to analyze my data, right? We can do this. Let me first go back over here and then visualize, right? So you can also build Power BI reports and dashboards by connecting your Power BI workspace. So if you have a Power BI license and if you have a Power BI workspace, you can also connect your Power BI to Synapse workspace so that you can work right from ingestion of the data, transformation of the data, to the end-to-end visualization of the data from within the same Synapse Studio. Okay, I'll show you how the Power BI also comes in, because I have a nice demo that will kind of show you the end-to-end art of possible. Okay. Now, beyond that, if you go to Knowledge Center, right? Now, this Knowledge Center gives you some of the information, right? Use samples immediately. So there are ready-made sample templates that you can use. Then you can go to gallery and you can use some industry-ready data models, right? And you can also take a tour of Synapse Studio. For example, if I go to browse gallery. Now in this browse gallery, these are something called as database template. Now what is database template? Database templates is a concept of lake house. Okay, see, you can see lake databases, right? Use these templates to quick start creation of a lake database. And you can of course click here to learn more about it. It will, you know, redirect you to the relevant documentation. What is Synapse database templates, right? And what is the concept of lake database, etc., etc. So if you keep scrolling here, it will, you know, give you complete details of, if I go to quick start, see, it will tell you how to create a lake database from database template, how to configure your lake database, etc., etc. Okay, so we can do that over here also. I will show you, right? Now, this is a very popular construct these days, right? Because in this, you can create a industry standard lake database. Okay, now what is an industry standard database and how it is useful? For example, let's say you are a customer in the retail industry or you are a customer in banking industry. Now, all of the existing customers, they build their data warehouse, right? They are, you know, or their data warehouse, let's say, think of a bank, right? Which is there since at least last 2 decades, right? Or last 10 years. Now this bank, does that mean that this bank today will not have an analytics platform? They will have a data warehouse, right? That data warehouse would have evolved from day one to today in last 10 years, right? And their data warehouse has evolved so much so that, you know, it is currently in some shape and form. But do you think that will be, you know, fitting to an industry standard data model? Probably not, because in most organizations, these things evolve over a long period of time, right? Now, what Synapse database templates help you is, they tell you that, okay, you have your data, existing data warehouse, right? Or if it's a new business, right, and you are first time creating your data warehouse, then you create it in a industry standard data model, right? Or if you are migrating from your existing data warehouse, then first you create a database template which is industry standard, and then you do the mapping, right, of an industry standard data model or fields to your specific existing fields, so that your data now comes and sits into a standard data model, using which you can very quickly build a lot of analytics use cases. And you can also do a plug and play of a lot of ready-made pipelines or ready-made AI ML algorithms, which are built on top of these industry standard data models. I'll show you, I'll give you a very quick demo of how you can build. Let's say, let's pick any example. For example, banking. Okay, let's say there is a new bank, and for that I want to build a industry standard data model. I can click on continue. It says, accept the terms of use, etc., etc. I'll click on OK. Okay, now it is already giving me this data model. If you see, I did not have to do anything. Right? Did I write any code to create any table? Do I have to know that in an industry standard banking data model, which all tables are there? I just selected that data model, and then you can see there are a lot of, some set of tables are already created, like employee, transaction, customer, channel, order, item, some kind of document, vendor, banking, products, warehouse, and whatnot, right? Now, I can pick and choose what I want. For example, this warehouse, let's say I don't want this. Right, so I can from here, I can just zoom in, zoom out, collapse, or zoom in, go to certain tables, select certain tables, or add more tables. This table, if I don't want, right, I'll say remove from diagram, or I can say add related table. That means if there are some additional related tables that are available, I can also add them. For example, this warehouse may be about, some kind of inventory, etc., right? Or let's say I don't want this in my diagram right now, right? I want a basic. So you can customize your data model. You can search from over here. Let's say I want something related to collections, right? I can, pick and choose. For example, letter of credit status, cash budget, or anything. Or let's say I want to choose something on accounts. I can try to search for different types of tables, and if I click over here, the table gets added. Okay, so this got added. Now I can say bring related tables, add related tables. So it also added related tables to that, right, into this data model. And then I can, define the relationship between these data models. I can pick and choose what I want, and I can simply click on create database. When I click on create database, it automatically creates a lake database for me. As you can see in this data space, a lake database is being created for me. I can also, change this data model to essentially, change the table structure, or add or remove certain columns, etc., etc. But essentially, what it gives you, database template, is a quick and ready to use industry standard data model, wherein you can build a good lake database, so that it will take advantage of a lot of readily built AI ML models that are built on top of this data model. So you can just plug and play. For example, in a banking use case, let's say I want to predict whether a loan is going to turn into a non-performing asset or not. Okay. Now, to predict whether a loan account is going to become an NPA in the next month, right, or in coming 6 months, I need to build some kind of machine learning model, right, or AI ML model. So if I want to build that ML model, I will have to build that model on top of my data that I have available, right? But just imagine somebody has already built that ML model on this data model, on this industry standard data model. Now, if I am able to bring my data into this industry standard data model, then I will be out of the box able to use that ML model which somebody else has already built, trained on this data model. So if I have my data in this format, I will be able to out of box leverage that ML model. I will not have to build it from scratch. So when you bring your data into these kind of industry standard models, you are able to take advantage of, first of all, you are creating a data warehouse which will, which will serve your company for a very long time, because you are not creating it, you are creating it in a standardized way. Number two, you will be able to leverage a lot of plug and play capabilities or features that are built on top of this model. So these are all the use cases. So you can also publish this, right? And your data lake database will be published and created. So I'll publish this. This is just an example I wanted to show of a lake database because somebody asked about it. Now, how this lake database will be created? These are just the tables, right? So far, so these tables are created. Now, how will the data come into this table and where will the data reside? Will it reside into a dedicated SQL pool? No, the data of these tables is actually going to reside into your data lake storage. Okay, and you will have to build pipelines to bring data. For example, imagine this is a banking product. Okay, this table. Now, this banking product table, whatever columns it has, right? Let's assume that you have a table in your OLTP database, right? Which has all this information, right? So what you will do, you will build a data pipeline. The source of that data pipeline will be your OLTP database. Let's say Oracle, SQL Server, whichever database in which you have all of this information. And you can of course modify these columns, etc., to suit to your requirement. So all you need to now do is create a copy data pipeline, schedule that pipeline to run on a set frequency, and that pipeline and map these columns, right? Map these destination columns with the source columns. And what will happen is whenever that pipeline runs, it will connect to the source table. It will bring the data, map these columns of the source table to the target table, and all of that data will be available in your lake database. Where will the data actually sit? It will actually sit into your Azure Data Lake Storage Gen 2 account that you have linked over here. So this is where your actual data is going to sit. Okay, now that's about the lake database. Let's complete the walkthrough of this Synapse Studio, and then we will come back to see a larger demo. Now this is the home tab. In the data hub, as we just saw, all your linked services, all your sources, this is your ADLS Gen 2 storage account. Then in the workspace, you can see there is lake database. You can connect to your Cosmos DB and some of the other things. Those will also be available over here. Then see, for example, here map data, right? It will quickly launch. So it says, I'm just turning the data flow debug, just like, we created a debug cluster. So when we click on map data, essentially it creates a mapping data flow. And in that mapping data flow, that you can select a source, you can select a sink, and you can do the mapping of the table. That's how it works. But anyways, I'll show you some of the pipelines which are already created. Now in the develop hub, right? In the develop hub, you will see that you can create a SQL script. KQL, we will skip for now because KQL is associated with Azure Data Explorer. So when we learn about Data Explorer, then we will come back to KQL. You can create your Spark or PySpark notebook. You can create an Apache Spark job. You can browse gallery. That is nothing but that database template and all. And you can also import some of the pipelines directly from over here. In the integrate hub, you can all your pipelines that you create will be available over here. So you can link a collection or browse from gallery or import a pipeline directly. So your pipelines will be available over here. When I show you the demo, right, that's where you will see a lot of information already available here, so that you will be able to appreciate this better. Now monitor. In this, again, similar to Data Factory, you will be able to monitor your pipeline runs, your SQL pool, Spark pool, Data Explorer pool, etc., etc. And in the manage, you create these things, right? You can create your dedicated SQL pool. So maybe let's do that. How to create a dedicated SQL pool, right? So if I click on plus, so it says dedicated SQL pool name. Let's say I'll call it SQL pool 1. And what is the DW capacity, right? Let's say I'll set it to bare minimum 100. Okay. Now, in this context, let's also understand what is DW100, and all the way, I think it can go to 30,000. Okay. Now, because it may be not available for my subscription for in this region, so it's giving me that error. But anyways, DW100 itself is a very powerful data warehouse capacity. DWU, or data warehouse unit, is a level or is a unit of measure of certain amount of compute. That means CPU processing power, the number of concurrent query slots, right? Because this is a data warehouse workload, so you don't have as much concurrency. You cannot run as many parallel queries as you can run in an OLTP workload, because in OLTP, online transaction workload, you can run large number of small queries, right? That is the nature of queries. Here, because it is analytical workload, in analytical processing, you run less number of queries, but you run very large queries, right? Or large data processing within those queries, because you are running aggregates that need to scan complete table, those kind of queries. So your number of query slots are limited, and I will click on here. So I will show you the Synapse capacity limitations that will also guide you through the documentation. So there are concurrency. Let me search for that link, but I'll show you after the break. Essentially, what I'm trying to look at is how do you understand how much data warehouse unit is good enough for you, right? And for that matter, I will also share a link to the series that we have created, because understanding some of these series, I will this is for Synapse specifically, because it's an abstract, right? So you're not able to tell that how many vCores DW100 will give me, right? Whether it gives me 1 vCore, 2 vCore, 3 vCore, or 10 vCore. Although internally we know as to DW100 is how much vCore, but essentially what is the guidance, right? The simple guidance from Microsoft is you start with small capacity, which is, let's say, DW100 or DW200, and you benchmark your workload to the level of performance you want, and accordingly you can upscale, right? Scale up to the level you want. So as simple as that. So it is always, because it's a PaaS service, so you can very easily scale. Anytime you can go from DW100 to 200, 300, 500, and some of the other criteria that you need to understand as to how to choose DW100 is also the size of the data, as well as the number of concurrent queries you want to run. Now, what is concurrent queries? That means at any given point in time, how many parallel queries should I be able to run? Because DW100 gives you 4 concurrent query slots. That means at any point in time, you can only run 4 concurrent queries. So if there are more number of queries that you want to run, if there are, let's say, 100 queries, they will be available in a pipeline. Likewise, you can keep up to 1024 queries in a pipeline. But after 1024 queries, let's say those initial 4 queries have not yet finished, and there are 1024 queries already in the pipeline. And if you are submitting one more query, then that query may bounce, right? It will not be accommodated. And that is how you will have to understand, right? How many concurrent queries you need to run to finish your workload by the given SLA, right? Service level agreement. If you were to start your batch at midnight and you want to finish your batch, let's say, at 5 a.m. So you have only 5 hours, right? So accordingly, you will figure out in 5 hours how much how many GB of delta data processing I have to do. Let's say I have to process 100 GB of data. So to process 100 GB of data, is DW100 going to enough? Because it will give me only 4 concurrent query slot. So accordingly, you will do some benchmarking, right? For how much time, for how long, each of your jobs runs. So if, let's say each job runs for 10 minutes. Likewise, I have 100 jobs. So 4 jobs will run, concurrently. So can I finish all my 100 jobs in 5 hours? So accordingly, you will do some calculation and arrive at whether what DW capacity is enough for you. Now, coming back to how to create a SQL pool, you just have to provide these details and click on review and create. And let's see, validation is successful. You can just click on create, and the dedicated SQL pool will be created for you. Okay. Now, when we come back, we will learn more about, how to, we'll now in the context of the hypothetical use case of that retail customer that we talked about. In that context, we will learn more about an art of possible as to what is possible in terms of end-to-end Synapse analytics. You can also link your Power BI to this. You can link your GitHub account to it. You can link your Purview account to it. So, and of course, create your Spark pool, SQL pool, Data Explorer pool. Creating a Spark pool is also very simple. You just have to specify very basic inputs like your Spark pool name, let's say Spark pool 1, then node family, whether you want a memory optimized or, any other family, if it is available in that region. Then you can select the size of your node, how many minimum number of nodes and how many maximum number of nodes. If you want to specify that, let's say I want to specify maximum 3 nodes and minimum 1 node, or minimum is 3. So maximum you can specify 3 or 5, it will automatically scale. And simple, let me just keep rest of the settings to default and click on review and create. And if I click on create, it will also deploy my Spark pool. Let's see if my dedicated SQL pool is ready. It is still deploying. So it will be available in a moment.
But when we are using the template, the fields may not be actually at the workplace, the fields may not be exactly the same, right? If we are using the template, so is there any?
So that templates is just a guidance. Okay. It's a ready-made template, which is industry standard template. So Microsoft had acquired a company called as ADRM. That ADRM is a company that was very specialized in creating industry standard data model. So as part of that acquisition, Microsoft has integrated ADRM within Synapse as database templates, and you have those available to use, but you don't have to restrict yourself exactly to that data model, that schema. You can change it as per your requirement. It just gives you a standard template to start with. You can customize it further as you need. I have workspace and I have linked, right? In this linked, I have linked by default. This is my ADLS Gen 2 account, right? Which I have linked. So I can go to this data lake storage account of mine. This is my primary workspace, primary ADLS Gen 2 account, right? You can see that there may be additional Gen 2 accounts that I can link, but this is my, now you can see there is lots and lots of data that is available in my demo workspace that I can access, right? These are all like containers and directories, which probably have some IoT data, a lot of different market basket, marketing DB data, lots and lots of data. This is NYC taxi data. A lot of demo data is available here, right? For example, out of that, I go to Twitter data. Okay. And in that, I go to a specific folder, and then there are these set of Twitter files, Parquet files that are available. Now imagine I want to start seeing what is inside this. I want to do some quick analysis. I want to build some data pipeline on that. But before that, I want to see what is inside these files, right? So what I can do, now remember, these files are where in my data lake storage. Where I am right now, I am in Synapse. Now I can just select as many files as I want by, selecting, and shift and select is what I did. I do a right click on that and I say, okay, I want to select top 100 rows. So automatically a query is created for me and I just have to run it. And this query has automatically run on Parquet files, that to the 3 Parquet files that I selected, and I'm able to explore the data. Now you just see how quick and easy it is to, without writing any piece of code on your own, to start exploring the data that is available in your data lake, right? I'm writing SQL queries, you can imagine, right? In any other ETL workload, right? If you were to write query on some Parquet format or different types, different file format, and you were to start exploring the data through a SQL kind of engine, SQL query, you have to first load it into some kind of database or some kind of external table yourself. You have to write some code. Only after that you will start exploring the data. Here, in a matter of few clicks, you are able to see that. Also, in an ETL tool, typically that you get, you only build data pipelines in that tool. You do not get a view of your data, right? So you cannot browse your data lake from within the data warehouse tool, right? Or from your database data warehouse kind of capability, you're not able to access data sitting into different storage locations, right? Here, as you can see, I can access not only my ADLS Gen 2 account, which is primary. I can access a lot of different ADLS Gen 2 accounts. I can access some of the integrated data sets. I can access even Cosmos DB, some data models, some Cosmos DB linked databases created over here. I'll talk about that. I can also access some of the blob storage accounts. So this becomes a quick and easy storage explorer. I can go to a specific data set that I want. I can right click and I can start exploring data. Now, where is this query running? This is running it is connected to my built-in, which is default serverless SQL pool. Okay, that means this query is not running on my dedicated SQL pool. I also have a dedicated SQL pool called as retail DW. Now you can imagine why I use built-in, because here my data is not available in my data warehouse table. I am directly running a query on the data available in data lake. For that, I'm using serverless SQL pool. If I were to write SQL queries. Now, if I go back to this data, right, and if I want to not use SQL, but let's say I am more comfortable in Python or PySpark. So what I'll do, load this into a notebook and let's say load it into a data frame. So for that, I will need a Spark cluster. So I have to attach it to Apache Spark pool. So you can see that I also have some Apache Spark pools that are created as part of this demo lab. So I can, and this is the language I can select, right? I can work on any of these language. So let's say by default, it is PySpark. I will attach it to a specific Spark cluster and it will start that cluster. When I run this query, it will try to start the cluster and run that query. What this query is going to do, it will load the data available in these 3 files into a data frame and display top 10 records. As simple as that. Did I have to write any code? No. Did I have to go to any other third-party tool or system or any other Spark service? No. Right from within Synapse, I am able to quickly explore the data. And we are just getting started. Okay. So this is how you can explore, and we'll come back to this, right, whenever it finishes. So no rush. Not finish. So because it's the first time, right, it will take some time to just start the cluster because it is serverless. So after that, it will start running. Now this is the 2 things, right? A built-in, which is serverless SQL pool that we saw, and Spark cluster, the Spark pool that we saw. Now let's also understand, why do we need dedicated SQL pool? Somebody asked that, right? And alongside that, let's also see this, right? For example, there is this data explorer pool, data lake database, right? So these are the lake databases, some template, one we had just created using template, right? So here you have some lake databases created and populated with data, and SQL database. These are your dedicated SQL pool. For example, this retail DW is your dedicated SQL pool. In that you have these tables. So whatever data warehouse tables, right, your star schema or snowflake schema that you will build, your facts and dimension tables that you will build, for that you create dedicated SQL pool, and all your data is sitting persistently in these data warehouse table. So typically, whenever essentially, what is the purpose of creating a data warehouse? Oops. The purpose of creating a data warehouse is so that you can bring some data into facts and dimension table, and you can run aggregate queries, efficiently run queries on that, right? So as you can see, there are lots of tables in which I have created those tables in my dedicated SQL pool where I have brought my data. Now, how have I brought my data into this table in these tables, for example? For that, I would have created some data pipeline, because this is my data warehouse table, right? Now, before data comes into your data warehouse, where is the data sources originating? They are originating in the front end systems, right? Let's say you have a banking application. That application will have a backend OLTP database, let's say Oracle or SQL Server or whatever, right? And that from that OLTP, you are bringing some data into data warehouse to do analytics, right? That means you will have to build data pipelines. Where are those data pipelines available? In the integrate hub, right? These are your pipelines. So these are different types of pipelines that are available, right? I will show you some of these pipelines. In fact, I had shown you some of these pipelines. For example, this SAP to HANA, SAP HANA to Synapse. I had shown you this data pipeline in the context of data factory discussion, right? So if I open this is the data flow, you would see and you would realize we had seen this, right? So this is how you connect to various source systems right from within Synapse. Now think of it that all of this experience is happening, everything within Synapse under this one umbrella. And you are able to now load data into Synapse table, again Synapse table. These are all your first code free kind of data pipelines, right? Pipelines, you are well aware. Now let me go back to Develop Hub. In this Develop Hub, just see what all do you have. You have SQL scripts, you have KQL scripts, which is Kusto query language, which is related to Azure Data Explorer. You have your Python notebooks. This is the first new notebook that we had just created, right? So once I save that and publish that, this notebook will also be saved, by the way. And by the way, as you see, this notebook has run, and it has run on using this Spark cluster, right? So when you want to do any Spark based processing, you use Spark pool. When you want to do any ad hoc SQL based processing, you can use built-in serverless SQL pool. And when you want to run query on your data warehouse tables, which are there in your data warehouse or dedicated SQL pool, right? These dedicated SQL pool, you will, let me show that with an example, right? Let me load this billion rows data, right? Now just see where this query is running. This is a SQL query, right? This query is just doing a count check from a table called cells. Let's see how long does this count check query runs. And by the way, if you notice, it is connected to this retail data warehouse, which is our dedicated SQL pool. It is running for the first time. It will take some time to access, and then it will, have a lot of this data available into cache as well. So let it run, and then I'm going to run the next query. Okay, by the time this query finishes, right, let me take you to the Manage Hub. In this Manage Hub, you can see information about your dedicated SQL pools, right? For example, this dedicated SQL pool is currently running at very bare minimum DW100 capacity, right? All of this data is available. You can see your Spark pools that are created and their specific configurations also. Data Explorer pools, if you have created any, its specific configuration, etc., that you can see from Manage Hub. Now let's go back and see if our query has finished. Anyways, it will take some time, but it will finish. Typically, as part of these demos, I have seen that these are created at a DW300 capacity, but for whatever reason, it has been set to minimum capacity, so it will take some time. Now, essentially, what you do next is you can run these kind of queries which are running across tables containing billion records, right? So this is a billion row data. That means this table that I'm trying to do a count check on, right? It has more than 1 billion records. And as you can imagine, that's why it is probably taking some time. And for these kind of billion plus record table, I can run this kind of query, which has this DBO cells table as the driving table. It is doing inner joins with a number of tables, left join, inner join with a number of other tables. Also, it is doing some group by, some aggregate, some total, etc., etc. This kind of query we will run after this query finishes, and we'll see the kind of performance that Synapse can give you. But that said and done, right? So this is where you can run different types of SQL queries on your data. That's about queries. Notebooks we already saw. We ourselves created one quick notebook. Similarly, you can have other notebooks that are created, right, which can actually have a lot of business logic for data transformation, etc. Right? This is the notebook code. This is where you can start running this notebook on each of these clusters, and it actually has some kind of transformation. For example, I think I had quickly done a walkthrough of this. This notebook does a derived column, right? For example, it tries to derive a column called as, there is revenue target, and probably it derives a column called as revenue variance, right? Create new column. It says this revenue variance is nothing but the difference between revenue target and revenue. So it's through a code way you are doing some data transformation by adding one more column to it, and maybe additional data transformation before you finally load that data into some ADLS Gen 2 destination. So these are your notebooks. Then data flows we have seen, right? So mapping data flow, all different types of data flows, this we already saw. So different types of data flows that you can create to create free low code, no code data pipeline. So different data flows are available over here. And these data flows are not only loading the data into Synapse. For example, see, if you see this retail SAP HANA to Synapse, some of these data flows are loading data actually into your Lake database, right? So the Lake database that you created using the template, that is coming over here like a sink, right? Like a destination, and sources maybe some CSV file or any other source using which finally you are loading data into your Lake database tables. As you see this particular pipeline, 1, 2, 3, 4, 5, 6. There are 6 destination tables being populated as part of this pipeline, right? So different pipelines you can build. And the most important, right, and interesting part is you can also have your Power BI reports available right within Synapse Analytics. But before I go to this Power BI, because they will probably, fail to load, I want to first load this Power BI dashboard. Once this loads, the other one will load properly. By creating event-based data pipelines, wherein you would create data pipelines in a way that one event triggers the other event. For example, there are multiple ways. In these kind of things, you are maintaining sequencing, right? So that means after this, follow this step, follow this step, follow this step, this kind of things. But now we want to talk about, let's say this data flow is being called from some pipeline, and I want to create one more pipeline which should follow this pipeline, or which should happen before this pipeline. For that kind of things in a pipeline, how does a pipeline execute? For executing a pipeline, you add a trigger to that pipeline, right? And to add a trigger, you can have 2 types of trigger. One trigger could be, let's say, time-based trigger that run this pipeline on midnight, number 1. Number 2, there could be other trigger, which could be like event-based trigger. That means when one pipeline finishes, generate an event, and when that event becomes a dependency for other pipeline to start. So to implement the dependencies that you are talking about, you need event-based trigger in Azure Data Factory. In a production grade world, right, you are not going to manually come over here, load this notebook and run it over here, right? You don't have to necessarily do that. This gives you ability to quickly develop, right? Everybody can see the notebook code, be it a BI engineer, data scientist, everybody can come and collaborate in this space. Now, do you want to use, some other Jupyter notebook or some other, integrated development environment? That is also fine, but you don't need that, right? In production, you don't come over here and manually run notebooks. Essentially, these notebooks will be called as part of some pipeline, and then that pipeline will be scheduled to run. But this is more like for your development, which you can do here or you can do otherwise also. You should not think of it like production versus development. You should think of it like serverless is serverless. That means you don't have to provision any capacity for any ad hoc kind of data processing. You can use built-in serverless SQL pool, be it in production or be it in development. Dedicated SQL pool is your data warehouse environment where you are persisting the data inside the data model, which is facts and dimension, number 1. Number 2, how a development will vary from production. In case of development, you will have, if your production is probably running at, let's say, 500 data warehouse, right? That's where typical production grade, sizing starts. The minimum DW 300 to DW 500 onwards. On the other hand, your development environment, as you can see, right? This one is running on a very bare minimum. And as we speak, this query finally finished. It took so long. And now let me run this query on this record, on this table, which is a driving table with 60 billion plus records. And then there are a number of other tables that it is joining with, doing some group by some operations. Let's see, how long that query takes. But anyways, coming back to the pricing part of it. Now the pricing for this built-in, right, serverless happens in a way that it is priced for every terabyte of data you scan. Right now, I ran this query, right? Let me go to my first query. I came to this Twitter data, right? This data is sitting on my data lake, right? I selected some Parquet files and I ran a query on those Parquet files, right? So I ran this query, it gave me the output. Now, essentially, and it used this built-in serverless SQL pool. So if this query has scanned, let's say 5 MB of data, 10 MB of data, or if it is scanning 1 terabyte of data. So for every terabyte of data that you are scanning, roughly the pricing is to the tune of $5 per terabyte of data scan. So it is pay as you go. For every 1 terabyte of data scan, you will be charged, right? And accordingly, pro rata basis billing will happen. On the other hand, for the dedicated SQL pool, right? For dedicated SQL pool, your pricing is transparently available. That means for 100 DW capacity that you provision, how much is the charge per hour? For 200, how much is the charge? So that you will know upfront, and that's why it is called as provisioned. You are provisioned compute, so you will be charged accordingly. And the beauty of that, right, to save cost is you can go over here, and you don't have to do this manually in production, by the way. So you can pause your dedicated workload, right? So once my job is done, let's say I want to build a overnight batch workload to build my data warehouse every day, right? Refresh the data. So I will start my dedicated SQL pool, let's say at midnight. And once all my jobs are done, I will automatically through a PowerShell script pause this, or I can come over here and pause this. That means the dedicated SQL pool will be charged. The compute part of it only will be charged for those many hours. You can save my cost. That's how it works. Now let's go back over here. See, I told you that I will show you the art of possible, right? So this is what is art of possible. Now we saw that retail use case. What they wanted to understand the historical information, right? So this is some of the info, and just look at it. This is the end result, right, of whatever analytics that they wanted to do. I don't know how to move this window, but anyways, so yeah, as an end result, just imagine they are now able to see their historical data. Now, what is their historical data says? Their total marketing campaigns that they ran were saying the return on investment was this much. Revenue, total revenue, their total revenue is this much. Their customer churn is, let's say, 33. Their goal was 30, whatever, right? And this is an alert that they need to look into. Very intuitive Power BI dashboards that they can see. Now, real-time data, real-time social media analytics and video analytics, right? How many Twitters, right? How many retweets? If they are running some campaign, are people, tweeting about that? Some video analytics from their, let's say stores, brick and mortar stores, or some IoT analytics can be done. Then there is campaign-wise, different. They can, click on particular campaign and see what is the details about that campaign. As you can see, these charts are very intuitive-looking charts, right? They can understand their revenue, right? For example, this is the revenue versus this is the marketing cost. They are seeing that this revenue is actually dropping, right? That means this data is giving them some hints that, okay, your revenue is dropping and your marketing cost is actually increasing from February to May 2021. So they can further deep dive into it as to, okay, why it happened, right? In this way, what actions to take so that they can reverse this, right? More revenue and lesser marketing cost, something like that. So this organization probably is burning money, right, in campaign and marketing, but the revenue is still declining, whatever. Right? So what are the tweets? How many ads somebody clicked, right? How many ads clicked on tweets, media, etc., etc. A lot of different kinds of analytics. So this is the end result, right? How it is built. How it is built? It is built by using these, right? So in Synapse, you brought in data. How you brought the data? You connected to your various data sources. You brought data from various line of businesses, external Twitter data, etc., etc., and you built data pipelines. You created these data warehouse tables, right, which are feeding this Power BI dashboard, and you are able to now do a lot of analytics, right? And if you think building these Power BI dashboards which look so intuitive, takes a lot of time. Synapse reduces that time significantly, right? Because Synapse makes it very easy to work with everything integrated. For example, now if I go to this Power BI report, right from within Synapse, you can access your Power BI reports and dashboards, and you can run some queries. So let me see if I can show you some of the reports. Let's say campaign analytics.
Let's have a quick quiz question, guys. What is the primary function of Azure Data Lake Storage Gen 2? Real-time data processing, data warehousing, secure data storage and analytics, or data visualization? Please mention your answer in the comment section.
Just a quick info guys, Intellipaat offers advanced certification in cloud and DevOps in collaboration with IIT Guwahati. Through this course, you will learn a multitude of tools used in the industry such as Azure, DevOps and AWS. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights, so visit the course page link given in the description and take a first step towards a career growth in the field of cloud and DevOps.
So let us begin with data engineer beginner interview questions. First, what is data engineering? When working with data, the term data engineering is used. Data engineering is the primary process of converting a raw entity of data into useful information that can be used for a variety of purposes. This entails the data engineer working with data by performing data collection and research. Second question, define data modeling. Data modeling is the process of simplifying complex software designs by breaking them down into simple diagrams that are easy to understand, and it has no prerequisites. There is a simple visual representation between the data objects involved and the rules associated with them, which provides numerous benefits. Third question, what are the features of Hadoop? It is free and simple to use. Second, Hadoop is highly scalable. A large amount of data is distributed across several devices in a cluster and processed in parallel. The number of these devices or nodes can be increased or decreased based on the needs of the hour. Third, data in a Hadoop cluster is replicated across multiple data nodes, ensuring data availability even if one of your system fails. Fourth, Hadoop is designed to handle any type of data set, including structured, semi-structured, and unstructured data. This means it can analyze any type of data in any format, making it extremely versatile. Finally, Hadoop allows for faster data processing. Fourth question, what are the 4 V's of big data? The following forms are considered to be the essential foundation of big data. First, volume. Then, variety, velocity, and veracity. Fifth question, briefly describe the star schema. A star schema in a data warehouse can have one fact table and a number of associated dimension tables in the center. It is known as a star schema because its structure is similar to that of a star. The star schema data model is the most basic type of data warehouse schema. It is also referred to as the star join schema and is intended for large data sets. Sixth question, briefly describe the snowflake schema. A snowflake schema is a logical arrangement of tables in a multidimensional database that corresponds to the shape of a snowflake. A snowflake schema is a star schema that has been enlarged with additional dimensions. The data is separated into new tables after the dimension tables have been normalized. Snowflaking has the potential to improve query performance in some cases. The schema is structured in such a way that each fact is surrounded by its related dimensions, which are linked to the other dimensions, forming a snowflake pattern. Seventh question, what is meant by COSH? The acronym COSH stands for Classification and Optimization Based Scheduling for Heterogeneous Hadoop Systems. It provides scheduling at both the cluster and application levels, as the name implies, to have a direct positive impact on the job completion time. Next question, name the XML configuration files present in Hadoop. XML configuration files available in Hadoop are core site, MapReduce site, yarn site, and HDFS site. Ninth question, what is the difference between Spark and MapReduce? Spark is a MapReduce enhancement for Hadoop. The distinction between Spark and MapReduce is that Spark processes and stores data in memory for subsequent steps, whereas MapReduce processes data on disk. As a result, for smaller workloads, Spark's data processing speed is up to 100 times faster than MapReduce's. In addition, unlike MapReduce's two-stage execution procedure, Spark creates a direct acyclic graph to schedule tasks and orchestrate nodes across the Hadoop cluster. 10th question. What is the replication factor? The replication factor is the number of times each data block is replicated by the Hadoop framework. The replication of the block provides fault tolerance. The replication factor is set to 3 by default, but it can be reduced to 2 or increased to meet your requirements. Let us move on to Data Engineer Intermediate interview questions. First, how is data security ensured in Hadoop? Some of the steps involved in securing data in Hadoop are as follows. To begin, you must secure the authentic channel that connects clients to the server. Second, the clients use the received stamp to request a service ticket. Finally, the service ticket is used by the clients to authenticate their connection to the corresponding server. Second question, in your opinion, what does a data engineer majorly do? A data engineer is in charge of a variety of tasks. Some of the most important are as follows. Handling data inflow and pipeline processing. Second, maintaining data staging areas and being in charge of ETL data transformation activities. Third, performing data cleaning and redundancy removal. And finally, developing ad hoc query construction operations and native data extraction methods. Third question, what is the data stored in the name node? Name node stores metadata about all the files in the cluster, such as the location of the block stored, the size of the files, permissions, hierarchy, and so on. The metadata associated with two files is fsimage. It stores the entire state of the file system namespace since name node's inception. Second, edit logs. It contains all of the most recent changes made to the file system in relation to the most recent fsimage. Fourth question, what is the use of Hive in the Hadoop ecosystem? Hive is used to provide a user interface for managing all of Hadoop's stored data. The data is mapped using HBase tables and worked on as needed. Hive queries are run to generate MapReduce jobs. This is done to keep the complexity under control when running multiple jobs at the same time. Next question, what are the table creation functions in Hive? The following are some of Hive's table creation functions. First, explode array, explode map. Third is JSON tuple, and finally stack. Sixth question, have you ever transformed unstructured data into structured data? So this is an important question because your response can demonstrate your understanding of both data types and practical work experience. You can answer this question by making a brief distinction between two categories. For proper data analysis, unstructured data must be transformed into structured data, and the methods for transformation can be discussed. You must describe a real-world situation in which you transformed unstructured data into structured data. And if you're a recent graduate with no professional experience, discuss information about your academic projects. Seventh question, how would you validate a data migration from one database to another? Data engineers' top priority should be data validity and ensuring that no data is dropped. Hiring managers ask this question to understand your thought process regarding data validation. You should be able to discuss appropriate validation types in various scenarios. For example, you could propose a validation that is as simple as a comparison or that it occurs after the entire data migration. Eighth question, what happens when block scanner detects a corrupted data block? It is one of the most popular and common data engineer interview questions, and you should respond to it by listing all the steps taken by a block scanner when it discovers a corrupted block of data. First, data node informs name node of the corrupted block, and then name node creates a replica based on an existing model. If the corrupted data block is not deleted by the system, name node creates replicas based on the replication factor. Ninth question, how can data analytics help the business grow and boost revenue. It all comes down to business growth and revenue generation in the end, and big data analysis has become critical for businesses. All businesses want to hire candidates who understand how to help their company grow, achieve their objectives, and result in a higher ROI. You can respond to this question by demonstrating the benefits of data analytics in increasing revenue, improving customer satisfaction, and increasing profit. Data analytics aids in the development of realistic goals and decision making. Businesses that implement big data analytics may see a 5 to 20% increase in revenue. Walmart, Facebook, and LinkedIn are some of the companies using big data analytics to boost their income. 10th question. Which are the default port numbers for Port Tracker, Task Tracker, and Name Node in Hadoop? Job Tracker has the default port 50030. Task Tracker has the default port 50060. And Name Node has the default port 50070. And now we look at Data Engineer Advanced interview questions. First, what is the meaning of skewed tables in Hive? So skewed tables are tables in which values appear repeatedly. The more they repeat, the more skewness there is. A table can be classified as skewed while being created in Hive. By doing so, the values will be written to different files first, and the remaining values will be written to a separate file later. Second question, what was the algorithm you used in a recent project? First, decide which project you want to discuss. Use a real-world example in your field of expertise and an algorithm relevant to the company's work to pique the hiring manager's interest. Keep track of all the models and analysis you have used. Avoid overcomplicating things by starting with simple models. The hiring managers want you to explain the results and their significance. Third question, what tools did you use in your recent projects? Interviewers want to assess your decision-making skills as well as your knowledge of various tools. As a result, choose this question to explain why you chose specific tools over others. Explain to the interviewer what tools you used and why you used them. You can also discuss the advantages and disadvantages of the tool you used. Also, try to use this opportunity to tell the interviewer how you plan to use the tool to benefit the company. Next question, how can you deploy a big data solution? The recruiter is interested in knowing the steps you would take to deploy a big data solution when asking this question. You should respond by emphasizing the three important steps, which are data integration or ingestion,